So you already coded a line or two of JavaScript, but what exactly is JavaScript actually? Well, that's what we're going to look at in this video. And so in this lecture, we will set the stage for the rest of the course. And so it's really important that you follow this one until the end. All right? So per definition, JavaScript is a lightweight, cross-platform, object-oriented computer programming language. Now that sounds a bit too much, right? But don't worry, it's simpler than what it sounds like. So lightweight just means that the language doesn't eat up much memory of the computer and that it has a relatively simple syntax and features. Cross-platform means that the language can be used on multiple platforms and systems, not just for web development. And finally, object-oriented means that it's a language that's based on objects. And we're going to explore all of that throughout the course. Now, as you already know, together with HTML and CSS, JavaScript is one of the three core technologies of web development. And more on that in a second. So for web development, JavaScript has traditionally only been used in the browser environment, which means that it was only a client-side language. However, more lately, thanks to a new technology called Node.js, developers are now able to actually use JavaScript on the server side as well. But that is a whole big topic for itself, and we will not cover that in this course. So as I mentioned at the beginning, this course covers the JavaScript language itself and how to use it in the browser, which is the more traditional way. Okay? So in summary, JavaScript is what made modern web development possible. It allows us to not only add dynamic effects and interactivity to more simple websites, but it also allows us to develop complex modern web applications that we can interact with and that almost feel like the apps that we can use on our computers and phones every single day. Now, something else that I think is important to mention here is that today there are lots of JavaScript libraries and frameworks out there that implement different architectures and help developers build complex apps more easily and faster than ever. So I'm talking about stuff like React or Angular or even jQuery, which are all extremely popular, and I'm sure that you have heard of them already, right? Now the thing is, they are all 100% based on JavaScript, and so before using them, developers actually need to be really good at JavaScript. They need to be really able to understand the language itself. And that's exactly where this course wants to help you. So I mentioned that together with HTML and CSS, JavaScript is one of the core technologies of the web. And so let's go a bit deeper into that and talk about the role of JavaScript in web development. So HTML, CSS, and JavaScript all work together to create beautiful, interactive, and dynamic websites or web applications. Now, the HTML is responsible for the content of the page. So the text, the images, the buttons, and all the content that you see on a web page is always written in HTML. Then the CSS, of course, is responsible for the presentation of that content. So basically for styling and for laying out the elements on the web page. And then finally, JavaScript is the real programming language that allows developers to add dynamics into the picture, like interactive effects, manipulation of the content or of the CSS, and much, much more. So again, HTML is responsible for the content, CSS for the presentation, and JavaScript for adding real programming capabilities to websites. Now, another way to easily visualize the role of each technology is to put them in terms of nouns, adjectives, and verbs. So in this thought experiments, HTML does the nouns like saying that the P element is a paragraph. So paragraph here is the noun. The CSS then is the adjective because it describes the noun like saying the paragraph text is red. And so there is the adjective. And then finally, JavaScript is the verb, like saying hide the paragraph. And so we are doing something here, and so we have a verb. Okay, does that make sense? And so that is the role of JavaScript in web development. And now just before we finish, I want to quickly mention that there are different versions of the JavaScript language. But I'm not going to go into that right now, and instead, I'll leave that for the end of this section, okay? For now, I just want you to start coding as fast as possible. And so we're going to use a version called ES5 over the next couple of lectures. But again, at the end of this section, there's a whole very important video about this. In this video, you will learn about the fundamental concept of variables. So variables are a fundamental concept of every programming language in the world. But what actually is a variable? Well, we can say that a variable is like a container in which we can store a value in order to use it over and over again in our code instead of having to write the value each time that we want to use it. Okay? So let's actually get rid of this code here. And so let me show you how to declare a variable for the very first time. So we have to use the var keyword and then the name of the variable. And I'm going to call this one first name, then equal, and then the value that we want to assign to the variable. And in this case, what I want to assign is a text, a string called John. Okay, and then again, our semicolon at the end. And so with this, we just declared our very first variable. So the variable name here is first name, and the value that we assigned to that variable is John. So you can basically think of this variable, this first name variable here, as a piece of memory in your computer in which this John string here is stored. So I used these quotes here to declare this text here, so this string. Okay, I could also have used the double quotes like this, but I think it's a bit more modern to simply use these single quotes. All right, so when we declare some text, we usually just use the single quotes just like this here. All right, so throughout this section here, I will be using variables about persons for all the examples. So stuff like names or jobs or age or something like that. So something defined persons. So let's now do again a console.log. And what we're going to log now is simply the first name variable. All right. And so what do you think will happen when we reload our page now? So let's take a look at that. And indeed, you see John now logged to our console. And that's because we assigned John to this variable. And then JavaScript can retrieve the value of this variable here, which we declared as John. And so first name here is effectively the same as John. Okay, does that make sense? Let's now declare another one. And again, we have to use var. And now let's say last name equal. Then again, I use these quotes. And then let's say that it's Smith. So John Smith. So that's the last name. And let's declare another one called age. And so let's say that John is 28 years old. And so you see that now it's no longer a string like we had here, but it's now a number. And so that means that it's a different data type. Okay, so here we have text, but here we have numbers. Okay, and so now this is a good time to actually talk about different data types in JavaScript. So in JavaScript, there are 5 different data types: number, string, boolean, undefined, and null. And so far, we have already seen the number and the string, right? Now, primitive data type just means that it's not for objects, unlike most things in JavaScript. So they are just simple, primitive, non-object data types. So first off, we have numbers again, and JavaScript numbers are always floating point numbers, which simply means that they always have decimals, even if we sometimes don't see or even don't define them. So for example, 5 is like having 5.0, all right? And in other programming languages, many times it doesn't work like this, and you have different data types for integers and decimals, but not in JavaScript. So here all numbers are simply float numbers, even if they look like integers. Next up, we have strings, which are simply a sequence of characters, and so they are just used for text, like we did in the example before with the last name and the first name. Next up, the Boolean data type is a logical data type that can only take one of the logical values, true or false. So to make it simple, a Boolean is always either true or false. Okay? And we will see why this is very important over the next lectures. Alright, and the next one is a bit more difficult to understand. So basically, undefined is the data type that is automatically assigned to a variable that doesn't have a value yet. Sounds a bit more complicated than it actually is, and don't worry, I'm going to show it to you a bit later, of course. But what matters here for now is that basically undefined means non-existent. Alright? And finally, there is another data type, which is quite similar to undefined, and that is null. So null also means non-existent, but it's slightly more specific. And again, we will take more about these two later on. Now, before we move on, there's something very important to note here, which is that JavaScript has a feature called dynamic typing. And this means that we do not have to manually define the data type of a variable, unlike in many other programming languages. So basically, JavaScript automatically figures out if a variable is a string or a number, or if it's undefined or a Boolean, and then assigns that data type to the variable without us having to do anything. Okay? And if we then later assign another value to the same variable, but with another data type, then JavaScript will automatically change the data type of the variable as well. So this can of course be very useful and save us some coding time, but it can also be the source of some difficult to find bugs, which means errors in our code. Okay, so we always have to be careful with what we do with our variables. Alright, and that's it. So let's now actually see these things in action again and move back to our code. So to show you the boolean data type, let's create a variable here called full age. So var full age, and then say true. And remember that booleans can only be true or false, and so in here we can simply say true or false. Okay, so I could of course also have written false, but in this case, well, John is of course of full age with his 28 age. And so let's now take a look at the console when we log this variable here. So full age, the semicolon, and then reload it. And now you see here that it's true. Okay, so it also appears in a slightly different color here. This one is blue, and the John string here is black. All right. So here it also looks a bit different. So it's of course not in quotes. We simply write out true like this because it's a reserved JavaScript keyword. Okay, now before we move on in this lecture, I want to quickly talk about these variable names here. Okay, so it's a best practice in always giving our variables meaningful names. Instead of simply writing something like X or ABC or something like that, we should never do that. We should always say in our variables what we actually want. Okay, or what this variable actually means. So in this case here we have John, and that's a first name, and so we call this variable first name and not just some random sequence of characters. Okay, and the same of course for last name, age, and full age. And so again, that's a best practice. Of course, it would work the same if we say A, for example, and then A here. If we now log it to the console, then of course John is still here. But again, we want our variable names here to really have some meaning. Then this way of writing the variable name with this first word here and then the name, where I separated them with a capital letter here, that's the so-called camel case notation. Okay, so we could have done it like this. So first name all together, but then it would be kind of difficult to find where the second word starts. We could also have done it like with an underscore, but in JavaScript it's kind of a convention to use the camel case notation like this. Okay, so we start with a small letter in the beginning, and then when we have a second word, then that one starts with a capital letter. In the case of age here, for example, that's not the case because we only have one word. But then here again in full age, we have the second word here with this capital A. All right, so that's not about the JavaScript functionality itself. That's more of a programming convention and a best practice. Okay, moving on, let's define yet another one, and this one I'm going to call job. Now the difference here is that I'm not going to assign anything to this variable. Okay, so I can declare a variable but not assign a value to it. And so let's see what happens when we now take a look at this variable. And can you guess what's going to happen here? I hope you can. And indeed what we see here is now undefined coming from script.js at line 11. So this line here prints undefined to the console. And remember that when I showed you that slide, I mentioned that undefined means not existent, and so that's the case. So we declared the variable, but we didn't assign any value to it. And so therefore job is simply undefined, and so that's what we see in the console. We can then later go ahead and assign something to it. So let's say job is teacher. And if we do the console log then again, and let's just copy it here, well, then we should see the teacher. And here we go. So from line 14 comes the teacher after we have declared it here in this line above. Okay, so we have strings here, we have numbers, we have a boolean, and we have also the undefined right here. And so these four are the most important data types that I wanted to show you. Now just to finish off this lecture very quickly, I want to show you some rules that we have to keep in mind when we name our variables. So I already talked about the best practices when naming them. So with this camel case notation that I explained before, but that was not really a rule, that was more of a best practice. But actually there are also some rules that we have to keep in mind. But don't worry, they're actually very simple. All you have to know is that variables cannot start with numbers or symbols except for the $sign or an underscore. Okay, so let's try to break some of these rules to see what happens. So var, and now I'm going to start a variable with a 3, so with a number. So let's try to say 3 years equals 3 and then reload the console. And now you see that we get an error here in line 16. And so this is here not valid. And again, because we cannot start a variable name with a number. All right. So I'm showing you this that in case you start naming your own variables, you don't run into these errors and then cannot figure out what this here means. So always take care and use these rules that I'm showing you here. Now, if we wanted to fix this here, we would either have to start with a number or with a $sign or an underscore. Okay, so these are the only symbols that can appear in a variable name here in JavaScript. So for example, with the underscore, it would work just fine. With the $sign as well. But as soon as I start putting something else, like this, well, then again, we get the error here, okay? And the same actually happens if I use a symbol in the middle of a variable name. So something like John/Mark, for example, John and Mark, and you will see that this here is not going to work again. Okay, so we have an error here at line 17 now, of course. But I want the error now on line 18, so let's take a look at that. And of course, it says unexpected token, which is this one. So in this case, we would of course use the camel case notation here to make it a lot better. And so now we don't have any error here anymore. So that was the first rule, that again, all variable names must start with either an underscore, a $sign, or a letter here. And then the second and last rule is that we cannot use reserved JavaScript keywords as variable names. So something like function, for example, is not going to work. So function equals 23, for example, and this will not really work. So you see unexpected token function. We can also not use something like delete, which is also a reserved keyword. And you will meet many of these keywords here throughout the course, of course. But right now, just know that any of these keywords that we're going to use later, something like if, for example, you will not be able to use these as variable names. So variable names really need to be our own made up words and not the words that JavaScript already uses in its language. And all right, that's actually all there is to know about the fundamentals of variables and data types. So that's already a huge step forward and a very important concept in any programming language of the world. In the next video, we're going to dive a bit deeper into variables and do some more stuff with them. So stay tuned for that next video. Welcome back. In this video, you're going to learn how to mutate variables and also how and why JavaScript does type coercion. But before we talk about any of that, I want to show you something else that we also have in any programming language in the world, and that is comments. So with comments, we can really comment like pieces of code and describe what they do. Okay, so let's try it out. And in JavaScript, there are two types of comments. There are single line comments, and we work them just like this, and then also multi-line comments. And I'm going to show you in a second how they work. But with single lines, we simply write // like this, and then we can do any text that we want after that. So in here, I'm simply going to write that these are the variable naming rules, okay? Because that's actually what I did here in these lines of code. So I showed you how we have to name our variables. And so now with this comment here, I can very simply describe that this is what we did here. Okay, we can also do a multi-line comment, and that is / asterisk, and then asterisk, and / again. And then on multiple lines. And everything that we put here in between will be a comment. So one line of comments, 2 lines, and so on and so forth. Okay, and here I'm going to use this multi-line comment to say that this lecture here was about variables and data types. So variables and data types, and this is also a common like pattern where you then add some asterisk here, just like this, basically just to separate these lectures. Okay, so variables and data types, that was the last lecture, and now in this lecture we will have variable mutation and type coercion. All right. Now, just in order to get rid of this code here so that it doesn't get in my way, I can also comment out this entire piece of code, just like I did before. So that's another common use case of comments, is where you basically comment out some code that you don't want to get in your way for some time. Okay, and so now I commented it, and now it will no longer be executed. So I can reload this now, and then we don't have anything logged to our console because all of this here is gray, and so it's really commented out. Okay. Anyway, let's continue with our person's example here and learn all about variable mutation and type coercion. Okay, so I'm going to reuse some of these variables. So first name is still John, and has also defined the age as being 28 again. So we have here two different data types, string and number. But let's see what happens if we want to print them together to the console. Okay, so let's give it some space here. I prefer when this text here is a bit more at the top. So console.log, and so let's basically do a string which contains John space 28. Okay, so we can say first name, then we can use the plus symbol, and I'm going to explain you later that this is an operator. So for now, let's just simply use this here to join these strings. Then we can do a space, and then another plus to add the age. Okay, so we are hoping that this here will then become John space 28 to the console. Okay, so let's check that out. And indeed, we have John 28. So how did this work? Because remember that age here is actually a number and not really a string, but still it logged it here as a string in this entire John 28 string. And so this works thanks to something called type coercion. Okay, so what this means is that JavaScript automatically converts types from one another as it's needed. And in this specific case, it converted this number here to a string in order to be able to join these three strings. So John is a string, then this space here is also a string, and then age, the number, will automatically be converted by JavaScript also into a string, so that it can then join all of these strings into one bigger string. And so automatically JavaScript does this work for us here by a process called type coercion. And other programming languages are not like this. We would have to convert our variables, but JavaScript is easier. It takes all that work away from us and does it automatically. And joining strings like this here is just one of many examples of type coercion that we will encounter throughout the course. So type coercion here happens all the time in JavaScript. All right, let's now try out another example here with joining strings. And so let's create some more variables. So job, and now I'm going to show you something different, which is basically to declare many variables on the same line and then define them later on. So job, to say John's job, and then we can also define a variable called isMarried. So basically like a marriage status saying true or false, whether he is married or not. And now we can say job is teacher, and then that isMarried is false. Okay, so we declared both of these variables here, and they are then undefined, remember? So that's what we had here. So I declared the variable here, job in this case, and it was then undefined, remember? And only later in this line here, I then assigned a value to that variable. And so that's the exact same thing that we do here. So here we declare multiple variables on the same line, and then I assign the values to them here in these different lines. Okay, and so that's also actually like a common practice. In case that we want to declare many variables, it's a bit cleaner to do it like this, all in one line, and then simply assign them the values a bit later. Now what happens if we want to log to the console a variable that has a boolean here included? So let's try it out with console.log, first name, and then let's say, so John is and then the age here, year old, and then finally the job. And if we then want to include the boolean that we defined before, well then we can also let's say, is he married? So we kind of ask a question here, and then let's see what happens when we try to join the isMarried variable here into the string. Okay, so that looks a bit confusing here, but what should happen here is John is a 28-year-old teacher. Is he married? False. So let's take a look at that. And we get this error here. And that's just because I was missing this plus sign here. Let's try it again. And so John is a 28-year-old old teacher, is he married? False. And so you see that even the boolean here gets converted to a string. So JavaScript also does type coercion with booleans. And if we now actually take away this variable here, and so I'm commenting it out here, well, let's see, then it should say undefined. Okay, so even the undefined is coerced into a string, so basically converted into a string. Okay, let's take a look again, and so now it says false. All right, so this is type coercion, and now again I can write a comment here saying what we did in this particular section here. Okay, and now let's actually look at the variable mutation. So variable mutation basically means to change the value of a variable. And so that's something that we didn't do up until this point, but of course that's something that we can do with JavaScript variables. And so let's now redefine the age. So we can say age equals 28, for example. And so this time we don't use the var keyword. So this part is not necessary because the variable was already defined before. It's already declared here in this place with the var keyword. And so when we want to change it, we no longer need the var keyword. So all we say is age and then the new value. And in this case here, it is 28 as a string this time. And so as I explained to you in the last lecture, JavaScript automatically figures out the data type and can change it on the fly. So before it was a number and now it is new and it's a string. So that is the magic of the JavaScript dynamic typing. Okay, we can also of course change something else. Let's change the job here. So job, and let's say driver. All right, and so let's now log it again to the console. Or instead of logging, I want to show you something else. So we've been logging these values to the console all the time, but now I want to use alert. So let me show you what alert is going to do. And it's this beautiful window here. So we get a pop-up window basically. So John is a 28-year-old driver. Is he married? False. Okay, and so this time it's not in the console, but instead it is like this small pop-up or alert window. And you see that basically the page here keeps loading until we actually hit OK here and make this pop-up disappear. So the page is loading. It cannot really finish its work until we hit OK on this. Okay, so we did some variable mutation here and type coercion. We also observed. I showed you the alert, which is an alternative to console.log. Let me just show you something else here, which is that we can actually, in an easy way, get data from the user with a similar method than alert. So we can use prompt and then basically ask a question here. So let's say, what is his last name? Okay, so we say prompt, what is his last name? And we will then be able to input a value. And that value we can then store into a variable. So var last name. So that's what we're asking for here. And then we can log it to the console just to make sure that everything works. So last name, and we can also add the first name here. Okay, so that's the pop-up from before, so this alert here. And now here comes the prompt. Okay, so what is his last name? And let's say Smith. And now this will be stored into the last name variable. And then we can log this variable to the console. So first name plus the last name will of course give John Smith. So Smith is what we just defined. If we now say like Miller, then it will log John Miller. Okay, so that's our input coming from that window. Great, you're progressing at a great level here and already learned a lot of JavaScript. Of course, there's tons more to come, and so let's quickly move on to the next lecture where we're going to talk about some basic operators. So like doing math operators and compare different values with one another. So stay tuned and see you in a second. Let's now learn about a couple of basic JavaScript operators. So here I already created like the title for this lecture and also commented out the code here of the last lecture. Okay, so we could actually do this here in different files, like one file for each lecture, but I prefer to just keep everything simple here, all in one file. Now for operators, they can be, for example, the simple math operators that we already know, like plus and minus and times. And then beside that, in JavaScript, we have a couple of other operators that I'm also going to show you. So in simple terms, operators are like functions that are written in a special way in JavaScript. And in case you're wondering what functions are, don't worry, again, we will talk about this a bit later. But for now, let's actually take a look at some math operators and how we can use them in JavaScript. So let's calculate in what year John was born, and that's very simple. So let's call it year John. And so we have 2018, which is the current year, minus John's age, right? And remember, we used to declare it as 28, and so let's use the same here. And so now we can then log it to the console. So let's take a look at that. And indeed, 1990. Okay, so this here, the minus is a math operator in JavaScript. And let's not do the same for, let's say, for someone else, like John's friend. Let's say he's called Mark. And so 2018 minus 33. So Mark is 33 years old. And now you see that we are starting to repeat some of the values. So for example, 2018 here, we are using it multiple times. And so let's declare it as a separate variable. So that is what variables are for. Okay, so we can say var year is 2018. And so now instead of having to reuse this 2018 here, we can then write year in these two places. Okay, so let's take a look at that. And of course, it still displays the exact same number. But if we wanted to change the year now, let's say to 2020, well, then we wouldn't have to change it here in these two places like we had before. So before, if we wanted to change the year, we would have to change it both here and here. And that's something that we always want to avoid in programming. And so we define this year in one place, and then it gets used in these two places here. Okay, and actually let's also declare all of these variables here in the same line like I showed you before. So year, then year John, and year Mark. Okay, and then remove these vars from here. So this just looks a bit better. So that is just the minus operator here. But of course we can do all kinds of math here. So for example, we can multiplications. So let's say we wanted to add 2 years here. And so now is not defined. So this is of course not now, but it's year. Well, actually this should be called now because now is the current year. So 2018. So what we want here is this to be called now, and also here and here. All right. And so let's take a look at what happens then. And indeed, it logs 2020 to the console, which is 2018 plus 2, right? Of course, we can also multiply. So let's say now times 2, and we can, of course, also divide. So let's divide by 10 here. All right, logging it all to the console. Well, then, of course, we see that this is 2018 times 2, and this is 2018 here divided by 10. And so we end up with this like decimal number here, okay? So these are the math operators that we used here. So let's add a comment here saying that. And now I'm going to show you some logical operators. So let's write that down here as well. And so let's say that we want to compare the age of Mark and John and figure out if, for example, John is older than Mark. And so for that, we can use a logical operator. So first of all, let's actually define these ages here as different variables. So age John is 28, and then age Mark is 33. And so of course here we use age John and then down here age Mark. So let's create a new variable here called var John older. And then we will say age John greater than age Mark. Okay, and then of course we need to log it to the console here to see our result. And so let's take a look at what happens now. And we see our result is this boolean and it's false, okay? And so what this means is that age John, which is 28 here, is of course less than age Mark, which is 33. And so basically here we ask the question, is age John greater than age Mark? And the result of that is false. Okay, and so our John older variable here turns out to be false. Now if it was the other way around, if we asked age John less than age Mark, well, then it should be the other way around. And so yeah, indeed it is now true. Again, because age Mark is 33, which is more than 28. And so we have a way now of basically creating a Boolean variable using one of the logical operators that I just showed you. And there are many more that we're going to explore a bit later in the course, and actually in this section in a couple of videos. So math operators here are pretty straightforward. Then these logical operators, which are also very important, as you're going to see later throughout the course. And then before we leave, I also want to show you the type of operator. Okay, and this operator is a bit different than the other ones. So the one that we used up until this point always required like two things to compare or to add or to multiply. So now times 2, or now divided by 10, or age John less than age Mark. So we always had two operands. But with the type of operator, we only have one. So let me show it to you. And so let's log to the console the result of using the type of operator on, let's say, the John older variable. Okay, and so basically what this will do is to tell us the type of this variable. And so indeed we get Boolean. And that's because obviously this is a Boolean variable. So we saw that here as it returned this true. And as you learned in one of the last lectures, a true or false value is always a Boolean, right? Remember that? So let's try it out with some other stuff here. So type of, and let's now say age John, and this should be a number. And indeed, it is. Let's actually copy this now. And let's try it out with a string. And we don't have any here. So let's just write it ourselves. Mark is older than John, for example. And then also, let's try something else. So let's just declare a random variable here and not define it. And then let's log to the console the type of this. And so what do you expect that the type of X will be? So let's test it. And I hope you know that it will be undefined. Okay, so that makes sense. Because indeed, we did not define any value for the X variable. And the one before here, of course, is string. So this may not seem like a big deal to you here, this operator, but actually you will see that we will use this here in the future, and actually also later in this section. Okay, so this is the very basics of JavaScript operators. Now in the last lecture, we will keep working with operators, where I'm going to show you some more, let's say, advanced stuff. So don't wait and come with me right to the next video. Hey there! In this lecture, we will continue talking about operators and operator precedence. So for this example, let's say that we want to calculate if John is of full age only based on the year in which he was born. So let's first declare a couple of variables. So now is 2018. The year John was born was 1989. And then we also define the full age variable. And that's the age at which you officially become of full age. So in most of Europe, that's 18. Maybe in the US, it's 21. I'm not sure, but let's use 18 here for this example. Okay, and so what we can do is to calculate the age and then compare it with 18 here. And we're missing the equal sign, of course. And so what I want to do is to do all of that calculation all in one line. Okay, so var is full age and then equal now minus year John, and that will calculate the age. And then we want to test if it's greater or equal to the full age. Okay, so does that make sense? So let's take a look at this and try to figure out why this works. So you see that we have actually two operators. We have the minus and then this logical greater or equal operator all in one line. So all in here. Now, how does JavaScript know which operator actually to execute first? Because imagine that first this here would be executed. So we would ask if year John is greater or equal of full age, which would return a true or false value. And then we would do now minus this true or false value. And so this would be nothing significant. So this would not be what we want. Instead, what we want is for this year to be executed first. So now minus the year of John, and then we want to compare that age with the full age. So this here works, and let's actually test that. And I'm going to show you why in a second. Okay, so this actually returns true. And of course, John is of full age. So in 2018, born in 1989, he is 29. And so of course, he is of full age. Now, in order to figure out why this works here, we have to think about operator precedence, which means which operator is executed first. And so if you come here to my resources page at codingheroes.io/resources, down here in the JavaScript section, you will find this operator precedence. Okay, so let's open up that link. And then down here, we have the operator precedence table. And so what we see here is that the operators that are here on the top of the list will be executed before the others. So you see that the one with the highest precedence is using this grouping here with the parentheses. And I'm going to show you that in a second. But what we're interested in here is our plus, or actually our minus operator, which is this one, and our logical operator greater or equal. So this one here. And so what we can see from this table is that the minus operator has a precedence of 16. Okay, so that's what this value here is the precedence value, which is greater than the one from the greater or equal operator, which is only 11. And so what that means is that this minus here will be executed first. And so all of this is executed first, and then we end up with the result here. So in this case, it will be 29. And then only after that, 29 will be compared with the full age with this operator, which has a lower precedence with only 11. Okay? And so after that, we end up with a result, which in this case here will be false. So let's actually write that here. Or actually, it is true. And so right now we have var is full age equals true. And what I want to show you next is that the equal operator itself, and where is it? Ah, here it is. So the assignment operator, as it's called, is also an operator itself. And I mentioned that to you in one of the last lectures, and now it makes sense. Okay, so you see that this equal operator is the one with the lowest, or almost one of the lowest, precedence. And that makes total sense, because of course we want the assignment to happen as the last step. So after all the other operators have done its work, in this case or minus and or equal or greater than operator, they all have done their work now, and we end up with a true result. And so as a final step, it is then assigned to the isFullAge variable. All right, does that make sense? So actually we not only have two operators, but we have three. The first one that gets executed is this one, then this one, and finally the assignment operator. All right. And whenever we need to know if something works, the order in which our operators work, you can always just consult this table here, which is why I put it here right on my resources page under the JavaScript section. All right, so let's now look at another example where we want to calculate the average age of John and his friend. So let's say age John, because we haven't really calculated it. We only calculated it here. So let's actually grab this here. So now minus the year John, and then the age of Mark. And let's just say it's 35 without any calculations here. And so the average will be to basically calculate the sum and then divide it by 2. So age John plus age Mark divided by 2. But this is not really correct, right? And you know that from your math classes that you had in school probably. And so you know that this dividing operator here will have precedence over the plus, okay? And so let's confirm that in JavaScript it also works like that. And you can see that right here. So the division here has a higher precedence of 14 than the addition of 13. And actually when we talked about this example here, I mistakenly used this operator here, which is the unary plus, but I meant this one here, so this addition operator. But of course it still has a higher precedence than the greater. Okay, so it doesn't really matter using this here or the unary plus operator. Okay, it's a different operator, but in terms of precedence, the addition is still higher than this logical operator. Okay, anyway, what we need to do here is to group this here together with parentheses, just like, again, you learned in your math class probably. And so that makes sense because we see up here that with the highest precedence, we have the grouping. Okay, and so that's using parentheses. And so if we do this, well, then this operation here has the highest precedence. So first we add up the age of John and Mark, and only then we can divide it by 2 in order to create the average age. So let's just take a look at it in the console, just to make sure that everything's working correctly. And so indeed, it is 32. And that's because, and let's quickly do it here in the console, 35 plus 29 is 64, and 64 divided by 2 is of course 32. So this calculation here is correct. Let's just add some comments here. So this is with multiple operators. Then here we have grouping. And now let's do some more examples with grouping and multiple assignments. So let's say that we have a value that we want to assign to multiple variables at the same time. And that's totally possible in JavaScript. And so let's create 2 variables, x and y. And so right now I'm not really creating variables with a meaningful name here, but that's no problem. This is just for doing some mathematical operations, okay? And so let's just start by saying x equals, and just some math operations here, let's say 3 plus 5, and then times 4 minus 6. Okay, so just something like this. And so we already know which will have precedence here, right? So the grouping has precedence, and this will then turn out to be 8. And so let's actually write it down here. So after the first step, we have 8 times 4 minus 6. Then the next step will be this multiplication here, right? So 8 times 4 is 32 minus 6. And finally, this will then turn out to be 26, okay? So x will be 26, and let's log that to the console, just to make sure. And indeed, here it is. So 26 is the result of this calculation. And so, as before, it did all of these operations, and only then it did the assignment. Now, if we wanted to assign this to x and y at the same time, we could very simply do x equals y, and then equals this entire calculations here. Now, the question here is why this actually works. Imagine that we're reading this line here, and we see x is equal to y. And so at this point, y is still undefined, right? Because we didn't define any value for it before this line. And so it would be kind of logical that x would be undefined at this point, but it is not. Let's take a look at that actually. And this is something that we didn't do before, which is to log 2 things at the same time. So we can say console log and then x and then a comma and then another variable. And so we see 26 and 26. So 2 results at the same time with the console.log. And so what we see here is that 26 is not undefined, which would be logical. So again, because y is undefined at this point, and if we say x equal to something that is undefined, well then x should also be undefined, but it's not. And so let's take a look at why that happens, and I can show it to you here in the table again. So we have the precedence here that we already talked before, but we also have the associativity. And what this simply means is the direction in which the operation is executed. So if we come down here to, for example, the multiplication or the addition, we have left to right. Okay, and so all that means is that, for example, if we had, let's add it as a comment, if we had 2 plus 4 plus 5, then it would do it from the left side to the right side. So first the 2 plus 4, which is 6, and then 6 plus 5 to 11. But there are some operators that work the other way around, so which are right from left. And the assignment operator is one of them. So here we have assignment, and assignment works from right to left. Okay, so that's the other way around. And so that is why this piece of code here actually works, because we end up with the result here of 26, and then the assignment works from right to left. So it doesn't start by doing x equal y, but instead it starts by saying y equal 26, and only then it does x equals 26. Okay, does that make sense? So again, the assignment operator works not from the left to the right, but from the right to the left. And so here we end up with a result of 26, and then that is assigned to y, and then that again in turn is assigned to x. And so therefore we end up with 26 in both these variables. Okay, so that is the associativity. That's the second part of the table that I wanted to show you. So we don't just have to keep precedence in mind, but also the associativity. All right. And now just to finish this lecture, I just want to show you some more operators. So let's say that we wanted to double x. So something like x equals x times 2, right? So that would be the double of x. But you see that we're actually repeating the x here. Okay, and so in JavaScript, there's a way of making this a bit more simple, which is simply saying x multiply equal 2. Okay, and so this is the exact same thing. So what this means is that basically it will do x times 2 without us having to write out that x times here like we did here. Okay, so let's take a look at the result. And so 52 is indeed 26 times 2, which was x before. And the same thing would work for plus, minus, or multiply. So we can say x plus equal 10. And so what do you think this will turn out to be? And I hope that you guessed 62, right? So that is 52, which is the result from before, plus 10. So it's the exact same thing as writing x equals x plus 10. All right? So that makes our lives a bit easier. And these operators, you have them down here in the assignment section, because they are actually assignment operators, just like the normal assignment operator. Okay, and now just the last one that I want to show you is the increment. So what we can do instead of writing x equals x plus 1 would be to write it like this. So we could do x plus equals 1, but there's an even simpler way if we only want to add 1. And that is to simply write x plus plus. And so this operator simply adds 1 unit to the variable that we're using this operator on, okay? So this is all the same thing here, but of course this one is the easiest to write and the most handy one. So just to prove you that it actually works, let's log this one to the console as well. And so it's of course 63. And the same way it works with minus minus. And so right now it should be 61. And yeah, indeed it is. So that was a lot to take in up until this point. You learned all about variables, data types, and also operators. So I hope that it's all making sense to you, that you're having some fun. And so next up, there's coming a coding challenge where you can put all of these new skills to practice in a fun and small challenge that I have for you in the next video. Welcome to your first coding challenge in this course. And so this is the challenge that I want you to take. So Mark and John are trying to compare their body mass indexes, which is calculated by dividing the mass by the squared height. Okay, so this formula here. And to calculate the square of a number, you simply have to multiply it by itself. And so the final formula becomes mass divided by height times height. Okay, and here note that the height must be in meters and the mass in kilograms. All right, now the first step that you have to complete is to store Mark's and John's mass and heights in different variables. Okay, so just like we've been doing all this time up until this point. Then next up, calculate both their BMIs, then create a boolean variable containing information about whether Mark has a higher BMI than John, and so that again we did before. And then finally, you can print a string to the console saying something like, is Mark's BMI higher than John's? And then the boolean that you created or that you calculated in step 3. Okay, so true or false. And so this is, again, very similar to something that we did before. And so this should be not a big problem to you, hopefully. Now, if you find some problem here, if you cannot really solve it, then it's absolutely no problem here, okay? So don't beat yourself up if you're not able to 100% complete this. So everyone has different learning speeds and learning styles, and so it's really okay if you're not able to do it 100% on your own here, okay? So if you need to look up something that we did before, that's not a big deal, but you should really try to remember the stuff that we did before and use that to solve this challenge, okay? Anyway, the solution to this is in the next video where I'm going to show you how I would calculate this. So good luck with this, and see you in the video after you complete this coding challenge. So here goes my solution to the coding challenge. We start by defining the variables. So var mass mark equals, let's say, 78, and you could use any numbers that you wanted here, so I didn't define what the masses and heights were. Just remember that they have to be in kilogram. Let's give us some more space here. So we have mass mark, then we have height mark. Let's say 169 meters. So not really tall. Okay, and we could declare all of these variables here in one line, but I'm not going to do that right now. I'm just going to declare them one after the other. So Mark and now John, 92 kilograms, and then the height. And so that's step number 1, I think. Now, next step, calculate both their BMIs. And so BMI Mark is Mark's mass divided by the square of his height. So height Mark times height Mark again. And then body mass index John. So mass John divided by height John times height John. So that was step number 2. And now we want to create a boolean to determine if Mark has a higher BMI than John. So var Mark higher BMI. And so all we have to do is BMI Mark greater than BMI John. So that should be our boolean variable, and now we can log it to the console. So is marks, and now we cannot just write a quotation mark to write marks, okay, because then that would be outside of the string. So this marks the beginning of the string and this the end of the string, but we still want to have the symbol here to say marks. And so what we have to do is to escape this quotation mark, and we do that by adding this backslash. Okay, so that is called escaping, and that's something really common in programming as well. So is Mark's BMI higher than John's? And now again we need to escape and then close that string. So we have our string, is Mark's BMI higher than John's? Actually we want to ask a question, and then we say plus, and now you know that is an operator. And so we basically add strings together and then mark higher BMI, which should whether be true or false. So let's load it. And so is Mark's BMI higher than John's? And it says true. And let's actually also log these two BMIs to the console, just so that we're sure if everything's working correct. So console.log. And remember that we can actually log two values to the console at the same time, simply by adding the comma here. Okay, so Mark and John. And so we see that the first one is 27, so Mark is 27 and John is 24. And so Mark's BMI higher than John's, and of course, yeah, it's true, because of course this here will return true. So it will give us the result of true, which will be assigned to Mark higher BMI. Okay, so that's the solution to the challenge. Of course, you could have done it differently as long as the solution is the same. So in programming, many times, there's not just one correct solution. There are many ways to solve the same problem, okay? And that's something very important that you should know and that you should keep in mind always when you're programming. So there's not one correct way to solve a problem. There are always many ways. And so if you solve this in a different way, which is still correct, then it's absolutely valid. And it's great that you found a different way of solving this from my way. And so, yeah, let's now move on to the next video. Welcome back to the next lecture. And this is a very important one, because in this one, we're going to start taking decisions using code. So JavaScript, as well as most other programming languages out there, has a couple of control structures, which are features that allow us to execute only certain parts of our code or to execute parts multiple times. And the first control structure that we will talk about is the if-else statement, which is a conditional which basically allows us to take decisions using code. Okay, so let me show you how that works. And first, let's bring back some of our variables. So let's say first name is again John. And now let's create a variable that we didn't use before, which is for the civil status. So civil status. And so this one basically says if you're married or single or divorced or something like that. And so let's just say that John is a single. Okay, so he's not married. Now what we want to do here is to log a string to the console whether he is married or not. Okay, and for that we can use an if-else statement to take decisions. So we write if, and then we open parentheses, and then in here we have to write a logical condition. So something that returns a boolean true or false value. So that's something like we did before. So for example, this one here. So this will return a true or false value. And so it's a perfect logic condition. Okay, now in this case, we don't want a greater or a smaller comparison like the one that I showed you, but instead we want an equality operator. So basically what we want to do is to test if the civil status is married. So let me show you how to do that. So we can say civil status equals married. Okay, and so this condition here will return true if the civil status is married and false if it's not. Okay, so this here again is like a logical operator which returns true or false. There's also the version with just 2 equals, but let's talk about that one a bit later. Okay, so again, this here will test whether the civil status is married or not. And then we open curly braces, and then this here is the block, so the if block. And in here we can now write our instructions basically. So in this case, our console.log. And what we want to log to the console is first name is married. So if the civil status is married, then this text here will be logged to the console. And if not, well, then nothing happens. So let's reload it. And indeed, nothing happens. And that's because right now, this here turns out to be false, right? Because the civil status is actually single and not married. And so this is different. And so when we have false, well, then this piece of code is not executed. Let's change it here to married for a second, just to see if it's working just fine. And it is. So now it says John is married because the civil status is the exact same thing as married here. All right. Anyway, let's change it back to single because now I want to show you the else part of the if-else statement. So we can have only the if part, but we can also add an else statement. So we can say else, and then we have the else block here. And so what this does is that if this is not true here, so if it's false, well, then it will execute the else block, okay? So let's test that out. We'll hopefully marry soon, okay? And so that of course means that he is not married at this point. So let's test it, and let's keep in mind that here it says single. And so this part here will not be executed because this here is false. And that means that we're gonna jump right to the else block. And so this text here should be logged to the console. Check it out. And yeah, it works. So John will hopefully marry soon. Now let's say that we actually have a boolean variable already. So we can have a variable called isMarried. And let's set it to false. And let's then test what happens in that case. So instead of this test here, we could put isMarried, and then we could put equals true. But that part is actually not really necessary, right? Because what we need here in this condition is a true or false value. But this isMarried variable is already a boolean. So right now it is set to false, but we could also set it to true. So let's do that. And so again, what we want here is a true false value. But isMarried is already true, so it is already a boolean. And so this part is not even necessary. Okay, does that make sense? So here we just need a true false value again. So no need to write the true. Let's test that. And now it says John is married here, coming from line 173. So this one here. Of course, this one here is still coming from this if-else statement from before, where we say that the civil status is single and not married. But this is just another example where I wanted to show you that it's actually enough to pass a true or false value here into this condition. Okay, so I hope that makes sense, that you now learned how we can make decisions using code. And of course, we could do much more difficult and much more complex stuff into these blocks, the if block or the else block. All right, now just to finish this lecture, let's bring back the code from our coding challenge that we coded up before, and let's basically write something better to the console. Okay, so what we did here is to simply log this string here and then together with this true false value. So that's not really the best solution, right? To just print true false to the console. So now that you know the if else statement, we can do a lot better than this, right? So what we can do instead of all of this, let's comment it out actually, is to write if BMI Mark is greater than BMI John. Well, in this case, we want to print something to the console, and if not, then we want to log something else. Okay? So in this case, we have, of course, marks, and now the escape string. Then John's, and of course the escaping. All right, let's copy it. And so here it's the other way around. Higher than marks. Okay, so let's quickly recap what we did here. So we're testing if the BMI of Mark is greater than John's. Okay, and so this here, of course, as you already know, will return a true or false value, and that is exactly what we need in an if-else statement. And so in this case, it will then log to the console Mark's BMI is higher than John's. And if it's not, so if this here is false, well then of course John's BMI must be higher than Mark's. And so then that's exactly what we log to the console. All right, and now just to test it out, we say Mark's BMI is higher than John's. Just missing the S, but that doesn't really matter. And just to test the other scenario, let's quickly increase this mass here. And so now John's should be larger. And indeed, so now John's BMI is higher than Mark's. Okay, putting it back. And so now again, Mark's should be higher. And indeed, it is working. And so now you know how to take decisions with code. That's awesome. But this is really just the fundamentals of conditionals and decision taking with code. And so there's a lot more to learn. And so yeah, stay tuned for the next videos. Let's now take conditional to the next level and learn about Boolean logic. And in this small example, we want to log to the console, depending on John's age, if he is a boy, a teenager, a young man, or a man. Okay, and so let's start again by defining the first name as John and then the age. And let's start here with 16, for example. All right, so we use our if-else statement. And we can say that if John is younger than 13, well then he is a boy. All right, so console.log first name plus is a boy. All right, and then we can say else, and let's just copy this line of code here, is a man. Okay, so that covers the boy and the man, but how do we actually decide if he is a teenager or a young man? We need some more options here, right? And we can actually do that with JavaScript. So instead of just having the if and the else block, we can also have an else if block. Okay, so let me show that to you. So here we can have else and then a new if. So let's put it back here. And so here we can put some more text. And actually we need to add a new condition here. And so what do we want to have here? So let's first put in the result here actually, so that we know what we're actually talking about here. So let's say that he is a teenager. And so teenager basically means that he's between 13 and 20, right? So let's write that down here as a comment. Between 13 and 20. Well, how do we write a logical condition to express exactly this? So how do we say that the age should be between 13 and 20? Well, that's kind of difficult, right? So let's think about it a little bit more. So between 13 and 20, what this really means is that the age is greater or equal 13, right? And at the same time, it's also less than 20, right? So again, having an age between 13 and 20 should mean that the age is equal or greater than 13 and less than 20. So these two conditions here at the same time, okay? And so what we need is an operator for this. And so there actually in JavaScript is an AND operator. And in order to learn how that AND operator works, we need to talk about Boolean logic. So in a very broad sense, Boolean logic is a branch of computer science that deals with true and false values. And it's actually something quite important in coding, and so you should make sure to really understand this part. All right? Now, there are several logical operators that deal with true and false values, but the most important ones are the not, and or operators. So let's start by looking at the AND operator. And here we have a table called a truth table, which allows us to see the outcome of the operator. So the AND operator works like this. Suppose that we have two variables a and b. Only if variable a and variable b are both true, the expression a and b will become true, okay? And in all other cases, the result will be false. And that's why it's called the AND operator, because a and b must both be true in order for the result to be true as well. So if either a or b is false, well, then a and b will become false as well. And the same applies if there are more than two variables. Only if all the variables are true, then the AND expression will become true as well. All right, and now the second truth table is for the OR operator. And here things work a bit differently. So with the OR operator, it's enough for one of the variables to be true in order to make a or b come true. And again, that makes sense, right? So it's called the OR operator because only a or b needs to be true in order for the final expression to be true. The result will only be false if both variables are false. And we can see that here in the truth table, right? And once more, it works the same way with multiple variables. So it's enough for one variable to be true to make the final result be true as well if there are like 3, 4, 5, or even 10 Boolean variables. So that's how the AND and true operator works. And then finally, there's also the NOT operator. And this one is really simple. All it does is to invert the true or false value of a variable. So if variable a is true, then not a is false. And if a is false, well, then not a is true. So easy, right? Let's now look at a couple of examples. So we start by defining a variable called age. Then we have age greater or equal than 20, which is of course false because 16 is less than 20. Then we have age less than 30, which of course is true. And finally, we have the NOT operator. So we know that age less than 30 is true. And we know that the NOT operator inverts the value. So not age less than 30 is of course false. Makes sense, right? Okay, so the next expression, we already know that the first part, age greater or equal than 20, is false. And we also know that age less than 30 is true. So here we have false and true. So can you guess the result? That's right, it's false, because they're not both true. Okay? Now the next expression is similar, but we have the OR operator here. So it's now true or false. So what will the result be this time? All right, now it's true, because with the OR operator, it's enough for one of them to be true. So I hope that made sense, and so we can now go back and use what we just learned in code. Okay, and now that we know about the AND and OR operators, we actually have a way of writing out the expression that we need here. So what we want here is the age to be greater or equal to 13, and so the AND operator, as you saw before, we write like this. And so we want age greater or equal to 13, and at the same time, the age to be less than 20. Okay, and so that's all we need. That is our expression here, or basically our testing condition. So let's say that the age is 16, so as it is right now. So if we now load this, well, then we log to the console, John is a teenager. And so it's actually working. So right now age is 16, and so age is in fact greater than 13. So this part here is true. Then the age is also less than 20. So this is also true. And so true and true makes true, as we just learned. And so then this block here is executed. Now just quickly talking about the precedence of this operator here, well, it has to be lower than the precedence of these ones here, right? Because of course we first want this to be executed in order to end up with a true or false value, and then this one here. And only after that we want to combine these true false values using this operator here. And so of course the AND and OR operator, they must have a lower precedence than these comparison operators, right? So let's check if that's actually true. And indeed it is. So the logical AND and OR, they have a lower precedence of 6 and 5 than these comparison, like less than equal, greater, and all these comparison operators here. So they have a higher precedence, and that's why it works the way it works here. Okay? And now just the final step, because we want a boy, teenager, and we also want like a young man between 20 and 30. Okay? So let's create a new else if here. Here the condition, and open a new block. So a young man. And what do we want the age to be now? Well, we want it to be greater or equal than 20, and at the same time it should be less than 30. Okay, and if we didn't put this equal sign here, well, then the 20 wouldn't be covered anywhere, right? So let's take this out here and go to 20, so set the age to 20, and let's see what happens then. So now it says John is a man. Okay, and that's because this 20 here is not included neither in this condition nor in this one. So here it's just less than 20, and here it's greater than 20, but nowhere is the equal sign. And so that's why we have to include it right here. Okay, we could also have included it here, but well, someone who is 20 years old is not really a teenager anymore, and so we include this equal sign up here. And if we reload it now, well, then it's gonna say young man. Okay, and so that worked just fine. All right, and I think that is enough for this lecture. So you learned all about Boolean logic and the AND, OR, and NOT operators, and also that we can add these else-if blocks here to our if-else statements. Okay, so we can have multiple, let's say, if-else statements all in one construct like this. Okay, so make sure that you understand all of this. If necessary, you can maybe review parts of the lecture, and then let's just move on to the next video. In this video, we will look at some more ways of taking decisions with JavaScript. So you've learned about the if-else statement in order to take decisions, but there are more ways of doing this. And so the first thing that we're going to look at is the ternary operator, which is also called the conditional operator. And it is an operator that basically allows us to write like an if-else statement all in one line. Let's take a look at how that works. And again, I'm bringing back my first name variable here. And then we're also going to set the age to 16. And so now let's use the ternary operator in order to log to the console if John drinks a beer or if he drinks juice, depending on his age. Okay, so let's say age greater or equal to 18, which is the legal age at which you could start drinking, at least in Europe, maybe not in the US. Okay, so we start here with the condition. Then we use the question mark. And then we write basically what we want to happen if this condition is true. So this is like the if block in an if-else statement. So in this case, we want to log to the console, console.log. Drinks beer. Okay, so that is the first part. And now we also have to write the else block. Okay, and so for that, we use the colon. And then let's actually go ahead and copy this part here. Drinks juice. Okay, and that's actually it. So this is the ternary operator. And it's called ternary because it has 3 operands. So basically 3 parts that interact with the operator. So we have the condition first, Then we have the if block here, basically, and then the else block. So let's now test if that works. And indeed, it now says John drinks juice, and that's because he is younger than 18. If you set it to 22, let's say, then it will say John drinks beer. Okay, let's take a look at another example, because we can do even better and assign values to variable using the ternary operator in a very simple way. So let's say that we want to define a variable saying what John can drink. So let's say var drink, and now we can use the conditional operator right here. So age greater or equal than 18. Then the question mark, so basically this is to ask a question. So is John greater or equal than 18? And if he is, well, then we can say beer. And if he's not, then we can say juice. And that's it. So basically the result of this entire code here will be beer if the age is greater or equal than 18, and it will be juice if not. And this result will then be assigned to the drink variable. Okay? So again, this is an operator here again, and so an operator always has a result, just like we saw before with any of the other operators. Okay? And so this operator, this ternary operator, is executed, of course, before the assignment operator. Remember, this one is also an operator. And so first we execute this part, which as a result will have either beer or juice, and then that result will be assigned to the drink variable. And so let's log it to the console now, just to make sure that everything is working again. And indeed, it says beer. 14, of course, he will drink juice. Now just to compare what we would have to do without the ternary operator, let's write out the same thing with an if-else statement. So we would have to write, so var drink equals beer in this case, and then the else block, and then here the juice. Okay, so that would be the alternative here of using this. And so what do you think looks better? Well, it's obviously the ternary operator, right? At least I prefer it very much about having to write something like this in case that we want something as simple as just assigning a value to a variable based on a simple condition like this. Okay, so of course you're not going to do a ternary operator for a rather complex decision, but in case that we have something simple like this, well, it is perfect to not have to use an if-else statement like this. So let me comment out this part here just so you know that this is the same. And alright, so we talked about the ternary operator as an alternative way of writing conditionals, but there is actually even more, and that is the switch statement. And this is like a huge if-else statement where we have multiple else-if clauses basically, and so we can replace that with an easier to understand syntax, okay? Now I'm not a big fan of this myself, but you will see it around when you search for like tutorials on the web, and so it's important that you also know the switch statement. So let's add some comments here before we start. So the ternary operator, and then the switch statement. All right, so let's define a job here first. And let's say that John is a teacher. And so now we can use this switch statement. Give us some more space here. All right, so we say switch, and then here between these parentheses, we put what we want to test, what we want to evaluate. Okay, and this will make a lot more sense after you see the entire switch statement. So for now, just let's write the job here, and you will then understand why it works like this. So we switch the job basically, and then we can add a couple of case clauses. So we say case, and then we can say, for example, teacher, then the colon, and then in the next line, we say what we want to happen. So in this case, let's say first name teaches kids how to code. So that's what a teacher does, let's say. So again, if the job is equal to teacher, then this code here will be executed. All right, let's add a couple of more. So case driver, let's say. And now I'm just going to grab this piece of code here. Let's say a driver drives an Uber in Lisbon. And so this is the basic functionality of the switch statement. Okay, So we can add a couple of more cases even. So let's say we also want designer. And then again, our console.log, let's say designs beautiful websites. All right, so what we're doing here is again to compare the job to each of these different cases. So if the job is teacher, then do this. If the job is driver, then do this. If the job is designer, well, then do this. Now, what we have to do here also is to add a break statement. So in here, we have to say break because otherwise it will keep evaluating these next cases. Okay, so even if the job is teacher, it will then keep evaluating these other cases. It will keep basically looking at them and see if they are also true. But we don't want that to happen. And so we have to use the break keyword at the end of this block that we want to execute. So break, and here break also. Now, if none of these here applies, we can then add a default. Okay, and so all we have to do is to say default and then define what happens in that case. So in this case, well, let's just say that John does something else. And then here, of course, we don't need to break because it's already the last case here anyway. Okay, so if none of these applies, so these are basically like the else if in the if else statement. So in an if else statement, this would be if job equals teacher, then do this, else if driver, then do this here, else if designer, then do this, and then else do this, right? And so this default here is basically our last else in an if else statement. All right, so let's try it out. And so indeed, it now says that John teaches kids how to code because he is a teacher. Now, if we say that he's a driver, then of course, drives an Uber in Lisbon. Now let's say that he is a cop. And so now none of these applies. And so we should end up with John does something else. Great. Now we can also have multiple case clauses for the same piece of code that we want to execute. So for example, if we want to execute this code here, if the job is a teacher, or also let's say instructor, then we can add simply another case here. So case instructor, and then this piece of code here will also be executed if we say instructor. Just to finish, let's try out that. And yeah, so it still works here as it should. So this is here again a simple way of replacing a huge if-else statement. For example, something like this, where we have this if and then else if, and then else, or it could be even longer. And so sometimes a switch statement looks a bit cleaner than having all of these blocks like this. Okay, and actually, since we're working on it, let's actually go ahead, copy this piece of code and try to replace this if-else statement here with a switch, because that's actually going to work in a slightly different way. And so it's a great opportunity to show you how that could work. So this first switch that I showed you here basically simply switches a variable and compares all of these cases to that variable. But here we have these number ranges, and so it works slightly different. And so it's a great exercise to do this one here as well. So to translate it basically to a switch statement. So in this case, what we want to switch is true. Okay, so we basically want to compare each of the expressions below that we're going to put here in a second to true. And this is a trick to simply make the switch work as an if-else statement with ranges. So our first case will be case age less than 13. And in that case, it will then log this piece to the console, and then don't forget the break. Okay, then the next case is this one, and let's actually go ahead and copy it because we already know how it works at this point. And then log this here to the console so that John is a teenager, and then let's break out of it. So let's complete the code here and then take a closer look at it and see how it works. Okay, so for this case, we want to log this part here to the console, then break out of it. And now finally, we have the else part here. And so for the else part, we are going to use, such as before, the default. So default, and then log that John is a man. All right, and so that's actually it. So we can get rid of this. And so we already translated it here to the switch statement. So we now have all of these conditions here, basically not as strings as we had before. So in this case here, and this is the more usual case of using the switch statement, okay? So where we have like a string that we want to compare with some variable. In this case here, we have basically these logical expressions here that will turn out to be either true or false. And so for example, if this here turns out to be true, so if the age is between 13 and 20, well, then this here is true and all of the others are false. And remember that we switched true. And so the case that will be true will then be the one that is executed. Okay, so let's try that out. And the age I think is not, actually it is defined as 14. Let's put it again here, so we don't have to go up and down to test this. So let's say that he is 10 now. And so let's check it out. So John is a boy. Great. Change it to 17. Now he's a teenager. Now 22 again. A young man. And a man. So all of these now work. So these are two ways of using switch statements, and they can be useful again in case that we have a long if-else statement with lots of else-ifs. So this can look a bit cleaner here. All right, and so that's 3 ways in which we can write conditional code. So the if-else statement, the ternary operator, and the switch statement. Before we can move on to our next big topic, we need to quickly learn about something called truthy and falsy values. So in JavaScript, a falsy value is a value that is considered false when evaluated in an if-else statement condition. And the values that are falsy in JavaScript are undefined, null, 0, empty strings, and not a number values. So let me actually write that down for you, okay? So falsy values, they are undefined, null, 0, empty strings, and not a number. So we didn't talk about this here yet, but you will see examples of this here later in the course, okay? So all of these 5 different values here will be converted to false when evaluated in a true-false condition, okay? And so that's why we call them falsy. They are not exactly false, but they will turn out to be false when evaluated in a if-else condition. Now we also have truthy values. And of course the truthy values are all the values that are considered true when evaluated in an if-else statement condition. And so basically it's all the values that are not falsy. Okay, so let's now take a look at an example to demonstrate how this works. Okay, so let's define a variable of height, let's say, and we will not actually define it, so we just declare it here. And now let's write an if-else statement. So we can say if height, and then log to the console the variable is defined, and else the variable has not been defined. So let's see what happens here. And what we get printed is that the variable has not been defined. And so why is that happening? Well, we declared the variable here as height, but we didn't define it. And so you already know that it's now undefined. And we also know that undefined is a falsy value, right? And so in here, when we say if height, then this height here is converted to false. And so therefore we enter the else block, which will then print that the variable hasn't been defined yet. And so this is a very handy way of testing if a variable has actually been defined or not. Okay, and now let's say that we actually do define a value. So let's say 23. And so watch what happens now. And so of course the variable is now defined. Okay, and so that's because everything that is not a falsy value is a truthy value. And so we already know that when a variable exists, well, then this here will be converted to true, and therefore the if block here is entered. Okay, so again, a very handy way of testing if a variable actually exists. Now there's just one thing to keep in mind here, and that is that notice how this 0 also is a falsy value, but the height can of course be 0. So let's set it to 0 here, and so the variable is actually defined now, isn't it? So we have a value here, it's not undefined. But if we now reload this, well, then it still says that the variable has not been defined. And so that's of course a situation that we want to avoid. So this here can not only be height, but we also have to say that if the variable is 0, well then the variable is also defined. Okay, and remember that we can use the OR operator to do exactly that. So we already used the AND operator before, but we also talked about the OR operator. And so we can say OR the height is equal to 0. Okay, and so that will fix the problem. And this is quite a common pattern in JavaScript to check if a variable is defined. So we check if the variable exists or if it is equal to 0. And then the if block here is in fact entered. Okay, so let's check that out again. And so now we see that the variable is defined. Okay, and remember that only one of these here has to be true in order for the entire condition to be true. Okay, so in this case now the height is 0, and so this here will be converted to false. Okay, but we then have height equal to 0, which is true, of course, because in this situation the height is 0. And so we have false and true, which will result in true. And so therefore this line of code here is then executed. All right, and now this is going to work with any number here and also with strings. So let's say 20, for example. And you see that it's still true because it still entered that first block. But if we have an empty string, remember that also is a falsy value as we see here. So with an empty string, it now says the variable has not been defined again. And so that kind of makes sense, right? Because in fact, there's not really something there. It's just like an empty string. Okay, so these are falsy and truthy values and the handy way to check if a variable is actually defined. Now, just to finish, let's talk about the two different equality operators. So we've always used this triple equal operator, right? And this is the one for strict equality comparisons. But there's also the equal equal. So this operator here, and the difference is that this one does type coercion, which means that the data types of both variables do not have to match. Okay, so let me show that to you actually in practice. So just a comment here, and now let's say if height equals 23, so we have a string now here, then let's simply log to the console the equal equal operator does type coercion. Okay, and so let's check out what happens. And before we do that, let's set this here back to 23. Okay, so what we're doing here is to compare the height, which is 23, a number, with the string of 23 with the non-strict equality operator, which is this one. So only two equals. So let's take a look at this. And so you see that this actually turns out to be true. And so we enter this first if block. And so you see the equal equal operator does type coercion. So what this means is that JavaScript, when we use this operator here, converts the string of 23 to a number and then says that it's the same as 23, the number. So let's take a look at that here again. So 23 and then the string 23, and it will say that it is true. Okay, so exactly what we observed in here. So again, JavaScript does type coercion, which basically means to convert the string here to a number and then compares the numbers, and then of course they are the same, right? Now, if instead we use the strict equality operator with the 3 equal signs, well, then it will not do type coercion. And so therefore, what do you think will happen now? Yes, indeed, it now says that it's false, because in fact, they are two different things. So we have 23 the number and 23 the string, and they are different things. And so in fact, we want them not to be the same. Okay? And so if instead we had the 3 equals here, well, then of course, we will not see this output here. We will not see this log to the console because it's false. Okay? So that is how the strict equality operator works. And it is absolutely a best practice to always use the triple equal, so the strict equality operator, in order to avoid unexpected situations and bugs. So that's why I've been using this operator all the time with the 3 equals and not just the 2 equals. So after learning all about conditionals and true-false values in JavaScript, it's now time for another coding challenge. So let's say John and Mike both play basketball, but in different teams. And in the latest 3 games, John's team has scored 89, 120, and 103 points. And Mike's team has scored 116, 94, and 123 points. Okay? And what I want you to do is to calculate the average score for each team, Then decide which teams wins in average, so the one that has the highest average score, and then print the winner to the console. And when you print that winner to the console, then also include the average score, okay? So we already calculated averages before, so all you have to do is to add up all the values and then divide by 3 in this case, because we have 3 results here, okay? And then what I also want you to do is to change the scores in order to show different winners, okay? And so here, don't forget to take into account that there might be a draw. So it means that there is the same average score. And so in your if-else statement, you will have to keep that in mind, okay? Now, after you finish that, you can take it to the next level and add a little extra. And in this case, Mary also plays basketball, and her team has scored 97, 134, and 105 points. And like before, I want you to log the average winner to the console. So what you're gonna have to do here is to check if one of the players has a larger score than the other two, okay? And in order to do that, you will probably need the AND operator to take that decision, okay? And if you cannot solve this one, then it's absolutely no problem. You can just watch the solution and see how I do it in there, okay? The most important thing is that you can do these number 1, 2, and 3, okay? Then if you want to take it to the next level here with the number 4, then that's also a great addition to this challenge, okay? So take a couple of minutes here, maybe half an hour, and try to really complete this challenge, and then I'll see you in the next video with the solution. So here goes my solution to coding challenge number 2. So let's start by calculating the average scores. So var score John is equal to, and we have the points, so 89 plus 120 plus 103 divided by 3. Then var score Mike is equal to 116 plus 94 plus 123 divided by 3 again. And now let's simply log these to the console. Score John and score Mike. And here we go. So the average score for John 104 and for Mike 111. So Mike is clearly the winner here. And so let's now log that to the console. Okay, and so what we're going to do here is of course an if-else statement. So give it some space here. And now if score John is greater than score Mike, well, then log to the console that John's, now we need to escape this quote here. So John's team wins with, and now let's also include the score here as I mentioned in the instructions. So score John points. All right, and else if it's the other way around basically, so score Mike is greater than score John, well, then let's of course log that Mike's team wins. Then here we also need to use the score of Mike, okay? And then else, and that's the situation where there is a draw. So if John's score is not greater than Mike's, and Mike's score is also not greater than John, well then it means that they have the same score, okay? And so that is here this else block. And so in here we can simply log that there is a draw. So let's test it out. And so yeah, Mike's team wins with 111 points. Let's now increase this here, let's say to 129. And so now probably John wins. And yeah, here we go. So now John's team wins. Now let's try to have a tie here. So we had 89 before. Let's put it to 95. And we need some more points here. So let's increase this to 115. That was a bit too much. 112 maybe. And now we're almost there, I guess. Yeah, so now they have the same scores, so both have 111, and so now we see that there is a draw. And so, of course, none of these situations here apply, because John's score is not greater than Mike's score, and Mike's score is not greater than John's score. And so, of course, we have a draw. So that is the easier part. Now let's also add Mary to the game. So, var score Mary equals, and let's get her points. So 97, 134, and 105. This should be a comma, obviously, and this should be plus signs, of course. Sorry for that. So we add all of them together and then divide it by 3. Also log it to the console just to make sure. So she has 112. And here let's put back what we had initially. So it was, 89. And so now we have these 3 different scores. All right, so let's get rid of this part, and I'm not going to delete it. I'll just comment it out. And okay, so how can John win the game? Basically, he has to have more points than Mike and also more points than Mary, right? And so that's what we have to translate into code now. So an if-else statement, and we have to say that score John should be greater than score Mike, and score John should be greater than score Mary. Okay, and that's it. So, does that make sense? That is a great use case of the AND operator here. And it works like this because we need this here to be true, and at the same time, we need this to be true. So John's score needs to be greater than both Mary's and Mike's. All right, and so only in that case, we will want to print that John's team wins the game. And then from here, it's actually pretty straightforward. So once we understand how the logic works, all we have to do is to do the same for the other players. So how does Mike win the game? Well, of course, he has to have a larger score than the other two. So score Mike needs to be greater than score John. And at the same time, score Mike, and what happened here? So score Mike greater than score Mary. So John, and here we have Mike, and of course score Mike. And then finally, the same for Mary. So score Mary needs to be larger than score John, and score Mary greater than score Mike. And now we say that Mary's teams win, and here the score Mary. All right. Now, what about the other situations? Well, let's just use an else here and say that there is a draw. Okay, so this doesn't really cover all the different situations here, but that's not a big deal. So for this small example, it's okay. Imagine that Mary and John had both the same score, but a larger score than Mike. So they two would have a tie, but would still have more points than Mike. And so that's one of the situations in which we will enter this else block and display that there is a draw. Okay, so these 3 situations here only work for a clear winner. All right, but again, that's not a big deal. We don't need to cover every single situation here. So these are the more important, of course, where we can define which one is the clear winner. So let's try it out now. And indeed, Mary's team wins with 112 points. Let's add some points here to Mike. And if we add 3 points, then he will have the same score as Mary. So let's put this to 19 here. And they now have both 112. And so we see that there is a draw. So perfect. And if we now increase this even further, let's say 29, well then of course Mike's team has the most point. And now finally let's add some more points here to John just to test if all 3 cases work. And indeed, now he has the most points and he is declared the winner. Great, so that's it. I hope you figured it out. And so now you are really ready to finally move on to the next part of this intro section, which is the hugely important topic of functions. So join me right there in the next video. Welcome back to one of the most fundamental concepts in JavaScript, and that is functions. So if we have a piece of code that we want to run a lot of times, we can put that into a function instead of writing it over and over again, okay? So functions are like containers that hold some lines of code, and we can pass arguments into them, and they can then return us a result. And instead of talking more about this, let me actually show you a very small and very simple example. So this is how we write functions. We simply write function, and then we give the function a name. So just like a variable, we have to give a function also a name. And in this case, what we want to do is to calculate an age. So calculate age. And as I mentioned before, we can pass something called arguments into a function. And so we open up parentheses, and then we say the argument that we want to pass in. And what we want to pass is called birth year. Okay, and so this will kind of be like a variable inside of the function. All right, but more on that a bit later. So we say function, then the name of the function, then the argument that we want to pass into the function, and then finally the curly braces in order to write the function block. So all the code that is in here will be the function block. Now we can of course also pass 0 arguments into this, or we can also pass multiple. So we could pass more like x and y separated by commas like this, but in this case we only want one argument, which is the birth year. All right, so we pass in the birth year, and then we can return something from the function. So in this case, what we want to return is the age of the person. So we calculate it by doing 2018 minus the year in which the person was born. And so we can now basically use this variable inside of the function. Okay, so this birth year parameter that we defined here in this function definition up here. So I like to think of a function as like a machine that receives some input, then it does some stuff with it, and finally returns something else. So something new created from the data that we put in. So that is our function definition. Now let's actually go ahead and use this function. Okay, so to call this. So we can say now calculate age, then we open the parentheses, and now is the time where we pass in that argument. So let's say that we want to pass in 1990, and so like this, we will call the function. And the function will then take this value, this 1990, as the birth year. So this is now 1990, and then we will do this calculations, 2018 minus that birth year, so in this case minus 1990, and will then return a result, okay? And so that result, we have to store it somewhere. So let's create a new variable for that, age John. And so in age John here will be stored the result of calling this calculate age function. All right, so test that out and log age John to console. And here we go. So 28 years old. And that makes total sense because it's 2018 minus 1990. So again, we define this parameter here, or this argument, and you will hear me saying these two words, and they're not exactly the same, okay? But for now, let's just keep it simple and assume that arguments and parameters are the same thing, okay? So we defined this argument here of birth year, and so when we call the function, calculate age down here, and we pass in the value, then this birth year variable here, or argument, will be assigned that value that we pass in. So 1990 in this case. And then inside the function, we can use that. All right. So let's now calculate some more ages. So let me copy this here. And so we want age Mike, let's say 1948, and age, let's say Jane now, so a new person here, 1969. All right, and now we can log all of these to the console. And so let's see. So 28, 70, and 49. And so now you start seeing the power of the function, because instead of having to write that same code here over and over again, we can simply always call the same function. Now in this case, it would probably not be so problematic to write this code. It's just one line, but of course functions can be huge. They can be much bigger than this. And so then it of course becomes a lot more useful. And so functions are very, very important for one of the most important programming principles, which is called don't repeat yourself, or DRY. Okay, so the dry principle is something really important in programming as general. So you should never repeat yourself, never write the same code, and instead put it into a function. And so that's why we have functions in JavaScript and in all programming languages in general. So that was just a very simple example of a very, very simple function. So let's now add some more complexity to it. And let's create a new function which will calculate the years until retirement. So based on our birth year, we will be able to calculate how many years we have left until we retire. So that's a little bit more complex, and so it's a good use case for a function. So years until retirement. And now let's pass in the birth year just as before, and also the first name. So as I mentioned, we can pass multiple things into a function, not just one argument. We can pass 2 arguments, or 0, or 3, 4, and as many as we want really. So how are we going to calculate the years until retirement? Well, first of all, we need to calculate the age. And so now let's actually call the other function that we already coded before. And so what this means is that functions can actually also call other functions. All right. And so let's calculate the age based on the birth year again. Okay. And maybe let's give it here another name so that it's not so confusing. So I'm just calling this year now here. Okay. And if I change it up here, then of course I also have to change it here. All right. And so when we now call this function, this years until retirement, then we pass in an argument as the year, let's say 1990, and that will then be passed into calculate age. So 1990 again, and that in turn will then be passed into the calculate age function here and can be used to return the age. All right. And so that age will then be stored in this variable, and then we can calculate the retirement. So the retirement is the age at which we retire minus our current age. So let's say that we retire at 65 years. So that's kind of a standard, I guess, at this time. And then minus the age. And that gives us how many years we have left until retirement. Okay, now functions don't always have to return something. So up here we return something so that we can then use the value later. But in this case, we don't want to return anything. We can simply log something to the console. So we want to say first name retires in, and then the retirement plus years. Okay, so that's our function. And let's now call it. So years until retirement, let's again use the year of 1990, and then the first name is John. Okay, and this time we are not saving the result anywhere because there is not really a result. So that's what I just mentioned before. There is no return here in this function, and so there's no result, and so we don't have to store any result anywhere. So if we just now call this function like this, then all that's going to happen is that these calculations will be done, and then we will log something to the console. So let's check that out. And so John retires in 37 years. So let's quickly recap what happened here. We passed in 2 arguments, 1990, which is now called year inside of this function, and we also passed in this string called John, which will be called first name inside of that function. And so in our console.log, we use that first name here, which is John, and then also the year is used to calculate the age. And that age calculation is, as I mentioned before, done using the calculate age function that we coded up before up here. Okay, so functions can call other functions, and they also do not have to return anything. It's quite usual that they do, but of course they don't always have to. All right, so let's now do this with some other years, and we can actually use the same as before. And probably it's easier to just write it out. So 1969, and here we have Mike, and then also Jane. And so now you have John retires 37 minus 5 and 16. And so hopefully by now you see even better how handy it is to have all this code here in one function. Because imagine how repetitive it would be to have to write this for each of these persons, right? Instead, we just put all of this code in one function and therefore keep our code dry. So dry, remember, means don't repeat yourself. Okay, now just one thing that I see here is that we have minus 5 years here, and what that means is that this person, Mike in this case, is already retired. Okay, so let's add a simple if-else statement here. So if the retirement is greater than 0, well, in this case, it means that we still have some years left to retire, and then we want to log this to the console. But else, so basically if the retirement is 0 or less, it means that we are already retired. So let's log that to the console. First name is already retired. So check that out. And so Mike is already retired, it says now, instead of what it had before. All right, great. So these are the fundamentals of functions, which again are one of the most fundamental principles in all programming and of course also in JavaScript. All right. So what you have to keep in mind here, just to recap, is that we can pass in arguments into a function like this and like this, like we see here. Then we can return results from a function using the return keyword, and we can then save these results into variables like we did here. Also, functions can call other functions like we did here, and they do not need to return something, so it's not mandatory. All right, so that's the fundamentals of functions. Next up, let's talk about something called function expressions and function declarations. In this video, you will learn about function statements and expressions. So in the last video, where we first talked about functions, I always declared functions using function statements, but there's actually another way of writing functions in JavaScript, and that is by using function expressions. Okay, so all the logic of functions that I explained to you in the last lecture still work the exact same way. We just write the function in a slightly different way. And under the hood of JavaScript, it also works quite differently actually, but for now that's not important for us. I just want you to know at this point that we have both function statements and expressions. So let me show it to you. And so when we write a function expression, we start by writing the function basically without a name. So we still use the function keyword, and then right after that, we put the arguments list. And so in this case, I want to pass in the job and the first name. Okay, and only then we basically assign this function to a variable. So we declare a variable, and this one I'm going to call what do you do. So basically it's a function where we pass in the job, and then the function tells us what that person does. So what do you do? So that is now a variable, and what we assign to that variable is simply this function. So function where we pass in job and first name, and then of course the function block. All right, so comparing that to what we had before, or actually let's write it out here. So that is a function expression. And if we did the same thing as a function declaration, then we would write function, what do you do, and then the arguments list. So something like this. Okay, so you see the difference? Okay, so let me comment this out here. So this is just so you know what the difference between a declaration and an expression is. And again, the way that we call the function and the way that we pass in the parameters and all that stuff that you learned before still works the exact same way with function expressions. All right, so let's now use a switch statement here so that you can practice some different stuff that we learned before. And we will do something similar to the switch that we had before actually. So we're going to switch the job here, and then our different cases will be for, let's say, teacher. And let's add the cases here before. So case teacher, then we have driver, then we have designer, and then finally the default case if none of the before apply. All right. Now, the other time where we did this similar switch, we had a console.log and then a break. But this time we're going to actually return something. So let's say we want to return first name plus the string that we had before. So teaches kids how to code. Okay, and now we will actually not have to include the break. That is because of something that I didn't tell you before. That is, when we hit the return keyword here, then we return whatever we define after it. But what also happens is that the function immediately finishes. So basically we immediately go out of the function and return to the place where we actually called the function. Okay, so the return keyword does not only return the value, but it also immediately finishes the function. Okay, so we do not need the break here. So in case that the job is teacher, then we return this string here and then immediately exit the function. All right, now in case that the job is a driver, well, then we return something else. Okay, and so in that case, this line here is never executed, obviously, and so it's not going to finish the function, and instead it will come to this next case, which is driver. So first name, and let's say drives a cab in Lisbon. Then the same thing for the designer. Designs beautiful websites. And then finally the default case. Does something else. Okay, so let's now give it a try. So just like before, we call our function, what do you do? And then we pass in the job and the first name. So let's pass in teacher. And of course, John. And don't forget that this function here returns something, and so we should save that somewhere. All right, or instead of saving it, we can of course also simply log it to the console. So let's do that instead. Okay, so that's something that we didn't do before. So immediately log to the console the result of calling this function. Okay, but that just works the same. So in this case, what we will return here is the string John teaches kids how to code, right? And so that will then be logged to the console. So exactly like I said, this is the string that we expected, right? And now, of course, we can do this multiple times. So let's say designer, Jane, and then, well, we can say that Mark is retired. Let's see what happens now. So Jane designs beautiful websites, and then Mark does something else, which is the default clause here. So again, you see how useful it is to be able to reuse all of this code. Otherwise, we would have to basically write this here 3 times if we wanted to have this scenario with 3 people and 3 different jobs. And like this, we simply pass to the function the things that change, basically. So what's different here is the job and the name for each of these cases. And so that's what we passed into the function, both the job and the name. And then based on that, the function does something, which is in this case, produce a string and then returns it. So again, we can always see a function like a machine that receives something, then does something with the data and gives back something different. Okay, so this is how we write a function expression. Now, statements and expressions, they do not only apply to functions, but they are a global concept in JavaScript actually. So before moving on, let's talk a bit about the difference between statements and expressions. So JavaScript expressions are pieces of code that always produce a value, and it doesn't matter how long they are, as long as the code results in a single value, and then it is an expression. So let's take a look at that in the console here. And so, for example, if we simply write 2 plus 3, well, then you see that this produces a result, so a 5 in this case. And so what we just wrote here is a JavaScript expression, okay? And the same is when we, for example, call this function. So let's call this function right here in the console, and we actually have access to these functions here right in the console, okay? So that's something that we didn't do up until this point, basically using the variables and functions that we define here in our code right in our console, but we can do that, okay? And so when we now call this function here, then you see that, of course, it returns a value. And so again, this function call here is an expression. And really anything that we do, again, that produces a result is an expression. So for example, type of 23, and it gives us back this result of number. And so again, this is an expression, all right? So what this means is that whenever JavaScript expects a value, we always have to write an expression. Okay, and the importance of this whole concept might be a bit hard to grasp at this point for you, okay? But it's really important to learn this stuff for the future, all right? So for example, here in this if-else statement, for example here, JavaScript, of course, expects a value here. And so this here needs to be an expression. And of course it is, because this operator here will, of course, return true or false. And so that is a result. And so therefore it's an expression. Okay. Now, anyway, about statements, they do just perform actions. So they do things, but they do not produce immediate results. So these are things like if-else statements, a while loop that we're going to talk about later, or even a function declaration. They don't produce any immediate value, and so they are called statements. So let's again take a look at that here in the console. And I'm going to write a very simple if-else statement here. So let's say if true, and so this if block here will of course be entered. So let's write console.log here of just some numbers, some random stuff. So it doesn't really matter here. And so let's hit return. And you see now here that what this returns is undefined. Okay, so it doesn't really return anything. But this 23 here simply comes from this console.log here. But the statement itself, it does not return anything. So it's just really this statement that doesn't produce a result. And so that's the difference between expressions and statement. All right, so coming back to functions here, we learned that function expressions produce an immediate result, while function declarations do not. And this will actually be very important for certain situations that you're going to learn about later in the course. So in these two lectures, we covered the very basics of functions, but of course there's a whole lot more to learn about functions. But again, I will leave that for a bit later in the course, so that we're now ready to move on to another huge and exciting topic, that is arrays. Arrays are a fundamental concept in JavaScript that you're going to use throughout your entire JavaScript life. Okay, so let's now learn exactly how they work. So in many previous lectures, we had different variables for different persons. But now imagine how handy it would be to bundle them all into one single variable. And in JavaScript, we have arrays for that. They're like collections of variables that can even have different data types. Okay? So let's declare a variable, like always, called names, and now we can use an array. And there are different ways of creating a new array, but the easiest and most used one is using brackets. So we use the brackets, and then in here we put our different values. So let's say we want an array of names. So John, then comma, and then we add a new element. So Mark, and then let's say a third element called Jane. All right, so now we have an array of names, an array with 3 elements called John, Mark, and Jane, all separated by these commas. Okay, so let's create a new one called years. And as I mentioned, there are different ways of creating arrays. So let's see another one, which is new array. So you can do an array like this, basically calling this array function here with the new keyword, and then in there you pass the data that you want to be in the array. So 1990, 1969, and 1948. All right, so this will be an array the same, but again, this here is far more used, and so you will usually not use this one, okay? I just wanted to let you know that it also exists. Now, we say that arrays are zero-based, which means that the first element is element number 0, the second one is element number 1, number 2, and so forth and so on. Okay, so let's now see how we can actually access elements in an array. So we're going to log to the console, names, and then we use the brackets again, and then the index, so the number. Okay, and so names brackets 0 will be the element 0 of the names array. And remember that arrays are zero-based, and so John is the element 0. So let's take a look at that, and indeed, we see John. Of course, we could also log the entire array. So this is how it's going to look like. So we have here, we say number 3, which is the amount of elements in the array, and then the entire array. And actually, we can also access this number here. And all we have to do in order to do that is to say names dot length. Okay, so we will learn later what this dot here means, but for now, just know that we can do names dot length, and then that will show us how many elements are in there. In this case, it just returned undefined, but that is just because I misspelled length. Okay, so that's what it should look like, and now we should get the number 3. So we have 3 elements in our array. Okay, so we access number 0, we can also access number 2, for example, and that should be then Jane. Okay, so this is how we retrieve basically data from the array. But we can also use the syntax to mutate the data in the array. Okay, so we can say names and 1, which will be Mark, and then we can say that we want it to be Ben instead of Mark. Okay, and so if we now log the array, then we should see that it's different. And so now it is actually on position number 1, it is Ben and no longer Mark. Okay, we can also add data to the array. So we can actually access a position that's not even there. So let's say we want position 5 to be Mary. So let's see what happens then. And actually let's put it here before this console.log. And so you see that now we have empty here, and then only then comes Mary. Now if we wanted to add the Mary as the last element in the array, we could use this property that we used before. So names.length. So remember that this is 3 at this point. If we say names.length, and this will then be 3, and so names 3 should be Mary. And so then it adds this as the last element in the array basically. Okay, makes sense? So first, let me actually edit here. So muted array data. Here we can say initialize new array. Okay, so first here we mutated the array on position number 1 and added Ben. Then here we mutate the array at position number names.length, and that is 3 at this point. Okay, and so at names position number 3 we will add Mary, and so position number 3 will be the last one. So 0, 1, 2, and then 3 is the new one. Okay, so I hope that you start to see how useful arrays can be by holding this different data all in one variable. And of course this can also be different data types. So let's say that we want to have all the information about John all in one variable. Okay, let's give us some more space here, and then let's say var John. And now we can put the first name, we can put the last name, we can put the date of birth, we can put the job, and we can put that he is single or that he's not married. So let's say false. Okay, so now we have different data type all in one data structure, which is this array. All right, so these are the very basics of arrays, but let's make it a bit better even, because there are a couple of functions that we can basically apply to arrays. And these functions are called methods that are specific to arrays. And you will learn all about methods and why they are called methods in this case in the next couple of lectures. All right, for now just know that we can do something like this. So we have our John variable, and then we can say dot push, and then this is like a regular function. And the push function, or the push method, what it will do is that it will add an element at the end of the array. So let's say that John's favorite color is blue. And so if we pass in blue now here, it will then add that element to the end of the array. All right, so console.log John, and so let's see how that worked. And so indeed, we have now the array that we declared initially plus the blue element at the end of the array. So that's what the push method, the push function here, did to the John array. All right, so don't worry about this dot syntax here and this function, this way we call this push function. We will learn about why it works this way in a couple of lectures. So there are a couple of methods that I want to show you now, because push is not the only one. There are tons of different methods for arrays, and I will just show you a couple of them now. So we can also use John unshift. And what unshift will do is very similar to push, but instead of adding to the end of the array, it will add it to the beginning. So let's say that we want to add a title, so Mr., so that it's Mr. John Smith. And so now we have the first element, the Mr., and then the rest, as we've seen in the previous steps. So these two methods here, they add elements to the array. Let's now see two methods that remove them. So John.pop, and what this will do is that it removes the element from the end. All right, so let's now then log it to the console again. And so now you see that we have the array from before, but without the blue element. And if we do it again, then it will remove yet another from the end. And so now we should also lose the false. So let's take a look at that. And indeed, it did now remove these two. Okay. And so finally, we also have a method, of course, to remove the first element. And that one is called shift. Okay, and so now we should lose the mister here. And yeah, indeed it's gone. Okay, so push, unshift, pop, and shift methods. And now just one last that I want to show you, which is the index of. All right, so let me show that to you. So index of will return the position of the argument that we pass in inside of this array. So let's say that we want to know the position of the 1990. So we pass in this value, and index of will then return in which position this 1990 appears in the John array. So let's log that to the console so we can take a look at it. And so what do you think it will be? So take a guess, and now let's see. And it is number 2, and indeed it is. So 0, 1, and 2. Okay, so it returns the position at which the element is in the array, if it is in the array, and if that element is actually not present in the array, it will return -1. So let's say that we pass in something else, let's say 23, and so now it should return -1. And indeed it does, because we don't have any 23 in that array. And so one of the things that this method here is most useful for is to actually test if an element is in the array or not. So let me show that to you. And so let's use the ternary operator that we learned about before. So John.index of, and so now let's test if John is a designer. So we ask the position of the designer element in the array. So that will return a number to us, and then we say if it's equal to -1, well, then John is not a designer. And else, John is a designer. All right. So let's check that out. And nothing happens, of course, because we didn't assign this here to any variable. So let's say var is designer. And then we can log it to the console. Okay, so John is not a designer. So let's see why that happened. So we searched for designer in the array, but that element is not actually in that array. And so it will return -1. So this entire part here will be -1. And so we test, is -1 equal to -1? And yeah, indeed it is. And so the isDesigner variable will be assigned the John is not a designer string. Okay, so let's say we now change it to designer. And so now we should see that John is a designer, because it will now actually return this index. Let's try that out in the console. So index of, and you see that it is 3. All right, so 0, 1, 2, and 3. And so 3 is of course different than -1. And so we now have John is a designer. Okay, so these are just a couple of methods on arrays, and I'm going to show you many more throughout the rest of the course. But for now, you know how arrays work, and that's amazing. It's a really powerful data structure that we can use in JavaScript. And so now I think that you learned enough already to take on another coding challenge. So let's do that right in the next video. Welcome to the next coding challenge. In this one, you're going to build a very simple tip calculator. So John and his family went on a holiday and went to 3 different restaurants. And the bills were $124, $48, and $268. Now, to tip the waiter a fair amount, John created a simple tip calculator as a function. And the way that John calculates his tips is that he likes to tip 20% of the bill when the bill is less than $50, 15% when the bill is between $50 and $200, and 10% of the bill if it is more than $200. And this may not make a lot of sense, but this is just for this small exercise, so we have some more stuff to do in our function. Okay, so in the end, John would then like to have two arrays as the end results. So one containing all three tips, so one for each bill, and then one containing all three final paid amounts. And with paid amounts, I mean the bill plus the paid tip. Okay, so we want a function that calculates the tip, and then we want two arrays, one with just the tips and one with tips plus the bill. Okay, and if you're not sure how to calculate a percentage, for example, if you want to take 20% of a value, you have to simply multiply that value by 0.2, which is 20 divided by 100. Okay, so that's very simple. All right, so I hope you managed to do this. This will be a good challenge for you to use most of the stuff that we talked about up until this point. So give it some time, try it out, and then I see you in the next video with the solution. Good luck! So I really hope that you gave the challenge a try, and of course that you managed to do it. So here goes my solution in case you're wondering how I did it. I'm going to start by creating the tip calculator function. Okay, so function, and I'm going to call it tip calculator. Then in here you pass a value, which I call the bill, and then we have our function body. Okay, now we want to, depending on the bill value, to determine the percentage of the tip that John likes to pay. Okay, so here we have our rules again. So 20% if the bill is less than $50, 15% if it's between 50 and 200, and then 10% if the bill is more than 200. So I'm going to define var percentage here, and then I'm going to leave it. And now in an if-else statement is where I'm actually going to define the value for the percentage depending on the bill. So if the bill is less than 50, then the percentage should be 20. Or actually it should be 0.2. So we could write 0.2, but we don't even need the 0 here. So just 0.2, because that's actually the value that later we are going to multiply with the bill. Okay, so remember, to calculate 20% of a value, we multiply it by 0.2 in this case, because that's 20 divided by 100. All right, so else if the bill is greater or equal to 50, and if the bill is less than 200. So that's very similar to the stuff that we already did before, right? And so this should be nothing new for you at this point. So in this case, our percentage is going to be 0.15, and else the percentage will be 0.0, or actually 0.1, sorry. So 0.1, which is 10%, okay? And in this case, we don't even have to specify the if here, because if the bill is not less than 50 and not between 50 and 200, well, then that means that it's more than 200. And so this case here covers all of that. Okay, and so all we have to do now is to return this percentage times the bill. Okay, and so for example, if our bill was $100, then we would divide it with 0.15, which would then be $15. And so we would return $15 from this tip calculator function. All right, now you could of course have done this differently. For example, you could have done a switch like we did before. For example, where is it? So something very similar to, I'm not sure where, yeah, so here is it. So you could have done something similar to this one here, for example, as well, where in each case you would then return the bill times the current percentage. Okay, but it works fine just like this, okay? So just to tell that there are always different solutions for the same problems. Okay, and now I just want to actually test this here with some value. So tip calculator, and let's set it to 100, and we need to console.log it. So again, this is just for testing to see if our function is actually working just fine. So this here should return 15, right? And indeed it does. Okay, so that's 15% of 100, which is between 50 and 200. Okay, now let's try it with 300, and we're going to take 10% of that, which should be 30. So Let's test, and indeed it works. And now let's put, let's say $10, which is of course less than 50, and so 2% of that should be $2. And yeah, indeed it is 2. And so that means that our tip calculator is actually working. So all we have to do now is to create these two arrays that John wants as a result. So the first thing I'm going to do is to actually store the builds into an array. So we have 124, we have 48, and then 268, I believe. Let's just confirm that. And yeah, so these are the builds that we have. And then let's calculate the tips actually. So the first tip is calculated by using tip calculator with the builds on position number 0, right? Then the second one, and actually let's put it in a separate line here. So the second one is tip calculator builds on element 1. And then finally, the last one is calculating the tip with builds at position number 2. Okay, so we just created an array here which contains these 3 values, which all come from the result of calculating the tip using our tip calculator function. All right, so let's log it to the console here. And so yeah, here we have our tips. Now this here is something weird that is happening with the 9.6 and 001. And this is something weird that JavaScript does with numbers, and no one really knows why this is happening. So it should just be 9.6. And the same is actually happening here with these 5999998. And this, of course, should be 18.6. Okay, but that's nothing we can change. That's not like our fault. So JavaScript just does these weird calculations here that do not really make sense. But so don't worry about them. Okay. So this is the first array that we want. So the 3 tips. And then finally we want one containing all 3 final paid amounts. And so that's also very easy. Let's say final values. So another array. And well, here we have to say builds at position 0 plus the tips at position 0. And that's it. So very simple. Let's just grab this here. And here it's 1. And here it's 2. And so this is actually all that we need to do in order to have our final results. Okay, and now you see that actually here, now we have this 0.6 and this 0.6 coming from these two. So this is really weird again, but yeah, don't worry about it. Anyway, what we really want to see here is that this 142.6 is really the sum of the original bill, which is 124 plus this 18.6. Okay, and the same of course for the others. So 57.6 is 9.6 plus 48, and the same here for this last element. And so with that, the challenge is completed. Okay. And you could have done it very differently, of course. For example, you could have declared empty arrays in the beginning and then used the push method to add all of these results to the array. But again, it's not really important that your code is the same as mine, okay? I cannot stress this enough. So what I really want you is to write code and to think about how to solve these problems. And if the results that you get are the same as mine, well then that's really fantastic. So you've come a long way in this section, but there's still a couple of more things to learn. So let's now move on. Welcome back. In this lecture, I will give you an introduction to objects, which is the single most important feature of the JavaScript language. So let's get started. So the arrays that we've been learning about are very useful and are, of course, very much used in JavaScript programming. But imagine that you wanted to access an element of the array, not by its index, but by a specific name. So basically naming each of the values. And with arrays, of course, you cannot do that, but you can with objects. So in objects, we define key value pairs, which means that each value has a name, which is called the key. So in simple terms, we can use objects to group together different variables that belong together and that have no particular order. just like, for example, the properties of John that we've been talking about in all these past lectures. So one fundamental difference between arrays and objects is that in arrays, the order matters a lot, while in objects, it does not matter at all. Okay, so let me actually show it to you how we can create an object. So we start again by defining a variable. And now the easiest way of creating a new object is with the so-called object literal, which is basically just like a container that we can fill with variables, which are called properties. So the object literal, we write it like this. So just curly braces, just like with arrays, we have the brackets. In objects, you have the curly braces. Okay, and so now we can start defining our key value pairs. So name, for example, and now John. Well, we can also say first name, just like we've been doing all this time, so that we keep our naming consistent here. So here in this example, first name is now a key and John is the value. And so we call all of this here a key value pair. We also say that first name is a property of the John object. Okay, but a bit more on that later. So for now, let's keep defining a couple of key value pairs here so that I can show you then how we can access them and also mutate them, just like I showed you in arrays. Let's also define the last name. So Smith. And then just like in arrays, as you've seen here, we have to separate these different lines, so these different key value pairs with a comma. Okay. So birth year, and again 1990. And you see that we can put all kinds of different data types in here, just like before. We can even put arrays in here. So why not? Let's define a family property. And now we can put an array in here saying the family members. So let's say that some family members of John are Jane, Mark, so Bob, and Emily. So as you see inside the object, we can actually have other elements like this. So we can even have an array. We could even actually put another object inside of the object. All right. And actually the same is true for arrays. So we didn't talk about that in the arrays lecture, but as an array element, you can actually also have an object or another array or really whatever you want. All right. And of course, you will see examples of all that throughout the course. So don't worry. This is really just the intro section. We're going to use all of this stuff a bit later. So we can define a job. And now also let's define the is married state, just like before. So we say false. Okay. And then the last one has no comma or semicolon. And that's it. So that is our John object. And we can now, just to take a look at how it looks in the console, just log it. Okay, and so here we go. So this is our object. We can open it up and take a look at the different properties. So as I mentioned, these are all the properties of the John object. And so maybe now you're wondering how we can actually access them. And that's a good question. And it's very easy. All we have to do is to use the dot notation. So dot first name, for example. And the text editor already suggests us what name we can write here. And so let's try it out. And here we go, John. So all we have to do in order to read the value of the key of first name is to use the dot. Okay, and so first name is a property of John, and we read it by using the dot notation. All right, so that's one of the ways in which we can do it, but there's actually another one. So one is the dot notation. And so let me now show you another one, which is using the brackets. So just like retrieving an element from an array, we can also use the brackets to retrieve an element from the object. But instead of using a number, we use the key name. Okay, so let's say that we want the last name now, and we then have to actually put it in quotes. So basically we have to put a string here. So last name. And so now let's check it out. And here we go with Smith. Okay, so this is here a string, remember. And so actually we can do even better, not exactly better. Well, there's one thing that we can do, for example, is that we can declare a variable, and let's just call it x here for simplicity's sake. And then let's call it the birth year. Okay. And so now in here, and this has to be a string, of course. And now in here, we can use that variable. So we can say John X, and this X will then be birth year. And John birth year will be 1990. All right, so let's try that. And indeed, it worked. Okay, and this small trick here can be useful sometimes. And so that's why I showed it to you. Okay, so keep that in mind. Sometimes this might come in handy. So this is how you retrieve data from an object. And now we also want to mutate the object, so just like we did with arrays, and it actually works in the exact same way. All right, so what we can do now is to say john.job, for example, and we can set it to driver or to designer actually. Why not? So all we have to do is to say john.job, and then we can mutate the data, okay? And then of course we can also do it the other way around, so with the brackets notation, okay? So then our quotes and is married. And so let's set it to true now. Okay, and so if we now log it to the console, then you will see that it should be different. Here we go, and so, here we go. So job is now designer and is married is now true. Okay, and so we can use the dot notation not only to access it like we did before, like here, but we can also do it to change the data, to mutate some of these properties. Okay, and the same here with the brackets notation. All right, and now just to finish, we had two different ways of initializing a new array, right? So to create a new array, and the same happens with object. So we can do an object for Jane, and just like before, we can say new object. So in the array lecture, we said new array, and now we can say new object in order to create a new empty object. And now we can just fill it up with some data here. Jane.name, Jane.birth year, and just one more. So Jane, and this time I'm going to use the brackets again, and so we can say now last name also. Okay, this one let's call first name, and now we can log it to the console. Okay, so just so you see that it's going to work in the exact same name. And here we have an error, so you see last name is not defined, and that's because it's not a string, which is should be. So let's try that again, and so it looks the exact same way as before. So again, it works just like the object literal. Let's actually write that down here. So object literal is a way of defining objects using this syntax here, so just with the curly braces. And then down here, we have the new object syntax. Okay, so that's the very basics of objects and properties. So in this lecture, we talked about properties, and the next one, we are going to talk about methods, which is also something very important related to objects. So stay tuned for that one. Let's continue learning about objects, this time diving deeper into object methods. So we learned in the last lecture that an object can hold different types of data, right? So including arrays and even other objects. But we can also even attach functions to objects, and these functions are then called methods. So let's see why and how we can create methods. And for that, let's actually go back and grab our John object, so we don't have to rewrite it all again. Okay, and so here we have our object. So what we want to do here is to add a function, so a method, to this John object in order to calculate the age of John. So we don't want to have the age hard-coded in the object because it changes every year. And what stays constant, of course, is the year. And so instead of having the age hard-coded here in the object, we have a function that calculates that age. So all we have to do is to basically define another key. So calc age, which stands for calculate, of course. So calc age, and now just like before, we define the value. And the value here is a function expression, basically. So we write function and then the birth year. All right, and that's it. Now all we have to do is to write our function body. And now maybe it makes a bit more sense why we learned about function expressions and function declarations before. So this here is clearly a function expression, right? So it's like we have a function without a name, just with the argument, which we then assign to a variable, which is in this case, this calc age. And so this function here is now a method of John, okay? So now all we have to do is return the year, just like we did before, minus the birth year. Okay, simple, right? Now, how do you think we are going to call this? Well, it's very simple again. And let's console log the result of calling that function. And so the way we call it is just the same way that we access properties. So John and then dot. And instead of accessing one of the properties, we simply access calc_h. And then it's just a normal function call. So calc_h, and then we pass in the year. So 1990 in this example. And so now we will get the age, which is 28. Great. So that is the very basic functionality of methods. And remember that in the array lecture, I showed you methods for an array. And so that means that arrays are actually also objects, right? Because that's the only way that they can have methods, right? Because only objects have methods. So arrays have all these functions to change them, like push and pop, remember? We will dive deeper into why things work like this and how we can create this same functionality for our objects later in the course, okay? For now, we're just talking about the method basics. So just to learn how methods really work. Now, continuing with our John example here, I'm sure that you noticed that the year of birth of 1990, this one here that we passed in as an argument of the function, is actually already defined in the John object itself, right? So it's already here, in fact. So what if instead of having to pass it into this function here again, we could access that property right from this method inside this object? Well, it turns out that we can. And that's because in every object, JavaScript gives us a special keyword called this. Okay, and so let's try that out. And so instead of having to pass in the birth year, which is already defined here, we can say this.birth year. Okay, so this, what it means here in this context is John. So this means this object, the present, the current object. Okay, and so when we call this method here, this.birthYear will mean John.birthYear. All right, so let's try that out again. And let's just change it here so that our output here is going to change. So let's put 92 here now. And if we reload, well, you see that he's now 26. And what that means is that this actually works. So we can access now this.birthday because this, again, means simply the current object. So basically the object on which we have calc_h. Okay, so that's great. But let's actually take it even one step further. So what if we actually wanted to store this result right into the John object? Well, we could do it like this. So we would first calculate the age. So just like this, and then we would say John.age equals the age, right? Or we could actually do it all in one line. So something like this. Okay, so we call John.calcAge, which will return the age, and then we set John.age to that result, right? So remember that we can set properties like this, just as we learned in the last lecture, right? But we actually can do even better. So if we can access a property in the current object like this here, well, then it means that we can also set it, right? And so instead of returning this number here, we can simply say this.age should be equal to 2018 minus this.birthYear. Okay, and so now all we have to do is to call this function, right? But then we can also log the entire object to the console just to see if the result is really there. And let's see, and indeed, here we have the age of 26. And so this worked. So the this keyword is something really powerful and really important that you will have to master throughout your journey of learning JavaScript. So remember, in this lecture, we went from actually having to pass in the birth year as an argument to the function to being able to read the birth year directly from the John object using the this. And then from there, we went even one step further, and instead of returning the age result, we also stored it right into the object. And so that's the best we can do, and that's the way it's supposed to be working, all right? So if you understand this basic functionality of methods and this keyword, then you're well on your way on mastering objects later in this course, okay? Because this is actually a very complex subject, and we will dive much, much deeper into it later in the course. But for now, I really just want you to understand that an object has a special this keyword, which basically points to itself. And I want you to understand that you can use methods like this. So just like I showed you in this video. All right, makes sense? So I think you're now ready for yet another coding challenge. I hope that you like these. I think they're perfect for you to practice your skills and what you just learned. So hopefully I see you there in a second. It's coding challenge time again. So here we go. And let's remember the first coding challenge where Mark and John compared their body mass indexes. So let's now implement the same functionality, but this time with objects and methods. So for each of them, create an object with properties for their full name, mass, and height. Then add a method to each object to calculate the BMI. And what I want you to do here is to both save the BMI to the object and also return it from the method. And then in the end, I want you to log to the console who has the highest BMI together with the full name and the respective BMI value. All right? And again, don't forget that they actually might have the same BMI. And if you don't remember the formula for calculating the body mass index, then it's down here again. And you can also go back to the other challenge and find the solution there. Just keep in mind that the mass has been kilogram and the height in meter. Okay, so this again is using the knowledge that we just learned in the last 2 lectures. So I think this is a fun way for you to retain that knowledge immediately. Okay, so good luck and see you once you're finished. So did you manage to successfully complete the challenge? Well, here is the way that I did it. So I'm going to start by creating the John object with the object literal syntax. And let's give it some more space down here. All right. So then the full name property will be John Smith. Then the mass is 92 kilograms. And the height is 1 meter and 95 centimeters. So 195. And then we need to calculate BMI method. So this is the trickier part, right? But it's still not really difficult. Okay, so we use a function without any argument, and that's because we're going to read the mass and the height both from the current object, right? And so how are we going to do this? Well, the formula is this dot mass, okay, divided by this dot height times this dot height. So the height squared. Okay, so remember that this here means the current object. So it will read the mass from the current John object. And so the mass here will be 92. And then the same here for this dot height and of course this here as well. So here it will be 1.95 times 1.95. And where do we want to store this result? Well, it should be in this dot BMI. So remember, we can not only read properties from the object using this, we can also set them. And so here we set this.bmi should be result of this formula. Okay, and so that's actually it. So we calculate the BMI, and then remember that here from the text that we should also return it. So save the BMI to the object and also return it from the method. And so return this dot BMI. Okay, so that's John, and now I'm just going to go ahead and copy it for Mark, because the method is actually going to be exactly the same, obviously. Okay, so it's going to have no difference. The formula and everything works just the exact same way, and so we have the exact same method on the Mark object. Here it's Mark Miller, then the mass is just 78, and the height is 1.69. Okay, and as I mentioned, the rest stays the same. So we're now ready to calculate the BMI for both of them. So John.calc BMI, remember that's how we call methods, and then the same for Mark. Okay, and so yeah, let's take a look at these 2 objects actually. So console.log both John and Mark. So we want to get both of these objects here into our console. So here they are, And we see that both of them now have the BMI. So John has a 24 and Mark has a 27. So great. So you see that it's actually very nice to have a method directly attached to the object, because this function is really related to this object, to this person in this case. And so it makes sense that we can have the method really together with the data instead of having an external function which could do these calculations as well. Okay, so that's why we make use of this pattern, let's say this best practice, to have the methods inside of the object. Now you're probably thinking that having the exact same method on these two objects kind of violates the try principle that I showed you before, so the don't repeat yourself principle. And that's actually correct. So this is not a perfect way of doing it, but for now, with the knowledge that we have at this point, this is the best that we can do. Later in a more advanced section of the course, I'm then going to teach you how we can have the exact same method on multiple objects without having to repeat the code. But for now, this is more than okay like this, okay? So finally, we have to log to the console. So what do we want to say? Who has the highest BMI together with the full name and the respective. Don't forget they might be like a draw, so the same BMI. And so we've done this many times before. So John.BMI, let's now read it here from the object. If it's greater than Mark.BMI, well, then let's log to the console that John.first name, or actually its full name, has a higher BMI of, and then John.BMI to read it again. All right, now an else if here, because there can be the case where they both have the same, and so we have to account for that as well. So now it's Mark.BMI is larger than John.BMI. And then let's just grab this piece here of code, paste it here. This should be Mark, and this one as well. And then just the else, in case it is the same. They have the same BMI. Okay, so according to our data, Mark Miller has the highest BMI, and indeed that's exactly what we log to the console. So Mark has 27, as you can see here, and John has 24. So let's now increase John's mass here to, let's say, 110. And so now, indeed, he has the larger BMI of both. So that's already almost perfect, but we can do even better. Okay, so let's get first rid of this. And what we can do is to actually calculate the BMIs right here. So we calculate the BMIs using the call BMI function, of course, or the method, I should say, and then we use that data to take these decisions here. But keep in mind that these methods, they actually also return the BMI, right? And so we could replace John.BMI here by the method call. And so let's actually do that. So I'm going to copy it, or actually cut it from here and paste it down here, and the same for Mark. All right. So does that make sense to you? So again, we know that this calc_BMI method here will return the BMI itself. So we have it here. So return this.BMI. And so down here, we will calculate the BMI and then immediately return it. And it will then be put here in this logical comparison, right? And the same, of course, for Mark. So in this case, this here will then be replaced with 27.3, okay, which is what we see here. And this John.calc_BMI will be 28.9, right? So this value here. And then the comparison can happen, and then everything can just work the same, okay? And so we don't need these additional lines where we first calculate the BMI and only then we read it. So we can basically calculate it and read it at the same time here, all right? And here, then we can read it already because at this point it is already calculated. And so, of course, we're not going to call BMI method again. So we only want to call it once, and then from there on, we can just directly read the value from the object. So we're not going to put calc_BMI here or here, because at this point, again, it is already calculated. Okay, does that make sense to you? And of course, again, you wouldn't have to do it this way. So it's not really important, but that's actually the reason why I asked you to also return the values here from the methods, so that we can then use this little trick where we can calculate and compare the values here all in one tag. All right, and just to confirm that it works the same, of course, here we go with the correct solution. Great, so we're almost at the end of the section. There's just one more thing to learn, which is the loops and iteration. And so that's exactly what we're going to do in the next video. So I hope you enjoyed this one, and so see you next time. So we're almost finished with the basics of JavaScript, but there's still one thing missing that's crucial to programming in general, and that is loops. So in the lecture where I first introduced you to the if-else statement, I mentioned that it was just one of many control structures. And so here are some more control structures: loops. So loops are a very important aspect of any programming language. Just imagine that you have a very repetitive task. Instead of writing, like, for example, 10 lines of the same code, you would just use a loop. So we can basically automate repetitive tasks using loops. Okay, and there are different types of loops in JavaScript, and we will start with a simple for loop. So suppose we needed to print the numbers from 0 to 9. Okay, so something like console.log and then 1. And then 2, 3, 4, 5, and so on and so forth. So you would have to do this 10 times, but that's not a good idea at all, right? And so instead, again, we use a loop. And I'm going to start with a for loop. So we write for, and then the for loop has 3 parts. It has the initial value of a counter, a condition that is evaluated before each loop iteration, and finally a counter update after each iteration. Okay, so let's go through them one by one. So the first part is the initial value of a counter. So imagine that we want to print from 0 to 9. Okay, and so we start at 0. And so we define a variable called I, for example, and set it to 0. And I use I here because I is kind of a standard in JavaScript for a counter variable. Okay, so this is the variable that will be updated in every loop. Okay, then we use the semicolon. And now the second part. So this is a condition that is evaluated before each loop iteration in order to see if the next loop should still be executed. So if we want to count from 0 to 9, well, then our condition will be that I should be less than 10. Okay, so only if this turns out to be true, then the next loop will actually run. Okay, so in the beginning we start with 0, and so I will be 0, and 0 is less than 10. And so it's true, and so the loop will start. All right? And then next up, and finally, we have the counter update after each iteration. So if we want to count from 0 to 9, like 0, 1, 2, 3, 4, 5, all the numbers, then in each iteration, we want to increase I by 1. Okay? And remember a special operator to do that. It is the ++. Okay? So this is the same as writing I equals I plus 1. Remember that? Okay, and then in here we have basically the loop block. So what should happen in each of the loops? And in this small example, all we want to do is to really log these numbers to the console. So console.log I. And so that's it. That's really it. Let's take a look. And so now here you see all of these 10 numbers from 0 to 9. All right, so let's go through it again and see why this works. So I'm adding a comment here and try to write out what happens in each iteration. So we start and I will be 0, right? Then the condition is evaluated, and so 0 is of course less than 10, and so that's true. And so we will then log I to the console. So log I to console. And then finally at the end, the counter is updated. Okay, and so I ++. Okay, then in the next iteration, we will have I is already 1 at this point, right? And so the test is now I less than 10, which is still true. And so the next iteration will start. And so again, we log I to the console, and then I will be incremented by 1. So we do that a couple of times until we reach the end. Okay, so let's actually copy this here And again, this is just to show you how this works. So this happens a couple of times until we're at a point where I is 9 already. And here I wanted actually the less symbol. Okay, and so at this point we are at 9, and 9 is still less than 10, and so it's true. Then we log the I to the console, and I gets incremented just like before. Okay, but then it means that at the next step we are at 10. And so 10 less than 10 is now false. And so we enter the loop. We exit the loop, which means that the loop finishes and it no longer continues working. Okay, and so that's why we stop at 9. All right, does that make sense? Now we could of course change some stuff here. So imagine that we wanted to count until 20. So we couldn't put 20. Actually, this will go until 19. Or imagine that we wanted to really start from 0 and include the 20. So we wanted to start from 1, not 0, sorry. So starting from 1, and we wanted to include the 20. So we can say less or equal, right? And so in this case, this will only fail as soon as I is 21. And so we start at 1 and go all the way to 20. And we can also add like a step here. So instead of simply adding 1, we can add 2 in each iteration. So let's try that. So instead of doing I++, we can do I plus equal 2. Okay, and remember, that's the same as writing I equals I plus 2. Let's check it now. And so indeed, it works. So we start with 1, right? And then we increase the counter by 2. And so the next one will be 3, right? And then 5, and so on and so forth, all the way to 19. And 20 is not included because 19 plus 2 is already 21, which is, of course, greater than 20. All right, so that is the very basic functionality of the for loop. Now let's look at a bit more practical example. So let's say that we have an array here, and let's actually copy the array from the array lecture here. And where is it? So yeah, this one is the one that I mean, so the John array, instead of having to write it out all over again. So we have a couple of data here about John. So let's say that we have an app where we need to display these 5 values here to the console. Well, maybe not to the console, but to the user interface, but we're just working with the console here. And so let's pretend that we need to log these 5 values here to the console. And so of course, just like before, we could do it like this. So John 0, and then like all the way to 5, oh, actually to 4, right? So we could do it like this, right? So that would solve the problem, but not in a good way. So imagine that we had actually 50 elements in this array and not just 5. So what would you do then? You couldn't just create 50 lines of the same code. And so of course, the solution here is to use a loop. So let's get rid of this here and instead write it as a loop. So again, a for loop. So var I equals 0. And why do we start at 0? Well, we start at 0 because the array is 0 based. And what we want to use the counter here is to read the element of the array at position 0, 1, 2, 3, and 4. All right, so we start at 0, and we want the loop to run as long as I is less than the length of the array. Okay, and why is that? Well, it's because the length of this array is 5, and so as long as the counter is below 5, so 0, 1, 2, 3, or 4, we can then read the data out of this array. But starting at 5, there's no more data in the array. So there's nothing at position 5 in the John array, and so at 5, we no longer want to read anything. So remember how we can read the length of an array, so the number of elements? Well, all we have to do is to use the length property. Okay, and then we want to read all of them, and so we do ++ just like before. All right, so this here will maybe not make 100% sense to you, but it will after you see exactly what we're going to do here in the block of this loop. Okay, so what we're going to do is to log to the console John at position I. Okay, so instead of writing out 0, 1, 2, 3, and 4, we let the loop take care of basically putting the numbers here. So in the first one, it will be 0, and then 1, and then 2, and then 3, and then 4. But not 5, because John.length is 5, and this loop only runs as long as the counter is less than 5 in this case. Okay, so let's test it out. And yeah, here we go. So all of these 5 logs are now coming from line 597, so this line here. So does this logic here make sense to you? Just to make sure, let's do it again. So we need this counter variable here, I, in order to log to the console John 0, 1, 2, 3, and 4. So we want all of these 5 elements to be logged to the console. And instead of having to write out John 1, John 2, John 3, John 4, and John 5, we just use this loop. And so we start at 0 because that's the first element in our array. After each iteration of the array, we increase the counter value by 1 because we want to read all of the 5 values. And finally, we run this loop as long as the counter variable is still smaller than the total length of the array, which is 5. So it will run for 0, for 2, for 3, for 4, but no longer for 5, because there's nothing at position 5. And we could, of course, manually have put it here with a 5, but then imagine that we would add something here. So something like blue as a favorite color, and well, then it would not dynamically change the array. So if we now reloaded, it would not display the blue here to the console. But instead, if we go back and put it to John.length, well, then it will automatically figure out the length and then loop through the entire array. Because now John.length is 6, and so it will also loop the element number 5 of the array. So indeed, now it appeared down here, the blue as well. Okay, so I hope that now it's crystal clear to you. And looping through arrays is actually one of the biggest use cases for loop. So this one is really important to understand. Now there are actually even better ways and also simpler ways of achieving it without using this specific for loop. But once more, let's talk about that a bit later, because that's a bit more of a complex topic. And for now, we're just really looking at the fundamentals. So that was the for loop, but there's also another type of loop in JavaScript, and that's the simple while loop. So let's try to replicate the same functionality here with the while loop. So the difference between the for and the while is that in while we only have the condition. So all we have to pass into the while loop is really this part. So we can say that while I is less than John.length, then it should keep executing this code. Okay, so basically this logging functionality here. And so if you want to have the exact same functionality as with the for loop here, we first would have to start by defining the variable out here. So I equals 0, and then at the end of each loop, we will have to increment I. Okay, and so that's actually it. So this here is now the exact same thing as this for loop here. But of course, it's much easier to just use the for loop here. Okay, I just wanted to let you know that there's also a way of doing it with the while loop. So let's add some comments here. So this is the while loop, and well, this here is the for loop. All right, and now I just want to show you the continue and the break statements. So we use the break statement in order to break out of a loop, and we use continue in order to quit the current iteration of the loop and continue with the next one. Okay, so let's just take a look at a couple of quick examples. And I think I didn't even show you the result of this one. So just to make sure, and now it is, well, now we have all of this here, but you see that it's just the same. So we have these 6 here coming from the for loop, and we have these 6 here coming from the while loop at line 604, right? And so in fact, it works just the same way. Now let's actually get rid of these here. Not really get rid, but I'm just going to comment them out so that they're not getting in my way for the next part. All right, so let's copy this here so that I can now show you the continue and the break statements. And let's start with the continue. So again, the continue, we use it to quit just the current iteration of the loop and then continue right to the next one, okay? So let's say, for example, that we only wanted to log elements that are strings. Okay, and so we can implement a logic that will do it so that if it's not a string, it will quit the current iteration and then continue with the next one. All right, so how do we check if it is actually a string? Well, remember the type of operator that we used right in the beginning of this section. So we can now say type of, and I think I misspelled that, so type of John at the current position. So if this one is different from a string, and I think we haven't used different up until this point. So we only ever used the equal, but now I don't want equal, I want different. And different, we use the exclamation mark like this. So this here is the strict different operator. And just like with the triple and the double equals, here we also have the normal different operator and then the strict different operator like this. And just like with the equality, we should always use this one. Here we always should use this one. So exclamation mark and then equal equal. Okay, and so this means different. So what we want to do here is that each time that the type of the current element is different from a string, well, we just want to continue. Okay, and I think this is also something new. I think that up until this point, we always did the if like this. So we had this block and then, well, kind of the text in there. Just like this, okay? But if it's only like on one line and just a simple if statement like this, we can actually do it in one line without the curly braces and just write it like this. So if this, then continue. And so this will then break out of the loop and will continue to the next one. So for example, when we hit Smith here, then the type of John I will be string. And string is not different from string, right? And so we will not continue. Instead, we will go straight to this line. But in the next iteration, when it's 1990, well, that is then different from a string. And so therefore, we will enter the if part here, and we will then continue. And so this line here will not even get executed. All right, so let me show that to you. And indeed, we now only have John Smith, designer in blue. It skipped the 1990 and also the false. And again, that's because the type of these two is different than string. So different here, different than string. All right, so that is continue. And now let's do something similar for break. But the difference with break is that it exits the current iteration and the entire loop as well. So it doesn't continue to the next iteration, all right? And so now this time, let's say that we only want to print until we encounter something that is different from a string. Okay, so as soon as we hit something that is not a string, we will not print anything else, all right? Let's simply replace this one here with break. Well, I could have just done it up here, but yeah, so this way we have both versions, all right? I'm just going to, I'm going to leave it like this. So let's now reload, and you see that these four here are from the other loop, so from line 615, and now from line 620, which is this one here, we only have John and Smith. Okay, and so that's exactly what we were looking for. So it prints this string, then this string, and then it encounters something that is not a string, and so it breaks out of the loop and doesn't print anything else from there. Okay, so that is how continue and break work. I hope that makes sense to you, okay? All right, and now just to finish, I want to give you a small challenge. Imagine that we wanted to loop through the John array here, so this one here, the other way around. So starting from blue, then false, designer, and then all the way to John. So how can we solve that? How can we loop through the array the other way around using a for loop? So do you think you can solve that? You can try to pause the video here and give it a second and try it out for yourself, okay? So did you figure it out? So let's add a comment here before we do it. Looping backwards. And really all we have to do here is to think where we want our counter to start, what the condition should be, and what we want to happen with the counter variable. So starting with I, what do we want I to be in the beginning? Well, we have this John array, give it some space here, and we have 6 elements in here, 0, 1, 2, 3, 4, and 5. All right, and we want to start at element number 5, right? And so what is this 5? Well, it's just the length of this entire array minus 1. Okay, and so let's write exactly that. John dot length minus 1. Okay, and that will be 5 in this case. Then how long do we want this array to run? Well, we want the array to run until I hits 0, right? So the last one that we want to print is the first element of the array, which is 0, okay? And so I should always be greater or equal to 0. So greater or equal to 0. Make sense? So remember that whenever this here turns out to be true, then the next loop will be executed. And so what we want here is it to be executed whenever I is larger than 0, okay? Because now what we will do here after each iteration is to actually decrease the counter, okay? Make sense? So we start at 5, and then after each iteration, we decrease the counter. So 5, 4, 3, 2, 1, 0. And at 0, it will still work because I is greater or equal to 0. But then after that, it will hit minus 1, and then the condition will no longer be true, and then it will stop working. Then all we have to do is to, of course, log it, and this is always the same part. And so let's now give it a try. And so these here are our results starting here. So all of these come from line 627, so this one. And so you see that, in fact, it is really looping it backwards. So it starts from blue, false, designer 1990, Smith, and John, which is number 0. Okay, so I hope that made sense to you. This was just a small exercise for you to think about these 3 parts here of the for loop and how we can achieve a different functionality than this simple one that I explained to you before. Okay, and so now it's time for yet another challenge. And this will be the last one for this section, using all of the stuff that we learned throughout all of these videos. So you have come a long way up until this point. Congratulations. And I hope to see you in the next challenge, because I think it's really important that you take these and try it out on your own. Welcome back to the last and most exciting coding challenge of this section. So remember the tip calculator that we created in another challenge? Let's now create a more advanced version using everything that we learned up until this point. So this time, John and his family went to 5 different restaurants, and the bills were $124, $48, $268, $180, and $42. And again, John likes to tip 20% of the bill when it is less than $50, 50% if it's between $50 and $200, and 10% if the bill is more than $200. All right, so implement a tip calculator using objects and loops this time. So here are the steps for doing that in order to help you. So first, create an object with an array for the bill values. Then add a method to calculate the tip, and this method should of course include a loop to iterate over all the paid bills and to do the tip calculations. Then as an output, you should again create 2 arrays. 1 containing all the paid tips, and 2 containing all the final paid amounts. So again, the bill plus the tip. All right. And a hint that I have to give you here is that you can start with 2 empty arrays as properties and then fill them up in the loop. Okay. So an empty array is just like this here. And you can start with 2 empty arrays, 1 for this number 1, so all the tips, and then 2 for all the final paid amounts. So start with these 2 as empty arrays, and then in a loop, you can fill them up. All right. So that is already a lot of work, but after that, I even have like a step 2 for you. So to even take it to the next level. And that is that Mark's family also went on a holiday, and they are going to 4 different restaurants. And the bill that they paid were $77, $375, $110, and $45. And Mark has a slightly different rules when it comes to tipping. So he likes to tip 20% if the bill is less than $100, 10% when the bill is between $100 and $300, and 25% if the bill is more than $300. Okay, so again, that doesn't make much sense maybe, but that's just, again, to make it a bit more exciting and to make these 2 tipping functions different for each of the persons. Okay. So I want you to implement the same functionality as before, but this time, of course, using Mark's tipping rules. Then create a function, and I don't mean a method, so like an outside function, to calculate the average of a given array of tips. And here I have to give you another hint, because up until this point, we never did anything like this. Okay, and so I give you a hint here to calculate the average, and that is that you should loop over the array and in each iteration store the current sum in a variable which starts from 0. Then after you have the sum of the array, then you simply divide it by the number of elements in it. Okay, so that's the formula for calculating averages. So if that's a bit too difficult for you, then you can just stop maybe after 0.5. Okay, but I would like you to try out to calculate the average. All right, so that's here on number 7. So you use the function that you created in number 6 to actually calculate the average for both families. And then you log to the console which family paid the highest tips on average. All right, so again, this one is a bit tricky maybe. So you can, no problem, take an hour or even more to try to accomplish this. All right, I think it's really important for your learning process to go through something like this, a bit more difficult even, so that you really have to try instead of it being super easy, because then you don't really learn anything, okay? So take an hour or something like that to really go through this and really try to solve these problems. All right, you don't need to be fast. Then if there's some parts that you cannot figure out, again, no problem, you can just check out my solution in the next video. All right, here goes my solution for the first part of the coding challenge that I just showed you. So I start with creating the John object. So the object literal again, then the full name, John Smith, and then an array of the builds, just as it says in the instructions. And the builds are 124, 48, 268, 180, and $42. Okay, and that's all the data that we need. Now we're already ready to write our calc tips function, or method, I should say. So function without any argument, such like before. And so this challenge here is actually a bit similar to the one before, where we calculated the BMIs for John and Mark. The only difference is that this time we also need some loops. And so that adds a new level of complexity to this function here. All right. So remember how I said that you should start with an empty array for both the tips and the final values. And while you could do that, you could do it like this. So tips, and then here an empty array. But I figured that it would be a bit cleaner to start without it here. And instead, as soon as we run the function, then we add these empty arrays to our object. Okay, so how do we do that? Well, we just say this.tips equals an empty array. And then also this.final values is also an empty array. Okay, so I'm giving it the same names as I did in the other tip calculator. So tips will be the array with all of the 5 tips, so one for each of these builds, and then the final values is the array where we will have the sum of each tip with each bill. Okay, and so now we have to loop through the builds in order to calculate the tip for each of these values. Okay, and so of course we're going to use the for loop, such as we learned in the last lecture. For, and we're starting at I, 0, and we're going until I reaches the length of the bills array. So once more, it's the exact same thing as we did in the last lecture, okay? So we're just applying what we just learned before. So where is this builds? Well, it's at this dot bills and then dot length. And so here you see something for the first time, which is 2 dots, okay? And actually the dot is an operator. So let's go to our operator precedence table that is still opened here. And here you have this operator, which is called the member access. Okay, and we see that this one is executed from left to right. All right, and so this is why this works. So here is the first one, so the first dot. And so this dot builds is the first part that will be executed. And so this here will be basically replaced with this array. And so we end up having this array here. And then after that, we read then the length property, this one here, of that array. Okay, so if it was the other way around, if we started reading this way here, then it wouldn't work at all, because bills.length would be something unknown. So it wouldn't exist, because all that exists is this dot bills. And so of course, it makes a lot of sense that we start basically reading, that we start executing from left to right. So that was just a small detail, but I think it's important to really understand why these things actually work the way they do. Okay, I hope you agree with that. So I++. All right, makes sense. So again, we're going all the way until we reach the length of the builds array, which is 6 in this case. So we execute it for 0, 1, 2, 3, and 4. Okay, so the length is not 6, it's 5. I think I said 6, but of course it's 5. All right, so what are we going to do in each iteration? Well, just like before, we are going to determine the percentage based on the tipping rules. Okay, so let's write that down here. Okay, and so I like to add these comments here in order to figure out beforehand, before actually writing the code. So we determine the percentage and then we add the result to the corresponding arrays. So this is the same stuff that we did before. So we defined the percentage without actually specifying it. So we just declare the variable here, but do not define it. And we do that based on the bill. So if the bill is less than 50, remember? So that's the rule that we have up here. So if the bill is less than 50, then the tip is 20%. It is 15% if it's between $50 and $200, and it's 10% if it's more than $200. All right, and so we are going to translate that here into code. Okay, and actually bill is not something that we have defined. So sorry for that. So it's not bill, but instead, what do we have here? We have this dot builds at the current position. Okay, so maybe this is starting to become a bit confusing. Okay, and I totally get that. And as I actually mentioned before, that was kind of the goal of this challenge, not to be confusing to you, but to make you think a little bit about how these things work. So how can we solve this kind of problems? Okay, so this dot builds is our array with the builds, right? And what we do here with the loop is to loop exactly through that array. And so it only makes sense that we then access the current position of this array using the current counter variable. Okay, and that is always I, just as we learned in the last lecture. All right, and so let's now define the percentage for this bill value, and that will be 0.2. Okay, so 20%. Then else, and let's actually grab this one here. So if it is larger or equal 50, and at the same time it should be less than 200, right? So that it stays exactly between 50 and 200. So in this case, the percentage is going to be 0.15. And then finally, in all other cases, the percentage is going to be 0.1. Okay, now as you see here, we have a lot of duplicate code here. So this this.builds and then at position I, we have repeated it here 3 times. And so let's actually create a separate variable for that. So let's call that one bill. Okay, and so before doing anything here, we simply create a variable where we store the current bill value. All right, and so we can now go ahead and replace all of these here. And so that's a bit better. So instead of repeating the same code multiple times, we just store the value in a variable. Okay, so that is much better. Okay, so for each of the builds, we have now figured out the percentage. So all we have to do now is to add it to the tips and to the final values array. So this dot tips at the current position, and remember that is I. Well, and now it's very simple. It's the bill variable that we defined before. So this dot builds at the current position times the percentage. And so this part here is exactly the same as in the more simple version of our tip calculator, right? And now finally, this dot final values at the current position will be the bill plus the this dot tips at the current position. Or actually we can do this one here, so it's the same. Okay, so we have the bill plus the bill times the percentage. All right, and so that's actually it. So that is our tips calculator, which will at the same time calculate the tips for all of the 5 builds. All right, so let's actually try that out. So john.calc tips, and then let's log it to the console. Console.log John. All right. Oh, we have some syntax error here at line 674. So where is that? And indeed, I'm missing the if here, so else if. Probably you already saw that one coming, so I'm sorry for that mistake. And so now we have the object here, and in here we have our builds, we have our final values, and we have our tips. So it's all here now, okay? So we have 18.6, 9.6, 26.8, 27, and 8.4. And these, if we add it to this builds, will then result in this final values that we have here. So for example, this 180 plus the 27 is 207, and that's exactly what we see here, right? So it means that it's actually working. So the first part of the challenge is completed, I think. Let's take a look. So add the method, then should include a loop, add as an output, create these 2 arrays. Okay, so the first part is finished. Let's take a look at it again because it's quite a lot of code here, and this is by far the most complicated code that we have written up until this point in the course. So the hardest part probably to grasp is the fact that inside of this method here, this calcTips method, we have this loop that calculates all of the 5 tips all basically at the same time, or one after the other, but automatically. So that's exactly the reason why we used the loop, okay? And so we had to have these kind of confusing like this.builds.length, where we first read the builds array from the current object, and then from there we get the length, all right? And then here we get the current bill, so the current value, and from there, well, basically the same is then the rest is the same as we did in the other challenge, okay? Then another particularity was that we had to create these empty arrays here so that we can then fill them up. And maybe you thought that we could do it like this. So this.tips is equals this.final values is equals an empty array. So maybe you try to do it all in one line, but that is not going to work. So this here will not work because what this is going to mean is that these 2 arrays will be the same. So in this case, if you did it like this, if you then added something to the tips array, so this one here, then you would have automatically also added to the final values because they would be in fact the same array, all right? And don't worry if that sounds a bit confusing to you at this point, because later on, again, we will learn why it is that way. So what I want you to do now is after this video, take a deep look again at this method here, and especially of course at this method here, try to figure out why everything works the way that it does here, and only move on if it really makes sense to you. Okay, so this was the first part of the solution. Now in the next video, I will then solve this second part. Okay, so I'm leaving that for a different video so that you can first go over this again and make sure that you understand 100% what's going on here. And finally, here goes the second part of my solution. And we left off after creating the John object, including this huge calcTips method. Okay, now for Mark, this is all going to be very similar. And so I'm just going to go ahead and copy this entire object and then do some changes to it. So the name, of course, is not John, but Mark. And it's Mark Miller. Then this is $77, $475, okay. Then 110, and finally 45. So he only went to 4 restaurants. Then down here in the calcTips, all that we have to change is like these tipping rules. Okay, so let's see how Mark does it. So he likes to tip 20% when the bill is less than $100, 10% if it's between 100 and 300, and 25 if it's more than 300. So let's translate that into our code. So here it's 100. So less than 100, it's 20%, or actually less than 100. Okay. Then if it's between 100 and 300, he gives 10% as a tip. And if it's even greater than 300, then he gives 25. So probably because he's at a very fancy restaurant and then he needs to give more tips, something like that. Okay, so that is the mark object, and it's already done. So let's do the calculation here for Mark as well, and then log both John and Mark to the console. So let's check it out. And indeed, here we have our tips and our final values. All right. So this worked already. We now have the tipping completely implemented for both Mark and John. So let's take a look at what the next step is. And it is to create a function to calculate the average of a given array of tips. And then, of course, calculate the average for each family using that calculator, so that finally we can log to the console which of the families paid on average the highest tips. All right, so let's create that function, and I'm going to do it here after this object. So function calc average, and it's going to receive a tips array. Okay, so now I'm going to do what I told you as a hint. So I'm going to start with a variable called sum, which will start at 0. Okay, so in the beginning, of course, our sum is 0. And now what we have to do is to loop over the tips, and then in each iteration add the current element to the sum. So let's implement that. So for, and once more we start with a variable called I at 0, with I less than the tips.length, and then we increment I. So this is pretty standard. You're seeing at this point that it's basically always the same here, right? And so now what we do is that we say that the sum should be equal to the current sum plus the tips at the current position. Okay, makes sense? So let's say that we pass in an array of 2, 6, and 4. All right, so in the beginning, our sum will be 0, and then we will enter the loop. And so at this point, we have that the sum is 0 plus the current element, which is 2. And so 0 plus 2 will be 2. And so the new sum will be 2. So let's just write that down here. So we start up, of course, with 0. After that, we have 2. And so in the next iteration, we have 2 here as a sum. And then the current element of the loop is 6. So this one here. Right? So 6 plus 2 is then 8. Okay? And so 8 is assigned to that sum variables. Okay? Then in the next iteration, sum will be 8, and 8 plus the current element of the array, which is 4, will then finally be 12. Okay? And so that's it. So we went through the entire array and added all of these elements together, and in the end, we ended up with 12, which of course is the result of adding all of these 3 together. Okay? So that's just an example, just to demonstrate how this function works. Okay, and so in the end, all we have to do is to return the sum divided by the elements that are in the array. So tips.length. Okay, so for example, in the array that we had before, it had 3 elements, and so tips.length would be 3. And so the average would then be 12 divided by 3, which would be 4. Okay, so that's how you calculate averages. So we have now our objects, we have our calc average function, and so now let's do all the calculations. So we already calculated the tips here, then we log them to the console just to make sure that they are correct. Then we can also calculate the average. And what we're going to do here is to actually calculate the average and then store them inside of each of the objects. Okay, so I'm going to say John.average is calc average using John.tips. Okay, and why John.tips? Well, that's because this is the array in which all of the tips are stored, right? So that is the array that we defined here. So this.tips, okay? And so we pass that into the calc average function, which will then return the average, and we will store that into the average property on the John object. Now you may ask, well, why didn't we add this calc average here as a method to each of the objects? Well, we didn't do that because that would be duplicate code. So we would have to have the exact same code on both of these objects. And so we would basically repeat ourselves with the exact same code. And that's not good. Okay, so it's best to just leave it outside here as this function, then calculate it outside, and then only then basically added to each of the objects. So we do it with John, and then we're also going to do it with Mark. All right, and so let's actually do this console log here after that, so that we also can see the newly added averages. All right, so let's try that now. And where is it? Yeah, here we go. So here's the average of the 3, or actually of the 4 paid tips. So we have these values here, and the average of them is 18. And in case of Mark, these are the 4 tips, and the average of that is 38, which is significantly higher, simply because of this huge tip here with $118. All right, so these are the calculations for the averages, and now all we have to do is to really do the console.log. So if John.average is larger than Mark.average, then we can say console.log, of course. So John.fullname. Now the escape, in order to escape the quotation here. So John's family pays higher tips with an average of, and now the average tip. Okay, and if it's the other way around, let's just copy it. It's Mark here, so Mark.average is greater than John.average. Well, then it's of course the other way around. So Mark and Mark here as well. All right, so that should be our final result. And indeed, Mark Miller's family pays higher tips with an average of $38. Okay, just to test this, let's decrease this one here from 110, or actually this one here. Let's decrease it from 475 to like $5. And so the average should then decrease. And so yeah, so now John Smith family pays the higher tips with an average of 18. All right, so that is the solution to this quite bigger and maybe a bit more difficult and confusing challenge. But I hope that you liked it and that you were able to at least do part of it. So I understand if you didn't do it all, okay? And so that's, again, no problem. You shouldn't feel bad about that. The most important part is that you try it here and that you put in the time to try to solve the challenge. So that's really all that matters at this point. And I'm serious here, okay? So that's really what matters most. Anyway, you're now done with the first JavaScript introduction. So congratulations on that for making it this far in the course. That's already a huge achievement. Now, some JavaScript courses stop at this point and consider that you know enough to write JavaScript on your own. But of course, that's very far from the truth. Now, don't get me wrong, you have already learned a lot by now, okay? But we are really just getting started with a lot of great content coming up over all of the next sections. And there's actually even one more video coming up in this section, which is just about the JavaScript versions. So make sure not to miss that one, because it's also important to know that kind of stuff. It's not about coding, but it's still important, okay? So I hope that you take a look at that right now. Now that you're familiar with the fundamentals of the JavaScript language, and before moving on, we need to quickly talk about JavaScript versions. Okay, now I could have probably talked about this right at the beginning of the course, but I just wanted to have you writing some code as fast as possible. Anyway, it's very important to talk about JavaScript versions because that's just something that every modern JavaScript developer should be aware of. And also because you will see these topics coming up in the developer community all the time. And so you want to be able to understand what's going on. So in order to do that, let's just very briefly talk about the history of JavaScript. So JavaScript was first released and called LiveScript in 1995, so a long time ago. But the name was then very quickly changed to JavaScript. And the reason for the change was just to attract developers of another language that was very popular at the time, and that's Java. So the Java in JavaScript was just for marketing reasons really, because the language itself has almost nothing to do with Java. Some beginners think that this is the case, but no. JavaScript and Java are actually two completely different languages. Now, 1 year later, the language was submitted to an organization called ECMA International in order to create a new standard. And so ECMAScript 1, or ES1, became the first version of the JavaScript language. In the real world, we usually use the term ECMAScript to refer to the standard, while JavaScript is used when we talk about the language in practice. Now, fast forward to 2009, ES5 was released with a lot of new features. However, it took many years for browsers to implement all these changes. And finally, the much-awaited new version ES6 was launched in June 2015. And it was the biggest update to the language ever, with a ton of new features. And this was, or still is, a really big deal for JavaScript and for the whole developer community. Now you will also see ES6 being called ES 2015, which is actually the official name. But most people just call it ES6, and so that's what I'm going to do here as well. And actually the reason for ES6 being called ES 2015 is that in 2015 we changed to an annual release cycle. So a new version of the language is now released every year with just a few new features per year, instead of shipping a huge new version every couple of years. So this way it's much easier for everyone to keep up to date, okay? So it's much easier for us developers like this. And so in 2016, ES 2016 or ES7 was released, ES 2017 in 2017, and like this, it will continue into the future. So what does JavaScript look like today, and which version should and can we use? So first off, ES5 is of course fully supported in all browsers today, and so that's the one that is safe to be used. Now about the newer versions ES6, ES7 and ES8, as of mid-2018, they are all actually quite well supported in all modern browsers. But the problem with this is that we can't just assume that our users use these modern browsers, at least not all of them. And the old browsers will of course not understand the ES6 syntax at all, and neither the ES7 and ES8 and so on and so forth. And so these old browsers are a big problem for us. Now the solution to this problem is to basically convert these modern JavaScript versions back to ES5 using a process called transpiling and also polyfilling. And I'm going to teach you how to do that by the end of the course, okay? And if you want to stay up to date with what features are currently supported in which browser, you can just check out the ES6 compatibility table, and the link is on my resources page. Next up, there are the future versions of the language like ES9, ES10, and so on. And these future versions together are many times called ES Next. Now some features of these future versions are actually already implemented in some browsers, and so you could use them by transpiling and polyfilling your code today. But to be honest, I wouldn't really advise you to do so at this point, because I believe that ES6, ES7 and ES8 together are powerful enough to bring the JavaScript development experience to a whole new level already, as you will see a bit later in the course, alright? So in this course, we're going to start by using ES5 in the first part of the course, and then move to ES6 plus, so ES6, ES7 and ES8 in the second part of the course, okay? And so here's how that's going to work. So we already talked about the JavaScript fundamentals using ES5, and we will continue using ES5 to look behind the scenes of JavaScript, do some DOM manipulations, learn all about objects and functions, and code up a huge real project. From there, we will then start using ES6 with an overview of what's new in the language. Then we're going to talk about asynchronous JavaScript, modern development setups, and code an even bigger and cooler real-world app, all using ES6, ES7, and ES8. Alright? Now, some people don't understand why I even bother showing you ES5 in this course at all, and actually have criticized me for doing so. And so here are a few reasons which I hope will make sense to you. So I truly believe that in 2018 and even 2019, it's still a good idea to learn the fundamentals of JavaScript in ES5 and then move to newer JavaScript versions from there, simply due to the fact that you will always have to understand ES5 in the future. And that is because many tutorials and example codes that you will find online are still written in ES5 today. Plus, as a developer, sometimes you will have to work on older code bases, which will most certainly be written in ES5 or even older. And all in all, I just believe that you will be a better developer if you start understanding how ES5 works and only then move up to ES6 or newer, because ES6 has some abstractions like classes that kind of hide how the language actually works behind the scenes. Alright, so I hope that this makes a lot of sense to you. And so let's now move on right to the next section. So, in this third theoretical lecture, we will just very quickly see how the JavaScript code that we write is actually executed. So, JavaScript is always hosted in some environment, and that is most typically a browser, such as Google Chrome, Firefox, Safari, etc. And this is where JavaScript runs. There can also be other hosts, such as the Node.js web server, or even some applications that accept JavaScript code input. We will, however, always just focus on the browser in this course, which is exactly what we have been doing so far. So when we write our JavaScript code and actually want to run it, there's a lot of stuff happening behind the scenes. So what happens is that the host where JavaScript is hosted has some kind of JavaScript engine that takes our code and executes it. So in very simple terms, a JavaScript engine is a program that executes JavaScript code. There are many different engines out there, like Google's V8 engine that is used in Google Chrome, but there are others, like Rhino, SpiderMonkey, JavaScript Core, and many more. Now, the first thing that happens inside the engine is that our code is parsed by a parser, which basically reads our code line by line and checks if the syntax of the code that we gave it is correct. So this means that the parser knows the JavaScript rules and how it has to be written in order to be correct, to be valid. And if we make some mistakes, it basically throws an error and stops the execution. If everything is correct though, then the parser produces a data structure known as the abstract syntax tree, which is then translated into machine code. So this code is no longer JavaScript code, but a code, or let's say a set of instructions, that can be executed directly by the computer's processor. And it's only when our code, already converted to machine code, actually runs and does its work. So it's not really important that you really memorize all of this. I just want you to get the basic idea of what actually happens once we choose to run our code. And there's actually way more going on behind the scenes, and different engines do things in a slightly different way. But this is absolutely enough for us to understand at this point. So let's now move on to the next lecture. The last lecture was a conceptual overview about what happens in the JavaScript engine once we run our code, how it's parsed and translated into machine code. Now let's focus on the order in which the code is run, and for that we need to talk about execution context. All JavaScript code needs to run in an environment, and these environments are called execution contexts. So you can imagine an execution context like a box or like a container, which stores variables and in which a piece of our code is evaluated and executed. We will go more in depth about this in the next slides. Now, the default execution context is always the global context. Remember that I said that an execution context is where a piece of code is executed. Well, in a global context, all the code that is not inside of any function is executed. And this is very important. So again, the global execution context is for variables and functions that are not inside of any function. Now, you can also think of an execution context as an object. Remember objects from the introductory lectures? So the global execution context is associated with the global object, which in case of the browser is the window object. So everything that we declare in the global context automatically gets attached to the window object in the browser. And it works like this. Declaring a variable called lastName or window.lastName is the exact same thing. It's like lastName is a property of the window object. And as we talked about in the intro lectures, properties are just variables attached to objects. So this makes sense, right? And I know this is a lot to absorb, so I really encourage you to take some notes about all these things to reference them later. And of course you can also watch these lectures again when you feel more confident with your coding. So remember, the global execution context is for code that is not inside of any function. But what about code that is in functions? It's actually very simple. Each time that we call a function, it gets its own brand new execution context. Let me show you that by an example. So this first declaration is not in any function. So we are in a global execution context here, as the red arrow down there shows on the right side. So this variable is stored in a global object. We will see how exactly that works in the next lecture. Next up, this function declaration is also in a global context. So we're still here in the same execution context. And the same about the second and the third function. And this is where the fun begins. Because here is where we call the very first function. And as I mentioned before, a new function gets its new execution context. And what happens is that this new context is put on top of the current context, forming the so-called execution stack. So for the duration of this first function call, the execution context for that function becomes the active context in which the code is executed. Okay, so let's get inside the first function with our arrow. So this a variable will now get stored in the execution context for this function, and not anymore in the global context. And now we call the second function, and I'm sure you can guess by now what will happen, right? So once again, a new execution context will be created and put on top of the execution stack. And here we go, this is now the active context. Okay, so now variable b is stored in this new execution context. And now we call the third function. And once more, a new execution context is created and put on top of the stack, as we already know. So now inside of the third function, we just have these two variable declaration and nothing more. So this function has now done all its work, and so we say that the function returns. So what happens to its execution context? It just gets removed from the top of the stack. Very simple. And then the context of the second function, which called the third function, is back to being the active context. And we go back to the second function. So this z variable gets stored in the currently active context, and after the function returns, the context is also pops off the stack. So back to the first function now. And here the same thing. The function is done, it returns, and so we exit it and the execution context pops off the stack. And like this, we executed all three functions, created three execution contexts, and popped them off the stack when the functions returned. I hope that all of that made sense to you. Now, you may ask, how are all these execution contexts actually created? And why is this so important? And the answer is in the next lecture. So go watch that one right now. So, hoisting may sound a bit confusing to you, but it's really not, believe me. So let me prove it to you by writing some code. So once again, I have some starter code for you, which I put here on my desktop. So let's just go to our text editor and open up the project. And in my case, it's brackets. And I have brackets and Google Chrome here side by side, such as we had before. So in case you're using brackets, just hit this button here and then hit open folder. And in my case, it's here on the desktop. So I'm just going to open this project, and here we are. So in this project, I have once again our simple HTML file, which is this bare construction of the HTML file, just the structure. And this time I already have included the script, which is also here already. And I have also already set the stage here for this lecture. Okay, so I'm just going to use some very simple functions here because I just want you to focus on how everything works and not exactly on what the code is doing. Alright, so let's start by writing a simple function, and we can actually use the one we have been using before, so the calculate age function. And remember, we have been writing it like this. Calculate age and then year. And this time we don't even want to return anything. I'm just gonna console log the result to the console. So 2016 minus the year. Very simple, but it's enough for us. So this is how we've been doing it up until this point. So we first declared the function and then called the function. So I'm going to use calculate age and let's say 1990, which used to be John's birth date. And now I'm going to open up our file, our HTML file, and here we go. And the console, so I told you in the last section that we can do inspect to open the console, but we can also come here to the view menu in Google Chrome, developer, and then the JavaScript console, which is the same as hitting this shortcut, so Alt Command J on a Mac and probably Alt Control J on a PC. Alright, and here we already have the result. Okay, so this is the way we have been doing things. But with what we learned in the last lecture, we can also do it the other way around, right? Let me show it to you. I'm going to delete it and use the function here before I actually declare it. Let's see how this works out. Calculate age, and let's now put 1965, for example. And if I now reload this, then this still works. Okay. And this is what I've been telling you about in the last lecture. So this is hoisting. So in the creation phase of the execution context, which is in this case the global execution context, the function declaration calculate age is stored in the variable object, and even before the code is executed, right? And this is why when we then enter the execution phase, the calculate age function is already available for us to use it. So we don't have to first declare the function and then use it, but we can also first use it like this and only later in our code declare it. Now remember another thing that I said in the last lecture, which was that this only works for function declarations, but there's also something called function expressions, right? So let's see how this works out with function expressions. So let's write another function as a function expression. And this is how we do it. So we declare a variable, and now we're going to reuse the function that calculates the years that we have left until retirement based on the year of birth. So I'm going to call it simply retirement. And then function and the parameter year. Okay, we just want to console log here the result. And the way we have been doing this is to make 65 minus the age. So it would be 65 minus the age, and the age is just 2016 minus the year, right? Okay. And we need the parentheses here because we want this part to be calculated first, and only after that we want then 65 minus this part of the operation. And remember, if we group something together with parentheses, it gets the maximum precedence in the operation precedence table, right? So this is the absolute priority. Okay, so let's now use this first like this. So retirement 1990 and hit reload, and here we go. So for someone who was born in 1990, it has 39 years left for retirement, right? So now let's try and see what happens when we do it like this. So the way we have done it up here. So I'm going to go ahead and delete this and try to first call the function and only after that to write it in the code. So retirement, and let's try again 1965, and then let's use it. Okay, and now this time it does not work. So this is what we expected, right? And once again, the reason for that is because this function is not a function declaration, but a function expression. And hoisting with functions only works for function declarations, which is what we have here, right? Okay, great. So in order to make this work again, I'm just going to commit out it here, but I will leave it in the code so that you can have it for yourself and download this code at the end. Okay, so that is function hoisting. Now remember that hoisting also happens with variables, but in a different way. So let's see some examples about that. So here we have functions, and take away this space here. So here, variables. So let's once again create a variable here. And I will create an age variable. So age, and set it simply to 23. And just to check that everything works, let's console log this variable just to see what happens. Okay, 23, exactly as expected. Now, what happens if we use this variable before we actually declare it in our code? So let's see what happens in this case. Console log age. So again, we're trying here to use this variable before we declare it in our code. So I'm sure you know by now what's going to happen. So here we go. All right. So we have undefined. And that's exactly how hoisting works with variables. Because remember, in the creation phase of the variable object, what happens is that the code is scanned for variable declarations, and the variables are then set to undefined. So imagine that we wouldn't even have this variable declaration here. If we then attempted to use the variable, we wouldn't get undefined, but we would get exactly an error, because then we wouldn't have any definition and JavaScript would not even know this variable. But in this case, JavaScript knows that there will be an age variable. We simply don't have the value yet. And that's also the reason why it's defined exactly as undefined, because in one of the first lectures we saw that variables that don't have a value yet will always have the data type undefined. Okay, so let's now take this one step further and write a small function called foo, which doesn't accept anything. All we're going to do here is to create our own age variable right inside this function. And let's set this one to 65, for example, and then console.log age in here, then call the function like this, and then console log the age again. So what do you think is going to happen in this example? So let's find out. Okay, so these are the results of these two console logs here, right? So line 26 and 29, so 26 and 29. So why does this console log here print the age of 65, and then this console log here prints the age of 23? So it's actually pretty simple, and it's because this age variable here gets stored in the global execution context object, right? So in the variable object of the global execution context object. Sounds a bit confusing, right? But if you go through the last lectures again, then it will make a lot of sense. So again, this age variable is declared in this global execution context object. And then this foo function here gets its own execution context object, in which we can also store an age variable. And it can be the same name. It really doesn't matter, because these are two completely different variables. This variable age is defined in the variable object of the execution context object of the foo function, while this age variable is defined in the variable object of the global execution context object. So each one gets its own variable object. So we have two different variables, and so the results when we print them are different. And we can see that the hoisting works indeed also the same way. Console.log. So if we attempt to print the age before we declare it here, then we will have also undefined. So an undefined comes here from line 25, which is this. Okay, so I hope hoisting is a lot more clear to you now. And the most important use case for hoisting is not even variables, but it's the fact that we can use function declarations before we actually declare them in our code. And that's the biggest takeaway from hoisting actually. So this is something very useful and something that confuses new JavaScript developers. So I hope that you understand it with these lectures. So you can take another look at the code or even rewatch some of the lectures that we've just seen. And then after that, once you're ready, then let's just move on to the next lecture. We talked about how execution contexts are created and how that is related to variable and function hoisting. That was the first step of the creation phase. So let's now talk about the second step, the creation of the scoping chain. So what does scoping even mean? Scoping basically answers the question, where can we access a certain variable or function? In JavaScript, each function creates a scope, which is a space or an environment in which the variables that it defines are accessible. In many other programming languages, a scope is also created by if blocks, for blocks, or while blocks, but not in JavaScript. So here in JavaScript, the only way that we have to create a new scope is to write a new function. And this is something very, very important in JavaScript. Also, in JavaScript we have lexical scoping. And lexical just means where something is written in the code. So it's about the position of something within our code. Lexical scoping means that a function that is lexically within another function, which means that it's written inside of another function, gets access to the scope of the outer function, also called the parent function. And with that, it also gets access to the variables and functions that the parent function defines. But let's look at an example to get a better idea of this. So here we have some more demo code. In blue, we have the global scope, which is the scope that is accessible from everywhere, from all functions. Like the global execution context, you can think of the global scope as the default scope. So in this scope, we have access to the variable a and also to the first function. In orange, we have the scope of the first function, which defines the variable b and the second function. And this is a local scope, not a global scope. And do you remember what I said about lexical scoping in the last slide? Thanks to lexical scope, this scope has also access to its parent scope and all the variables and function that it defines. And in this case, that's the global scope. And finally in green, the scope of the second function. In there we have a console.log statement which attempts to print the values of variables a, b, and c. Now, these variables are not defined in that function, only c. But as we already know, a scope has access to the scope of the function in which it sits lexically. So when running this code, the JavaScript engine will not find variable b in the current scope, right? So it just goes up and looks in the scope of its parent function and says, oh, here is b, so let's use that. And the same happens for variable a. It does not find it in the current scope, and also not in the parent scope, so it goes even more up all the way to the global scope. And this is exactly called the scope chain. Only if the JavaScript engine does not find the variable anywhere, it throws an error and stops execution. Now, it's very important to note that this does not work backwards. For example, the global scope will never ever have access to the variables b or c, unless we return the values from the functions. So locally scoped variables are not visible to their parent scopes. And this is why I put that red arrow pointing upwards, because that's the only direction the scope chain works. Now, how does this actually work behind the scenes? Remember the execution context object that we have been talking about before? In the creation phase, each execution context object will get the exact scope chain, which is basically all the variable objects that an execution context has access to. Because remember, the variable object is what stores all the defined variables and functions. So in this example, in the second scope, we have access to the variable object of the second functions, of the first function, and the global variable object. So what do you think will happen with this code in practice? Let's go back to our text editor and find out. So I have this code already here in my starter code, which is the one that you will have available for download. So here's the exact same code that we had in the slide before. So how exactly do you think this is going to work? I'll give you a minute to think about it. Alright, so let's see the solution. Great, so the console log actually printed variable A, B, and C. So hey, hi, and hello, right? Hey, hi, and hello. So why does this work? So this works because, of course, the scoping chain. And in this case, thanks to the scoping chain, the second function has access to the variables of the first function and of the global scope. And that's because the second function is written inside of the first, which in turn is written inside of the global scope. And that's why we call it lexical scoping. So another extremely important concept and very much used in practice as well. Alright, so we have seen that the concepts of execution context, scope, and scope chain are very related. Now before moving on, I just want to make sure that you really understand how these are related and where the differences are. So we saw that the scope chain for each execution context is stored in the execution context object. But I just wanted to make very clear that the execution stack is different from the scope chain. So here we see another simple code example. And we already know how the execution stack works, right? So the first function gets called, which then calls the second function, which in turn calls the third function. And for each of these calls, a new execution context is put on top of the execution stack. Now, for the scope chain, things are a bit different. We see that the global scope contains the A variable, as well as the first and third functions. Then the scope of the first function contains the second function. And this is how I like to represent it. Now let's remember that the execution stack is the order in which functions are called, but the scope chain is the order in which functions are written in the code, where they are lexically in our code. So the order in which functions are called does not determine the scope of the variables within these functions. What determines the scope of variables is where the functions are written. Since the third function is not in the scope of the second function, of course it cannot access variables b and c defined in the second and first functions. It can only access the global variable a, because the function is written in a global scope. So, it's the execution contexts that store the scope chain of each function in the variable object, but they do not have an effect on the scope chain itself. This is important to understand. So what do you think will happen in this case? Let's go find out. Let's first analyze the code that we have here. So we have in a global scope the var a, which is defined as hello. We have the first function here, and we have the third function, all in the global scope or in the global execution context. And then inside of the first function, we have the b variable, we have the second function call, and the function declaration. And we already know that because of hoisting, we can call the function before it's written here, right? Okay, and then in the third function, we just define variable d and attempt to console log variable c. All right, so I'll give you a minute to think about what's going to happen once I hit the refresh button here in order to run this script. Okay, so I'm going to do it. I'm going to push the button. All right, and so we have an error which tells us that C is not defined. So two things here. The first thing is, why can the second function even call the third function? So this bug here came from line 73, right? Which means that someone or somewhere this function was called, which of course was here. So the third function was called from the second function. And this once again is possible because of scoping. The second function has access to the third function because of the scope chain, right? So the second function has access to the global scope out here, in which the third function also sits lexically. And so the second function has the ability to call the third function because of the scope chain. And there's nothing new here, right? And now the second thing is, why do we actually get this error saying that C is not defined, even though it was the second function who called the third function? So the second function is the function that defined the C variable and then called the third function, but still the third function cannot access variable C, which it is trying to print here, which as we see resulted in this error. So by now I'm sure that it's obvious to you that the third function cannot access variable C because the execution stack is different from the scope chain. And so to answer the question, who can access the C variable, the order in which the functions were called does not matter. All that matters is that the third function is in a different scope than the second function, and so it cannot access variable C. So which variables could the third function actually access? So try to figure that out by yourself. So did you get it? Okay, so it's variable A and D. So let's just test that. So I'm going to console log this one here and then do console.log A plus D. And if I run this now, then I have hello John. And hello is A and John is D. So these are the only variables that we have access to because they are in the scope chain for the third function. Great. This is really cool, right? You are already familiar with a lot of super important and advanced JavaScript concepts here and a lot of important theory. And I can absolutely guarantee you that you already know a lot more than a lot of JavaScript beginners. So this is amazing, right? There's only one thing that we have left in this section, and that is the this keyword. So let's go right to the next lecture where we are going to talk about that. See you there. So we have seen in this section that the creation phase of an execution context has two steps: creation phase and execution phase. So far, we have talked about the object variable creation as well as the scope chain creation, both part of the creation phase. I hope that you have followed along just fine, and taken a lot of notes so that we can now talk about the third and last step of the creation phase, which is determining and setting the value of the this variable or the this keyword. So the this variable is a variable that each and every execution context gets, and as we already know, it is stored in the execution context object. So where does the this variable or the this keyword point? In a regular function call, the this keyword simply points at the global object, which in case of the browser is the window object. And this is actually the default. Simple as that. In a method call, which as you remember is a function that is attached to an object, the this variable points to the object that is calling the method. And something very important about this is that the this keyword is not assigned a value until the function where it is defined is actually called. So again, even though it appears that the this variable refers to the object where it is defined, the this variable is technically only assigned a value as soon as an object calls a method. But armed with all the knowledge that you have gained in this section so far, this makes total sense, right? And that's because we know that the this keyword is attached to an execution context, which is only created as soon as a function is invoked, which also means called. So invoked and called are the same thing. Alright, so let's now check out some practical examples of this in the next lecture. After the theory about the this keyword, now comes the practice. So let's start and simply log the this keyword for this global execution context. So all we have to do is console.log this. And what can we expect here? Alright. So all this means is that the this keyword in the global execution context is very simply the window object. And that makes sense, right? That's because the window object is the default object, as we learned in the last lecture. Okay, let's comment out this part of the code and let's write a simple function. And once again, we're going back to our calculate age function, because we already know that so well. Alright, so console.log 2016 minus the year. And what we also want here is to console log the this keyword once again. This. Alright, and when we call this function, what can we expect this time? Actually, we have to write the function call up here. So calculate age, I'm going to go with 1985. So let's refresh this and try to guess what we're going to see now. So we first have the result of 31, which comes from this log here, and then the this variable is once again the window object. So does this make any sense to you? I hope so, because this is a regular function call and not a method. As we learned in the last lecture, in a regular function call, the this keyword always points to the window object. And it actually makes sense, because the object that this function is attached to is the global object. And it actually makes sense, because the object that this function is attached to is the global object. So it has to be the this variable here as well. Okay, so not a method, a regular function call. So the this variable is the global object. So let's move on to an object here. And we'll go back to our old John object. So name, John. And here's not a semicolon, but a normal comma. Then year of birth is 1990. And let's now add a method here, and it will be our calculate age method once again. So calculate age, and once again this is a little bit different than what we had before, right? Because this is like a function expression and not a function declaration. So in here we can also console log this keyword. But first of all, we have to perform the method call. And that's as simple as this. So we use John, and then we use to calculate age method on it. So what's going to happen now, and let me actually comment out this part of the code. All right. So the this variable now is the John object, and it makes absolute sense, right? Because as we know, the this keyword refers to the object that called the method. And in this case, it was the John object. So of course, it has to be the this variable. And we actually already saw this in action before in the introductory lecture about objects, but at the time we didn't really understand it, but now it makes total sense why the this keyword refers to the John object, right? And now it also makes sense why we can then use this to calculate John's age. So console log this dot year of birth, right? So let's run this again, sorry. And then we have final result. No, of course not, because it's of course 2016 minus this. All right, here we go. Now let's take this even a bit further here. And what we're going to do is to add a function inside of the calculate age function or method. So I'm simply going to call it inner function, okay? So this function will not really do anything. I just want to console log the this keyword in here as well. All right, and then we can call it, of course, inner function, and just like this, because it doesn't have any parameters. So now when we call the calculate age method down here, not only will these two console logs here happen, right? But also this function will be declared and then called, and therefore the this keyword will be logged as well. And now try to guess what the this keyword is going to be like. All right. So once again, the this keyword in here is the John object as expected. Then the outcome is of course 26 as we had before. But now comes something that looks rather strange, right? And that's the fact that the this keyword in this inner function here is now back to being the window. And this is a bit counterintuitive, right? And in fact, some people in the JavaScript community agree with this and others don't agree. Some people think that the this keyword in here should still be the object, is the John object, right? But to me, actually, it makes sense that it's not, because it's simply the rule. And the rule is that when a regular function call happens, then the default object is the window object. At least that's how it happens in the browser. So once again, this is not a method, because the method is calculate age, so it's a method of the John object. But this function here, although it's written inside of a method, it's still a regular function. So when we call it, the this keyword will no longer point to the John object, but instead point to the window object. Okay, and this is something very important to keep in mind for the future and also for a future project. And now that this is really crystal clear, let's now complicate things a little bit more. So remember how I said that the this variable is only assigned a value as soon as an object calls a method? So I said this was important, so let's now see an example. And for that, I'm going to create another object, which will be called Mike. Var Mike will be another object, and this name will now be Mike, of course, the year of birth can be something like 19 84. Alright. Now imagine that we want to calculate the age of Mike. So one thing that we could do is of course to go ahead and copy this calculate method here and paste it here in the Mike object. But we could be really smart and instead do something that's actually a very common practice in JavaScript and that we will also use more in the future, and that's something called method borrowing. So we are going to borrow John's method to use it on Mike. And how are we going to do it? It's very simple. We just say that we want Mike.calculateAge to be John.calculateAge. Simple, right? So you see that in this case we don't have the parentheses, because these parentheses are for calling a function. And now we simply treat the function here as a variable. And so we can say that we want the Mike.calculateAge function to be the exact same as John.calculateAge function, which is this one here, right? Alright, so if we now go ahead and use a function calculateAge, because now I want to really call it, so I use the parentheses. So now I'm going to go ahead and call the function. But first I will actually make it a bit simpler. So I don't want this code here anymore to get in my way. So I'm now going to call it, and what are we going to see? Alright, so from the John calculate age call here comes the John object and the 26 age of John. So exactly what we had before. But when we now call the calculate age method for Mike, which we had borrowed, then the object becomes the Mike object, and now we have Mike's age here. So this is truly amazing, right? And this proves what I had said in the beginning, which is that the this variable is only assigned a value when the object calls the method. So if it wouldn't be like this, then this variable here would always be John, right? Because it's in fact attached to the John object. But when we now call the same method from the Mike object, then the this variable becomes the Mike object. So again, the this keyword only becomes something as soon as the method gets called. And this is something really important once again. Okay, so I hope that this is really crystal clear now. And with this, we reach the end of our theoretical lectures. And for me, it's really good to see that you're still with me after all of these more theoretical lectures. And believe me that these lectures were really worth it, and they will absolutely make you a better developer over time. And even if you don't understand it now, I'm sure that you will eventually. And so from now on, we can build on what we've learned so far, and we can now focus even more on coding. So let's continue doing that right now. See you in the next lecture. So in this section, we are going to make JavaScript interact with a web page for the first time. And the technical term for that is doing DOM manipulation. So in order to do that, we need to first know what the DOM and DOM manipulation actually is. So DOM stands for Document Object Model. Now, the DOM is a structured representation of an HTML document that can be used to connect web pages to scripts or programming languages such as JavaScript. Imagine a very simple web page like the one we see here on the right side. We can say that each HTML element can be represented by a box like this, right? Now, the DOM is a fully object-oriented representation. So for each of these boxes, there is an object in the DOM that we can access and interact with, right from our JavaScript code. But before moving on, I just want to make crystal clear that JavaScript and the DOM are two different things. So what we have been doing so far was to just use the JavaScript language without any interaction with any web page. All we did was just to print some stuff to the console. But now we're going to use special JavaScript methods that allow us to interact and manipulate which means change, the DOM, and therefore the web page. And since I said methods, that means that they are functions attached to some object, right? And that object is the document object. So this is the object that gives us access to the DOM. Okay, once again, the HTML web page content is stored in the DOM, which can then be accessed and manipulated via JavaScript. And that is exactly what we're going to do in the project in this section. In case that you have no idea what HTML and CSS are, you're in the right place. Because in this lecture, I'm going to very quickly go over the most important parts of HTML and CSS, just by looking at the project that we will be working on in this section. So if you're already familiar with HTML and CSS, then please feel free to mark this lecture as completed and then move on straight to the next one. This is the starter code of the project that we will be working on in this section. And this here is the HTML document. Alright, so an HTML document is what always holds the content of our web pages. In HTML, we have elements which are composed of ending tags, content, and closing tags in most of the cases. We then write these elements into one another and like this create a nested structure. And there are different elements for different things, such as links, paragraphs, images, sections, etc. For example, the div tag here has this opening tag, this closing tag, and this content here in between. And in this case, the content itself are even more HTML elements. But eventually some of these elements have some plain text content here. For example, here, or here, or here. Okay, so HTML elements can also have attributes, which are these. So this is the class attribute, the ID attribute, or for example, the source or alt attributes. And there are a lot of different attributes. Now, probably the most used one is actually the class attribute, which is this one here. And it allows us to give a certain element a name. And IDs, which we have for example here, also allow us to give elements a name. But the difference is that an ID has to be unique, but a class name can be used over and over again throughout the pages. For example, we have player name here and then down here again, but we have, for example, the ID name 0 only here because down here it's called name1. Alright, so these are elements and attributes. Now about the structure of an HTML document, it is always divided into two parts, which are the header and the body. So the body is what we just looked at, and it contains the visible content of a web page. So it's basically everything that's here enclosed into these body tags. So that's it for the body. Now the header is what contains additional information about a web page, such as the title here or even some page keywords. And we can also do other things here. For example, in here we import into our code a custom font from Google Fonts and also an icon font, which will give us some nice icons that we can use to make our interface look nicer. And then here in the next line, but also still in the head of the HTML document, we connect our HTML file to a CSS style sheet, which brings me to CSS. So let us open our external CSS file, which is this one here. Okay, so if HTML is the content of the web page, then CSS is the presentation. And here in the CSS, we simply write rules to style our web page. So we have all these rules here. So here and all the way. So all this file is filled with CSS rules. And the way we connect the HTML with the CSS is by using usually class names. We can also use IDs or other selectors, but the most common one is the class selector. So this is the class name that we specify in the HTML. So let's go look at that. So player name, and that is right here. So the rule that we just saw here in the CSS styles all the elements which have the class of player name. And this here is the class selector. And if we go up here, we see another selector, which, for example, we have this one here. And this is called a type selector because it selects all elements with the type of body. So it simply selects the body of our web page. And we also have the universal selector, which simply selects all of the elements on the web page and applies these styles to all of them. Okay, so I think that is actually all I had to tell you. I hope that you got a small idea about HTML and CSS now. This should absolutely be enough to allow you to follow the next lectures, where we are going to need some of these concepts. If you want a full deep dive training into HTML and CSS, then you can of course try out my other course, which is called Build Responsive Real-World Websites with HTML5 and CSS3. Let's finally set up our project and take a look at the game that we will code, as well as the rules of that game that we will need to implement in order to make it work. So I have the starter code here on my desktop once again. So this code here that is available for download. So I'm gonna go to my text editor now and open up that project. And by now you already know how it works, right? So I go to my desktop and then hit open, and this text editor, so brackets, creates a new working project for me. Okay, so this time the starter project includes a little bit more than just a bare bones HTML structure. So this time we have a real user interface that I coded for this game here in HTML, as well as the CSS code for this project. And you can of course take a deep look at it if you want to know exactly how I coded that up. But on this project I want to focus fully on JavaScript and not how the HTML and CSS works in the background. Okay, so let's now take a look at the interface that I coded for this. And now as you see, I have the text editor here in full screen because now I need all the screen size that I can get. And I have the interface here on this side. So this is a beautiful interface that I created for our small little game, which is this one. So we have two players on left side and right side, and the goal of the game is to get to 100 points first. So I want to actually first take a look at the rules with you before I show it to you in action. So let's go back and open our JavaScript file, which is this one. And once again, I already connected it for you. So down here we have the script where we include the app.js file. Okay, so this is the file which is empty, except this comment here, which includes the game rules. So as I mentioned, there are two players and the game is played in rounds. And in each turn, a player rolls a dice as many times as he wishes, and each result gets added to his round score. But if the player rolls a 1, then all his round score gets lost, and after that, then it's the next player's turn. But in order to avoid that, the player can choose to hold, which means that his round score gets added to his global score. And after that, it's again the next player's turn. And the first player to then reach 100 points on the global score wins the game. So let's now see the game in action very quickly. So player 1 starts the game, and I'm going to start roll the dice. Alright, so I rolled a 4. So down here on my round score, I now have a 4. And I'm going to choose to hold, and then the 4 points get transferred to my global score, which we have up here in this big size. And now it's placed to turn, which we can see by this gray background, and here this red dot. And I'm going to roll a dice as well, and now I have 5. And I'm going to choose to roll again, and I rolled a 3. So 3 plus the 5 that I had before is now 8. And I'm going to choose hold as well. So now player 2 here is in the lead. Alright, player 1 once again. Now I'm going to roll the dice all the way until I roll a 1, which, as you know, will make me lose all of the score. So just to show you what happens. Alright, so I apparently rolled a 1 and lost all of my round score and nothing got added here, right? So I will now play with this one here, choose hold, and let's play this game until the end. And we have a winner here. Player 1 won the game. Alright, so this is how this game works. Super fun, right? I think it's really cool for a first real project. So let's go straight to the next lecture and start coding this. Now it's time to finally start coding up our game and put into practice what we learned so far about the DOM. But one more thing before that. From now on, in all the coding lectures of a project where we learn multiple new things and concepts in one single lecture, I will give you a quick summary like this one, so that you can later reference what we did in each lecture. And this will be very useful in case that you need to ever come back to these lectures later. And that being said, in this lecture we are going to learn how to create our fundamental game variables, how to generate a random number, how to manipulate the DOM, and how to read from the DOM. So here we are back in our JavaScript file. Let's create some empty space here. Okay. So one thing that I didn't mention yet so far is that this game is actually called the pig game. So if you try to Google this, you will then also find these exact same rules and also some variations that we'll maybe talk about later. Okay, but let's start. So we need to first create a couple of variables to keep track of the most important things happening in our game. And probably the most important thing of all is the score for each player. Now I could go ahead and create a variable for each player like this, score 1, set it to 0 and score 2 and set it to 0 as well. But we want to keep things clean, and so I only want one variable. So how are we going to do this? We are going to use an array. So I'm just going to call this one scores and set both scores to 0 in the beginning, right? Okay, and I also want a variable for the round score. And this only needs to be one value because we only have one score at a time, one round score at a time, right? So round score equals 0. Now let's keep our code a little bit more organized. So instead of doing it this way, I'm actually going to declare all of these variables up here like this. So var scores and round scores, and then remove the var from here. Okay, just like this. So these are the variables for the scores. What I also need is a variable which will tell me which is the current active player, right? And this variable is to keep track of the player that is currently playing. So let me declare it here actually. So active player, and then I will set it to 0. So 0 will be the first player and 1 will be the second player. And I'm doing it this way because later we will use this variable to read the scores out of this array. And since this array is 0 based, we need the 0 for the first element here and then the 1 to read or write the second element. Okay, so these are the basic variables that we need for now. We will probably add some later, but it's enough for now. So let's now think about the dice. So in order to create the dice, we need to calculate a random number, right? So let's call it dice. And of course, as you know, I need to declare it here. So dice. And now I'm going to use the math object. And the math object is a JavaScript built-in object that has a lot of properties and methods for mathematical constants and functions. that can be very useful for us to do this kind of calculations. And the random one is one of them. But let me actually show it to you in the console. So I'm just going to set this to some value and then come back later here. So to open the console, I'm opening Google Chrome, and actually I will simply open my file here. So the index.html file, which will then open our app and our user interface. Okay, so here we have it. So this is the default. So when we open this, we actually already have some pre-filled numbers here, as we can see in our HTML here. So you see here 43 is the score for player 0 and 72 is the score for player 1. Okay, but back to the console. I'll hit inspect and then head over to the console. Now let's start by using the math object. So math dot, and now there's a very handy method called random, which basically gives me a random number between 0 and 1. So if I run this again, it will give me another number, and another, and another, and another. So these are all different, right? Now I don't want a number between 0 and 1, right? I want a number between 1 and 6. So the first thing I'm going to do is to multiply this value by a 6. So let's clear the console. So if I multiply this by 6, then we will have a number between 0 and 5, right? So 0.9, 4.6. Okay, but you see the problem here, because these are decimals. But we don't want decimals. What we want is an integer, right? So there's another very handy function in the math object, which is called floor. And the floor method simply removes the decimal part of a number. So let's test it. For example, 4.6 will become 4. Okay, so what we should do now is to use this with the math random times 6, right? So I'm going to use math.floor of math.random times 6, which is what we had before. And now this will give me a random number between 0 and 5. So 0, 3, 1, 2, 2, 1, 4, 4, 3. Okay, so as I said, this will be a number between 0 and 5, but we want from 1 to 6, right? So all we need to do now to make this perfect is to simply add 1. Okay, so now this will give me a nice number between 1 and 6. So let's now copy this, and I did this in the console so I could show you the effects of the random number generator. But now we want this in our code. So I'm coming back here and paste it here. So now our dice variable takes this random number each time that it's defined. So let's now console log this dice. Can close up the console. No, actually we can't, of course. Alright, so 6. And if we now reload this, then this time we have 5, 3, 6. So as you see, this is a random number now. Okay, so this was the first thing. Now the next thing is to actually do some DOM manipulation. So let's do that. So as I said in the theoretical lecture, the object that will give us access to the DOM is the document object, right? So let's use that. Document. Now there are a couple of methods that we can use to select elements from our web page. And the most useful one, and the one that I use all the time, is query selector. So again, I need to use the dot and then query selector. Alright, and how does query selector work? So query selector is really to use because it lets us select stuff exactly the way we do it in CSS. The only difference is that it only selects the first element that it finds, but there's a solution for that I will show you later. But for now, what you need to know is that it's really easy to select things with query selector, because if we know how to select stuff in CSS, then we can do it with query selector. So let's now select something from our page. And what I want to do is to select this text here and put the value of our dice right here. so that we don't have to open up the console anymore to see our value, but instead we can print it right here. So in our HTML, we see that this 43 is right here. So in order to select this, we need to use this ID score 0. And if we wanted to do the same thing for the other player, which is player 1, then we'd have to use score 1. But now all we need is score 0 here. So we need a string here, and then, as you know from CSS, in order to select IDs, we use the hash symbol and then simply score 0. And that's it. So now we have selected the element. Now if we want to change the text in this element, then we need another method, which is the text content method. So text content. And now we can simply say that this should be the dice, which is the variable that we define up here. So I can now remove this and check out our web page. So let's now really close the console and reload this. And now actually the dice appeared here, not where I wanted it, not down here. So let's reload this. Okay, so the value appears here, but it's no problem, right? So 6, 6, and 6 again, and now 2, and 5. Alright, so this is actually working. Not the way we intended to, but it's still working. Because we actually had to select current 0, not score 0, because score is the global score and not the round score. So let's put it in the current. Great. Now right in the beginning we defined a variable called active player, right? So this was to keep track of the player that is currently playing, and we're going to use this variable to read and store values here, but also this number here is used in our HTML. For example here, for player 0, for score 0, and current 0. And down here we have 1, 1, 1. So we can also use the current player variable to select stuff, right? All we need to do is to build our string here. So I can do current and then plus active player, right? Because of type coercion, JavaScript will then convert all of this to current 0 if this is 0. But if it's 1, then it will be current 1, which is exactly what we had before. But now it's more dynamic because then we only have to write it once. So when we change the active player, then the score will be printed in the other label. So let's test this. So let's set this to 1 and let's see how this works. Okay, so now we have it here. Let's dice again, roll the dice again. So 6, 1, and 2, and so on. Okay, cool. So what we did was to simply change the content of an HTML element here. Now to change the content of a selection, there are actually two ways. So we used the first one here, which is text content, but there are two ways. And the text content that we have here can only set plain text, so no HTML. But if we want to put some HTML also in the selected element, then we have to use the inner HTML method instead of the text content. So let's see how that could work. So let me comment this out and write it again. So document.querySelector, and I want again the current one. What I'm going to do is like this, active player. And now instead of text content, I'm going to use inner HTML. And now I will write some HTML, which of course needs to be a string once again. Because if I would just write it like this without being a string, then the JavaScript parser would think that this is some JavaScript code, which of course, if we have something like this, then this is of course not JavaScript, and we would have an error. So every time we want to write some HTML here in our code, it needs to be a string. So let's now use the EM element here around the dice value, which will then emphasize it. So basically it will be an italic text. So dice, and then close this element. So let's see what happens now. Alright, so now we have this italic text here. So it is slightly to the side, right? This number 4. 4, 6, and so on, so on. Okay, so what would happen if we would simply do this with the text content method that we used before? Text content. So let's reload this once again. And then we would have all this text here, because once again with this method we can only set text and not HTML. So then it would interpret all of this HTML code as plain text. So this is not what we want. So this was just to illustrate you. Set it back to inner HTML, and I will comment it here, because what we want really is this. Okay, so we just did our very first DOM manipulation, which means that we use this query selector method here to manipulate, to change values in elements of our web page. Now we can also use this method to actually only read the elements from our web page and then store them in some variable, for example. So let's now do that. I will create some space. So let's simply create like a random variable, and this is just to show you var x, and once again document dot query selector, and let's now use something else. For example, the global score here, right, which is 43. So again, this is an ID, so I use the ID selector that we already know from CSS, and then score 1. And this time I'm just going to write it out like this, or actually score 0, because this is just to show you how we could use a query selector the other way. Okay, and now the text content. So this time we don't set it to equal anything, because again, this is just to read the value or the content of the element with this ID, score 0, and then store it here into variable x. So let's quickly console.log x so that we can see that this also works this way around. So I am going to hit Command-Alt-I to bring up the console, and let's now reload the page. And here we are. So 43, which is the value that we read from here, stored in our x variable and then printed right here to the console. So this works not only for setting, but also for reading. And in this case, when we do it like this, we say that it's a setter because we set a value, and in this case, we say it's a getter because we get a value. Alright, and now there's only one more thing that I want to show you in this lecture, which is that we can also use the query selector to change the CSS of some element. So let's now use the document object once again, query selector, which will return a selection, and I'm going to go back to the web page. What we want to do now is to hide this dice here right in the beginning. So when we open up the game, we don't want to see this dice with this random number here, right? So in CSS, we do that by setting the display property to none, right? So let's do that. So in our HTML, where do we have the dice? And it's right here. So it's this image here with the dice class. So this time we have not an ID, but a class. And to select the class, it is the dot selector. So all we need to do is dot dice. Alright, so this gives us our selection. And now instead of changing or getting the content, we want to change the style. So we first need to use the style method and then the CSS property that we want to change. And it's as simple as that. So as I said, we want to change the display property and set it to none. So we write display and then set it to none. And that's really it. So if you remember what CSS looks like, let's take a look. So this here is the property and this is the value. And in JavaScript, what we do is we use first the style method, and then this is the CSS property, and this is the CSS value that we attribute to this property. So let's see if this actually works by reloading this. And yeah, here we go. So our dice is now gone. If we now inspect this page, let's actually do this and go here to our dice, then we can see that with JavaScript what we did was to basically change the inline CSS and set the display to none here. So we also can see it in your HTML. So we now have the style attribute here and the display was set to none. Okay, and that's it for this lecture. Now the next step would be to actually display the value each time that we click our nice button here, right? Because right now nothing really happens. But what we want is to show our dice here and to show our score. And right now nothing of that happens. So let's do that in the next lecture. So let's continue our coding journey. And we're getting really close to having our first real JavaScript application. So by now you have already learned a lot of stuff about DOM manipulation and even other things. So in this lecture we will just continue practicing some of these things and implement another feature in our game. Alright, this is where we left our game. So let's now implement this functionality here. So when we hit this button, that the game starts from the beginning. So if we have a button and an event, then of course we need to listen to that event. So once again, we will use an event listener. So let's check out the name of the button, and it's simply button new. So document.querySelector and button new. And by now you already really know how to do this. So add event listener, and once again we are listening for a click. And we will once again use an anonymous function here, which by now you know in your sleep, right, what this is. Okay, cool. So what do we have to do when we want to start a new game? The first thing that I can think of is that we have to reset our player scores. So we set our scores back to 0 and 0. And we also have to say that the active player is back to being 0, because that's always the player that starts, so the first player. And also if there is some round score left from the last game, so from the game that we were playing, then we also need that back to 0. So round score should be 0. Okay, so if this is starting to look familiar to you, then you're not the only one, because actually we already wrote that exact same code up here, right? So this is not ideal, not at all. So once again, we should stick to our dry principle here, so not repeating our code. So what can we do here? And you guessed it, once again we are going to use a function. And I'm calling this one init function, because this is to initialize the game. And the logic behind this is that once again we will write a function, and then even before doing anything else, we will run that function, and this will then initialize or start our game. So not only when we hit a new game button, but also right in the beginning when we first load our application. So I'm going to delete this from here, okay. And I'm writing my init function now. So function, simply init, and again it doesn't receive any parameters. We just want to use this code. So I'm removing it from there and putting it right here. And then all we have to do is to simply call the init function right in the beginning. So the first thing that we do is to call the init function. And so that piece of code that we had here will then be run. Now the things that you see here are also things that are done right in the beginning of the game, right? So of course it also makes sense to include this right into our init function. So all the things that happen before we can start to play will now be placed right into this init function. So we call this function as soon as we load our application. But remember, we also want to call this function when we hit on our new game button, right? Okay, so we could do it like this. So we can simply call the function in here now, and that's it. But there's another way of doing this, because why should we create an anonymous function here, right? So this anonymous function only to then call another function. So it doesn't make much sense. Actually, as we set up our very first event listener, I told you that we can write any function in here, in this argument. So I'm just going to delete this, and what I can do now is to not call the anonymous function, but instead our init function. And actually I'm not calling it, I'm just passing it here into this event listener function, this method. And that's why I don't need to use the function call operator here, which is this one, because if I would, then this function would be immediately called, but I don't want that to happen. I just want to tell this event listener that, hey, when someone clicks this button, then please call the init function for me. So that's all that I'm doing here. So back to our game init function, which starts the game. Another thing that we have to do here is to actually change back the player names. So when someone wins the game, we print winner here. But when we start a new game, of course, we want to say player 1 and player 2 right there. So let's do that as well. And we know from up here, yeah, it's right here. So we know that these are called name and then the number of the player. And actually, let me just copy this from here, because by now we already know in our sleep how to do this, right? So we have to do this for name 1 and 2. So we don't need this active player variable here. So player 1, and now I'm simply duplicating it here for player 2. So player 2 here. And since we are using get element by ID for all of these IDs here, let me just do this here as well. So get element by ID. And now remember, we have to remove this hash symbol because this is only for the query selector. So this looks pretty cool. So let's now check this out. Alright, so let's roll the dice. Well, nothing's happening, so we probably have some bug somewhere. So let's open up the console. Alright, so we cannot say text content of null in line 93. So let's check out where that is. And of course, I did a big mistake here, right? And you probably already saw it coming, because the players are not 1 and 2, but they are 0 and 1. So of course I cannot set the content of an element called name2 if there isn't one on the page, right? So let's now load this. And yeah, so it actually works. So we already know that it works because before we had some different values here, not 0, 0, 0. But we see that our init function is already doing its work by setting everything to 0, just because we call it right in the beginning. So right here, before doing anything else, we call this function. So let's now play. Hold, and now player 2. And hold. And with this we can already win because remember, it's still set to 20. So I'm saying hold, and now I win. Cool. So now if I hit the new game, let's see what happens. Alright, so we are back to 0 points here and here. But what we still have is this winner class here, which formats this text arrayed, and also the active class. So we need to do a couple more things in our init function. So first thing is to remove the winner class. Let me actually check where we put this winner class. Alright, so we put it here. So let me copy this to make our life a bit easier. And just paste it here. Alright, so player 0, and this time I'm not making the same mistake. And now, not adding but removing. And since we don't know who won the game, we will simply remove this class from both. So it doesn't matter, even if the class is not there, we can call the remove method without any problem. And actually we will do the exact same thing for the active class. So a class that defines or that shows which one is the active player. So again, of course, only one of these is the active player, but we have to remove it from both because we don't want any of them to be the active player. And now only one thing to left, which is to set the first player to the active player. So I will just duplicate this line and set it to add. Now this sounds a little bit strange, right? First removing it and then adding it. But I'm doing this because imagine that player 0 was the active player. Then in this case, the active class would be there. And if I then call this method here, so this line, then another active class would get added. And then we would have two active class, and of course we don't want that. Because if we later went to remove that class, then there still would be one left, and then the styles associated with the active class would still apply. And we don't want that. So we need to always remove them. And actually let me put this down here so that the ones that belong together are together. So we first remove these two so that we are sure that no active class is anywhere, and then we add the active class back to the first one. And with this, we should be good to go. So player 2 is in the lead this time, but I'm still rolling a lot of ones. Alright, so I'm going to let player 2 win. So I click hold, and alright, player 2 won. Everything looks nice. So now look at these numbers and at here when I hit the new game. Alright, so this works just fine. Everything is back to 0. Player 1 is the active player, the winner class is also removed, and everything is fine. So if I play again now, let me hold it here. Okay, so I won. Now, it makes sense that the game stops with this, right? But instead, if I continue hitting this, the game continues. And now we have two active players, and all of this is really weird and not working the way that it should be. So there's one more thing to do, and that will be in the next lecture. So if you're curious on how to solve this problem, then don't wait and come right with me. Now the time has come to finally finish up our application with only one small thing to do. So in this lecture, you will just learn what a state variable is, how to use it, and also why to use it. And this is really something about programming in general and not just JavaScript. So remember that the problem here was that we can continue to play the game even after we have a winner here. So this starts to look really weird and really not what we want. So we need something called a state variable. So what is a state variable? It's actually very simple. A state variable simply tells us the condition of a system. So that's the definition. And we need a state variable when we need to remember something or the state of something. And in this case, this will be, is our game playing or is our game not playing? So we will simply create a variable that tells us this and that we can then use in our function. Because there are, of course, a lot of things that we only want to do when the game is active, when the game is playing. So let's do that. And keep in mind that we want to use the variable in a couple of places. So imagine if we would just declare it here, like saying var game playing is true. Now, if we declare it here in this init function, then would all the other functions have access to this variable? And I know that you know that the answer is no, because of the scope chain. So all the functions do only have access to the global scope or of course the scope of their parents. So here, the init function is really the only function that would have access to the game playing variable. So we need to define it outside, so right in the global scope. And that's also the reason why all of these are here in the global scope. So I'm just writing it here, game playing. Once again, I don't need to define it here, I simply need to declare it here. I need to say this is a variable that is defined here in this scope, so that I can use it then in other scopes, in other functions. Okay, so when we start our application, the game playing variable will be set to true. So let's now work through our functions here to our event listeners one by one. So this one is for the event that happens when we hit our roll button. So we create a random number for the dice, then we display, and then we update the round score. Now we only want all of this to happen when the game is actually playing, right? Which means that we don't have a winner yet. And that's because the game playing variable will be false only after we have a winner. So after this weird situation that we saw before happens. So by then we want it to be false. But before, all the time during our game, we always want this game variable to be true. So what can we do here? It's actually very simple. All we need to do is to add an if statement here. So if game is playing, then we do something. And why does it work like this? So why do we only need the game playing variable here and nothing else? It's actually very simple. That's because the condition that the if statement wants here is a true or false value. And usually we use an operator here which returns a true or false value. For example, down here, we check if dice is different to 1, and this returns either true or false. But in this case, the game playing variable is already true or false, so we don't need anything else. Okay, so now all we want is to have this code right here. So all this code is now wrapped in this if statement. So all of this only happens if the game is actually playing. So after the game is finished, we can push this button as hard as we want and nothing's going to happen anymore because this will be set to false. So let's actually set it to false before we forget it. So what do you think is the perfect place to set this variable to false? I will give you a minute to do that by yourself. Alright, so I'm sure you figured it out. And so the perfect place to set this variable to false is here, right? So this is where we detect if a player wins a game. So after he won, which is this condition here, so when his score is greater than 20, which I still have to set back to 100, so right here, we will turn this variable to false. So we say game playing should be false. And that's it. That's all there is to this mechanism. Simply setting our state variable to false will avoid this situation here. Of course, together with this if statement here, right? Now, what else do we have here? Okay, where is the other event listener? Ah, yeah, it's right here. And once more, we also want all of this only to happen if the game is playing. So we can only hold our points if the game is actually active, right? So we'll do the exact same thing here. So if game playing, then do all of this stuff here. And of course there's not an else, because we don't want anything to happen if the game is not active. Alright, and that should be enough to make our game work perfectly fine. Eight, 11. Okay, now this player's turn. Alright. So we have a winner, we have 22 points, and let's see what happens if we try to keep rolling our dice. So, nothing happens. The game has effectively stopped. We can also not hold. And let me check if we have any bugs in our code. Actually no, so no bugs here. So it's not working because we blocked it with our code. So our if statement is really working, meaning that our state variable game playing is currently false. Now if I hit this new game button here, then remember the init function is called, and the init function sets our state variable game playing back to true. So now it should be working again, right? So let's hope it does work. And yes, it does. Great. So another winner, and again it doesn't work. Alright, so that's it. That's the end. This is your very first JavaScript application, and it's fully functioning now, and it's really working great. So now I hope that you're really proud of what we have achieved so far together here in this course, and especially in this really cool section. You can play this game with your friends and then tell them that you coded this by yourself. How cool is that, right? Really, just go play this game with your friends and let me know what they thought of the game here in the comments. I'm waiting for it, really. Alright, if you still haven't got enough of this game, then here come not 1, not 2, but 3 coding challenges just for you. So after finishing this game, I had 3 ideas about rules that we could change in this game. So I thought that these were 3 really cool challenges for you to do. So here they are. So the first one is that a player loses his entire score when he rolls 2 6 in a row. So not just the round score, but really all of his score. So 2 6 in a row, and then the player loses his entire score. And then of course it's the next player after that. And one hint that I can give you about this is that you should always save your previous dice roll in a separate variable so that you can access the present and the past dice roll at the same time. The second one is that you add an input field to the HTML where the players can by themselves set the winning score, and so they can change the predefined score of 100. And again, I have a hint. So in order to read the value from the input field, you can use the value property in JavaScript. And if you can't manage to make this working, then this is a good case for you to use Google to figure out the problem. This 100 here brings me to correcting what we still had here. So we still had 20, but of course the original rule was that the game ended at 100 points. Alright, and so the third challenge is to add a second dice to the game. And in this scenario, the player loses his current score when only one of them is a 1. And for this one, you are going to need some CSS and of course HTML to position the second dice. So if you have a hard time with that, then you can just look at the CSS code that I provided for you. And if you still can't manage to do that, to position the dice, then you can simply watch that part of the solution, right? So I really encourage you to do all of these 3 challenges, because this really allows you to get immediate practice with the coding, but also with the thinking about these solutions. So that's really the best thing that you can do right now if you really want to learn JavaScript. And that is why I designed these challenges for you. Okay, and after you did all of them, then you can just check the solution that I have for you in the next video. This is the first part of the solution for the coding challenge that I just gave you in the last lecture. So let's start by creating a new file which has all of this code so that we don't mess up our original code. So I select and copy all of this, and now I'm just creating a new file here. And this one will be called challenges.js. So I paste all my code here, and I will put these challenges at the top. Don't need this one here too. And we already know the game rules. Alright, so here are our 3 challenges. Actually, another thing is that now I have to comment out this part of the code and link our new JavaScript file to this HTML document. So script, source, and now challenges. Okay. So let's start with the first one, of course. So a player loses his entire score when he rolls 2 6 in a row. So as I already mentioned in the hint, we need a variable where we can store the previous dice roll. So let's do that. And of course, we are going to do that right here in the function, which handles all of our dice number generation and displaying in the user interface. So our dice value is generated here. What I'm now going to do is to create a variable at the very end of this function, but still inside of this if statement that we added in the last lecture. So here I'm going to declare a new variable var last dice, And what I'm going to do is to set it to dice. So let me explain that. So we generate a dice number here, then we do all of this stuff, and then we check the dice number. So if we then store the last dice number, we can use that variable the next time that the function runs. But actually not yet, because this variable should not be declared here, but in a global scope. So let me simply create a new var here, last dice. And the reason for that is that once the function returns, so this function here returns, then the value of last dice will get lost if we only declare it in here. So for example, the value stored in this dice variable here will not be accessible to us after this function returns. But we need this last dice value the next time that someone hits the roll button. And that's because now, down here in our if-else statement, we are going to add another condition. So we want the player to lose his score when the current value and the last dice value are both a 6. So how do we do that? So dice must be 6. And now the boolean operators are back. So the dice value should be 6 and the last dice should also be 6. And then player loses score. And then, of course, we still also want this part here. So else, and then the rest of the code that we already had. Okay, so once more, at the end of this function, we stored the value that we rolled with our dice in an external variable. So a variable that was defined outside of the scope of this function here. So we do that at the end of all this code here, so that the next time that someone rolls the dice, we have still access to that variable and can then perform this check here. When we just rolled a 6 and we rolled a 6 the last time, then the player loses his score. And if this does not happen, then we of course apply the logic that we had before. Alright, so how does the player lose the score? Remember, we use the scores variable, which is an array, to store these values. So all we need to do is to set it back to 0. And such as we have done all the time, we use the active player variable here to define which score it is from the first or the second player and set it back to 0. So that's really simple. And then of course we need to update the DOM as well, so that on our web page we see this value 0 as well. So instead of writing it all over again, make it a little bit quicker, I will just get it from down here. So now it's not scores. Well, we could actually leave this as it is here because scores active player is now 0, but we can also just set it to 0, right? Because we already know that that is the value. And what also happens then is that it's now the next player's turn. And so therefore we once again use our next player's function that we created before to apply the don't repeat yourself or dry principle. And now this should work. So let's come back here and refresh this. So let's try. Actually I should hold because otherwise there's no score to lose, right? Alright, so we see we lost some score here. We didn't see it because it was too quick. So let me try it again. Alright, so here we had it. Once again we lost the score here after rolling 2 6 in a row. It's not really visible in the video, but I actually clicked twice and there were 2 6s and we lost the score. And I'm sure you will experience that for yourself as well. So in the next video we have the solution for the second challenge. Alright, here goes the second part for our current coding challenge. So this time our task is to add an input field to the HTML where players can set the winning score, and then we can use the value of that in our code. So let's start by doing that, and I'm going to put it right down here. So what we need here is an input element. So input and the type of text. So text, we also want a placeholder here which tells us a final score, and let's just call it with a class final score as well. Alright, so really simple. And now we also need to style it in our CSS in order to make it visible. And I will just put it here at the top. So the class selector and then final score. So this will be a bit of CSS. I'm not going to really explain this. I'm just writing the CSS that is necessary to style this, also based on the rest of the code that I already have here in this file. So this is a nice little technique to center it in a page. Translate x minus 50%. Okay, and from the top I want it at 520 pixels. The color is the same as the rest of the page. The font size should be 18 pixels. And we also need to set the font family for this one, which is Lato in this case. We want the text in the center. And also some padding, let's say 10 pixels. And we want the width to be 160 pixels. And we also want a text transform of uppercase. So you see that I care a lot about design. So this really has to look the way that I want it to be. So let's now reload and see how this looks. So here's now our input field. Let's just remove this weird blue border here that we have when we focus it. So final score focus outline none. Okay, so now back to our JavaScript. And the question to ask here is, where are we actually going to use this value? So the value that the user is right in there, the number, where are we going to use it? And the answer is, it will be in the part of the code which checks if the game is finished, so which checks if someone won the game. And this is exactly in a function associated with the event handler, which handles the event that someone clicks on the hold button. So it's right here. So right now we simply assume that the winning score is 100. But now we want to read this value from the input field and use that one. Let me just add it here in the code. So I'm going to call it input, very simple. So I'm going to select it using the query selector. We know that it's called final score. And now, instead of using text content or inner HTML or something like that, I simply use the value property. And this will give me the content that the user put it into this input field. And just to see how this works, let's console log this result to our console. So input. Alright, so let's now just check this out. I will reload this, open up our console. It doesn't have to be this big. Okay, and let's play the game and hold. And now we don't have anything here because this is empty, right? So if we continue playing, we will always have this empty here. So now it's twice the empty because we already clicked 2 times here on hold. Now let's put 50 here or something. Continue to roll the dice and click hold. And now it's 50 down here. Cool, right? So we can continue to roll and hold and then change this value to 200. Roll the dice, hold, and now it's 200. So the winning score by now would be 200. So the players can even change this during the game. Alright, so let's now use this value. So don't need this anymore. And alright. Now what happens if the users don't put any input into that field? Then we don't want to use the value, right? So we first have to actually check if there is a value. So we need to check if the input variable is not empty. And that's actually also pretty easy to do. And that's because, once again, type coercion. And I will actually write it down, which is that all the values of undefined, 0, null, or even the empty string, like this, are coerced to false. So if we have a condition like in an if statement, and I'm actually going to write it. So if we have something like this, so a condition here, then JavaScript will try to coerce this value here to a true or false value, so to a boolean. And in case that the variable that we have here is set to undefined, to 0, to null, or to the empty string, then these are coerced to false. And anything else is coerced to true. So if we would check this with something else, for example with the scores variable, so if scores, then this would return true, because it's not undefined, not null, not 0, and also not an empty string. In this case, the value of this input when the user doesn't put anything into the field is actually the empty string. So we only want to use this input if it's not an empty string, so when it's true. And down here in this if statement, we actually already have that. So if there is an input, so if input is true, then we want to do something. And that something is to create a new variable called winning score, in which we then store that input. And we need to do that because in the case that we don't have an input, we can store something else in that variable. So winning score is then the original 100 that we defined before. And so now, instead of always using 100 here, we use the winning score. And of course, this variable definition should not happen here, but outside from this if-else statement. So I'm just putting it here. And alright, here we go. So once again, when there is an input, which means that when the input is coerced to true because it's not the empty string, then the winning score will be set to the value that we just read from our input field. But if there is no input, then the winning score should be 100. And we can then use that winning score down here. So let's now check this in action, reload our page, and input a 10 here. So this should be a really quick game. Alright, and yes, it works, so we have a winner here. Nothing else works, so the game has finished as usual. And so we can now try this out with another value. So we could even start without anything, holding again, and then setting it to, say, 20 or 25. And we still don't have a winner. But now we should have. And yes, player 2 won the game. Alright. So, challenge 2 completed. For solution of challenge number 3, just go to the next video. Finally, here goes the last part of the solution of our coding challenge. And this coding challenge is a really fun one, because this time we have to add another dice to the game, and then we will have 2 dices instead of just 1. So let's now do that. So the dice is down here, and I will just duplicate this line, and now we have 2 dices. And since they are different, we need a way to identify them both separately, and therefore I'm going to create an ID called dice1, and down here we will have an ID. And you can imagine that this will be dice number 2, right? And now just for the CSS, it's also quite simple because all I have to do is to position them. So I just need to specify their top. So top of this one will be 120 pixels, and then duplicating it, and 250 pixels for the second dice. And since they both share the dice class, all of these rules here appear to both. Alright, so let's, before we start coding, See how this looks? Actually, we cannot really see how this looks because one of the dice gets hidden, and that's because of the code that we wrote exactly to hide the dice. So maybe let's start by changing that code. So it's right here. So as I mentioned right in the beginning, probably in one of the first lectures of the section, the query selector only selects the first occurrence of the elements with this string here. So we could use the query selector all method here, and then we would have to use a for loop or a while to loop through the results. And we will do that later in the next project, but for now, let's keep things a bit simpler. And I will therefore just use the select element by ID method here. So I don't want this anymore. I'm just going to say document.getElementById, and the first one is called dice1, and I'm just going to set its style, or better, its display property to block, so that we can see it here. And the same thing for the second one. So we don't need this one anymore. And now, since this variable here is gone, I will also simply go ahead and replace this code with this part here. Okay, so dice1 will be the value of dice. Now, we still only have one dice value, right? So we need to fix that as well. So I'm going to create dice1 instead of dice, duplicate this line and create dice1 with the exact same formula. So if this runs twice, we already know that the math random always generates a different number, so these will be two different numbers. Not always, but generally there will be two different numbers. So now here it's dice1, and then duplicating this line we will have dice2 here, and then the value of the random dice roll. Alright, and now down there, in the places where we actually hide the dice, now I will need to change that as well. So for example, in here we have the dice. Now we need to put it to none for both, and the same thing here as well. None and none. Now maybe you're thinking, oh, I'm repeating a lot of code here. I could just create a function instead. And yes, that's true. You could actually create a function called hideDice, for example, and replace this code by that. And would actually make some sense, but in the solution of this coding challenge, I'm not going to do that. But of course, you can try it out and then see for yourself that it's going to work too. Okay, so here we are back. And actually let's comment out this part here from the last challenge. Actually this one as well. So we don't need this less dice thing, okay? Because what we want is only this, what we had before. Or let me just copy it from the original, okay? So it's less confusing like this. So we want the original part, so this. Okay. So this is what we had before. If the dice is different to 1, then everything happens normally. But now it's different, because now it's enough for one of them to be 1, and then we lose our score and the next player's turn is. So what has to happen that we can continue playing and that our score gets added? So the first dice, of course, needs to be different from 1, and at the same time dice 2 also needs to not be 1. So this solves coding challenge number 3, and let's now test if this actually works. So in the beginning there's no dice, as we know. Now if I roll the dice, okay, so here we have now 2 dices. But there's still one problem, because here we don't have a number right now. So actually the problem is not yet solved. So let me look at the console here, and there we have an error. And an error happened in line 32, where we see that we still were using the old dice value. And actually, yes, we did. So of course we don't want the dice here anymore. But now what gets added to our score is not only dice 1, but of course the sum of these two. So dice 1 plus dice 2. So that's what we're missing here. So closing this, and once again, roll the dice. And yes, now 4 plus 2 is 6. Hold it, and then next player, oh, and he once again rolled one of them was a 1, so it's right back to player 2. So yeah, this was challenge number 3 with 2 dices. So we did 3 nice changes here, which hopefully helped you get a bit more practice with your JavaScript. Alright, so see you soon. Let's now finally write some code to use the concept that we talked about in the last lecture. And I will start by opening up the starter project that you can download for this section. And once again, it's on our desktop already. So I just need to open it. And here we have the HTML file, which connects with our script. And here's just the empty file. Alright, so this lecture will be about creating objects using the function constructor. So I'm just writing it here to structure our code better. So I'm going to start by writing our well-known John object, right? So John with the name of John, of course, and the year of birth. And then our job. So this is the way that we have been writing objects using the object literal, right? And now imagine that we wanted to create a lot of objects with different names and ages and jobs. So as we learned in the last lecture, we can use some kind of blueprint for this, right? So in JavaScript, there are a couple of different ways to create objects. But probably the most popular way is using something called a function constructor. And this is a very common JavaScript pattern. And the pattern is something like a standard way that we have to solve a problem always in the same way. So the function constructor is a pattern for like writing a blueprint, such as we have been talking before. So the name function constructor implies that we're going to use a function here, right? And we want this constructor to be called person. So we create a function called person, and the usual convention in JavaScript is that we always write function constructors with a capital letter here, right? So person is with a capital P, okay? And we always do this for function constructors. All right, so function, and the parameters for this function constructors will be the variables that we want to set in our object. So in this case, it's going to be name, year of birth, and the job. And now I'm just going to show you how this is done, and I will explain to you why this works just in a second, okay? So what we do is to attach these variables, so these arguments, to the this variable of this function's execution context. So just like this. So this.name, and remember that the this variable is simply an object as well, so we can do it like this. So this name will be name, which means the one that we get here as an input for the function. So this dot name will be equal to name, which is the parameter of the function, and then the same thing for the other two. So this dot year of birth will be equal to year of birth. And then this dot job will be the job that we pass into the function. And that's it. This is the function constructor. And again, I will explain to you why this works in a second. Alright, and now that we have this function constructor in place, we can then use it to create a John object. So let's create some space here and then var John, we call new and this is the new operator, new person, and then we pass our arguments into the function. So we already know our arguments, so 1990, and then the job teacher. So this is how we create new objects using the constructor function. And this is called instantiation, because these objects here are instances of the person object, as we learned in the last lecture. Alright, and as promised, I'm now going to explain you how all of this works. So first, in order to understand how this works, we need to first understand what the new operator does. So when we use the new operator, first a brand new empty object is created. Alright, so an empty object, this is important. Then after that, the constructor function, which in this case is person, right, is called with the arguments that we specified. Okay, so first an empty object is created, and then the function is called. So, and as we already know, calling a function creates a new execution context that also has a this variable, right? Now, we know that in a regular function call, the this variable points to the global object, right? But if we now look at our function constructor here, then having the this variable pointing at the global object wouldn't be so useful, right? Because like this, we would simply set all these properties on the global object. And that's of course not what we want. And that's why the new operator takes care of this. And it makes it so that the this variable of the function points to the empty object that was created in the beginning by the new operator. Remember that? So again, what the new operator does is to point to this variable not to the global object, but to this new empty object that was created in the beginning when we used this operator. So then after that, when we set the name, year, and job properties to this, then that's the same as setting them right on our new empty object. Okay, and finally, if the constructor function does not return anything, and as you can see here that is clearly the case, then the result is simply the object that was created in the first step. So this new empty object here. And this empty object, which was created here, now has the properties that we defined. So the name, year of birth, and job in this case. Okay? And then finally all of this is simply assigned to the John variable. And just like this, we created an object called John simply by calling a function constructor. So again, our new operator here first creates an empty object, then it calls our function with the this variable not pointing to the global object, but to the new object that was created here. And then when this code here runs, the this variable is no longer the global variable. And so these are all set on the new object, which is then in the end assigned to this variable. So I hope that makes sense. So let's now add inheritance to the game. And for that, we are going to bring back our calculate age function. So let's now suppose that we wanted to add a method to our objects. And that sounds easy, right? We could just add it to our function constructor like we would do with a normal object. So just like this. So this.calculateAge, it's simply a function which logs to the console the age. So 2016, we already know this by now, minus this dot year of birth, right? And now we can actually use this, and it should, of course, work. So john.calculateAge, and let's now open this. And that's not what I wanted, so here we are. And in a console, and what's this here? Now it's nothing special. So now it's all right. So 26 is our expected outcome here. So everything works just fine. So let's now create a couple of more objects here for more people. So var Jane is also a new person, and this is going to work the exact same way, right? So now I say Jane was born in 1969, let's say, and she's a designer. And it will also create Mark. So a new person called Mark, obviously. He was born in 1948 and he is retired. So if I now run this, then each of the object that is now created has the calculateAge method attached to them, right? Because it's right here in the constructor function or the function constructor of all of these three objects, right? So again, each of these objects now has the method. Now in this case, it's just one function with one line of code. So this is no big deal. But now imagine that we had 20 functions in each object and that each of them would have 100 lines of code. Now that would not be very efficient because then we would have 3 copies of the exact same thing, right? And that is exactly why we use inheritance in the exact same way that we have learned in the last lecture. So what exactly did we learn in the last lecture? So we've learned that we have to add all the methods and properties that we want to be inherited into the constructor's prototype property. And that sounds difficult, but it's really not. So let's just do this. Just creating some space here, and I will actually do it here. So all we have to do is to say person.prototype, because as I was saying, it's simply a property. So all we have to do is to use the dot and then prototype, and then we can add our function there. So calculate age and then our function. And I can actually copy it from here because it's the exact same code. Okay, and now I'm going to remove it from here. So right now, if I reload this, effectively none of the objects have the calculateAge method really attached to them, but still they are going to be able to use it. They will have access to it because it's in their prototype, right? So let's prove that. So I'm going to put all of these together and then call these methods on all of them. So calculateAge for Jane and also for Mark. CalculateAge. And if I now reload this, here is the result. So all the 3 ages for all the 3 people. So again, the method is not anymore in the constructor, right? But we can still use it. And that's because it's in the prototype property of our function constructor. So inheritance actually works, and this is inheritance in practice. So this is really great, right? This is so powerful. You just really understood how this works and how it works behind the scenes. So you can not just use it, you can also understand why this works. And this is really extremely powerful and it's really great for you. So attaching methods to the constructor function's prototype property is something that is really common to use. We can of course also add properties instead of methods, but that's not really common, but I still want to show it to you, okay? So such as we did with the method here, we can do the same with properties. So once again, person.prototype, and now we can say, for example, a last name property. And we can say that they should all be called Smith, right? Because as we know, this will be inherited for all of them. And once again, I want to prove that to you. So let's console log this property. So first for John dot last name, and then for the other 2. So console.log Jane.last name and then Mark.last name. So let's see what happens. Okay, so all of them are called Smith. So once again, this property is not directly in the object, right? But we have access to it because it's in the prototype property of the function constructor. So all John, Jane, and Mark inherit this property. So once more, we proved that inheritance really works. And this is a really big deal. So if you understood this lecture and the last one, then you are well on your way to become a really great JavaScript developer. What I want you to do now is to create your own type of objects to play around with constructors and prototypes a bit. And this way you can consolidate what you just learned here. So I hope that sounds like a great idea for you. And then after that, let's go straight to the next lecture. The JavaScript console in our browsers is a very powerful tool to inspect objects and the prototype chain. So let's now quickly see how we can do that in practice. So I'm first going to show you how we can inspect the object that we just created in the last lecture right here in the console. Because the console is not just to log some stuff here into our console like we've been doing, but also to do more powerful stuff like inspecting objects. So let's first clear this, alright? And now we simply have to write the name of our object. So you see this is a person object, and then our name, year of birth and job. But now if we hit this little arrow here, then we get a lot of additional information about the object. Alright, so first here we can see all the properties that we added to this object. So the job, the name and the year of birth that we associated to this very particular object. So everything is correct here, right? Now down here we have something called the proto. And this is in fact the prototype of the John object, which is, and I'm sure you remember this, the prototype property of the person constructor. So let's take a look at that. Okay, so here we have the calculateAge method that we added to our prototype here, right? So here we said person prototype calculateAge, and so we can see the calculateAge method here in the proto, which again is John's prototype, and therefore it's the prototype property of the person function constructor. And we also have the last name property that we also added. So let's also quickly take a look at person.prototype. Okay, and let's get some more space here for our console. So we see that this is in fact the exact same thing, right? This and this. Here it looks the exact same way. And just to prove you that John's prototype is in fact the prototype property of the person, I can actually do it like this. So proto, and then let's see what this comparison operator now is going to give us. Okay, true. So all this means is that in fact the prototype of John is the prototype property of the person function constructor. But I'm sure that you know this already by now. So let's go back to our John object here. And actually I'm going to clear this and write it again. Alright. So this is the proto. Now if we look at the prototype of John, we see that there's also a prototype here, right? So let's open that. And here we see that this is the prototype property of the object constructor. So as I said right in the first lecture about the prototype chain, all of the objects are actually instances of the object, right? So let me open this again. Okay, and so here we have a bunch of methods that are associated to the prototype property of the object function constructor. So again, this one here is the prototype property of the person function constructor, and this here is the prototype property of the object function constructor. And that's because the person function constructor is in fact an instance of the object function constructor, right? And that's why we can see this whole prototype chain here, right? So as I said, this console here is really useful to visualize this prototype chain and all of the prototypes that are in it. So as we already know, we have now access to these methods here, right? And that's right to our John object. So thanks to the prototype chain on John, we can use these exact methods that are here. And now I'm going to use the hasOwnProperty method just to show it to you, because it can be useful sometimes. So we can use this method to ask basically if an object has a property or not. So we can do John dot hasOwnProperty and then job, for example. And this is true because this object has a property called job, right? Now, if we try this with the last name property, then it's going to give us false. And that is because this is not John's own property. So this method only looks for own properties. This is a property that we inherited from the prototype. It's not really John's own property. And that's why this gives false. And this method can sometimes be quite useful. And now there's another operator that I want to show you. And this one is called instance of. So I'm going to say John instance of person. And this is also like a question because it will also give us true or false. And in this case, you can probably guess that it's going to give us true. So John is of course an instance of person because we created it through the person function constructor. And this one can also be useful sometimes. Okay, and with this we inspected our John object and the prototype chain that we just created. Now there's only one more thing that I want to show you, and that is to prove you again that almost everything is an object. So let me create an array here, just like this, just a very simple one, and let's now get some information about it. So if we just hit X, not a lot is going to happen. We cannot inspect this object right now. So we need to use console.info, and now we will be able to look inside of this object. And this is what we see. So we see the elements, and then we also see this length property here, right? And do you remember this length property? We use it all the time, for example, in our loops, right? And so now you know where this actually comes from. It used to look a bit like magic, right? But of course it's not. So it's always stored right here in this array instance. And that's why we can very simply use this property. So something like this. So x.length is 3, simply because this is stored right into this array object. Alright, and it gets even better because down here we can also see the prototype of this array, which of course is the array function constructor. So this is another function constructor that is built right into JavaScript and allows us to simply build arrays. And here in its prototype property, we can see all of these methods that we have already used before, like pop and push here, right? Or we used unshift as well. So all these methods are right here in the prototype property of the array. And that's why we can use them. So did you never wonder why we could simply call the push method or something like this on all of our arrays? So now you know, it's because of the prototype chain. So all the arrays that we ever create will always have access to these methods because they are stored in their prototype. And that is how useful inheritance really is. So I hope things are really starting to make sense for you now. So let's now move on. In this lecture, we will talk about another way that we can create objects that inherit from a prototype, and that's the object.create method. So we have seen the function constructor pattern to create objects from a blueprint in the last 2 lectures. But there are more ways to create objects and inheritance. So let's talk about the object.create method now. And let's first comment out this code here. Okay. So this is object.create. Alright. So with the object.create method, things work a bit different. In this case, we first define an object that will act as the prototype and then create a new object based on that very prototype. So let's do that right now. And we're going to recreate the person example that we used for the function constructor lecture. So first we have to write the prototype as a simple object. And I'm going to call it person proto. So person proto, and now you see we no longer use the capital P in the beginning because it's not a function constructor. And what I want in the prototype, such as before, is the calculate age method. So we already know why and how inheritance work. Now we're just doing it in a different way. Instead of using function constructors, we will do it the object.create way. So it's simply a different way. Alright, so calculate age and function. And again, I'm going to console log it 2016 minus this dot year of birth. Now there is no year of birth here anywhere, but we're going to take care of that later. Okay. And now let's create John again. So we simply say object.create, and then we simply pass it the object that we defined to be the prototype object, which will be person proto. Okay, so let's see this in the console. Alright, and I'm not gonna console log this, so I will just do it the way we did before in the last lecture. So John, and here is the object. And now it's empty, there's nothing here, right? But we still have the prototype, and this already has our calculate age function. So this looks a little bit like before, doesn't it? Now we just have to fill this John object here with our data. So we can simply do it the old way, right? So John.name is John. John.year of birth is 1990. And John.job is teacher. And if I reload this now and say John, then here we have our object. And it looks a lot like it did before with the function constructor, right? So we have our data here, the job name and year, and then the prototype, which contains our calculate age function. However, it was not ideal the way that we had to fill this here, right? So the object that we created was empty, and then we had to fill it here with the data. So this time we're going to do it a different way because the object.create accepts a second parameter. So let's now do that for another person. So Jane, object.create, and of course the prototype is again person proto, but then we can pass a second argument, which is an object specifying the data that we want to have in the object. So name, and now we cannot simply put the name here, but we have to do it in this rather strange way like this. So we have to say value, and then we can say Jane. Okay. So this looks a bit strange, but it's actually how it works. So there's no way around doing it like this. So year of birth, and then again value, and 1969, and then the job, and once again value, and then designer. Okay, and let's now reload this, and John again, and Jane. So both share the same prototype, as you can see here, because both have the calculate age method, and then they have both their own type of data in there. Okay, so let's think about this again. The difference between object.create and the function constructor pattern is that the object.create builds an object that inherits directly from the one that we passed into the first argument. While on the other hand, the function constructor, the newly created object inherits from the constructor's prototype property, right? So that's the big difference. And I hope this makes sense to you. Actually, one of the biggest benefits of object.create is that it allows us to implement a really complex inheritance structures in an easier way than function constructors, because it allows us to directly specify which object should be a prototype. Alright, so function constructors and object.create will be the most common ways of creating objects that you will find the most when you're looking for tutorials on the web. And that's why I showed you both in this course. But the most popular though is still the function constructor. And so that's the one that I'm going to use mostly in the rest of this course. Before moving on from the topic of objects to the topic of functions, I just want to very quickly compare primitives and objects. We actually talked about this very briefly at the beginning of this section, but then we were too busy talking about the prototype chain and those important things. But let's get back to it now. So let's get first rid of this code here. All right. So, primitives versus objects. And we basically know that only numbers, strings, booleans, undefined, and null are primitives, and that everything else are objects. And we already know a lot of differences between the two, so let's now compare them even more. So a big difference between primitives and objects is that variables containing primitives actually hold that data inside of the variable itself. On objects, it's very different. Variables associated with objects do not actually contain the object, but instead they contain a reference to the place in memory where the object sits, so where the object is stored. So again, a variable declared as an object does not have a real copy of the object, it just points to that object. So let's see this in practice. And I'm going to start with primitives. So let's define a couple of variables. So let's simply call it a and set it to a random number. And then let's create variable b and say it should be equal to a, okay? So b is now also 23, right? And now I'm going to mutate a, which means to change its value, and I'll change it to 46. And let's now simply console log a and b. A and b. So 46 and 23, that's what you expected, right? So a is 46 because we changed it from 23 to 46 here in this line, and b is 23 because up here we said that b should be equal to a, right? So what we did here was to simply copy the value of a to b. And when we then changed a to 46, this did not affect the value of variable b, which still is 23. And this means that each of the variables actually hold their own copy of the data. They do not reference anything. So two variables holding primitives are really two different things. So let's do something similar with objects this time. So obj1, so this is our first object named John, and then just set the age to 26, okay? And now something very similar, I just say object2 equals object1, okay? Such as we did before with b equals a. And now I'm going to mutate the age on object1. So .age, and I'm going to change it to 30. And then let's console log the age on object1 and duplicate this line and object2. All right. So we have a small bug here, all right? So because this should be object 1, of course. Right, so what happens now? Okay, they are both 30. So object 1.age and object 2.age are both 30. And that's really strange, right? Well, not really actually. And that's because when we said object 1 should be equal to object 2, we did not actually create a new object. No copy was created here. All that we did was to create a new reference which points to the first object. So the object 1 and object 2 variables both hold a reference that point to the exact same object in the memory. And that's why when we change the age on object 1, this change is also reflected on object 2, because in fact it's the exact same object. So this is some really interesting stuff, right? It took me some time to actually understand this. Now with functions it works in the exact same way. So let's see what happens when we pass a primitive and an object into a function. So let's create some space here. Objects. These were the primitives. And now functions. So I'll start by creating an age variable. Okay, and then another object. And this time it's not going to be John, this time it's me. So Jonas. And I will say the city, and that's Lisbon, so the city where I'm currently located. And now we write a simple function which I'm just going to call change, and it receives two parameters, a and b. And all this does is to mutate the data. So we want a to be 30, and we want b dot city to be San Francisco, for example, because it's a really nice city, you know? So now we're going to call this function, and as you can guess, we are going to pass age as the a variable, so as the a argument, and the object as the b argument. Okay? And now, once again, we will simply console.log the result to the console. So the age, and then console.log obj.city. So what do you expect is going to happen now? And let's see. Okay, so 27 is age, and this object city, so the city attached to the object variable, is San Francisco. So we have the same thing here. We pass the age variable holding a primitive and the object variable holding a reference to an object into our function. This function then, as it was invoked, attempted to change the arguments that we passed into it. So when we then console log the values, we see the same thing as before. And that is that the primitive has remained unchanged, but the city in the object has changed from Lisbon to San Francisco with this line of code here, right? So this shows us that when we pass a primitive into the function, a simple copy is created. So we can change a as much as we want. It will never affect the variable on the outside because it is a primitive. But when we pass the object, it's not really the object that we pass, but the reference to the object. Okay? So again, we do not pass an object into a function, but only the reference that points to the object. So when we then change the object inside of the function, it is still reflected outside of the function. So I hope that this shows you that it's really something very important that we should really be careful about, right? Because this can lead to some unexpected results and some strange bugs. And that's why it's super important that we have this information now. Cool. So let's now go to the next lecture right now. Now that we have learned a lot of new stuff about objects, let's switch to another topic, functions. And actually, it's not a completely unrelated topic, because we already know that functions are also objects. And that being said, it makes sense that with functions, we can do the same things that we can do with objects. So let's see some facts about functions. First, as we already know, a function is an instance of the object type. And because of that, a function behaves like any other object. We can store functions in a variable, and we already know that. And we can pass a function as an argument to another function. And we can also return a function from a function. And because of all that, we say that in JavaScript, we have first-class functions. So let's see a real-world example of how functions can accept other functions as arguments. And actually, we already did this. Do you remember the Pickgame project that we coded before? We set up some event listeners back then, right? And we passed a function into each one of them in order to handle each event. So back then, we already used first-class functions, but we didn't just know it. Alright, so let's now imagine that we have a couple of arrays filled with values and that we wanted to do some calculations with them. And a birth year array could be a good example of this. So let's write an array with some years in it. So 1990, 1965, 1937. I'm just going to write 5 numbers here, so 5 years. 2005 and 1998. Alright, so 5 years. So remember, we want to do some calculations with these values, or based on these values. Now, we could do a huge function which does all of these calculations that we want to perform at the same time, and then results all the result arrays at the same time. But that would not be really good practice, because instead, we can write a function that will receive an array and return a new result array and do the calculations based on a function that we pass into the calculation function. So let's write that calculation function and call it array calc. So function array calc, and what we're going to pass in here is the array, which will be, for example, the years array, and then we will pass a function which does the actual calculations. So let's see what this function does. So in here, we will simply loop over the array and return a result. So the first thing is to create a new empty array, which will be the one that we're going to fill and then return. So var r for the result. So I'm just going to say res here. And it's an empty array. Alright, and do you remember how we loop over arrays? So we've always been doing it using the for loop, right? So let's continue doing it this way. So we set up a new variable I, which is our counter, set it to 0, and then loop as long as I is smaller than the length of the array that we input, right? And by now you already know how this length property works, right? And then after each loop, we increment our counter by 1. Okay, and so down here, inside of the loop, we will then use the function that we can pass into this function. So we will push something into our result array here, right? So we can do it like this. We use the push function, or the push method, to be correct, which, as you remember, inserts an element at the end of an array. Okay, so the big question here is, what are we actually going to push into the array? And the answer is that it will be the result of calling our fn function. So fn, and then we pass the current element of our input array into this function. Array I. Okay? And this will make a lot more sense after you see one of the functions that we're going to program next. So I will explain it a little bit better by then. And now all we have to do is to actually return this result array. So return, of course, the res. So let's now quickly write one of the functions that we can then later use here as our fn function. So we will write a couple of simple functions that do only one single task. And these functions will actually be called callback functions because they are functions that we pass into functions that will then call them later. In this case, our callback function fn will be called here when we want to push a new element into our array. So let's now write one of these functions, and it will be our well-known calculate age function. So let's do it like this. Function calculate age. And this time I'm simply going to call it L, which stands for element, okay? And we're going to return 2016 minus the element. So this was usually called our year of birth parameter, right? But this time we're simply going to call it EL. So this is one of these simple functions. So you see it only has one task. It receives this L argument and then returns the age based on that argument. So really simple. And now our array calc function can make a lot of more sense, right? So let's see what happens here. So again, we have our empty array here, and then we start looping through the array that we input, which is, for example, this array here with all of these birth years. So when we then hit this line in code here, what's going to happen is that our callback function fn will be called with the I element of the input array. So imagine in the first loop I is 0. So with this ri, we're going to retrieve the first value of the years array, so 1990, and then we'll push this 1990 into the fn function, which will be calculate age, right? Then this function does its work, and it returns 2016 minus 1990 in this case. And then the result will simply get pushed into the array. And after this is completed 5 times, then the result will be returned. So let's see this in practice and actually call the array calc function. So array calc with our years and calculate age as the callback function. So again, I'm not going to call the function right here because this way I would need the parentheses like this, right? But that's not what we want. We don't want to call a function here. We want it to be called later by the array calc function. And that's why it's called a callback function, because it's called later. So we simply pass this variable, which is this function, right into this other function. Okay, now we just have to store this into a variable, because other way we cannot really see it. So I'm going to call it ages, right? Then we just need to put the correct name here. And then let's console log this array. Ages. So let's see if this works. Okay, so we have a small bug here in line 109. You see? So line 109. And here I see the error. It's not a comma, it's a semicolon. Okay, let's try it again. And now we have our ages. So this actually worked. So our array calc function looped through the years array 5 times, right? And 5 times the calculate age function here was called and then pushed the result right into the array that we then returned. So again, we can imagine this function as a generic machine that loops through an array, and we can tell that machine what to do with each element in the array. And that's what we do with our fn parameter, which is the callback. Okay, so let's now write another callback function so that you can really see how powerful this pattern can be. So let's now write a function which can determine if someone is of full age. Okay, so function is full age. And again, we're going to receive an element simply here. So we just use a very generic parameter name here. So this time we're simply going to return if the element is greater or equal to 18, right? So we simply want to return a true or false value, and that's what this comparison operator here returns, right? So if the element is greater or equal to 18, it will be true, and otherwise it will be false. Okay, so let's test this one as well. Down here. And this one I'm going to call full ages. And then again we use our generic function, which I like to think of as a machine, and then we can use that as an input, the ages array that we calculated before, right? And then this time we pass the isFull function into our generic calculation function. And so now I want to log the full ages as well. Console.log full ages. Alright, so let's see this. And alright, this makes sense. So the only one here that's actually younger than 18 is this one. And so this one is the only one with false, right? So everything is working just fine. And as a third example, I have a really cool one, which is the maximum heart rate. And that is the highest rate measured in beats per minute that a person can reach when exercising. And it's calculated based on the age of a person. So it's a great fit for this example here. And I thought this would be a really cool use case for people who like to work out. So let's see this formula and let's see how to use this. So function and max heart rate. And again, we're using simply an element as the input, and the formula is actually really simple. So return 206.9 minus 0.67 times the age, and the age will be the element. So we will always call our array calc function here with the age as the input, right? So not with the years, but with the age. Now we also want this to be an integer. So we want to return a value here that's not a decimal. So let's do that. And I'm sure that you remember the math object. And we used the ceiling method before, or the floor method, I don't remember. But now we're going to use the round. And what round does is very simple. It simply rounds the number to the closest integer. So very simple. Now only one thing left in this function here is that this formula is actually only valid for people between 18 and 81 ages. So you already know how to do that, right? So we use an if-else statement. So if the element is greater or equal to 18 and at the same time less than or even equal or less than 81. And that's it. So in this case, we want to return this. And if the person is out of these ranges, then we simply return -1. Okay, and that's it. So that's our function for the max heart rate. And once again, let's now use this. So let's just call this rates and then array calc. And again, we're using the ages as an input. And then our callback function is the max heart rate. And now instead of the full ages, I want to log the rates. Okay, so here are the calculated heart rates, maximum heart rates, which is only -1 for this person here. And that's because it's clearly younger than 18. All right, let's think again about what we did here. So we created a generic function which loops over an input array. And then we gave it a function as an input, which is used to calculate something based on each element of the array. And we have created a bunch of different callback functions for this, and we could create even more. And this is way better than having one big function calculating all of this stuff at the same time, because it creates more modular and readable code. So each function here, of these three that we coded here, each one has a simple and single task. So this is a really good practice. Okay, so this was an excellent use case of why and how we should make use of the fact that we can pass functions around just like variables. So with this simple technique, we wrote some cleaner code, and this code is more reusable and readable, which is really cool. All right, see you in the next lecture. After functions accepting functions as input, let's now talk about functions returning functions. And to learn how to do that, let's create a function that creates different interview questions for different jobs. And this is how we're going to do it. For each job, we will return a function that builds a string using the person's name as an input. So basically a function returning another function. So function, let's call it interview question, and it will accept a string which is a job. And then in here, according to each of the different jobs, we will return a different function which will then log a question to the console. So we're going to do an if-else statement here. So if the job is designer, okay, then return, and here comes the fun part, because we will simply return a function which will accept the name, and then in here we put our code. So this is basically an anonymous function, right? So this function here, it's an anonymous function because it doesn't have a name. So all of this is what we're going to return if the job is a designer. So console.log, and the interview question for a designer will be first the name, because we will pass that into the function, right? So here is the name parameter, and then let's ask the person, can you please explain what UX design is? So user experience design. Okay. And now another job, let's say a teacher. So teacher, and in here we again return a function, an anonymous function again, which also accepts a name and then a similar string, so console.log, and then it's a teacher, so let's ask the teacher in the interview, what subject do you teach? And then maybe the name of the person. Okay, now we could continue this with a lot of jobs, or we could even have used a switch statement, right? But I don't want to overcomplicate things here, because this is just for demonstration. So I'll just leave these two, and then here an else statement. And again, we're going to return a function. And in here, we'll once again console and then ask hello, then the name. What do you do? So just a random question if we don't know the job. Alright, so this function here that we just wrote will not just return a simple value as we usually do with functions, right? So instead it returns an entire function that we can then use later. And this is possible because functions are always first-class functions in JavaScript, because they are effectively objects. So we simply actually return an object here, right? It's simply an object that happens to be a function. So let's now use this. And remember, this returns a function, so we have to store the result somewhere. So let's create a variable, and I will call this one a teacher question. So this means it will be a question always for teachers. So now interview question, and then what I pass into it is the string teacher. And now if I run this, then this teacher question variable here will be the function that is returned from the interview question when we pass teacher. Where is it? So here. So again, this variable teacher question down here will now be this function here, right? This is just like when we store a function expression in the variable. This is the exact same thing, right? So let's now use this, and I'm going to say teacher question and the name John. So I'm now calling this variable here, which is a function, and I will put the name John into it here, right? Because as we know, this function accepts a name as an input. So let's see what happens. Alright, so what subject do you teach John? Exactly as expected. So with this method, we can basically write one generic function, which is the interview question in this case, and then create a bunch of more specific functions based on that generic function. And in our case, that's this function here, the teacher question, which produces questions for teachers. So we can now also create a function which produces questions for designers, right? So let's say designer question. And then again, we simply call the interview question function, right? But this time with the designer as the argument. And now we have a function which is for designers. So let's console log this here as well. So designer question, and again, John. Let's console log this. Okay, so I misspelled something here. All right, so it's question. Okay. So, John, can you please explain what UX design is? So once again, we have now created a bunch of more specific functions here. So the teacher question and the designer question functions based on our more generic function, which is the interview question function. And we could now go ahead and use this as many times as we want. So let's say designer question for Jane, and for Mark, and for Mike. And you get the point, right? So we can now use this for as many, let's say, designers as we want. So Jane, Mark, and Mike. So all of them will get this question. Let me just show you now that we could also have done this in a different way. So let's say interview question. Okay. And then teacher. And as you know, this will return a function, right? So this will return this function here. And we don't even need to store it in a variable. We can call it right away. So we can use the parentheses once again and then put, let's say, Mark in here. So this looks a bit strange, but it works. And that's because this is evaluated from left to right. So first this part here, so the interview question function gets called, it returns a function, and then with this here we call the function that was returned before with Mark. So let's see. And yes, this still works. What subject do you teach, Mark? Alright, so this is of course a really simple example, but it shows you how useful this technique can be. And it really takes some time to getting used to this way of thinking and using functions. But once you understood, it can be really powerful. Okay, and once again, I really want to encourage you to try this out on your own, write your own functions, and do some experiments with these new concepts of first-class functions. And after that, you can just proceed with the course. So see you then. Welcome back. I hope you're still following along just fine. In this lecture, we're going to talk about an extremely common pattern in JavaScript, and that is immediately invoked functions expressions, also called IFI. Imagine that we wanted to build a little game where we win the game if a random score from 0 to 9 is greater or equal to 5, and lose if it's smaller. So just a small and silly game really. But we want to keep the score hidden in this game, okay? So the score should not be visible. Now I'm sure that you can think of a way of doing this, right? And the answer is to write a simple function, because we already know that variables defined inside of a function cannot be accessed from the outside scope, right? Because the scoping chain only works the other way around. So we could simply write something like this. So function game without any parameters and then calculate a random score, right? So math.random times 10, so between 0 and 9, and then simply log to the console if the score is greater or equal to 5. So just a really silly game, right? Then call it, and then let's see. Okay, so false. So this doesn't really matter here, because what I want to show you is that we can do this in a different way. Because there are a few problems with this. If the only purpose is to hide the score variable from the outside, so which means creating a private variable, then we don't need to declare a whole function with a name and then call it. We can do this in a better way, and that is to use an immediately invoked function expression, which is usually abbreviated as IFI. So let me first write out how an IFI looks like, and then I explain you how and why this works. So we start with parentheses, and then in here we simply write our function, and actually our anonymous function, so without a name. Okay, and then let me just actually copy this. There's no need to write it again. Okay, and then we just invoke this function like this, and this is it. This is an IFI. So how does this actually work? Let's start at the beginning. So if we just wrote something like this, so function, so just something like this, so without the name, but also without the parentheses, then the JavaScript parser would think that this is a function declaration. But since we don't have any name for the function declaration, then it will throw an error. So we basically need to trick the parser and make it believe that what we have here is an expression and not a declaration. And the solution is to wrap the entire thing into parentheses, because in JavaScript, what's inside of parentheses cannot be a statement. And like this, JavaScript will know that it should treat this as an expression and not as a declaration. And then after that, we only have to invoke the function, because if we didn't do this, so if it would be like this, without the parentheses, then it would never be called and never do anything. And since we don't attach this to a variable, then nothing would ever happen. So, does that make sense? This is just how the IFI works. And just like this, we can no longer access the score variable from the outside. So we created data privacy here. And let's confirm that actually. So let me remove this. So let's try to console log the score, but we already know that this is not going to work, right? So let's take this out here, okay. Alright, so we have true, which is the result of this IFI, and then score is not defined, of course. So outside here in the code we cannot see the score variable. We can of course also pass arguments into the IFI. So we could extend our function by adding a parameter called good luck to the game. And the more good luck we add to the game, then the higher the chance that we win the game. So very simple, let's just copy this. Just to show you that we can use a parameter here. So let's call this good luck. And then we subtract the good luck here. Okay, so makes sense. So the more good luck we add here, imagine we had 5, then 5 minus 5 would be 0, and then the score would always be bigger than 0, and therefore we would always win, right? And how do we now pass the argument into the function? Right, we just need to add it here. So let's use the example of 5 that I just gave you here. Okay, so let's just reload this. And now it didn't work because we have the error here. So we first need to take out this part and then true and true. And of course, the second one will always be true. So as you see, we can of course only call the IFI once, right? Because this function is not assigned to any variable. But that's no problem at all, because in this case we are not using the function to create a piece of reusable code. All we want here is to create a new scope that is hidden from the outside scope, so where we can safely put variables. And with this, we obtain data privacy and also don't interfere with other variables in our global execution context. So if this is the goal, so if this is exactly what we want, then the IFI is the perfect solution. So again, this is not to create a piece of code that we will reuse. This is just for data privacy. Alright, so this is going to be yet another very useful tool in your JavaScript toolbox. This was, of course, just a toy example, but later in our project, we will see how important this IFI pattern is in real-life applications in order to structure our code and obtain data privacy and code modularity. So let's now move on. We have learned a lot of theory up until this point, but now you are ready to understand one of the most crucial and advanced things about JavaScript: closures. And this is probably one of the most difficult to understand topics for beginners. But you already know everything that you need in order to understand and use closures. So let's dive right into this lecture. So as our example for this lecture, we want to write a small function that returns a function which calculates how many years we have left until retirement. So let's quickly do that. So function, and let's simply call it retirement. And we pass into it the retirement age. So the age at which someone can officially retire. So for example, here in Europe, it's mainly 65 years, usually. Okay, and this function will then return another function which will actually calculate the years that someone has left. So we already did this in the last lectures, so let's not do it again. So we simply return an anonymous function here. So we don't have a name, all we have is a parameter, and this is the year of birth again. So we start by calculating the age in here, so 2016 minus the year of birth, and then we log to the console the retirement age that we passed into the first function, right? Minus the age that we just created. And then let's add something else, like a string, to make a sentence out of this. And I'm calling this one A, which I didn't declare yet, so I'm going to declare it here. So var A years left until retirement. So I will explain you in a second why we actually wrote this function like this. It's because we want to use closures here, so I will explain you in a second what closures are and how they work in here. But for now, let's just write this function so as it is. And now let's try to use this function. And as you know, this returns a function, so we can store the result of calling this function in a variable, and then this variable will be a function as well. So as you noticed, we passed the age that someone has to have in order to be able to retire. So this is an age that changes from country to country, and so we can basically create one function for each country. So this is similar to creating the interview questions for different jobs, like we did before, right? So let's create a function here for the US. And I know that in the US the retirement age is actually 66. So we call our retirement function, and then we pass 66 into it, and this will return a function where the retirement age, so this here, is 66. So if we now call our newly created function, which is this one here, right? So retirement US, and of course we need to pass the year of birth, right? So let's use our well-known 1990, okay? And then let's check it out. Alright, so 40 years left until retirement. Or we could also write it like this, like we did before. So for example, retirement, then pass an age, like 66 again. So this will return a function, and then we can simply call this new function with a year of birth again. So this should give us the same result. Okay, so 40 years again. So this works. And let's take a look at what just happened here. So let's examine this together. So we started by calling the retirement function and passed the value of 66 here, right? The function then declares this a variable here and returns this function. Then the function finishes and its execution context gets popped off the stack. And you remember that part, right? Okay, so we stored the returned function here in the retirement US variable, right? So here we call it. And now comes the cool part. So in here, in this function, we use the retirement age parameter of this outer function here, and also the a variable that is also declared outside of this anonymous function. And still, when we run this, this works. So somehow we are able to still use these variables even after the retirement function, which declares these variables, already stopped its execution. So think about that again. Our inner function here is able to use the retirement variable and the a variable of this function here that is already gone. It has already returned, but somehow the variables are still there. And this is the closure. This is really fascinating, right? This really blows my mind each time that I use it, really. So now that we know what a closure is, let's see how and why this actually works behind the scenes. So again, we can summarize how a closure works like this. An inner function has always access to the variables and parameters of its outer function, even after the outer function has returned. So let's see what happens when we call our retirement function. As we already know, the new function gets a new execution context that is put on top of the execution stack. That execution context has an object, which stores the variables, the scope chain, and the this variable. So let's see the scope chain for the retirement function, which means the variables that the function has access to. And remember, the scope chain is like a pointer to all the variable objects that the function has access to. Alright, so of course, the function has access to the retirement age argument set to 66 and the a variable that holds our string. Okay, and then the function returns. So after the function returns, now the execution context of the retirement function is effectively gone. And with it, the variable object and the entire scope chain should be gone, right? Actually, no. The secret to closures is that even after a function returns and the execution context is gone, the variable object is still there. It's not gone. It still sits here in memory and it can be accessed. And that's why we still see it there in the execution stack on the left side. And also in the scope chain on the right side, because, and I'm sure that you remember this, the scope chain is in fact a pointer to variable objects. And in this case, the variable object that we have here on the stack. So let's see this in action. Let's call the inner function that we effectively called retirement US with the argument of 1990, which puts, of course, a new execution context on the stack. Let's now look at the scope chain. So since this inner function is written lexically in the retirement function, it gets access to its scope. And you already know and use that. And now here comes the magic. Since the variable object of the retirement function is still there, the scope chain stays intact. It keeps working. And so we can access the variables that were created in the retirement function long after the function has completed execution, and after its execution context is of course gone. The current execution context has closed in on the outer variable object so that it can use it, and that's why it's called a closure. So the scope chain always stays intact. This is the most important thing that you have to understand and remember. Okay, and just to finish this, the function simply returns and the context is popped off the stack, as usual. So now you not only know what closures are, but you also know how and why they actually work. And note that we don't create closures manually. This is something that's really built into JavaScript. We don't have to worry about anything. We don't have to say that we want a closure. JavaScript will always do this work for us automatically. And now this summary makes even more sense to you, right? So an inner function has always access to the variables and parameters of its outer function, even after the outer function has returned. So let's now see how this function that we created can be useful for us. So we can create 3 different functions for countries with different retirement ages and use these functions over and over again. So this is similar with something that we did before, right? So we have a more generic function up here, the retirement function, which we can then use to create more specific functions. And this is only one of the many application cases of closures. And we will see more of these later on in the course. So let's now create some more functions. We just get rid of this here. Okay, so let's create a retirement function for Germany. Because in Germany, the retirement age is not 66, but 65. Okay. And we can also create one for another country here in Europe, which is Iceland, which has an age of 67. So Iceland, we will call the retirement function with an argument of 67. And now we can go ahead and use these functions for different people in these different countries, for example, and see how many years they have left. So let's use these 3 for the same people, imagining that they lived in Germany. So the retirement Germany function, and that they lived in Iceland. So retirement Iceland, and then also 1990. And if I now run this, we have 3 different ages. Actually 3 different years that the person has left until retirement. So 39 in Germany, 40 in the US, and 41 in Iceland. And all of this is possible thanks to the power of closures. Okay, now just to finish this, I have a very small challenge for you. And this challenge is that you should rewrite the interview question function that we wrote in another lecture, but this time using the power of closures. And the function that I'm talking about is, let's see, yep, it's this one here. So let me copy it, paste it here. Okay, and I'm gonna comment it out. Okay, so again, I now want you to write this using the power of closures. So please pause the video now and do that, okay? Okay, so I hope that you managed to do it. So let's now see the solution. So of course, we again write a function, and it's again called interview question. And we still accept the job. But now the difference is that we will always return the same function. So there's only one return keyword in here, okay? So one function which accepts the name, and then we do our if-else statement right in here. And that is possible because of closures, because we will be able to use the job argument, this one, right here into this function, even after the interview question function has returned, right? So let's now write our if-else statement in here. So job designer, and I will then copy the code from up there. So, and then else if job is teacher, and then the else part. Okay, so if it's a designer, it's this code. There's of course no need to write this again. Then this is for the teacher, and this is for all the other jobs basically. Okay, so let's now use this function for a teacher. So interview question, let's say teacher, and then we can call it right here. There's no need to save it in another variable, as I already showed you, right? And let's now run this, and it works. So what subject do you teach? John. So we see this is clearly a question for the teacher, right? So again, the difference between the two functions is that now the decision is taken right inside of the function that we return. And that's possible because we can use the job variable to take this decision here, even after the interview question function has already returned. So when we first wrote this function, we didn't know about closures, so we wrote it this first original way here, right? But now we don't need this anymore because now we know about the power of closures, right? And so we can harness that power and effectively use them. Because this is a better way of doing it. This is cleaner code. So we have only one function and then the if inside of here. So let me explain it one last time, okay? So this function call here will return this function here, okay? And then we call this function with the John parameter, the John argument, and then this execution context will close in over the variable object of the function that we had before, that we called before. So it will close in on the variables that we defined in the old function, which was the job variable. And so we can use this variable right into this function as well. And we do that in here. So here in our if-else statement, we use the job variable of the interview question function that has already returned by the point that we use this inner function here, right? So now I hope that this is crystal clear to you. Alright, and this was closures. And as you have seen, they allow us to do really powerful things, and you will see that in our project later. So make sure that you really understand closures. And I hope that you can see now why it was so important to learn all the JavaScript theory that I showed you before. Because without that, you would not be able to understand what I just showed you in this lecture. Because this was really, really advanced stuff. So if you actually understood this lecture, then nothing can stop you anymore on your path to become a really amazing JavaScript developer. So how cool is that, right? In this lecture, we will expand our JavaScript toolbox even more with the bind, call, and apply methods. So we know that functions are a special kind of object, right? And such as the array objects, for example, functions also get a couple of special methods which they inherit from the function constructor object, right? So in this lecture, we will talk about the powerful call, apply, and bind methods. And in a nutshell, these methods allow us to call a function and set the this variable manually. So let's see a small example here. And for that, I'm going to create an object. And in this case, it's just a very simple object. So no fancy function constructors or inheritance, none of that stuff. So just John and then the object literal syntax. So his name is John, of course. And we've done this a lot of times by now. His age. And then his job, which is a teacher. And now what we also want here is a method, and that's a method basically for John to present himself. And we are going to have two styles here. First a formal style and then also a friendly style. So John is basically going to say a sentence in which he presents himself. And we will also make this dependent on the time of the day. So presentation is a function which accepts the style and the time of day. Okay, so depending on the style that we chose, we will have two different sentences. So if the style is formal, then we console log something. And if the style is friendly, then we say something else. So console log something else. Okay, in the formal part, we are going to say something like, good morning, ladies and gentlemen. So good, then the time of day, ladies and gentlemen. And now remember, if we want to have this symbol here, then we need to actually escape it so that JavaScript thinks that it's not closing the string, but that it's really part of the text. So and then his name. So I'm John in this case. Then we want to say how old. So or let's actually first say his job. So I'm this.job. So I'm a teacher in this case. And and now the age. Years old. So a bit confusing, but it makes sense. So now if the friendly style is chosen, then we want to start our sentence with something like, hey, what's up? And then again, and now we can actually copy this. And I see I'm missing a plus sign here. So let's copy this. So then close it. And I also need to use the time of day. So have a nice plus time of day. Okay, so first of all, let's test this. So John.presentation with a formal style, and let's say in the morning. Okay, so it looks good, right? Actually, there's only one space here missing, but the rest is good. So it's just here, a space, right? And so also here. Now let's add another object here for someone called Emily. So the name is Emily. She's 30 years old, 35. And she is a designer. Okay. Now, suppose that we want to use the presentation method for the Emily object, which does not have this presentation method, right? We can use the call method to do this. So how does this work? The first argument of the call method is always to set the this variable. So let's see this. So we can say again John presentation, and now we use the call method on this function, on this method here. So call, and now as I said, the first argument here is the this variable. So if we set the this variable to Emily here, right, then the this variable here and so on, then this will no longer be John, but it will be Emily, right? And now we can set the other arguments. So let's this time use the friendly style, and it's in the afternoon. So let's check this. And it works. So now it's Emily and it still works. So we have the job and her age. And this is called method borrowing, because we actually borrowed the method from John to use it here on the Emily object. So again, the call method allows us to set the this variable here in the first argument. And we set it to Emily because we wanted to use John's presentation method, but setting the this variable to Emily so that we can use John's method on Emily, right? So that is the call method. There is a very similar method which is called the apply method, and the only difference is that this one accepts the arguments as an array. So there's only two arguments, first this variable and then an array where all the other arguments go. So it would be something like this. So John.presentation and apply in this case, and Emily, and now as I said, the array. And then in here we would set the other arguments, friendly and afternoon. Now this is not going to work because our method does not expect to receive an array as the input, right? So the presentation wants two normal arguments here. It doesn't expect to receive an array, so this is not going to work. But I just wanted to show it to you because we will actually use this later in our project. So let's just comment this out here. Alright, and let's now see the bind method. So we use the call and the apply. So the bind method is the one that's missing here. So the bind is very similar to the call method as well. So it also allows us to set the this variable explicitly. However, the difference here is that bind doesn't immediately call the function, but instead it generates a copy of the function so that we can store it somewhere. And that can actually be extremely useful to create function with preset arguments. So let's see how. So let's create a variable because, as I said, the bind method will return a function. So we have to store that function somewhere. So we're going to use the bind method to create a function with preset arguments because bind allows us to do that. So we're going to preset the friendly argument so that we don't have to input it again and again. So let's call this function John friendly. Okay. John.presentation. And now I'm going to use bind. And again, the first argument here is to set the this variable, which in this case doesn't really matter. So I'm just going to go with John. Okay. And now I say friendly. So this is the first argument of the function, of the presentation function. So the style. But I will not set the time of day, okay? This will not be set here at this point. I will just leave it like this. So let's now use the John friendly function. Because again, this method here returns a function. So the function will get stored here in the John friendly variable. So John friendly. And now there's only one argument left to be set, right? Because I already set the other one as friendly. So I can now say like morning here again. And this is just going to work as it did before. So let's see. All right. So I'm John, teacher 26. Have a nice morning. So you see how useful this is, right? So we have a function now which is always for the friendly version of the presentation method. So we can now use it for another time of the day. So John friendly again. Now let's say in the night. And again, everything that changes here now is night. So again, bind allows us to preset some arguments here. And this, what we just did here, actually has a name, and it's called currying. So currying is just a technique in which we create a function based on another function, but with some preset parameters. So exactly what we did here. And bind is extremely useful for that. And we can of course do the same for Emily. Okay, so let's say var Emily informal. So John.presentation and then bind. And this time the this variable matters again because we need to use the presentation method on Emily. So the this variable will become Emily. And now I'm going to preset this argument to formal. And I can now use it. So Emily formal and then afternoon, for example. And here we go. Good afternoon, Emily, designer and 30 years old. All right, so now we saw some example for call, apply and bind. Once again, these are more like small toy examples, but they really help you to understand what we can do with call, apply, and bind. And we will actually use them in real situation in our next project. But before doing that, I want to just very quickly show you a cool real-world example right here. So let's bring back some of the code that we wrote in a lecture about passing functions as arguments. So I have the code up here. Let me see. Oh yeah, this is the one that I want. And this one here as well. Okay, so let's create some space here. And alright. Okay, and do you remember this one? So this was the function that we created here, where we then passed a callback function, which was to calculate age and calculate if someone was of full age. So imagine this like a machine which accepts a function and then applies that function to all of the elements of an array, right? So back then we had this full age function here, but actually the full age varies from country to country. So it's not always 18 years like we have here. For example, in Japan, you have to be 20 to be of full age. And in other countries, it's actually something like 16 or 17. So what we can do is to pass in a second argument for the age limit. So something like this. So we pass in a limit, and then instead of having 18 here, we say that the element in the array has to be greater or equal to the limit that we defined. Alright, so let's again start by calculating the ages. So var ages is array calc, then the years array, and then our callback function calculate age. Now, the problem with our full age function is that it accepts 2 arguments, but our array calc function here can only use it with 1 argument. So here, right, the fn function is always called with only 1 argument, which is this element of the array, right? So what can we do here? I would say that the best solution is to pass in our isFullAge function, but with the limit already preset, right? And that's what we're going to do. Do you remember how to do that? Exactly. We use the bind method, because bind allows us to create a copy of a function with a preset argument, which is exactly what we need here. And we did that before, and so now we're going to do it again. So let's create a variable again called full, but this time it's called full Japan, because I'm going to do it for Japan, because they have this limit of 20 years. So this is what we did before also. So array calc, and now we pass in the ages that we calculated before. And now we cannot simply pass in the isFullAge, as I explained before, right? So isFullAge. So we will not just pass this function like this, but we will use the bind method on it before passing it. So now we can preset the argument. So first the this keyword, don't forget this, the first thing always has to be the this keyword. And in this case, we don't really care about it. So we just say this, and then our preset limit, which is 20. Okay, and now what will be passed into the array calc function is not simply going to be the full age function, but a copy of the isFull function with 20 as the preset argument for the limit. So let's see if this actually works. So let's console.log the full Japan. And also let's show the ages so that we can see if this is actually correct. So ages. Okay, so yes, it seems like it's working, because here we have someone which is 18, right? But our isFullAge function tells us that this person is not of full age here, right? And that makes sense, because in Japan you're only full age when you're 20, as we specified here. So this is working. And this is another very useful way in which we use the bind method, and this is really a real world example. Cool, so now you have yet another tool in your toolbox. And that toolbox is getting really, really full, right? We are now almost ready to start our big project. So let's very quickly move on and see you in the next lecture. Hello there! It's time for another coding challenge, so that you can apply some of the concepts that you just learned on a fun and practical coding exercise. So in this challenge, we're gonna build a fun quiz game right here in the console. So you see here in the console we have a question, and then in here we have this pop-up window where we can insert the correct answer. So there's no fancy user interface, we do everything just here in the console and using this prompt window. So in here we can select the correct answer, and the question is JavaScript the coolest programming language in the world? And yes, of course it is, right? So let's insert 0 here, okay, and then correct answer. So if we want to play again, we just reload the page, we get another question, and right now I only have 3 questions, and these are selected randomly, so it's very likely that we have the same questions again. So 0 again, let's reload this again, and now we have a new question. So what's the name of this course's teacher? And yes, you already know, it's number 2, Jonas, right? Alright, so you see how this works, right? So let's check out some instructions for this challenge. So again, let's build a fun quiz game in the console. And the first step is to build a function constructor called question to describe a question. And the question should include, of course, the question itself, right? And then the answers from which the player can choose the correct answer. And in here, you should choose an adequate data structure, like an array, an object, or whatever you think is best. And then also, we need to store the correct answer so that we can check if the input answer is correct. And for this one, I would use a number. Okay, and then when you have the function constructor properly set up, you can then use it to create a couple of questions. And then number 3, store all of these questions inside an array, because that makes it a lot easier to code step number 4, which is to select one random question and log it to the console, together with the possible answers, of course. And then each question should have a number, such as we saw in the demonstration. And the hint that I can give you for this is to write a method for the question objects for this task. Then after that, you use the prompt function to ask the user for the correct answer. And the user should then input the number of the correct answer, and these numbers are of course the numbers that you displayed in task 4. And then finally, you check if the answer is correct and print to the console whether the answer is correct or not. And I would write another method for doing this. Now in the end, suppose that this code would be a plugin for other programmers to use in their code. And so we have to make sure that all of your code is private and doesn't interfere with the other programmer's code. And we learned a special technique in this section to do exactly that. So use that one to complete this step. So this is the most basic version of the quiz, but this time I also have an expert level. And so let's take a look at that first, and then let's see the instructions here. So this time, after we answer to one question, we will always get a new question. And we also keep a score and display it so that we know how many answers were correct. So again, what is the name of this course's teacher? And number 2, Jonas. And you see, we get a new question right away here, right? So we see correct answer, then your score is 1, because we have 1 correct answer at this point, and then we get the new question here. So is JavaScript the coolest programming language in the world? And yes. Okay, so now we have 2 points. So what's the name of the course's teacher again? So let's now put a wrong answer here. Let's say 1. And then wrong answer, try again, and our current score keeps at 2, such as it was before. So this question again, so number 2, 0. And here is the third question that I wanted to show you. So what does best describe coding? It's boring, hard, fun, or tedious. So the answer is, of course, number 2, right? And now our current score is 5. So this version of the quiz is a lot more fun, right? So let's see the instructions for this one. So after you displayed the result, you should display the next random question so that the game never ends. And if I were you, I would write a function for this and then call it right after displaying the result. But be careful, because if you do that, then the game will actually literally never end. And so you have to include an option to quit the game if the user writes exit instead of the answer. And then in this case you don't call the function here in task 8. So let me actually show that to you. Okay. Because if I hit cancel, then I will always get a new window, you see, and I cannot close this. And so the only way to exit this game is to write exit here. And that's because I coded it this way. So exit, and then the game ends. Okay, so you have to code this too. Now after that works, you can track the user's score to make the game even more fun. So each time that the answer is correct, you just add 1 point to the score. And for this task, I am actually going to use the power of closures. But of course you don't have to, you can do it in another way. Because for me, the most important thing at this point is that you actually write the code on your own. So that you really try to solve these problems on your own, okay? So it's absolutely no problem if your code is different from mine. The most important thing, again, is that you should really do it on your own at this point. Because right now in the beginning of your journey, the most important thing is that you really practice and that your code works. Then optimizing your code to make it perfect comes after that. But for now, just get your hands dirty with some coding and not trying to make it perfect, okay? Then finally, in the end, just display the score in a console such as you saw in the demo before. And for that, you can use another method. So again, just try to code this on your own. And then after that, once everything works the way I showed you, you can check out the solution to see the way I implemented this game, okay? So good luck and take all the time that you need. So, I hope that you took the time and completed the coding challenge and made the quiz work. Now, if you want to see my solution, then here it goes. So let's start with step number 1 and build our function constructor down here. So, function, question, and as we already saw, what we need as inputs here is the question, the answers, and the correct answer, right? So I'm simply giving it these names. So question, answers, and the correct. Alright, and now this is how the function constructor pattern works. So we set everything that we input into this constructor on the this variable of this function, right? So this dot question is the question that we input. This dot answers, the same, and the same for correct. Alright, and that's it. That's our function constructor. So let's now use it and create a couple of questions. So var question1 is a new question, and in here I'm going to pass first a question, right? So I'm going to go with the ones that I showed you in the demo. So, is JavaScript the coolest programming language in the world? So that's the first argument. Then the second argument are the possible answers. And I'm going to choose to use an array for this, because that allows us very nicely to store all of the different options in one single variable. So in here, we only have 2 different options, which is yes and no. Okay, and the third one is the correct answer, and that is number 0. So remember, an index is 0 based, and that's why I'm going with these 0 based correct numbers here as well. So the first one is 0, and the second one is 1, and so on. And with this, we created our first question. Now remember why that works. It works because the new operator here creates a new empty object, then it calls the question function and sets the this variable of this function to the new empty object that was just created. And therefore, when we then set all of these properties of the this variable, these will be assigned to the this variable of the new object. And that new object will then be stored here in the Q1 variable, right? Or as you already know, actually, the Q1 variable will hold a reference to the spot in memory where the object sits. And then we can, of course, use our newly created object. So let's now create another one. So question 2. So the second one was, what's the name of this courses? And remember, I have to do it like this. So I need to escape this symbol so that JavaScript doesn't think that it's the end of the string. Teacher. And now the answers. So John, Michael, or Jonas. And as you see, we can have different numbers of answers. So here we had 2, here we have 3, and in the next question we're actually going to have 4. Okay, and in here the correct answer will be in number 1, obviously, right? Because the index is 0 based, and so this last one here is 0, 1, 2. Alright, and let's create a third question. So var Q3. And now, what does best describe coding? So is it boring? Or is it hard? Or fun? Or maybe tedious? And I would say that it's number 2. So it's really fun. So 0, 1, and 2. Alright, so we just created 3 questions. That should be enough for now. Of course, you can add more to make it more interesting, but just to show it, it is enough. Now, number 3 and 4 is to store them in an array and then select one random question. So let's say questions is, of course, Q1, Q2, and Q3. Alright, and now we need to retrieve a random question from this array. And so the first thing is to create a random number, which we can then use to take the question. So we want the number between 0 and 2, right? So 0, 1, or 2 should be the number of this random question. Now in case that you have more questions, of course the number will be higher. And so we need to write code that gives us a random number between 0 and the number of questions that we have, right? So let's do that. And I'm going to call this number simply n. Okay. And as we did before, we're going to use the math.random method, which, remember, returns a number between 0 and 1. But we don't want between 0 and 1, but between 0 and the length of our array. And so we multiply it to make it a bigger number. And we multiply it by the length of the questions array. So length. So now we just need to use the math floor, a method such as before, to remove the decimals from this number. Because remember, this will give us something like this. So let's see it in the console. Okay, of course it doesn't work like this. So let's say we know that the length is 3, right? So let's simply do it like this. So this is going to give us a number between 0 and 3, like this, right? And so we want to simply cut out these decimal part here. And that's exactly what the math.floor method does. And this way our number will always be nicely between 0 and 2. Okay, so now writing questions n will give us a random question. Now all we need is a way to display this question in a console, right? And so as I mentioned before, I'm going to use a method for that, right? And so we're going to use the concepts of prototypes and prototype chain to write this method. Because I should not write this method right here into this object, right? Because then all of these three questions would have this method attached to them. And that would not be ideal. So remember what we discussed in the lectures before. And so what we talked about in the lectures before is to write the method into the question's prototype property, which is the prototype of all of the instances, so of all of the objects created through it. So of Q1, Q2, and Q3. And it works like this. So question.prototype, and now the name of the method. And this one is going to be simply display question. And the first thing is, of course, to display the question, so console.log, and this dot question. So when this method will be called on Q1, then the this keyword here will of course point to Q1, right? And then a question associated to Q1 will be retrieved. If we call it on Q2, then the this keyword here points to Q2. And of course the same thing with Q3. So that's the cool thing about the prototype chain, that this method is not actually attached to one of these questions, but it's in their prototype. And so all of these objects can access it through the prototype chain. Okay, so this displays the question. Now we need to display the answers. And since we have multiple answers, and we also don't know how many these are, so in some cases we have 2, and here 3, and here even 4, we need to loop through all of these answers and display each of them. So we're going to use a for loop for that. So var I equals 0, and then I will be incremented until we reach the length of the answers. Dot length. Okay, so we did this a lot of times before. And E++. So imagine that there are 2 answers, then the length will be 2, and so this will run when I is 0 and when I is 1. And then when it's 2, this condition here no longer holds true, and then the loop stops. And so in here what we're going to do is to console.log each of the answers. So this dot answers, and then we're going to retrieve in each iteration the corresponding answer. But actually we not only want the answer, but also the number. And so for that we're going to use this I counter variable. So it's going to be 0 and 1 in this case. So we want this, then we want to add a colon and a space, and then the actual answer. Okay, so this should already work. So let's test this out. So with this here we already retrieved the random question. Now all we need to do is to call the display method on it. So display question. Actually I need to call it, right? And so now it's time to test this. And we have a bug in line 335, but it's no problem. Let's see where it is. Yes, of course. The assignment operator is missing. And another one. And yes, of course, that's because I'm still missing here the function keyword. Okay, so this was totally missing, of course. You probably saw it coming already. And again, another error here. Now it should work. So the question is already here. So JavaScript, the coolest programming language, but the answers are missing here. So something is wrong in here. And so the problem is here. I misspelled this one. And now here we are. So yes and no. So let's reload this. And yeah, it works for the other questions as well. So here are our 3 random questions. Let's check out the next step. So now we use the prompt function to ask the user for the correct answer. So we're simply going to do var answer. And then remember this prompt, a function that I showed you right in the beginning. All it does is to open like a pop-up window where the user can input something. And what we pass in here is simply the string that will be the question that we want the user to see. So please select the correct answer. So let's test this. And we say 0. So now of course nothing happens because we didn't yet code the part that validates the answer, right? But before we do that, let me show you something. So I will just log the answer here. So answer. And what you see now is that this is actually a string, right? If it would be a number, it would look like this. So it's blue and it doesn't have, of course, these quotes. So this is really a string and not a number. But the correct answer that we have here in our questions are, of course, numbers. And that's what we're going to compare the user's answer with. And so therefore, this also has to be a number and not a string. So what we can do is to use the JavaScript built-in function called parseInt. So parseInt. And this simply converts a string to a number, to an integer number. So parseInt, actually with E. And now let's see this again. So number 2. And let me check the answer here again. And now you see it's a number. So it no longer has these quotes and it's displayed here in the blue color. And now to check the answer, if it's correct, we are going to write another method here into the prototype. So question.prototype.checkAnswer. So what should we do here? It's actually very simple, right? All we need to do is to compare the answer that the user gives with our correct answer, right? And so we need to actually pass in this answer into this method. So let's simply call it ans. Okay. And then in here we just need an if-else statement. So if the answer from the user is the same, then our correct answer, then we console.log correct answer. And if it's not, then we simply log wrong answer. Try again. And that's it. So now all we need to do is to call this method down here. So again, we use our question that we are working on, and that is questions n. And then we use check answer and pass in the answer from our user, which is stored in this answer variable. We could, of course, have stored this here in a separate variable because we're using it here and then again here, but let's just leave it this way here for now. And now this is actually all we have to do to make this work. So let's test it out. So is it the coolest programming language? Yes, it is. And that's the correct answer. Cool. And the same question. And again, the same question. What's going on here? And now we have a different one. So what does Bass describe coding? It's fun and correct. Just to try another answer here. And now it's wrong. All right. So let me see the tasks up here actually. So we completed all of them except number 7. And this one tells us that we should give our code a privacy so that it doesn't interfere with other programmers' code. So what did you learn in this section to do exactly that? That's correct. We're going to use an immediately invoked function expression. And it's really simply, we just have to do function just like this, and then invoke the function at the end. And this creates a new scope in which we define all of this that we did here, right? And then at the end, the function is simply executed. And so if now someone else includes this code in his own project and also has a variable called question or a variable called n or answer, then that one will not interfere with our code. So our code is always safe because no other code is ever going to override it. And that's the main goal of using an IFI like this. So this is really a great use case to show you how important this can be. Let's just test it again to see if it still works. And yeah, of course it does. So that was the first basic level of our quiz. Now in the next lecture, I'm going to show you the solution for the expert level quiz. So stay tuned for that. Alright, so here goes my solution to the expert level of our small quiz app. So let's first take the code that we just wrote and copy it down there. So I'm going to comment it out and copy it. Alright, and paste it down here. So this is a starting point to now code the expert level of the quiz. So let's take a look at our first task here. So after we display the result, we then want to display the next random question. So let's do that and simply write a function. And what this function is going to do, it's going to do all of this game logic here so that we can call it over and over again. So let's call this function next question. So function next question. And of course it doesn't need any parameters. And now let's put this to the inside. And then of course we need to call it next question. Okay, so right now this is actually exactly the same thing that we had before, so nothing different is going to happen. Because now we need to also call this function here in the end. So imagine we execute this function here, and then after all of this is done, so after we selected our question, displayed it and checked the answer, we simply want to call this again. So very simple, we simply write next question again. Actually this part here, we only need to do once, right? So the array of our questions is always going to be the same, so nothing changes there. Now remember the problem that I described, which is that right now, if we would call this app like this, then we would have no way to actually ever stop this quiz. Because each time that we hit the cancel button on our prompt window, it simply opens a new one. And then there's no way to really stop this. So we have to have a way to stop the game. And that is by writing exit into the prompt window instead of writing the number for the correct answer. And so let's say that we only want to call this next question if the input from the user is not exit. Okay, so we say if the answer is different from exit, only then we want to call the next question again. So this makes sense, right? And actually we also want to only do this one if the user doesn't choose to exit the game, right? So we only need to check if the answer is correct if the game continues. So if it's not an exit. All right, now before we can actually try this out in the browser, there's still one issue with this. And that is that up here, we converted the answer, right, to a number. But here, down here, we want to check if the answer is exit. So if it's this string. And that means that we actually do not want to convert the answer to a number here at this point, because then we can no longer perform this check here, right? Because at this point, the answer will no longer be an exit string, never. Okay, so we need to take this out from here and move it. So we are going to move it to here. So parse int this answer. So we're simply moving the parse int function down here, which is where we actually want a number. So we want to pass a number into the check answer method. And so now everything should be set for this to work correctly. So let's try this out. So the name is Jonas. And all right. So you see, we have a next question and we have a new prompt window here. So what does best describe coding? It's fun. Correct answer and the next question. So great, it's working just fine. So the first step, or the first two steps actually, are completed with this. Now remember, we need to write exit if we want to exit from this game, right? So let's try that out. So to see if this also works. And yes, it worked. So our code is complete at this point. Remember all of this stuff that we wanted to do again. Here each time after the user gave an input, we simply wrote it in a function, called it at the beginning, and then called it each time that we want to continue the game. So each time that the user didn't write exit into the prompt window. So this was the easier part of this challenge. So let's now talk about keeping the score of the user. And as I mentioned before, I'm going to use the power of closures here in this case. So let's see how. So my solution is to write a function here, which is going to keep the score and to update it when the answer that the user gave is correct. And this is going to be like a nice container where I can keep everything that is related to the score. So the score itself and a function to update it. Instead of having like global variables and variable mutations all over the place in our code. So let's just see how this is going to work. So functions and very simply score. Okay. And in here, I'm going to create a variable called score. So let's say SC, so the short version of score, and 0, just because I don't want to repeat the same name here, okay? And this function here is going to return another function. And what this function does is to increase the score if the answer is correct and then return it. So we actually need a parameter here which says if it's correct. So this is going to be a true or false value. And then if the answer was correct, then update the score. And we know there's a nice operator for that, right? And it's this one. So it's the same one that we always use in the for loops. So this simply adds 1 to the score. And then either way, so if it's either correct or true, it's going to always return the score. Okay. And so this way, everything that I need about the scores is here in this function that this closure returns. Now all I have to do is to call this function and store it because it returns another function. And so I want to keep that function in this variable. And I'm going to call it keep score. So score and call it, and that's it. So what's going to happen? Remember what closures are. So we call the score function, it defines this variable, and then we return this function here. And it's going to be attached to this variable. Now, thanks to closures, we always keep access to the variables that the other function defines, right? And so this means that this score variable here will always be accessible by this keep score function here. So this is exactly what we did in the other exercises in the closures lecture, right? So the exact same thing, but now it's applied to this problem, so this application. And up until this point, maybe this doesn't make so much sense to you. So why I use it this way? So let's now see it in action. And it's going to work like this. So we check our answer here, right? So here actually. So we check our answer. And in here, we can then call this function that I just defined to update the score if the answer is correct. Okay. And so in order to be able to do that, we need to actually pass this function into this method here, okay? So we're going to make use of the concept that we can pass functions around because they're first-class objects in JavaScript, so first-class functions. So the check answer method is going to be called here. So check answer. And so we're not only going to be passing the answer in here, but also the keep score variable. So keep score, which is the variable that contains the function and a closure which keeps track of the score, remember. And so now in here we also need to set the parameter. So answer and call back. Let's call it like this. Okay, and now in here we can simply call our function. So it's going to be callback here, but remember that this is the keep score function. And now we pass in true, right? Because we know that here when the answer is equal to the correct answer, the answer will be correct. And remember that this function here, which is effectively stored in the keep score variable here, accepts a correct parameter. So if it's correct, it's going to update the score and return it. And if it's not correct, so if it's incorrect, it's going to only return the score and not make any updates. So in here we always have to pass true or false. And since this returns something, we need to store the score somewhere. So let's say SC again, which is short for score, and then declare it up here. So var score, and that's because I'm going to call the function here as well. So score, callback, and this time with false. And therefore the score is not going to be updated. All this does is to return the current score. And that's because we want to display the score in a console either if the answer is correct or if it was false. So we always need to retrieve the score value from the function, which again has access to it because of the closure. And so let's now write a method for that. So a method which is going to display the score in the console. So question.prototype.display score. Okay, actually we need a parameter here, which is the score. So all we do in here is to simply console.log the score. So your current score is, and then the score, and then simply like a separator line so that we have our questions like nicely separated. So something like this, okay? And now all we have to do is to call it here. So this dot display question and then pass the score into it. And once again, we have access to this method here because of the prototype chain. Because this variable here will point to the object on which this method here was called. So this check answer method was called. And then of course it has access to the display score method as well. And so it's called and then prints our current score to the console. So does all of that make sense to you? Let's now check it out if it works. So we know all of the answers by now, right? Well, something is not really working here because this printed 2 questions here now, right? So let's now check out what's going on here. So I'm going to exit the game so that we can check out what's going on here. So everything looks good here actually. Well, what I see here, so here we return a score and not SC. So we were currently returning this function here, okay, instead of returning SC. So this was something really wrong. So maybe that was the reason why this wasn't working properly. So let's check it out again. So coding is fun. So you see that this is still not working fine, right? Because we have still 2 questions here. So this kind of means that the display question here is called twice, right? So this is really wrong. So let's check it out again. So, and I see that here is probably the problem. So here we have display question, which is this method up here, which displays a random question, but instead, of course, it should be displayed a score, right? So in here, we of course don't want to display the question again, but the score. And it's completely normal that these kind of bugs happen in programming, so this is just a matter of a small distraction, and then you can cause these kind of bugs. And then all you have to do is to think about why this is happening and then try to hunt these bugs down. So basically to find where you did a mistake. And I'm pretty sure that this one here was the mistake. Also because this score was never appearing, and also this line here was never appearing. So this means that we were not really calling this method anywhere. And so this is here the place where the bug has to be. And now I'm pretty confident that it's gonna work. So fun. And now the current score is 1. So great. Then the same question, and it was updated to 2. So it's working. So the closure and this mechanism that we coded is working. So 1 now, so a wrong one, and the score stays at 2. Now it's 3. Now let's put a wrong answer again. And yeah, the score stays at 3. And so everything is working properly. Exit, and that's it. So take a look at this code again and try to really understand why the score function here works the way it does. We learned everything about this throughout the section, but it can be a little difficult when you actually see it in practice. So make sure that you really understand how and why all of this works. Alright, I would say challenge completed. So see you in the next lecture. So let's finally start our big project. In this lecture, we'll take a first look at the application that we're going to build throughout the section and set up our project. So this is our budget app, and I called it budgety here for a lack of a better name, but it serves, right? So this app allows us to add incomes and expenses for a certain month, which is in this case September 2016, and the app then calculates how much money we have made and how much we spend, and then it gives us a nice budget here in this field. So just to test it, let's add some incomes here. Let's say we have made a website project and that we made 2,500 euros or dollars, and then we hit this button and then our income appears here in this list, so the value, and then here these total income updates and the budget as well. So let's put another income, and suppose we sold our car, we didn't need it anymore, so for 1,500 euros or dollars. So this gets added to the list, and then our income gets added together. So 2,500 plus 1,500 makes $4,000 or euros. And then of course we can add expenses, so we need to change this to minus here. And then let's say we have to pay rent. So $900. And here we go. So now it's in the expense list and this budget here got updated. So 4,000 minus 900 is 3,100, right? So this is the budget. Now let's say we went to grocery shopping. So groceries, and we spent 97.42. Okay, so commas also work in here, right? And now let's say we went on a holiday and spent $1,700. And if we make some kind of mistake or just want to remove an item here from the list, we just need to click on these icons that appear as we hover over them, right? So imagine that we didn't pay this amount after all, so we can just hit here and then it disappears and everything else gets nicely updated here. So really cool, right? And there is more. So here we see in these percentages here, the percentage that each of these expenses is of the total income. So for example, this holiday that we went on accounts for a total of 43% of our total income of $4,000. And then this 900 euros here or dollars for the rent is 23% of our income, right? And in total, we see that our expenses account for 65% of the money that we made in this month, so in September. So these are basically the features of the app that we're going to code. And I also gave this app a nice design so that the whole project gets more exciting for you. So you're gonna really end up with a cool and great looking app that you can show to your friends or someone else, and not just some boring, ugly, toy application. So I really put a lot of effort in this app to make it the perfect first real project for you. So you see, we have a lot of code to write to make all of this work. So let's get to work and start by setting up the project. So the starter project that you can download is already on the desktop, as always. So again, the name budgety, and then just open the project folder, and here is our project. So as in our pig game project, we have an already coded HTML file, which we will see in greater detail later as we start coding the app, and then of course a CSS file where all the styles, where all the design of the application sits. But that doesn't matter to us, because what we want is of course this app.js file, which is the file where all of our JavaScript code will go, right? So now we know how our final app looks like, how it works, and we have our project all set up. So we're ready to move on to the next lecture. See you there. Alright, so now that we are familiar with our project, we're ready to start coding, right? Well, not really. Because we cannot just start coding without having a plan of what we're gonna do. I mean, it was okay to build like the pig game project without a clear plan. But in a bigger project like this one, we really need to think about the structure, the architecture of our application. So let's do that in this lecture. So in the end, we're gonna end up with something like this. Now, is this a great piece of art or not? No, I'm just joking around. This is actually a representation of the final architecture of our app in the way that I like to display it. But not so fast. We need to think one step at a time, and we need to think together so that everything makes sense to you and so that you can think on your own when you start coding your own projects. That is really important and one of my biggest goals with this course. I want you to learn how to program and how to think, not just to copy my code. And that's also what you want, right? Okay, so let's look at our application again and identify the most fundamental parts that we need to code. And we're actually going to do this planning in more than one step. Right now, I just want to identify the most fundamental things that our app has to do, and then start coding them. And later, we're going to come back to this and then plan the rest of the app's features. So this is step 1. Alright, so we know that we can input an income or expense description and value, then hit the OK button, and then the data will appear on the user interface and the budget calculation will update. So it actually starts with a click on the button. And we already know that we can handle these kind of events using an event handler, right? So the first thing on our to-do list will be to add that event handler. Okay, and then we need to get the data out of our input fields. So we need some code for that as well. We see that this data then will be printed to the user interface. So we need to first add the new income or expense to our internal data structure and then add them to the user interface as well. And finally, the budget is also updated. So we need to internally calculate the new budget and then again update the user interface. Does that make sense to you? Okay, so we're going to write functions and methods for all of these tasks in our application, right? So we already have a nice list of tasks that we have to complete now. But before we start coding, we also need to talk about how to structure our code. And for that, there's nothing better in JavaScript and programming in general than modules. So, modules are a vital aspect of any robust application's architecture. Also, modules help us in keeping the units of code for a project both cleanly separated and organized. And lastly, modules can allow us to encapsulate some data in privacy and expose other data publicly. all of this keeps getting more important as our applications get bigger and bigger. So basically, modules allow us to break up our code into logical parts, which are the modules, and then make them interact with one another. So what modules should we have in our project? Let's think about the tasks that we have already on our to-do list. So looking at these tasks that we specified before, we can see that some tasks have more to do with the user interface and others with doing internal data manipulation, right? So we're going to create a module for each of these so that we have cleanly separated and organized units of code in our app. So we start with a user interface module and a data module. Okay, so I would clearly say that get input values, add the new item to the user interface, and update the user interface with the new budget should all go into the UI module. Do you agree with that? Okay, and as for the data module, let's add the new item to our data structure and calculate the budget right into the data module. Now, there's still one left that doesn't really fit in any of these modules, right? So I'm going to create a new module and I'm going to call it the controller module. So in here, we'll add the event handler and specify the response to the event. The goal of this module will be to control the entire app and basically acting as a link between the other two modules. Alright, so now we have some nicely separated units of code here. And all of this will make a lot more sense to you when we actually start writing our code, which is exactly what we're going to do in the next lecture, where I'll show you how to set up these modules. So again, the planning that we did in this lecture is only for the first step of coding this project. There are a lot more functions that we're going to need in each of these modules so that we end up with a final functioning app. But we'll come back to this later. Okay, see you in the next lecture now. Let's now start to implement the modules that we talked about in the last lecture. And for that, we're going to use the extremely popular module pattern, which is one of the most popular patterns in JavaScript. And since we're now back to a big project, you'll have these what you will learn topics in the beginning of each video again, where I will list all the new things that you will learn, so you can reference these lectures later on. So in this lecture, you're going to learn what the module pattern is in JavaScript and how to implement it, and you'll learn more about private and public data, exposing methods, encapsulation, and separation of concerns, and how all of that is related to the module pattern. So this is going to be a really important lecture. But let's first remember why we're going to use modules for our project. And do you remember why? The answer is that we create modules because we want to keep pieces of code that are related to one another together inside of separate, independent, and organized units. And in each of these modules, we'll have variables and functions that are private, which means that they are only accessible inside of the module. We want that so that no other code can overwrite our data. So our data, or code, is going to be safe, and this is really important. And beside private variables and methods, we're also going to have public methods, which means that we expose them to the public, so that other functions or modules can access and use them. And this is called data encapsulation. So data encapsulation allows us to hide the implementation details of a specific module from the outside scope, so that we only expose a public interface, which is sometimes called an API. It is extremely important to have all of this in mind when building complex applications. So how do we actually create modules in JavaScript? We use the module pattern, which is incredibly powerful, but at the same time incredibly simply to implement. All we need to know are the concepts of closures and ifs, but we already know that, right? So let's start with the module that handles our budget data, and I'm going to call it budget controller. So budget controller, and here is how we write the module with the module pattern. This variable is going to be an immediately invoked function expression that will return an object. So let's write that out. So remember, an immediately invoked function expression, or IFI, is simply an anonymous function wrapped in parentheses. So just like this. So function, and this is the function body, right? And then we just invoke the function at the end, like this, and that's it. And in here goes our code. So let's simply put a variable here for now. Let's say x is 23, and just some simple function. Let's say we want a function to add two numbers. So I'm going to call it add, simply. And our parameter is just a. And we return x plus a. So this is just a variable and a function to show you how the module pattern works. So you already know that an IFI allows us to have data privacy because it creates a new scope that is not visible from the outside scope, right? So our variable and our function, they are safe in here. They cannot be accessed from the outside. Now, the secret of the module pattern is that it returns an object containing all of the functions that we want to be public. So the functions that we want to give the outside scope access to. So let's now test this out and return an object containing a method here. So return, right? And then an empty object, and all we need to do now is to add a method. And I'm going to call it public test. And it will simply be a function that uses our other function add so that we can use it in the outside scope. So we accept the parameter b, and then we console.log the result of calling the add function with b. Okay? Let's now quickly test this in the console, right? So this time I have the browser here on the other side in full screen because we're going to need that for this application. So let's open up the console here, give it some space, and let's start by testing that we can in fact not access the x variable. So we first need to reload this, of course. So our budget controller, right? So .x, and it's undefined, of course, because as we know from the outside we do not have access to the inner scope, and also using our add function does also not work. So remember, this is our private add function. So let's now prove that we cannot use it from the outside. So let's say budget controller dot add with 5, so 5 plus x, and it doesn't work because it's not a function. So this is what we expected. And if we now go ahead and use our public test method, so public test, and now use 5, then we have a result of 28. So let's see why that is. So we pass 5 here into the function, and then this 5 value is passed into the add function, and therefore the result will be 5 plus x, which is 23, which is then 28. So using the public test method, which is the one that we exposed to the public, actually works, while using the add methods or the x variable does not, because they are private. Okay, so how does this work actually? Let's analyze what happens here. So when the JavaScript runtime hits this line here, it gets executed, and this anonymous function is declared and immediately called or invoked because of this operator here. Then these variables here and functions are declared, right? And we return an object right here. And this object contains the method that we called public test. But it could of course be lots of methods, not just this one. So this object is what gets assigned to the budget variable after this function returns. So again, after all of this runs, the budget controller variable is simply an object containing the method called public test, right? Because that's what we returned from this function here. Okay? Now we saw in our example that this public test method here then uses this add and this x variable even after this function has already executed. So why does this work and why is it so powerful? And I'm sure that you can already guess why this works. And so yeah, this works thanks to the power of closures. So remember, because of closures, an inner function has always access to the variables and parameters of its outer function even after the outer function has returned. And that's what happens here. So the iffy, the immediately invoked function expression, returns immediately, and so it's effectively gone. But the public test function that we return here will always have access to the x variable and the add function, because a closure was created here. That's why we say that the public test method is public, because it was returned and now we can use it. But the x and add variables are private, because they are in the closure, and therefore only the public test method can access them. So again, all of this works because of closures. So these functions and this x variable are in the closure, even after this iffy here has returned. So if you truly understood all the basics that we talked about before, then this pattern is actually quite simple, but still very powerful at the same time. And if you're not 100% sure that you fully understand this concept, then you can always review the lecture about closures. Alright, so the first module is created and we now understand how the module pattern works. So let's create another module, which is the one that's going to take care of our user interface. And let's call that one the UI controller. So we talked about this module in the last lecture, right? So let's now create it. So user interface controller. So again, we write an iffy here, right? So an anonymous function wrapped in parentheses, which is then immediately executed or invoked. So here we will write some code later. And now we need our last module. Now the two modules that we created by now, they are completely independent modules. So there will not be any interaction between these two ever, because I want them to be as standalone, as independent as possible. So for example, imagine if you ever want to create a more complex budget app with a completely different user interface, you can take the budget controller module and then expand it and not think about the user interface at all. Because the user interface is separated from the data. They don't communicate at all. And that is called separation of concerns. And separation of concerns basically means that each part of the application should only be interested in doing one thing independently. So again, these two controllers don't know about each other. They are standalone. They don't even know that the other one exists. Now, we need some way to have these two connected, right? For example, we need a way to read data from the user interface and then add that data as a new expense in the budget controller. And that's why we create a third module, which is the app controller. And we also saw that one in the last lecture. So let's create that one as well. So controller simply. And now we already know how this works, right? Some space here, invoke the function, and that's it. Now, of course, modules can also receive arguments, because remember, they are just function expressions, and so we can pass arguments into them. And that's what we're going to do with this module. We'll pass the other two modules as argument to the controller, so that this controller knows about the other two and can connect them. So I will specify two parameters here. budget controller, and I'm going to write it in a slightly different way, and I will explain why in a second, and the UI controller. So these are the parameters. And so now, when we call this function, we can pass our arguments into the function. And we want our created budget controller, so this one here, be assigned to the budget controller, which is this one here. So inside of our function here, of our controller module, it will have a different name. And the same thing with the other controller. So UI controller, okay. So I could, of course, simply have used the original controller's name inside of the app controller. Or I could even not have passed anything into the module and simply have used the other controls in here in our function, because of course we have access to them because they are in the outer scope, right? So I could simply use the, let's say, the budget controller like this in here. But that is not a good practice, because this would make the controller a little bit less independent. Because imagine that we would change the name of the module, then we would have to do this all over our code. We would have to change the name everywhere in here, right? But we don't want that. So this way, we don't have to do it. So in case we want to change the name of the budget controller to something else, we would just have to change it down here. And then inside of the module, it would always be called simply budget controller. So this controller now knows about the other two modules, and it can use their code. So let's now actually try this out. So we use our budget controller, and let's test the public test method and pass it again the value of 5 into it. Okay, so let's now test this. Then we store it in a variable, let's say z this time. And now, as you know, we don't have access from the outside to this variable, so we have to create another method simply to print this variable to the console. So we need to return an object once again, and I'm going to create another public method. So I'm just going to call it another public. So these names don't really matter, because all of this is just to show you how these modules work and how they interact with one another. So this is not going to receive any arguments. And now all we do is to console.log the z variable, okay? Because again, doing it like this is the only way that from the outside we can have access to z. So let's now test this. So controller, and now we use our another public method. We call it, and nothing happens. And alright, I actually know why this happened, okay? And it's because in here we don't return this value, but we console log it. And that's also the reason why this 28 appeared here in the console, because again we did console log it right here instead of returning it. Okay, so we actually want to return this result of the add function so that it can get saved in the z variable. So let's now test this again. Alright, so this time we have nothing in the console so far, and now controller dot another public. And here we go, so 28. So we have already done a lot of stuff here. We wrote different modules, both with private and public methods and variables, and we also made them interact with one another. So really cool stuff, and really important concept that we learned in this lecture. So what we just created is the bare bones structure, or let's say architecture, of our application. And it's a simple one actually, but it's perfectly enough for this relatively small application. And I hope that you see how important it is to follow a good architecture, and I'm sure that you will see it even more as we progress with the course. A lot of courses will only teach you the coding part, but not the structuring and architecture that are so fundamental for this kind of project. Alright, so let's now start filling our newly created modules with some actual code right in the next lecture. Welcome back to the project. And in this lecture, we're going to set up our first event listener to handle our input button. So the new things that you're going to learn in this lecture is how to set up event listeners specifically for key press events, and you will also learn what the event object is and how to use it. But let's start by cleaning up our code here, because I want to get rid of all of this, because this was just to show you how everything works. And up here as well. So let's delete this. So some code. And I'll give it some structure here. So this is the budget controller. Give it some more space here. The UI controller. And then finally, let's say the global app controller. All right. So I'm going to set up the event listener for the input button right here in our controller, because this is the central place where I want to decide, so where I want to control what happens upon each event and then delegate these tasks to the other controllers. Okay, and we already know how to set up event listeners, right? So we first select an element and then attach it the event listener. So we use the query selector method. So document.querySelector, and you remember that one, right? And now we need to know the class or the ID name of this button. So in order to do that, let's check out our HTML file. And then I will just try to grab the class name. So we see that down here we have the button. All right. So this is the class that is attached to this button. So I'm going to copy it. And actually we should probably take a closer look at all this markup structure, but I'm going to leave that for later. Okay. So for now I'm just going to grab this class name here, but later we're going to look better at the structure of this HTML file so that we can better understand our user interface. Okay. So let's move back here and paste it here. So the add button, and this, remember, is the class selector because it is a class. And since this is how we select with CSS, remember this is then the exact same way that we select using the query selector, because it uses the same syntax as the CSS selectors. Okay, and now all we need to do is to use the add event listener method, right? And what we want is the click event, and then the function that gets executed as soon as the user clicks on the button. All right. So just to test this, let's create a console.log here. So button was clicked. And let's check this out. So reload and clicking the button. All right. So button was clicked. So it works. The event handler is properly set up. All right. So this was just a test. Now, of course, we cannot yet write the code in here, but we can write what we want to happen here later. So we can basically create a to-do list in here, which is basically the to-do list that we did in the planning lecture. So as soon as someone hits the button, we first need to get the input data, right? So get the field input data. Okay, after that, we need to add the item to the budget controller. So here we're basically creating a recipe for what we're going to do next. Then we need to add the new item to the user interface as well. We need to calculate the budget and we also need to display the budget on the user interface. All right. Let's create some space here. So this is what we're going to do as soon as someone hits the button, right? So we get the input data. We then add the item to the budget controller, to the user interface, and then we calculate these budgets and display them. So over the next lectures, we're going to focus on that. But for now, there's one more thing that we need to do. Because we not only want all of this here to happen when someone hits the button, but also when someone hits the return key, so the enter key. So let's see this. So imagine that someone writes something in here, let's say project, then a value here, and then instead of hitting this button here, hits the return key. So in this case, we also want all of that to happen. We also want to get the input data, we want to add the item to the user interface and to the controller and all of that. So it should be the exact same thing. So not only the click event, but also a key press event. And this is something new, so we did never use the key press event. So let's now do that. So we need another event listener here. But now we're gonna do it in a slightly different way. We're not going to select anything. We will just add this event listener to the global document, okay? So just like this, document and then add event listener. And that's because this key press event doesn't happen on any specific element, but it happens on the global web page, so on the global document, anywhere in the document, right? Now there are actually more than one type of event that handles when someone presses a key. So let's look at the event reference that I have already open here. Okay, so this is the reference for all the JavaScript events or the DOM events. And you can find this on my resources page as well. But now I already have it here open. And so here we see the keyboard events, and there are actually 3. So key down is when we start pressing the key. So any key is pressed. Then the key press event is when the key is already in the pressed position, and then the key up event is after we release the key. So for us, there's no need to use the key down or key up events. We're simply going to use the more common key press event here, okay? And remember, this is when any key is pressed, not just the enter or the return key, but this is for any key, right? So we'll need to talk about that in a second. But first, let's use the key press event here. So key press. And then again, our function. Like this, okay. Now we actually only want to execute some code when the user hits the return key, right? Not just some random key on the keyboard. So how are we going to do that? And the key to this is that this function here that is passed into the event listener can receive an argument, which is the event argument. And this is something that we have not been up until this point. So we've been using this function here, this anonymous function in this case, all the time without any parameters. But now we're going to use it for the first time, and I'm going to call it event. And actually we can use any name for this that we want and then use it in our event listener function. But I'm just going to go with event here. Another popular name that developers use is simply E, like this, but I'm going to go with event so that we are sure what this means. So this automatically gets passed into our event handler by the browser, and there's nothing we have to do. So we just need to specify it here, and then we can use it. And just to see what this event object actually is, let's start by logging it into the console. So console.log event. And remember, this is going to happen when we press any key, so not just the return key. So take a look at the console, and I'm going to hit a button now. All right, and here we have a keyword event. So this is simply an object, as we can see, with a lot of properties. And it has a prototype, so just for the sake of curiosity, let's take a look at that. So keyword event is the prototype, and this one has also a prototype, which is an UI event. So this means that the keyword event is a UI, an user interface event. And this one is also a prototype, which is an event. And this one is also a prototype, the object. And that's it. So we know that the object is usually the last one in the prototype chain, right? So we can use all of this here with the keyword event, right? And you know that already because of the prototype chain. But right now, I want you to focus on something else, which is this key code property here. So here you see a key code and a number, and this number is what identifies the key that we pressed. So right now I pressed a key and the key code is 107, but a different key will have another one. So let me press now another key. So I'm going to press the space key now. Actually, it has to be here in the document. So I press the space button, and this time the key code is 32. And now I'm going to press the return key. Again, it has to be here. So the enter key, and now the key code is 13. So this key code here is what we're going to use to say that we only want something to happen when this key code was pressed. So in this case, that the enter key was pressed. And in case that you ever need the key code for another key, I have this cool reference here, which you can also find on the resources pages. And in here, if we hit some button here, then we have the key code. So again, the enter key is 13, the space is 32, and this happens on any other key here. Okay, so just a cool reference. So let's now go back and use this knowledge. Okay, so what we're going to do is, as you can probably guess, an if statement. So we're going to use the event and then the key code property. And we say that it should be 13. And if it's 13, so if it's the return key, then let's log to the console that enter was pressed. Now, some older browsers, they don't use this key code property here. They use another property called which. And so it's a good practice to use that as well. And so we're simply going to use an OR operator here and say event.which 13. So if the key code is 13 or the which property is 13, then this happens. So again, this is for more older browsers or other browsers that simply don't have this key code property. And in this case, we're also safe because then we have this part here. So let's now test this. So I'm refreshing, and now I'm hitting some random keys here, as you can hear probably, and nothing happens in the console, right? And now I'm going to hit the enter key. Okay, enter was pressed. So this works. Now, what do we want to happen here? Because we don't want the console log, of course, but we want something to happen, which is, as you can guess, the exact same thing what we want to happen when someone hits the input button. So we could copy this code that we're later gonna write here and paste it here. But as you probably know, this doesn't make any sense at all, because that would completely disrespect the don't repeat yourself principle. So the solution is once again to write a custom function. So let's do that up here. And I'm going to call this one the control add item function. So var control add item. And I'm going to prepend this control here to this function name because there may be functions with similar names in the other controllers and I want to be able to distinguish them. So I'm already planning with that, okay? So a function which simply will do all of this here. So this is not real code, of course, but this will then be where we specify all of these actions. So now what we do in here is to simply call this function. So in case that someone hits the return key, we want to call the control add item function. And that's it. And now here, the same thing. So I'm going to remove this from here. So we no longer want the anonymous function here, but we actually want to pass the control add item function in here. And we already did that before actually in our other project. So it doesn't have to be an anonymous function. We can simply pass a function that we have, a standalone function, pass it here into the add event listener method. And again, we're not going to call it here, so we don't need this call operator because this is a callback. And so the add event listener method will call it for us when needed, so when necessary, so when someone clicks the button. So just to finally test this, let's log something to the console here. Doesn't matter here, so it works. And alright. So I'm going to hit the space key, nothing happens, and now the return key. So it works. And now I'm going to hit this key here, sorry, this button here, and so it should appear again. And yes, here it is. So it works. Alright, so now we're all set up to start adding some code to our event listeners. So let's do that in the next lecture. In this lecture, we are going to read the income or expense data out of the user interface input fields, so that we can use it in our app later. So it only makes sense that in this lecture you're going to learn how to read data from different HTML input types. Okay, so here we are in the app controller, and the logic in this project will always be that in the controller is the place where we tell the other modules what to do. So we write methods in the UI controller and in the budget controller to get some data for us or to calculate something, and then in here in the controller we call these methods. So in this particular case that I want to get the input from the user interface, I'm going to write a method in the user interface controller and then call it here in the controller so that I can get this data and then use it further. For example, to pass it into the other controller so that it can then add the input data as a new expense or a new income to the data structure that we're going to create later. So let's now start by writing a method into the UI controller to get our input. So here in the UI controller, we're going to write a method or a function. Now, this is a function that we want to use in the other controller, right? So it cannot be a private function, right? So instead, it's going to be a public function or a public method. So it will have to be in the object that this function here, this iffy, will return. So again, and I'm sure that you remember this code here will execute immediately, and then the object that we return will be assigned to this UI controller here. And all the variables and the functions that we define in the function will stay in the closure even after this function returns. The object that's going to be returned from this will have access to these private methods or functions and variables. Alright, so let's write our method. So return, as we were saying, right? And we return this object. So let's say get input. So a function without any parameters. And now in here we read the data from the user interface. So what do we have in the UI? So we have the type here. So if it's an income or an expense, then we have the description and the value. So let's see that in the HTML file. And let's actually now take a deeper look at this file as I promised you before. So basically the UI is divided in two parts, which is the top part here, which is this one. All of this is the top part, and then all of this here is the bottom part, okay? So we have the top part, and in here we have, of course, the budget title, the month, which we're going to replace later. Then we have the budget value here. We have the budget value of the income only, and also of the expenses. So all of these are in the top part, and we're going to use all of these later on, right? And then we have the bottom here. And in here we have the add container, so which is basically our form, so where we have all our input, And then our inputs are the add type, which is for the income or expenses type. We have the add description and the add value, and the add button that we already used to set up the event handler. Okay, and then below that, the container. So basically all of this here, right? This part here of the user interface is the container, which is also divided in two parts. It has an income part on the left side and an expenses part on the right side. And each of this has, of course, a title, right? And then it has a list, so an income list, and down here an expenses list. Okay? So right now these are empty because all of the items are commented out here so that it's empty in the beginning. But this is how an item looks like. So this block of code here is an item, and we will take a closer look at this one once we start adding items to our user interface. So let's now concentrate on what we need for this step, which is this add type, add description, and add value. So value, description, and type. So we're gonna select all of them and retrieve their value. So let's start with the type. And we already did this in our other project, right? So the logic is always the same. We select something and then we do something with the selection. So document.querySelector, and then remember it was the class called add and type. And actually it has 2 underscores, I think, but let's just double check. Yes, so 2 underscores, which is a special notation. Okay, and then simply use the value property. Remember that one? So that's actually it. So with this, we read the value of the type. And since this is a select element in the HTML, it works a bit different. So in these normal input elements, like this one here, so like these, we simply get the value that's written here, right? But in the select element, which is this one here, what we get is these values that are specified. So if the first one is selected, what we get is inc, which stands for income, and if the second one with the minus is selected, then what we get is the exp, so expenses. So let's just annotate this here so that we don't forget it. So will be either inc or exp for expense. All right, and now the description. So document.querySelector, and this one is add description. And again we use the value. And now finally the value. So document querySelector, add value, and reading the property called value. All right. Okay, so now we have the 3 input values stored in these 3 variables. Now remember, the controller is going to call this method and it wants to receive back all of these values. So we have to return something here, right? So how do we return 3 values at the same time? The best solution for this is to simply return an object containing these 3 as properties. So instead of having 3 separate variables, we should simply return an object with 3 properties, which are these 3. So let's do that. So I'm saying return an object. And so let me copy this in the inside. Now of course I need to change some stuff. So we don't need these var keywords. And it's not the equal operator. But this is how we define properties, right? Oh, and also these should be commas and not semicolons. Okay. So this is our method for returning all of the 3 inputs that we have in the user interface. So let's now call this method from our controller And we're going to do it right here. So under this comment here, we will say var input should be the result of calling the getInput method. So, and it's a method of the UI controller, right? So UI controller, which is the module that we have access to, and then getInput, which is the public method that we can access. And no parameters here. So let's not console log simply the input. And we can remove this console log from down here. Okay. So remember, this will happen as soon as we either click the input button or hit the enter key, because this is in the function, right? So this is in a function that is called when either one of these actions happen, right? So let's now test this. And I'm going to refresh it. So let's say it's a minus, so an expense, and I'm just calling it test and some number. And now I hit enter and okay. So we have an object actually, and it has type expense. So this is correct because I chose the minus here. Then the description is test, right, which we have here, and the value is 23. So everything is correct. Let's just create another one. So test2 with something else, let's say 12. And now hitting the key, so it also works. So income and test2 and 12. Cool. So now we have these two modules talking to one another by calling each other's methods. So this is a pattern that we will see a lot of time happening. So basically the controller calling some method, and these methods then do something and return it. Now if we move up here to this method here and to this controller, there is actually one small problem that I don't like so much. And that is that we're starting to have all these strings here for query selectors all over the place. Like this one, this one, this one, and down here is also this one. And they are only going to get more as we proceed with our application. And that's a problem because imagine that we make some changes in the UI and the class names, and then we would have to change all of these strings manually. And this, of course, could cause some serious bugs. So instead, we can simply create an object where we store all of this data. And since we're talking about the UI here, we should, of course, do it in the UI controller. So we can create a private variable here and call it DOM strings. So DOM strings. And it's going to be an object. And I will store all of the strings in here. So let's say input type, and then I put this one here. And now I could go ahead and simply write DOM strings dot input type. All right. So now if I decide to change all of the class names in the entire user interface, then it's not such a big problem. Then I just have to come here and change the string in here as well, and not in our entire code. So this means that we have now a central place where all the strings are nicely stored, and we can then retrieve them and change them easily. So once again, programming is not just to make things work in some way, but it's also create the necessary structures to make our life easier. And this is definitely one of these moments where we have to create some kind of data structure to make it easier for us later on. Okay, so input description. And of course, it's going to be this one. And then the input value. And now I just need to put them back here. So DOM strings, and this was the input description. So input description, and then here the DOM strings dot input value. So just to confirm, let's reload this and see if it still works. So test, 78. And yep, so it still works. All right, so now there's only one place left where we have a hard-coded string, which is in here. Now the DOM strings object is in a different controller, right? So we don't really have access to it from here. So is the solution just to copy this object here into our controller? No, of course not, and you already know that by now, right? So the best solution is, of course, to pass this object from one controller, from one module to the other. So what I'm going to do is something similar to the getInput method here, and this one will simply be called get the DOM strings. And all we need in this function, in this method here, is to return our private DOM strings into the public. So basically we're now exposing the DOM strings object into the public. So I can now come down here into our controller and define a new variable to get the DOM strings. So UI controller dot get DOM strings. And that's it. So now inside of this DOM variable we also have the DOM strings that we have up here in this controller. Because once again we expose them to the public by using this method here. Okay? So now what I can do is, of course, I first need to add this to the DOM strings, right? So I say input button. Okay. And so now I can use it here. So DOM dot input button. Because remember, now it's called DOM here because that's the variable where it's stored now and no longer DOM strings. So in this controller it's called DOM. So let's test this again very quickly. So again, test. Then let's say 55 here. And now I hit this button. And yes, so down here it is. So we're making some great progress here in our application. And we're getting a really nice structure here, which is something really important, as you know by now. And so in the next lecture, let's continue with that. So see you then. In order to make our app structure even a little bit better, let's now create an init function such as we did with our pig game project before. So in this lecture, you're going to learn how and why we should create an initialization function in our current architecture. So here is our controller again, and I feel like things are all a bit scattered here in the controller, like these event listeners here are just hanging around here, and then up here we have this variable declaration. And so I think we should organize this a bit and make it so that we only have functions here in the controller. So let's create a function here called setup event listeners. Okay, so a function in which all our event listeners will be placed. Because right now we have 2, but over the course of this project we will probably add some more. So let's do that. So setup event listeners. So function, and we don't need any parameters. And so I'm just going to copy these event listeners right here into our function. We don't need this extra space here. Okay, so here I left out a semicolon. And now this can go. And also into our function should of course go this here, right? Because we'll only need these DOM elements here for our event listeners. Okay, so now we have a function that sets up all our event listeners, and we have a function that gets called when we want to add a new item. And these are both private functions, right? They're not exposed to the public. Now, if we want these event listeners here to be added or to be set up, then these lines of code here, of course, need to run, right? Which means that this function, this setup event listener function, has to be called somehow. And up until this point, this wasn't a problem because all of this was here in this IFI, so in this immediately evoked function expression, meaning that we didn't have to think about if this code is executed or not, because it's automatically executed, right? But now we need to call this function. And the best and most common way to do this is to create a public initialization function, which we're going to call init. So let's now do that. So since we want it to be public, we need to return it in an object, right? And we simply call it init. All right. So in this function, we can, for example, say that the application has started with a simple console log, just to test this. And then we need to call our setup event listeners function, which was why we created this init function in the first place, right? So setup event listeners. Okay, so that's it for now. This init function will be useful for other things in the future, so that's also a reason why we created this. But for now, this is enough here. So this means that our event listeners are only going to be set up as soon as we call the init function. So we need to do that, and we do that outside of the controllers. So this will be the only line of code that's going to be placed on the outside. So controller.init. And without this line of code, nothing is ever going to happen. And that's because there will be no event listeners, right? And without event listeners, we cannot input data, and without data, there is no application. So let's check out if this works. All right, so application has started. Let's see if this still works. Yes, so we still see our object here, which we still print to the console. And we can actually now go ahead and delete that console.log, if I could find it at least. Here it is. Okay, so yeah, this is our init function. We created it because we want to have a place where we can put all the code that we want to be executed right at the beginning when our application starts. And right now, that is to set up the event listeners, but there will be more code in the future. So more things that we have to do right at the start of our app. All right, that's it for this lecture. So let's now move on and create some function constructors. Let's now finally use the user input data to create a new item in our budget controller data structure. And by doing that, we'll learn how to avoid conflicts in our data structure, and also how and why to pass data from one module to another. And we actually already did that, but in this lecture, it will make even more sense. So let's now create a public method right here in the budget controller that's gonna allow other modules to add a new item into our data structure. So we return an object once again, which is going to contain all of our public methods, which for now is only this one, add item. So a function with some arguments that I'm going to specify right now, and then our function body. So if someone calls this method, what do they have to tell us in order that we can create a new item? First, we would have to know the type. So if it's an income or an expense. So type, and we also need the description, right? And of course, the value of the income or of the expense. And I'm using different names here so that we have less confusion. So in this method, they have their own names. So type, des, and vol. All right, so how would we add, for example, a new expense? We would simply do it like this. New expense, and then we need an ID we would pass the designation and the value, right? And then we would also store this, of course, in a new variable. So let's call that one new item. And I'm going to declare it up here in the beginning of the method. So var new item. Okay. So this is in the case that we're talking about an expense. So the input here can be an expense or an income. But what exactly are we going to receive here in this type argument? For that, let's take a look at the controller again. Okay. So the input that we're going to receive here, this input variable, which will come from the UI controller, will actually contain this type, right? So let's go check out this method. So it's here, right? So one of them will be the type. And this is the type that we're later gonna pass into our addItem method. And remember, we wrote down here that it will be either inc for income or exp for expense. Okay, and since we know that this is the data that will be passed into the addItem method, we know that we can expect either inc or exp. So we can now use this knowledge here in this function. So we can say that if the type is an exp, so an expense, then this is what we're going to do. So the new item will be a new expense. So I was missing the equal operator here, right? But if it's not an exp, so if it's an income, so an inc, then what we want is of course to create an income object. Okay, so again, if we receive this string here as the type argument, then we want to create a new expense using the designation and the value that we pass in. Or if the type is an income, then we want to create a new income object based on the income function constructor that we have, remember, up here also in this budget controller, right? And so this is how we create our new items. Now there's of course one missing piece, which is this ID, but let's leave this one for later. So for now, let me just say that ID is 0. And I'm going to change that later again. But for now, let's leave it like this. And so after we have the new item, we can then add it to our data structure. So remember, all of these new items will be stored in this data object, and inside this data object in the all items object. And in there we have two arrays called exp and inc. And now see that these names are the exact same names that we have here. So exp and inc, which is what we receive here from the type. So this is very, very useful because now we can simply do it like this. So data dot all items, and now we don't need any if or else statement to determine in which of the arrays we want to store the data. No, we can just do it like this. Type, right? And if we now say push, and I'm sure that you remember this method, we can add our new item at the end of the array. And that's it. So let's think about this again. So we have the type that is exp or inc, which comes from here. And these two designations are the exact same that we have here in our data structure. And therefore, we can use these brackets here to select the array that we want here from our all items object. So if it's exp for an expense, then this array here will be selected from the all items object. And if it's inc, then of course this array here will be selected. And then we can use the push method on it. And the push method, remember, simply adds a new element at the end of the array. Okay, so this is very simple. And now all we need to do is to return that new item as well. Because then the other module or the other function that's going to call this one can have direct access to the item that we just create. And this will be useful as you will see in a second. Now there's one thing that we left for the end, remember, and that's this ID part here. And this ID is a little bit tricky. So remember, the ID is a unique number that we want to assign to each new item that we put either in the expense or in the income arrays for the all items, right? So how can we determine, how can we specify this ID for each new item? The first thing that comes in mind would be to simply use the length of the already existing array and then add 1, right? So imagine that we had an array with 5 elements. So let's say 1, 2, 3, 4, 5. Then it would sound logical to say, okay, the next one should have an ID of 6, right? So the next ID equals 6. So this is just a comment just to show it to you. So this would be the simplest solution. Now there's a big problem with this, and that's because later on we're going to delete items from this. And so imagine that instead of this nicely sorted array here, we would have IDs like this. So for example, 1, 2, 4, 6, and 8. Something like this. If we would now go ahead and say that the next ID should be 6, then the problem would be that we would have 2 elements with ID of 6. So this is not ideal at all, right? Because each ID should only exist once. So in this case, what should the next ID be? It should be 9, right? So next ID should be 9, because that's the number that comes after the last one. So let's describe what we want and then code it. So we want the ID to be equal last ID plus 1. And how do we determine the last ID? In this case here, the last ID would be the position number 4, right? Because 0, 1, 2, 3, 4. And why is it 4? It's 4 because the length is 5, and since the array is 0 based, the last one is 5 minus 1. So based on that, let's do this. So we want to first select the last element. So data.allItems, and then of the type that we're currently using, right? And I already explained that down here, why this works this way, right? And now we want the last one. And the last one is simply the length minus 1. So again, data.allItems type length minus 1. Okay, so this looks a bit strange, right? So imagine that the type would be inc. So in this case, this would be data.allItems inc. So this one here. So we want to now select the last item. So we need this here, the brackets, with a number in it, so that we can select the last element. And the number is, as I explained before, the length of the array minus 1. And so we need to type all of this again, and then retrieve the length, and then minus 1. Okay, so now we have the very last item, but we only want the ID, right? So we retrieve the ID like this. Okay, so this is basically the last ID. So if our array would be this one, then our last ID would now be 8. And remember, the ID that we want is 9, so last ID plus 1. So this is the last ID plus 1. And here we have the ID for a new item. So this is actually already it. So let's just comment this. So create new ID, then recreate the new item based on inc or exp type, then push it into our data structure, and finally return the new element. And I actually highly encourage you to do this kind of comments whenever you can, so that later your code becomes more easily for you to understand when you didn't look at it for some time. Alright, so now this method is ready to be used. So let's do that in a controller, of course. Where else could it be, right? And we're going to do that right here in the control add function. So we already have our input. So we can now use that input to add the new item. And for that we call the add item method on the budget controller. So budget controller add item. And now let's remember the data structure that we returned from the get input method here. So it was type, description, and value. So an object with these three properties. So this input variable here right now has that object. So we now say input.type, then input.description, and input.value. Make sense? So our add item method accepts three parameters, so three arguments, which are the type, description, and value. And so in here we pass the three which come right from our input that we get from our user interface here with this method. And now remember that this add item method returns an object, so we have to save it here. So let's call it new item here as well. So var new item. And let's actually also declare all the variables here at the top. So var input and new item. All right. So this should now be working just fine. And remember that this will not be yet displayed on the user interface, of course, but it should appear in our data structure. Now the data structure is a private variable in our module, right? So this data structure here is not visible. So when we add now something, then it will be here in our data structure, but it will not be accessible from the outside. So let's just quickly add a new method here, just so we can see it in the console, okay? So this method is going to be testing. Again, this is not for us to use in the application, but just to test this in the console, okay? So function, and all this does is to console.log our data structure, okay? And now we're ready to test this. All right, so let's add an an expense, like new car for $1,500 and hit OK. And all right, so we have a bug here on line 37. So let's check that one out. So line 37 again, and it's here in this line where we create the new ID. And let's go back. It says that it cannot read a property ID of undefined. Okay, and that makes a lot of sense because right now we don't have any item here in our data structure here, okay? So of course, here this length will be 0, and then 0 minus 1 is minus 1, and there's obviously no minus 1 in this array. And so this ID cannot exist because there is no item in the array for that. So what we have to do here is that when the array is empty, then the new ID should be 0. Okay, so let's do that. So if data.allItems and then the array with our type again. So the length of this should be greater than 0. And only in this case this will happen. Okay. And if not, then the ID should be 0. Okay. So this is for the beginning. So right now, the all items array of both income and expense both have a length of 0. So the ID will always be 0 now. But then as soon as we have some element, then the new ID will be defined based on this. So let's see if it works now. And again, an expense for a new car for $1,500. And all right. So nothing happened because we didn't write a method yet for displaying this in the user interface. But let's now use our testing method. So testing, and okay. So this is our data structure. And it has, of course, the all items object and the totals object. So exactly what we put in the data structure in the budget controller. Alright, and here's the expense array. And there are actually already two. So I click twice on this button here. And here's our expense, the one that we created with the expense function constructor. So new car 1500 and the ID is 0. And let's see, the other expense is also new car 1500, but the ID is 1. Okay, so this was because I clicked twice here on the button. So we created two expenses. But what this shows us is that this is really working. So let's just add an income as well. So project, doesn't really matter, for 2000. Hit enter. And then let's use this again. So the totals there are of course still 0 because we don't have any code for this as yet. But now the income also has one element. And it's this income that we just added. So project with a value of 2000 and an ID of 0. And of course, our two expenses are also still here. So this is really working now. So all we need to do now is to actually add this new element into the user interface. So let's now do that in the next lecture. In this lecture, it's finally time to add our newly created object to the user interface. And this means that we're going to do some DOM manipulation for the first time in this project. And this means that you're going to learn a technique for adding big chunks of HTML into the DOM, how to replace parts of strings, and also how to do DOM manipulation using the insert adjacent HTML method. So it's time to go back to our user interface controller and add a new public method here, right? And I'm going to put it right here. And this one is going to be called add a list item. So add list item. So a function, as always, and a function body. And what kind of information do we need to add this new item to the list? First, we need the object itself. So let's call it object, and then the type. So if it's an income or an expense, so we already know that. So and this object is the exact same object that we created using the function constructor and then passed to our app controller in the last lecture. So let's quickly review that. So down here in the control add item function, which remember is the function that is called when someone hits the input button or hits the enter key, then we first read the input out of the fields, store it into the input variable, then using this input variable and the add item method, we create a new item and we return it and store it in this variable. So in here, in the new item variable, we now have the new object. And that's the object that we're going to pass to our add list item method. Does that make sense to you? So again, the logic here is that this method here, or this function, is like the control center of the application. So it tells the other modules what it should do, and it then gets data back that it can then use in other things, such as this input variable, for example, and this new item variable that we will use to display the object on the interface. So let's go back to the add list item method. So what are we going to do here? So this will be in 3 steps. So the first thing is to create an HTML string with some placeholder text. So create HTML string with placeholder text. And then we're going to replace the placeholder text with some actual data, which is the data that we receive from the object. And then finally, we insert the HTML into the DOM. Make sense? So let's talk about the first part, which is creating the HTML string. And for that, we need to look at our HTML file. Okay, so in here, this is how an income item looks like. So we have the description here, right? So salary in this case, then the value, which would be 2100 here. Then we also have a delete button. Okay, so this is the HTML for an income. And then down here, we have the expense, which actually looks pretty similar. The only difference is that we have the item percentage class here, which we're going to talk about later. So this is one of the differences, and the other difference is that the ID for the expenses is expense 0, expense 1, and so on and so forth. And then here it's income 0, income 1, income 2, and so on and so forth. So we actually need to create different HTML strings for incomes and for expenses. So let's start with the incomes, and I will just copy all of this and paste it here into our JavaScript. Okay. All right. So this looks a bit weird now, because the JavaScript file is of course not to write HTML. So what we're going to do now is to put this in our single quotes, like this. And now all we need to do is to remove all of these spaces here. Okay. So this is a bit boring work, but we'll have to do it. Okay. Alright, so now this is a string which contains a lot of HTML. And actually this is a good place to show you the difference between the single quotes, this one's here, and the double quotes. So inside of these single quotes, we have lots of double quotes in here. So all of these, as you see here, all of these are double quotes. And so JavaScript doesn't interpret this as an end of the string, because we began the string with a single quote, and so the end of the string is a single quote as well. Now if we have put the double quotes here like this, then JavaScript would only interpret this as a string here, because then it would be the beginning of the string and here the end. And then here a new beginning and here a new end, but that's of course not what we want. So we want a single quote here. Now if all of these would be single quotes in here and not double quotes, then in the outside we would put double quotes, and then it would work as well. Alright, so let's call this one HTML. And I'm going to declare it up here. Okay, so this is the one for income. And the one for outcome will actually be pretty similar. So let's get this one as well. So this is like a template that we copy here into the JavaScript file so that we can then use it. So once again, removing all of these white spaces here. And here we go. So now put the quotes around this. And here we go. And now what I need to do is actually to create an if-else statement because of the type. So if the type is an income, so inc, then we want this to be the HTML string. Okay. And else, if the type is exp, so for expense, then it should be this HTML string. Alright, and now what we want to do is to replace the actual data that is in here with some placeholder. And that's because when we then receive our object here, right, we can then go ahead and replace these placeholders with the actual data. So let's do that. So let's replace this with something like this. So percentage ID percentage. And I use these percentage symbols here so that the placeholder text is easier to find here and that we don't overwrite something that we don't want, okay? So in here, it's gonna be a value, right? So value. And I'm missing the description. Ah, here it is, okay. So description. And of course the same thing in here. So this is where the ID will go. This is the description. And then here, the value. All right, cool. So let's now go to the next step, which is to replace the placeholder with the actual data. And in order to do that, we will use a brand new method that we have never used before, which is the replace method. So let's say I will create a new variable first, new HTML, okay? So let's say new HTML is HTML, which is our string, and then strings have a bunch of their own methods, just like array. And since HTML is a string, we can use all the strings methods here. So we use the replace method. And what replace does is exactly what we want. It searches for a string and then replaces that string with the data that we put into the method. So let's start with the ID here. So our placeholder text goes like this, ID, and what we want to replace it with is our object dot ID. Okay? Because remember, the ID property is the one that holds, of course, the ID. And we can see that here. Okay? So these are our function constructors, and they are called ID, description, and value. So these are the three that we will have here in our addList method, and that we can use to replace our placeholder strings. So this was the first replacement. And now we can overwrite this new variable that we created. And now we will not replace the placeholder in HTML again, because it's in the new HTML variable now, where we have made this replacement here. So if we would now do HTML replace again, then this ID placeholder here would still be there. Okay, so we actually need to do it on the new HTML. Replace. And let's go with the description now. And say object.description. And now I'm just going to duplicate this. So here is value, and here is value as well. Alright, and now all we need to do is to insert this into the DOM. And that's something new that we didn't do before, so let's see how we can do that. So we first need to select some element on our web page, so from the DOM, and then we can insert our HTML next to that. And we're going to use the insert adjacent HTML method for that. So let's take a look at the reference page of that element, and it's right here. So this insert adjacent HTML method first accepts the position and then the text, so the string, the HTML that we want to insert. And there are 4 different positions in which we can insert the HTML. So imagine that this P element was the one that we selected. We can then insert before that element even begins. So we use before begin. We can insert it as a sibling after that, so after end, or we can insert it as a child of P. And then we have 2 options, which is after begin, which is basically before any content inside of the P element. So after the P element began, and then before the end. So at the end of the P element, but after all of the content that is inside of it. And that one is actually the one that we're going to use. So we're going to use before and I will show you why that is. So let's go back to our HTML file. And what we're going to do is to add the expenses into this expense list container. And in there will be a lot of child elements. So all of these expenses will be childs of the expense list container. So that's for expenses. And for incomes, it's called the income list. So in this case, the div element here has a class of income list. So we actually need these two and then decide which one we want to append this new HTML. So let's start with the income list. And maybe you can guess what we're going to do now. We will put a new field, a new property here in our DOM strings, okay? And I'm going to call it the income container. Income container. And then I will paste it here. Oh, sorry, I didn't copy it. So income list. Okay. And then I'm going to duplicate this line and do the same for the expenses. So expenses container will be the expenses list. So again, this is the element that we want to select if we have an income, and this is the element that we want to select if we have an expense. So let's do that here in our addList item method. So we can use this if else statement for that, right? So if it's an income, we can say that the element should be DOM strings dot income container. All right, and I still have to declare it here. So element. And now in case that it's an expense, then the element will be DOM strings dot expenses container. All right, and now we're ready to select this. So document dot query selector, and now we simply select the element. Okay, so very easy. This element will be the income list if it's an income, and the expense list if it's an expense. All right, and now it's time to use our insert adjacent HTML method. All right, and as we said, we're going to use before end. So before end, and then what we want to insert there is of course our HTML. So the string that we produced, and actually it's not HTML, it is new HTML, because that's the one that already has all our values, description and ID. So again, this before end keyword here makes it so that all of our HTML will be inserted as a child of these containers, so this income list and the expense list, but as the last child, so as the last element in the list. So if you already had like 2 or 3 items here, then the next one would be here after that, so the last one. Let's just look again at the reference. So imagine if we would use before begin, then the new element would be inserted right here. So before this income list, so not as a child, but as a sibling and before this element. And then after the end would be down here. So also as a sibling, but after this element. Okay, but enough code. Let's now see if this actually works. So again, we need to reload this. Okay. Application has started. So everything seems to work up until this point. So I'm now going to add an income. Let's say project for 1,500 euros. And nothing happened. And that makes a lot of sense, of course, because nowhere in our code we called this addListItem method, right? So before making it possible to anything appear here, of course, we need to first call this. So we do this, of course, in our control addItem function. So it's as simple as this. The UI controller, addListItem, and now, as I said in the beginning, what we're going to pass in here is the new item that was created here before. Okay? So the object created through one of our function constructors. So the new item and then the type. So we're going to use input.type, right? Because that's where our type is stored. So whether it's an income or an expense. And now it should be ready to work. So again, project 1500. Oh yeah, here it is. So it worked. It is here in our user interface. How cool is that, right? So it really worked. This is really cool. So let's try it with another one. Let's say we sold our car for 2500. And yeah, here it is also. So for me, this is a really magical moment when we hit the enter button here and then something like magic appears here on a web page. So this is really cool. Let's try out an expense now. Let's say our rent is like, I don't know, $950. And now it should appear in the expenses, right? And yes, here it goes. So everything works exactly as expected. Now forget about this 21% here, because this is just the text that we copied from our HTML page, and we're going to take care of this later. But for now, what matters here is that at this point we're able to really add the elements to our user interface. So this is already a great achievement. So now that we have this, over the next lectures we're going to take care here of the budget part. So we're going to calculate the budget and update it here on the user interface as well. So don't wait and join me right in the next lecture. So in the last lecture I promised you that we were going to work on the budget calculation now, but first we need to actually fix a really annoying thing in our user interface, which is to clear the input fields after we entered an input. And in this lecture you're going to learn a lot of new stuff. So you'll learn how to clear HTML fields, how to use query selector all that we hadn't used before. You'll learn how to convert a list to an array, and also a better way to loop over an array than for loops. And that is the for each method. So a lot of stuff to cover in this lecture, so let's do it. So here is the problem that we need to solve. So in the last lecture we added this rent here, but now this rent and the value as well is still here. So we can continue to click here and the new one will be added. And if we continue to click, new ones will be added. So all of these rents are now here. So of course we need a way to clear these input fields, right? So let's now do that. And since this has clearly to do with the user interface, we go to our UI controller, which is right here. So we're going to add a new method to this controller. And of course it's going to be a public method once again. And this one is called clear fields. So clear fields. And of course we don't need any parameters because we already know which are the fields that we're going to clear, which are the two that we saw before. Alright, so these are two fields. So let's now use the query selector all instead of doing the query selector that we've been using. So we could do that, then we would use it twice, but instead we can reduce it to one line of code by using the query selector all. So let's do that. So document.query selector, and this time it's the query selector all. So let's check out which one we need. So it will be the input description here and the input value, right? So we need to select these two. So DOM strings dot input description here. Okay. And now remember, the syntax here is like CSS selecting. So we separate different selectors simply with a comma. So we need a string with a comma here, and then we can join these strings together, right? So what is left now is the input value. Input value. Okay, and let's actually store this in a variable. Okay, so I'm going to call it fields. So fields, because these are our two fields, right? And let's declare the variable once again here in the top. So var fields. Okay, so this fields variable now holds the result of this selection. Now the problem is that the query selector all method does return something strange. It doesn't return a nice array which we can then use and loop over, but instead it returns something similar but still different, and that's a list. So again, a list is a bit similar to an array, but it doesn't have all of these nice methods that we have for arrays. So the solution to that is to convert the list to an array. And there's actually a nice little trick that we can use for that. And the trick is to use the array method called slice. And what slice does is to return a copy of the array that it's called on. So usually we call this method on an array and it then returns another array. But we can kind of trick this method and pass a list into it, and then it will still return an array. So that's the solution for this. Alright, but there's only one small problem with that, because we cannot do it like this. So fields.slice will not work, because again it's not an array, and so we cannot call array methods here on the list. Instead, what we have to do is to call the slice methods using the call method, and then passing the fields variable into it so that it becomes the this variable, and then it's gonna work just fine. And how can we do that? So where is the slice method actually stored that we can use it? Let's think about that. So where do you think it is stored? And the solution is that it's in the array prototype. So we can write something like this. So this array is the function constructor for all arrays, right? And we know that all the methods that the arrays inherit from the array function constructors are in the array's prototype property, right? And therefore we know that the slice method must also be there. So we can write array.prototype and then .slice. Alright, so here it is. And since this is a function, we can then use the call method on it, right? So call. And then in here, we set the this variable to the fields. And this will trick the slice method into thinking that we give it an array, and so it will return an array. So if we now store this into a variable and call it fields array, then this will be an array. And actually, again, I'm putting it up here. So fields array. So this is now an array. So this is a nice little trick that we can use. This means that we can now loop over this array and clear all the fields that were selected, which were only 2 in this case, but if it would be more, then all of the fields could be cleared at once. Now we could do it with the old school for loop that we have been using all the time up until this point, right? But let's make it more exciting, and so I will show you a new method that we can use on arrays, which is the for each method. It works something like this. So fields array, and now for each. And this is really simple. All we have to do is to pass a callback function into this method, and then this callback function is applied to each of the elements in the array. So let's put an anonymous function in here. Okay. Just like this. Now this callback function here, so this anonymous function in this case here, can receive up to 3 arguments. And this is really like the callback function that we saw before on the event listener. Remember that? In that case, we did automatically have access to the event object. And we could name that object as we wanted, right? So here it's actually pretty similar. So here we have access to 3 things. We have access to the current value. So this means the value of the array that is currently being processed, let's say. Then we also have the index number. So the number going from 0 to the length of the array -1. And then also the entire array. So we have access to the entire array here as well. And again, we can name this as we want. We could just call these something like cur, let's say. And this one just index or just I. So we can do it as we want, and it will always work. So this is something really nice that JavaScript has for some methods. So remember, what we want to do here is to simply clear all these fields. So we want to see them empty. And that's actually really simple. So all we have to do is to select the current, okay, which is this here. And this means the current element that is being processed. So it will first be the input description and then the input value, right? So if we set the value of these back to empty, then the fields will simply be cleared. And it really is as simple as this. So again, this for each method here loops over all of the elements of the fields array and then sets the value of all of them back to the empty string. And we have access to the current element thanks to this callback function here, which has access to these three arguments. So the current element, the current index, and the original array, which in this case would be fields array. Okay? So let's now use this method. And for that, we're going to go back to our controller. And this is something that we actually didn't put here in our comments. So let's say for clear the fields. And what we're going to do is UI controller and clear fields. So as simple as that. So let's now test this. So reload. And now salary, let's say, of 1200. And yeah, the fields are empty now. Let's try it again. So holidays, 600. And yeah, it's empty again. Now, one thing that we should also do is to set the focus back to the first field here, right? So that we can easily continue to put more items in here. And that's also pretty easy to do. So let's just go back to our clear fields method. And then we just need a line of code here, which sets the focus on the first element of the array, right? So fields array 0, which is the first element, which will be the input description, which is exactly what we want. So it will select the first element, and then we simply need to use the focus method. So focus, and that's it. All right, let's see that again. And again, salary, 1200, let's say. And yeah, the focus is back to the description. So this makes it easier to input the values. All right, but now it's really time to start working here on the budget and on the total income and expenses. So come with me right to the next lecture. In this lecture, we're going to start working on updating the budget, and the first step is to look at our controller module. We'll also fix some minor problems that our app still has at this point. And so you'll learn how to convert field inputs to numbers, and you'll also learn how to prevent false inputs. Alright, so here in our controller module, and more specifically here in the control add item function, we already have these spots here to call the methods that are going to handle the budget update. Now, I want to move this to a separate function. And that's because first, these steps kind of belong together. And second, because we're going to do all of this again later when we want to delete an item. So instead of repeating this code by then, we can simply write a new function to keep the dry principle, so to don't repeat yourself principle. And so I'm going to do that right now. And I'm going to call it update budget. So very simple. So var update budget. And we don't need any parameters. So all of this will actually go in here. So first we calculate the budget, which we're going to do in the next lecture in the budget controller. And then we're also going to have a method that will then return the budget. Okay, and I'm doing two separate functions here. So one that calculates the budget and one that simply returns the budget and does nothing else. And that's because I want you to get used to this kind of philosophy that each function has a specific task, and that simply getting some information from a module is a good task for a simple function. And we actually have already done some of these get functions like get input or get DOM strings, and so we're going to continue with that here. So we will have another function in the budget controller that will simply return the budget. And then of course we need to display the budget on the user interface, and that will be a method on the UI controller that we're also going to code not in the next lecture but in the one after that. Okay, so then we have to of course call this function in here, right? So let me just say calculate and update budget, and then we call update budget. Alright, so in here we set the stage. Now we just need to code all of these methods over the next lectures, and I will then call them from the update budget function. Now before we can move on to actually do all of these calculations, there are still two things left that we have to take care of. And in order to see them, let's look again at our project here. And the first one is this. So let's suppose we add something here. Let's say salary again, and then 1200. Okay, so everything nice here. So let's use the test method that we did for the budget controller. Remember that? So we had budget controller and then a testing method, which was only to display the internal data structure where all the incomes and expenses are stored. So here is the object, if I remember, is called data, and it has these two objects in it. So here we have the income that we just added, right? So this array, actually this object, so the description is salary and the value is 1200 and the ID is 0. Now here is the problem. We see here that this value is not really a number, it's actually a string, right? And that is a problem. So the ID here is a number, so everything's fine here, but this is a string and we cannot do calculations with strings. So we need to change this. So remember where we actually read this data from the interface? There's a method up here, and here it is. It's the get input method, right? So here in this line of code we read this value, and what we read is a string as we just saw and not a number. But fortunately there's a very handy function in JavaScript which is simply called parse float. So parse float, which converts a string to a floating number, so basically a decimal number, a number with decimals. And so we can have numbers with decimals. So instead of having $10, we can have $10.50, for example. Alright, so again, this function is going to take this string here that this returns and convert it to a number, which is then assigned to this value property. So let's now reload this and check if that actually worked. So salary once again, 1200, and then we need to use our testing method again. And now you see why it's so useful to simply write a testing method like this, not to use in production, so not to use in the final application, but here during development, it's really useful to have a public method like this to expose some internal data. So all items again, the income, and alright, here we go. You see, now it's a number, so it no longer has the quotes, and it's also here printed blue, like the 0, right? So now it's a number, and now we can use it to make calculations. And so we solved one of the two problems. So let's see the second problem, and to show it to you, all I have to do is to keep clicking on this button. So, do you see what's happening here? We are simply adding empty lines without anything in them. And that's because we don't have any test. We don't have anything in our code that says that we actually need to have some data here and some values here, right? And so this is another thing that we really need to take care of before we can move on. So let's do that now. And the best place to do this is in the function in our controller where we say what to do when the user hits the button. Okay, so let's come back down here, and this is the control add item function, right? So what we can do here is to say that we only want all of this here to happen if there actually is some data that we can use. So we can of course use an if statement for that, right? So let's put it right here. Okay. And what do we want here? First, we want the description to not be empty, right? So let's say input.description should be different from the empty string. Okay, so this will prevent that there are some inputs where there's no description at all. Now we also want the same thing with numbers, right? So there's a function in JavaScript which tests if a number is not a number. So this sounds a bit confusing, so let's go back here to the interface. Okay, so in JavaScript there's something, this NaN, and this means not a number. And so as we hit this input button here, without any number here, this then returned not a number, okay? And so what we want is that this is not a number. Make sense? So right now it's not a number. So what we want is the other thing. So we want it not to be not a number, so that it's a number. So what we can do is to test if it's not a number, like this, is not a number, and then we pass the input dot value. Okay. Now, if this is not a number, it will return true. And when it is a number, it will return false. But we want the exact opposite, right? So we can simply use the not operator here. And this way it will be true if it is a number, and it will be false if it's not a number. And now all we need is the AND operator here. So we want this to happen at the same time. The input description should not be empty, and the number should actually be a number. So it should not be not a number. So this is already pretty good, but we can do even better, because imagine the case that the input value is 0. That is also not really an expense or an income, right? But it's still a number, so it will pass this test here, right? So what we can do is to simply add input value should be greater than 0. So make sense? And now all of this only happens in case that these three conditions are all true at the same time. And that's why we use the AND operator. So this is what we want always to happen, because without this we don't have any data at all to test. But all of the other stuff, so adding the new item and to the budget controller and to the UI, clear the fields, and all of this should only happen if there is actually some significant data that we can use. So let's now test this. Okay, so if we now hit this here, nothing happens. If we add something just like this, but without the number, also nothing happens. And now let's put 12. Okay, so now it worked. Now let's test only with the number, and it does not work. So test 2, and now it should work. So I hit return. All right, and now let's add another test, test 3, with 0. So it should also not work, right? And it doesn't, so great. But 0, 1 works. So we have 1 here. So perfect. So all of the problems are solved now, and so we're ready to move on to actually do the real calculations. Let's now do the actual calculations of the total incomes, total expenses, and the budget. And so in this lecture you're going to learn how and why to create simple, reusable functions with only one purpose each, and also how to sum all elements of an array using the for each method. So let's go to work. So this is how we left the update budget function in a controller after the last lecture. So it's now time to calculate the budget here in step 1, and for that we're going to create a public method in the budget controller, right? And so it's up here, and I'm going to call it calculate budget. So very simple. And it's a function, of course. And in here, there's a couple of things that we have to do. So I call this the calculate budget function, but in fact, we're also going to calculate first the sum of all incomes, as well as the sum of all the expenses. So the total income and the total expenses. And then of course the budget, which is one minus the other, and then also the percentage. So let's show that on the user interface. So this is the percentage that I'm talking about. And this is very simply the percentage of our income here that we have already spent. So which are expenses. So let's write all we have to do here. So calculate total income and expenses. Then calculate the budget, which will of course be income minus the expenses, right? And then finally calculate the percentage of income that we spent, basically. Okay, so let's start at the beginning right here. So calculate the total income and expenses. So this sounds like we're going to do the same thing 2 times, right? Once for the income and once for the expenses. So I think this sounds like making an extra function for this, right? So a function that receives if it's either the income or the expenses that we're talking about, so that we want, and then sum all of the items. Okay, and since we don't want no one else to use this function, we can make it simply a private function. So it's just an internal function to help this calculate budget method. Okay, so I'm going to do it out here, and I'm simply going to call it calculate total. So calculate total. And then what we need to say here is simply if we want to calculate the total expenses or the total incomes. So we're again going to use our type keyword. Okay. Okay, so how are we going to do that? So we already know that all of our items are stored here in the all items object, right? And all the expenses are in this array, and all the incomes are in this array, right? So at some point of our application, there are going to be a couple of objects in both this and this array here. So what we need to do is to get this array, then loop over it, and then sum all of the values. So add all of the values together. And so the first thing that we need to do is to simply create a sum variable, which will store the sum, okay, and set it to 0, because that's of course the initial value. Okay, and then we loop over this array. And do you remember a great way that we learned in one of the last lectures about looping over an array? It was the for each method, right? So let's get our array and use the for each method on it. So data, which is where all of this is stored, then the all items object, okay, and then, such as we did before, we use our type argument to select if we want to expense array or the income array, right? So this type here will of course be either exp or either inc, such as we've been using before. Alright, so this is the array, and now we can use the for each method. And remember, this accepts a callback function, okay? So function, and then this function here has access to a couple of parameters. Remember that? So we can access the current value, the current index, and also the complete array. In this case, we only need the current element, okay? So I'm going to call it cur simply. And remember, we can do that. We can call it whatever we want. And so now I say that the sum should be equal to the previous sum plus the current value. And so it's cur.value. And it's cur.value because value is the name that we gave it here, right? So in the expense and in the income, they both have this property called value, which is where we store the value. And so this cur here now refers to either the income or the expense object that is stored at the current position of the expense or the income array, okay? Okay, just to illustrate this, let me just write a simple example here, okay? Just so this makes more sense to you. So the initial sum is 0, right? And imagine we have an array which has these sums, so 200, 400, and 100, for example, okay? So in the beginning, our sum is 0. So in the first iteration, our sum is 0. And so the sum will be 0 plus 200, because it's the first element of the array, the first value in this case. So notice that these are only values. This is just an example to see you how this iteration works and how we calculate the final sum. So in the next iteration, then our sum is already 200, right? And so now sum is equal to 200 plus the 400 from the next element. So this is 600. And so in the next loop, in the next iteration, it will be 600 plus 100. So 700 in the end. All right, so this is how this loop works. Now we can do this better, right? Remember, there's this operator where we can put a plus here, and then we don't need this. So this is a bit simpler. And so after this loop, we have our sum stored here in this value. And what are we going to do with this then? We could return it, but I think it's even better to store it in our global data structure. So in our global data model, which we have here, okay, so this data object, which contains all of our information. And so in here, we before already put this totals object. So now we can use this and store our sums in here, right? So let's do that. Data.totals. And then again, we use our type, because once again, there's expenses and income. And then we simply say that this should be equal to the sum that we just calculated. And that's it. So this function is completed now. So let's use it here in practice. So we're going to go back to our calculate budget method. And so now I can call our private function. So I just say calculate total, and here it is. And I first do it with the expenses, and then I do it with the income. And that's it. So after running these two lines, or a data structure here has these two values here filled, so they are not 0 anymore. So they are now set to the total expense and the total incomes. Okay, and now we just need to calculate the budget. And where do you think I should store this budget? Exactly. Once again, we are going to use our global data structure that we have here. So we're going to create a variable in here called budget and set it initially to 0, okay? And now we can go ahead and fill this value here with our budget that we're going to calculate. So we say data.budget will be equal to the income minus the expenses. And remember where these values are stored? Exactly, they're also in the data structure. So data, and now remember they're in the totals dot income. And now minus data.totals dot expenses. Okay, so this retrieves these two values here from our data structure, then calculates one minus the other, and then stores it again in the data structure in the budget property. And now the final task of this method is to calculate the percentage of income that we spent. So once again, let's create a new property here and simply call this one percentage, and also set it to 0 in the beginning. Or actually, let's set it to -1, because -1 is usually a value that we use to say that something is non-existent. So if there are no budget values and no total expenses and incomes, then there cannot be a percentage. So we set it not to 0 but to -1, so it doesn't exist at this point. And so now we can store the percentage that we calculate also in the data structure. So data.percentage. So the percentage of income that we spent is the expenses divided by the incomes, okay? So data totals expenses divided by data totals dot income. Okay, so just an example, let's see. Imagine we have an expense of 100 and an income of 200. Then we spend 50% of our income, right? So this is equal to 100 divided to 200, right? And this is actually 0.5, so we have to multiply it by 100. So let's do that here as well. So I'm going to put some parentheses here, which are actually not necessary. But this way it looks a bit better, a bit more structured. Now the thing is that this will have a decimals. So imagine it would be here, instead of 100, it would be 300. Then we would have spent 33.333 and so on. So this would be 0.3333. But we don't want that. We really just want this integer part here. So let's also round this result. And we already did that before. So remember, we used the math object. And in here, there's a nice method called round. And so this will round whatever we input here to the closest integer. Okay, and with this, we calculate our percentage. So we have now everything that we wanted this method to do. So we have our total income and expense, we have our budget, and our percentage. So let's now use this method in our global app controller. So this is down here, so calculate the budget. So we say budget controller, as you already know, and then our newly created method, which is calculate budget. Alright, so this calculates the budget. And now we need a method which returns the budget to us so that we can store it here in a variable and then pass it on to the user interface controller, which is then gonna display it here in this third point. So let's do that very quickly. So again, in our budget controller, we need a new method, and this is going to be called getBudget. And again, I'm doing it like this. I'm creating a method only for returning something from our data structure or from our module, so that you get used to this whole philosophy of having functions that only retrieve data or functions that only set data. So let's write this very simple method here. And again, budget returns not only to the budget itself, but also to the total incomes and expenses and the percentage as well. So we want to return these 4 values. And what's the best way to return 4 or even more values at the same time? Exactly, we're going to use an object. So we simply do it like this. Return this object. And in here, we now create the 4 properties for the 4 values. So budget will be data.budget, right? Because remember, that is the place where we store the result of that calculation. Okay? Then we want the total income. So just like this. And this is stored also in the data structure, in the totals, and then in the inc property. Now the same for the expenses. And finally, we also want the percentage, of course. And that's it. That's all that this function, that this method here has to do. So let's now use it here. And this time we return something, so we have to store it in a variable, of course. So let's simply call it budget, okay? So var budget is the result of calling budget controller dot get budget. And that's it. So now we should have the budget stored here in this variable. So we are ready to display it in the user interface, but I'm going to leave that to the next lecture. So right now I just want to console log this object so that we can see if everything we did before is working, okay? So budget here. And remember, this whole update budget function is called each time we enter a new item into the user interface, right? So let me see. So it comes from here. Okay. So the control add item function is called each time that we input a new element. Okay, so this calls the update budget function, which is this one, which then in turn calls all of these methods here. So the calculate budget and get budget methods. So this console.log here will appear in the console each time we input a new item. So let's now test this. So let's say project and okay. So down here we have our budget object, okay? And let's take a look at it. So the total expenses are 0, the total income is 2100, and the budget is of course 2100, and there's no percentage. So everything seems to be working, right? Let's just add another one. So I sold my car again for $1,500. And so let's see the budget now. So this is the sum of 2100 plus 1500, and this makes 3600. And the budget is also 3600 because we don't have any expenses yet. So let's say we went on a holiday, which was $1,800. And now here we are. Oh, actually I did this wrong. I put it in as another holiday, as another income. So I have to change this, of course. So let's now say holiday. For 3600. That's because I want to show you the exact percentage. Okay, so now this seems to be working. So the budget is 1800 because it's 5400 minus 3600. Yeah, makes sense. And then the percentage is 67. And that's because, let's calculate it here. 3600 divided by 5400 is this number here. And if we multiply this by 100, then it gives us 67% if we round this, okay? So this is actually working. So there's only one thing to correct, and let me just reload this for that. Imagine that we only have expenses, okay? So let's say again, holiday for $900, and now we have this problem here. The percentage gives us this weird infinity value. So infinity. And that's because we cannot divide anything by 0, which is what we attempted to do here. So we did 900 divided by 0 because we don't have any income yet. And that is not allowed in mathematics. And so we have to fix that in our code. So let's go back to the method where we calculate this, and it's right here. So what we have to say is that we only want this calculation when we already have some income. So when the total income is greater than 0. So let's use an if statement. So if the data totals income is greater than 0, then we want this to happen, okay? And if it's not, then we simply want the data percentage to be -1, which, as I explained before, is basically the non-existence. So when there's no percentage to calculate, we just say it's -1, and we'll use that -1 later when we display this percentage on the user interface, okay? So let's now very quickly test this again. So add an expense, holiday for $900. And now here it is. So now our percentage is -1 and everything else is also working. So the total budget is negative, of course, because 0 minus 900 is -900. So the next step is, of course, to add this budget here to our user interface right here in this field. So here and here and here and here. So let's do that right in the next lecture. Now comes the fun part, where we'll finally see the budget updating on the user interface. And since this will be a shorter lecture, we will just practice some more DOM manipulation by updating the budget and total values in the user interface. So of course we need to add a new method here to our user interface controller, right? And let's call it display budget. And let's put it here. So display budget. And what do we need here in order to be able to actually print the budget? Of course, we need the object where all of this data is stored. So I'm going to call it obj, just like we did before. And this will then contain the 4 pieces of data that we want to print here, right? So the budget, the total income, the total expense, and also the percentage. So we're going to do some more DOM manipulation. And in order to do that, we need to know the class names of the elements on our user interface that we want, right? And so once again, we're going to add some more strings here to our DOM strings object so that we can use them then in our methods. So let's go to our HTML file where our user interface is stored, right? And so this is here in the top part, as I showed you right in the beginning. So the actual budget value, which will be stored here, so right here, this will be called budget value. So let me copy this and then paste it here. And I'm going to call it budget label, because these basically act as labels in the user interface, okay? So the class selector and then the class name. All right, so next one. So now we need our total income, which is here, right? And the total expenses is down here in this div element. So let's just check. So it's this here and this. So these are called budget income value and budget expenses value down here. So let's add these two as well. So let me call this income label. And actually I didn't copy it. Okay. So now it's here. And now the expense label. So income and expenses. And finally the percentage as well. So let me check that as well. And it's here. So this is called budget expenses percentage. And copied this as well. And now percentage label. And now we're ready to use this. So remember, we store all of these class names here in this central object that we have here, so that we don't have all of these class names here floating around in all of these methods, okay? And so if something changes in the user interface, we can simply come here and update all of these class names if we want. So this makes our lives as programmers much easier, having this kind of structures. Okay, now we already know how to display all of these values on our web page, right? So we have done this a lot of time. So we use document.query selector and then DOM strings dot budget label, which is the first one. And then in this case, we don't want to change the HTML, but only the text content. So we say text content, okay? And now this should be equal to the budget. And this budget comes here from the object that we pass into this method. So object dot budget. And that's it. And now I'm just going to duplicate this line because we already know how to do this, right? So now I just need to replace a couple of things here to make it work. So the income label, right? And now we need to know the name of the property where the total income is actually stored. So let's go back to where we generate this object. So remember, it's here in the getBudget method. So this is where we create the object that's going to be returned to the app controller, which then passes it into the displayBudget method that we're working on right now. Let me just copy this so that I have the names here. Okay. So this one is called total inc. Total inc. And here is the expenses label, right? And this one is called, as we see, total exp. We're just going to copy it. And then here, this one is called percentage label. And this should be percentage label. Let me change it in both places. Okay. And now this one is simply called percentage. So I'm copy and paste. And now before we can see this in action, we need to, of course, call this method here, right? And also add this comma. Okay, so this playBudget is the method that we're going to call. Oh yeah, it's here. So before we had this console log here, which we don't need anymore. And so now we use the UI controller to call the displayBudget method. And now what we have to pass in here is the object that we called budget, right? So this object here, which is, as I showed you a couple of moments ago, the object that is returned from the getBudget method. Okay, and now we're ready to check this out. So project 1500 and all right, it works. So the budget is 1500, our income is 1500, and our expenses are 0. Let's now add another one, salary, let's say 2500, and now it should be 4000, right? So let's see. And yes, it is. So it updated very nicely here. And now I'm going to add an expense as well. I'm going to call it holiday again for 1200. And it works. So we see 1200 here, then our budget, which is now 2800, and then the percentage here is also correct. So with this holiday here, we now know that we spent 30% of the money that we made in this month. Now we don't only want this to be 30 here, right? So let's add the percentage sign here. And actually there's another thing that we have to do. So let's reload this. And that's simply add an income. So now we have -1%. And we don't want the user to see -1%, right? Because that doesn't make any sense at all. So we need to be prepared for this case and display something else there. So let's do this. So back to the displayBudget method here. We basically need an if-else statement here, right? So we say if there is a percentage, so if it's not -1, then we want to add the percentage sign. So if it's 30, we want to display 30%. But if it's -1, we simply want to display something else. So let's say if object percentage is greater than 0, then we want this to happen here. Let me cut this from here and paste it here. So we want this object percentage plus the percentage sign, right? But if it's not, we want something else. So we don't want to see the percentage value here, but we want to see something that shows us that there is nothing to show actually. So let's put simply some of these dashes. So this shows that it's empty. And notice that this is not only going to happen when the percentage is -1, but also when it's 0, right? Because in here we said greater than 0. So this only happens, so this percentage is only shown if the percentage is greater than 0 and not if it's greater or equal. But that's totally okay. So let's see that in action. So I'm going to add a holiday for 1200. And yeah, now we have these 3 dashes that we had before. Cool, right? Let's now add a salary for us of 2400. And now we see that we spend 50%. So now it's working really good. Only one small thing that we can improve now is, you see when we reload this, then we have these weird numbers here that we obviously don't want, right? So remember, there's something that runs each time that our application starts. And do you remember what that is? Yes, it is the init function. So we can not only call this method that we just created each time that we input a new item, but we can call it right in the beginning when we start to run our application. So let's copy this. And then say that we want to run this right in the beginning. Now the thing is that we don't want to pass the budget in here, right? Because what we want is basically to reset everything. So we want everything to be set to 0. So what we need to pass here is actually an object similar to the budget object, but with everything set to 0. So let's just grab this object from up here, okay? And put everything to 0. So very simple. So back to our init function, okay, here. Let's pass this object, but we set everything to 0. So the budget is 0, the total income is 0, the total expense is 0, and the percentage is not 0, but -1. So there's no percentage at all. So let's check this now. So when we reload, everything should be set to 0, right? And yes, here it is. So no budget, no income, no expenses, and no percentage to show. Okay, and with this, we have actually finished everything that we had planned for the first step of building this application. And it already looks pretty cool, right? So great work so far. So we can now already do a lot of stuff with this. But there are actually still a lot of more cool features coming up over the next lectures. So with the last lecture, we completed the first step of our app. Congratulations for that. You have come a really long way. So let's now take a look at the structure of the app that we have built so far, so that we can then outline what to do next. Alright, so this is how I like to represent the structure and architecture of an app like the one that we're building right now. So we have our 3 modules, so the budget controller, the app controller, and the UI controller, and in each one of them we can see the functions or methods that we have written so far. And then with these green arrows we see the connections between them, so that we can see functions calling other functions. So this really helps us to get a nice overview of what we're doing here, right? So it really makes it easier to plan and organize our app and code. For example, we can see the effect that a simple click on our input button has, which is this green dot here that represents an event. And there will be more of them in the future. So as we know from our code, clicking this button will call the control add item function, which will then call all of the other functions and methods that we see here connected with the green arrows. So again, this gives us a very nice high-level overview of our app. And I really advise you that you always draw up something like this for your own apps or whatever you're gonna do with JavaScript. Let's now continue with the planning and see what we can do in step 2 of building our app. So far, we can input data into our app, which is then stored in a data structure and displayed on the user interface. What's missing here is the functionality of deleting an item from this list. So let's take care of that now. So we already have our delete buttons in the UI, but they are not doing any work yet, right? So once more, we start by adding an event handler to them. We then go ahead and delete this entire row as soon as the user clicks the button, both from our data structure and from the UI. And after that, of course, we also need to recalculate the budget and update it here on the user interface. Alright, so we have a nice little to-do list here again, so let's get back to work right now. Before we can start implementing our code to delete items from our application, we need to talk about something called event delegation, which is a very important and much used concept in JavaScript programming when we interact with a DOM. Alright, so in order to talk about event delegation, the first concept that we actually need to talk about is event bubbling. And event bubbling means that when an event is fired or triggered on some DOM element, for example by clicking on our button here on the right side, then the exact same event is also triggered on all of the parent elements. So again, the event is first fired on the button, but then it will also be fired on all the parent elements, one at a time. So it will also fire on the paragraph, the section, the main element, and actually all the way up in the DOM tree until the HTML element, which is the root. So we say that the event bubbles up inside the DOM tree, and that's why it's called bubbling. Now, the element on which the event was actually first fired, so the element that caused the event to happen, is called the target element. And so in our example here, it's of course the button that was clicked. The important part is that this target element is stored as a property in the event object. And we already talked about that one, right? So this means that all the parent elements on which the event will also fire will know the target element of the event, so where the event was first fired. And that brings us to event delegation, because if the event bubbles up in the DOM tree, and if we know where the event was fired, then we can simply attach an event handler to a parent element and wait for the event to bubble up. And we can then do whatever we intended to do with our target element. And this technique is called event delegation. In this example here, we could simply add the event handler to the main element. Alright, so again, event delegation is to not set up the event handler on the original element that we're interested in, but to attach it to a parent element and basically catch the event there, because it bubbles up. And we can then act on the element that we're interested in using the target element property. And why would we actually want to do this? So let's see. There are basically two big use cases for event delegation. And the first case is when we have an element with lots of child elements that we are interested in. In this case, instead of adding an event handler to all of these child elements, we simply add it to the parent element and then determine on which child element the event was fired. And the second use case for event delegation is when we want an event handler attached to an element that is not yet in the DOM when our page is loaded. And that's of course because we cannot add an event handler to something that's not on our page. So in the case of the application that we're coding, it's actually both cases, right? So we have a lot of expense or income items that are not in the DOM when we load our page, so there's no way to attach an event handler to them. And also, there may be a lot of items, so it wouldn't be useful to have one event handler attached to each of them. And that's why we're going to use event delegation. So let's see it in practice in the next lecture. Let's now create a new method in our budget controller so that we can delete an item from our data structure. And so in this lecture, you're going to learn yet another method to loop over an array, which is called map, and you'll learn how to remove elements from an array using the splice method. So let's do that. So here's our budget controller in which we will add yet another public method. So let's actually put it here after the add item. We will have the method to delete an item. So delete item, a function, and so this is our method. Now we know that this method is going to be called by the budget controller, right? So what kind of information do we need to have in order to be able to delete an item from the data structure? So what parameters, what arguments does the app controller have to pass into this method? So let's look at our data structure. So here it is. And we know that in these arrays, we will have all of our expense objects and all of our income objects. Okay? And both expense and income objects, they are both identified by their unique ID, right? So what we need in order to delete one of the items from these arrays is we first need to know if we're talking about an expense or an income, and then we also need the unique ID. So this is what the controller will have to pass into this function. And so we need to set up the parameters here. So the type, which is the way we've been calling it, and ID. All right. Now imagine that we passed an ID of, let's say, 3 into this function. So 3. We cannot simply select the element that we want to delete like this. So data.allItems type, and then just use the ID here, right? So we cannot do it like this. So this would select our array here, right? So for example, the expense array, and then select the element number 3 using this, right? Now this would work if we were certain that the IDs are all in order like 0, 1, 2, 3, 4, 5, but we know that it's not the case. And we already talked about that when we wrote this method here, right? So we had this example here. So imagine these are the IDs. And so let's actually copy this example. So imagine these were the IDs. If you would then select the element number 3, so 0, 1, 2, 3, and would then delete it, you would not delete the element with the ID of 3, but with the ID of 6, right? So this is not what we want. And again, the reason for the fact that these are not all in order like 1, 2, 3, 4, 5, and so on and so forth, is the fact that we can delete items. And so in this case, for example, the elements with the ID 0 and 3 and 5 and 7 were all deleted, and that's why they're not here anymore in this example. And so we need to take that into account when we write this method. So what can we do now? The solution here is to create an array with all of the ID numbers that we have, and then find out what the index of our input ID is. So basically the index of the element that we want to remove. So let's say that the ID that we want to remove is 6, for example, right? Then the index is not simply 6, as we already discussed, but instead it's 0, 1, 2, 3. So the index in this case would be 3. So we need a way to find out why it's 3, so why it's the number 3 that we need to delete. So again, the solution is to create an array with all the ID numbers that we have. So let's comment this part out as well, because none of that is what we're going to do. Instead, what we're going to do is to loop over all of the elements in an incomes or an expenses array. So data.allItems and then the type that we pass in. And now let's meet a new method here. So before we used the for each method, right? But there is another one which is very similar called map. Okay? And map also receives a function, a callback function, which also has access to the current element, the current index, and the entire array. Okay? But the difference between map and for each is that map actually returns a brand new array. So in here, so in this function, in this callback function that is called for each element, we will always return something, and this will then be stored in a new array. So let's say return 2 simply. If we now say var IDs, then we would end up with a brand new array with the same length as the all items type array, but with the number 2 in all of the elements. So this of course wouldn't be so useful, because what we want is not a 2 in all of them, but what we want is the current ID. Okay? So going back to our example before, imagine that in the all items type we had 5 income objects which had these IDs, so 1, 2, 4, 6 and 8. So after executing this map method, we would end up with exactly this array. Okay? So let's actually call it IDs. Okay, so that we keep this as an example. And now all we need to do is to find that index. And we already know how to do that, right? So we say index is IDs dot index of the ID that we pass into the method. And it's really as simple as that. So let's now declare these, so IDs and index. All right. So remember, this index of method returns the index number of the element of the array that we input here. So again, imagine that the ID would be 6, then the index would be 0, 1, 2, 3, because this is the 6 that we're searching. And so this index variable here would become 3. So index equals 3. And now all we need to do is to actually delete this item from the array, right? Okay. And remember that this index here can be -1 in case that this item here is not found in the array in which we're searching. So we only want to remove something if the index actually exists, right? So if the index is different from -1, because -1 is when it didn't find the element. So if the index is different from -1, then we want to delete. And now, in order to delete, we're going to meet yet another method of the array. And this one is called splice. So don't confuse it with the slice method that we used before. This one is called splice. And this one is used to remove elements, while the slice elements is only used to create a copy. And so let's see how to use that. So data.allItems type, and this is the array of our objects, right? So on this array, we now can use the splice method. And it works like this. So the first argument is the position number at which we want to start deleting. And this is of course the index. And then the second argument is the number of elements that we want to delete. And we of course only want to delete 1. So again, this will start removing elements at the number index, which, if we come back to our example, is number 3. So at number 3, it will remove exactly 1. So in our case, it would be 0, 1, 2, 3, and then this one would get removed, like this, okay? Okay, so I hope that this small example here actually helped you understand why we needed to do it this way instead of just writing out this piece of code here. Instead, we had to create this entire array here and then retrieve the index of the element that we want to remove. So this one was a bit tricky, but we still solved it, right? And you also learned yet another 2 methods for arrays by writing this method. So I hope that you somewhere keep track of all these methods that we have already used on arrays, so that you don't lose sight of all the amazing things that we can do with arrays. And now the last step is to just use this method in the controller. So where is our method for that, or function actually for that? It's here. So the control delete item function. And so we say budget controller delete item. And now is the time where we can finally use this type and this ID that we created in the last lecture. Remember that? So we can now simply pass in the type, which is what our method expects, and the ID as well. And like this, the element with the specified ID and the specified type will be deleted from our data structure. So let's now see this in action, okay? So reload. All right, so we have a bug here somewhere. So in line 82, let's check that out. Line 82 all the way up here. Okay, we have 1 equal too much. Okay, so the equal operator is with 3 equals, and the difference operator is with this exclamation mark and the 2 equal signs. Okay, so again, and now the application has started. So let's add something to here. Let's say test 1, $10. Test 2, let's say 20. And test 3, 30. All right. Now remember, if we click here to delete this, nothing will happen on the user interface. So we actually need to see our data structure, and we have our nice handy testing method here for that, right? So here's the object that we created with all the items, which are these 3 incomes. So 3 income objects with 10, 20, and $30. So let's now remove the second one. All right, and we have a bug. So yet another one. So let's go to line 282. And 282 is down here. Okay, so this was a stupid mistake. It's of course ID with the capital letters and not like it was before. So I hope now it's gonna work. So test 1, test 2, and test 3. And now let's delete this. Alright, so I clicked the button, and again, it wasn't removed from here, but let's take a look at our data structure. So our testing method, and now if we look at here, oh, we still have 3. So there's clearly still something wrong here. And since there's nothing happening here, so nothing happens when we hit these buttons here, so there's not even a bug, nothing happens really. So I suspect that there's something wrong with the if statement that we have. So let's go back. So this if here, remember that this gets only executed when the ID that we pass into is actually in the array. So when it's not -1 here, okay? And since this here is simply not executing, it means that probably this here always returns -1, and therefore this here is always false. So there must be some problem in here. And so let's check the ID. Maybe there's something wrong with the ID. So let's go down here. And so yeah, here's where we define the ID. So let's see how we did that. So we split this string here in 2, and then this created a new array, which is split ID, which had the 2 strings in it. So the type string, which is the first element of the array, and the ID string, which is the second element of the array. So the one with the index number 1. And maybe now you're starting to see the problem, and the problem is this. So we pass this ID into our delete item method, but remember that this is a string because it came from this item ID string. And therefore, up there in our delete item method, we are comparing a string to a number. So that's something that we cannot do. I mean, we can, but it's not going to give us the results that we want. So if we ask that the string 1 is in an array of 0, 1, and 2, which are all numbers, then the string 1 is not in there because what's in there is the number 1, okay? So we want this ID, this one here, to be a number so that we can then ask if the number is in the array with the index of method. So remember, we used the parse float function before, which was to convert a string to a float number, so a number with decimals. Now these IDs are integers, right? So no decimals. And so there's another function which is simply called parseInt. So we're going to use that one here. So parseInt. And just like this, we convert the string here to an integer, so to a number, which is then stored in ID. And so let's now check out if this works, okay? So reload, and then test1, 10, test2, 20, and test3, 30. And in here are our 3 income objects. And now I'm going to delete this one. So again, we have no bug. So let's see our structure now. And yes, so now it's working. Now we have only 2 elements in our array. So great. So let's see the first one. It's test1. And the second one should be test3. Sorry. So test3, yeah. Because I deleted test2. Remember, I clicked here and I deleted it. So now it's finally working. And what we need to do next is to actually also delete the item here from the user interface, right? And then update the budget here, because this still stays the same. So I can delete all of this and nothing happens in the budget, right? So let's just check our data structure now that I deleted all of them. And so yeah, so we no longer have any income here because I deleted all of them. Okay, so this really works, and now we're ready for the next lecture. This is the last lecture about removing an element from our application, and all we have left to do is to actually remove the item from the user interface. And so in this lecture, you're going to learn some more DOM manipulation, and more specifically, how to remove an element from the DOM. And so in order to remove something from the user interface, we create a brand new method here in our UI controller. So here we have addListItem, and so after that, I'm going to put deleteListItem. So a function, once again. And what do we need to know in order to be able to remove an element from the DOM? That's right, we need a class name or an ID name so that we can first select it and then remove it. And in this case, of course, we're going to use an ID because we've been talking about that all the time. So let's say selector ID, right? And the ID that we're going to pass into this will be, of course, this entire ID here. So the one that we read from the DOM in the first place. So we don't want just the type or the ID, but we want the entire ID that we read. So for example, the income 0 or the income 1, right? So that we can then go ahead and delete this item, right? So for example, this item or this item, this is what we want to delete. And so let's do that in our method. And removing something from the DOM is actually pretty simple, because for that we have the removeChild method. Okay, and since it's the removeChild method, we first need to know the parent, right? So basically we have to move up in the DOM so that we can then remove the child. So this is a bit strange, but in JavaScript we cannot simply delete an element, we can only delete a child. So remove a child. So we start by selecting the element, as always. So document dot, and now since we have an ID here, I will use getElementById. We haven't used that in a long time, right? So getElementById, and then selector ID. So this is our item that we want to remove. But remember, we can only remove a child. So we first need to move up, and we already did that before, and we do that using the parent node property. So parent node, and now we can say, from here, we want to remove a child, and then we need to again select it. So really, this is a bit strange, as I was saying, but it's just how it works. So we need to pass this into here again. So this is how it works. Now I would suggest to not do it this way, but to first actually save the selection here in a separate variable, right? So let's say element is this, okay? And so then we say element, then we want the parent node from that element, and then we remove the child, which is this element. So pretty weird, but yeah, that's how it works. There's actually an excellent reference that I found where lots of these things are explained. So lots of DOM manipulations like this. So let's take a look at that. I already have it here. And you can also find it on my resource page, as always. And here we have a comparison between jQuery and the JavaScript DOM API. So this is for, let's see, removing elements here. So this is what we did here, right? So we selected an element, then set parent node and remove child and the element again, right? But here is a lot of different stuff that we can do, and some of that we already did. For example, let's see, so creating and inserting elements before and after is what we did here. So insert adjacent HTML, and we already used, I don't know if it was the after and, but it was something like this, okay? And so in here, you can find something for your needs if you want to do some DOM manipulation, like inserting or removing elements from the DOM. Okay, so our delete list item method is actually complete with this. So this is a pretty simple one, because all we really wanted to do here is to just remove this element. So let's now call it. So in here, so UI controller dot delete list item. All right, and now remember, we have to pass in the ID, and it's the item ID as we were talking about right in the beginning. All right, and now all we have left to do is to update and show the new budget. But that's really simple, right? Because we already have this code. So let's go here to our control add item function, so this one. So when we coded this part of the application, we already had this function here, which does exactly what we want. So let's just copy this and paste it here. All right. And that's why back then I said that we should create a function to update the budget, because we were going to use it again, and now is that time. So instead of writing the same code here in this function and in this function, we created an update budget function, which contains all of the stuff that we do here. So let's remember what this is. So we calculate the budget, then we get the budget, so we basically read it from the budget controller, and then we display it on the user interface with the UI controller. Okay, so let's check this out. So I'm refreshing it, and then let's say salary 1500 or something like this, okay? And sold car 2000. And let's remove it. And it's gone. So it's working. So really cool. And did you see that also this budget here was updated? So not only was the element actually removed, but also the budget was updated. So let's remove this one as well. And so we're back to 0. So let's add an expense. Holiday 500. And now another income, like logo design for $2,500. So a great logo probably, right? And our salary again. So all of this has updated, of course. And now I'm removing this one. And yeah, again, it updated. It updated here. And so everything works perfectly. Let's only just look at our budget again and check if this is also empty. And yeah, it is. So, perfect. And with this, we concluded the part 2 of the project, which was just to delete an item here from our application. And we did that perfectly. So our app is growing and growing and is getting better and better. So let's now move on to see what's next. Welcome back. Now that we have 2 out of 3 steps completed, let's look at what we have achieved so far. So this is the updated version of our app's structure. And now we also have the new functions and methods for deleting an item here that we just coded. So this is an overview of everything that happens when the user clicks one of the delete buttons. And this makes it visible why it was so important to create the update budget function, because it's used to update and display the budget changes after both adding and deleting an item. So let's move on to planning the rest of our app. So this is going to be the last step in coding our application. And so what is there left to do? The first thing that comes to my mind is these percentages here that show how much each expense represents in percentage of the total income. So that's the main thing that we're going to take care of now. So we calculate the percentages and of course update them in the user interface. Another thing that we have left to do is to display the correct month and year at the top of our app, because currently we only have some placeholder there. And there are actually a couple more things that we can do to improve our app, like getting this nice number formatting that we see all over the place here, and improve the user experience of the input fields in order to make it more clear if we're inputting an income or an expense. Alright, so yet another to-do list for us to work on here. And after doing all of this, we're going to be finished with our application. So are you as excited as I am to continue with this right now? Then join me right in the next lecture. In this lecture, we're going to start with updating the income percentages, which is the main task for this step 3 of our project. And this will be more of a short lecture, and so we're just going to reinforce some of the concepts and techniques that we have learned so far. So here we are once again in our app controller. Now the question that we should ask is, when will these income percentages actually be updated? And the answer is that these percentages are calculated and updated each time that we add or delete an item. Because remember, these percentages are the percentage of the income that each expense represents. So when we add a new income or when we delete an income from the list, then all of these expense percentages will be updated. They will all change. And also when we add a new expense, the percentage must be calculated and of course updated and displayed. So again, when we add and when we delete an item. And this means that we should probably create a new separate function for this so that we can then call that function here in our control add item function, in our control delete item function. Okay, so this is something very similar to the update budget function here, right? So we also created a function for that, a separate function here, which is called update budget, and then called it in both of these control functions here, right? And so now we're going to do something similar, and I'm going to call it update percentages simply. Update percentages. And we don't need any arguments here. And that's it. All right, and what are we going to do here in this function? And again, this is very similar to the update budget function. So we first need to calculate the percentages. Then after that, we're going to read them from the budget controller. So very similar again. And finally, we then update the user interface. With the new percentages. And we're going to do that such as we did before over the next 2 lectures. So in the next lecture, we're going to take care of the budget controller and then code these 2 functions here to calculate and to get. So similar to calculating the budget and then getting the budget. And then finally, we're going to code a method which will then display these percentages on the user interface. But for now, all we need to do is to call this function here in our other two functions, right? So in here, we have a step 6, which is to calculate and update the percentages. And update percentages. And this one is called update percentages. So we call this function from here so that we don't have to write the exact same code down here in the function that handles the deleting of an item. Okay, and calculate and update percentages. And in here it's just step number 4. Alright, so in the next lecture we're going to take care of coding these two methods into our budget controller. Let's now create the methods that will do the actual calculations of the expense percentages. And so in this lecture, you'll learn how to make the budget controller interact with our expense prototype. So let's start by adding a new method to our budget controller. And it's going to be another public method. So calculate budget, get budget. And so I'm going to put the calculate methods basically here together, okay? So we have calculate budget and now calculate percentages. Okay, so let's think about this. So basically, we need to calculate the expense percentage for each of the expense objects that are stored in the expenses array, right? So imagine that we had 3 expenses, and I'm going to write them here as an example. So imagine we had A 20, then expense B of 10, and then another expense, let's call it C, of 40, okay? So just an example. And our total income would be 100. So what would the percentages for each of these be? So for A, we would have 20 divided by 100, right? So this makes 20%. So with expense A, this means that we spend 20% of our total income. And then of course, in the same way, B would be 10 divided by 100, so it would be 10%, and C would be 40%. Right? So this is just so that we know how to calculate each of these percentages. So this means that we're always going to need this total income here. Now, we said that we need to do this for each object individually. And so this sounds like there should be a method on each of these expense objects that calculates this percentage, right? And so let's actually do that. So let's go to our expense function constructor here. So in here, and we want to add a method. So how do we do that? And I'm absolutely sure that you remember this. So we're not just going to add the method right here into the function constructor, right? But instead, we're going to add it to its prototype. Because like this, all of the objects that are created through this expense prototype will then inherit this method because of the prototype chain, right? Because it's in their prototype. So the prototype property of expense. So let me do that. We did this before a lot of times, so we already know how to do this. So expense.prototype, and let's call this method the calculate percentage, or just calc percentage. Okay, and we already know that we always need something in order to be able to calculate the percentage of one of the expenses, right? And we just talked about that. And that is the total income. So total income. Okay. So now we can calculate our actual percentage. But first, where are we going to store this percentage? We should actually create a new property here in the expense object, right? So let's do that. So this dot percentage. And in the beginning, before it's defined, I'm going to set it to -1, such as we did somewhere else in our code before, right? So when something is not defined, we use -1. And so now here in this method, we can then define this property to something meaningful. So this dot percentage will be the value of this expense, right? So the value divided by the total income, which is the argument that we receive as an input here. Now, such as we did before, in another function, we will multiply this by 100 and then also round it. So again, we're using the math object and then round. And with this, we have an integer percentage value. So we did this before in this way. Let's remember it. So yeah, it was here. So when we calculated the budget, we also calculated the, let's say, global percentage. And so we also divided the expense by the income, multiplied it with 100 and then rounded it. And something else that we did here was to only calculate this when the income was actually greater than 0 here, right? And that's because we cannot divide anything by 0. So we should do the same in our method that we're writing right now. So in here, I'm going to do the same thing. So if the total income is greater than 0, and only then we calculate this percentage like this. And if it's 0, then the percentage will just be -1 again. All right, and that's it. So this method calculates the percentage. And since we always have a get method, so for example, a get budget and a get percentage, which we're going to write in a second, I will also create a get percentage method for this expense object or function constructor. So expense.prototype.get percentage. And this, of course, will be the simplest function ever, right? Because it's just going to retrieve the percentage from the object and then return it. But this again is so that we have different functions which each one only has one specific task. So this one calculates it and then this one returns it. Okay, so let's now use this method actually. So this is the one that we were working on here, so the calculate percentages method. And now we can call the method that we just wrote for each of the elements in the array in our data structure, right? So for all of the expense objects that are stored here in this data structure, okay? And do you remember the new method that we learned to loop over arrays? Yes, it was the for each method. So let's use it now again. So we first need our array. So we're going to retrieve it from our data structure. So data, all items. And in this case, we only want the expense array, right? And now in here, we can call the for each method because this is an array. And now our callback function. So this specifies exactly what we want to happen for each of the elements. So we have access to the current variable here, right? I'm just going to call it cur in this case. And what I want to happen to each of the elements is to simply call the calc percentage method. So I write current and then calc percentage, which is the method that we coded before. And that's it. So this is going to calculate the percentage for each and every expense that we have in our object. And now we just need the get percentages. So get percentages. And some space here as well. And all right. And this one will actually be a bit similar because we once again need to loop over all of our expenses. And that's because we want to call the get percentage method on each of our objects. The difference to the loop that we wrote here in our other method is that this time we don't want to just loop over the array and do something. No, we also want to return something. So we want to store it somewhere. And remember, that's what the map method is for. So instead of for each, we're going to use map. So var all percentages, let's say, is data dot all items exp, so the expenses, and then I use map, because remember, map returns something and stores it in a variable, while for each does not. And now our callback function again. And now in here, in the callback function of the map method, we usually just return something. And what we return here is what is then stored here in this variable. So we just return the result of calling the get percentage method. And in the end, all we need to do is then to return the all_perc variable, which is of course an array with all of the percentages. So again, imagine we had 5 objects in our exp array here, in our expenses array. So then this here would get called 5 times, right? So for each of the 5 elements. So for each of them, we would call the get percentage method, return it, and then store it here in the all percentages array. And then in the end, we just return it. All right. And so with these 3 methods, we calculate the percentage on each individual object, and we then return an array with all of these percentages in it. So let's now use these methods that we just coded here in our controller. And remember, we created this update percentages function in the last lecture. And in here, we will now say budget controller dot calculate percentages. And then we just say that we want to get the percentages. And of course we need to store this somewhere, right? So var percentages. And now, since we can't see anything on the user interface just yet, I'm going to log it to the console. So console.log percentages. All right. So it's time to test this. And I'm going to use the example that we had before. So project 100 is our income. And our 3 expenses are going to be A of 20. And now we have some kind of bug here. Okay, so let's go to line 135. Okay. 135. And okay, so of course there's a problem because we used current here, but the parameter name is core, right? So just like this. So it's completely normal that we sometimes have some bugs that we do this kind of mistakes, and everyone does that. So it's really no big deal. So let's try this again. So I'm just calling it inc here. And then on 3 expenses. So A is 20. And now we see -1 here in the console, which is weird, right? So let's see why that happened. So the percentage can only be -1 if the income is 0, right? But the income is not actually 0. So let's see what we did wrong. So the calculate percentage method here. And so here's the problem. So we called the calc percentage method and didn't pass the totals into it, which we should have. So let's do that now. And we already know where that is stored. So data, totals, right, and then inc. So let me show it to you just to remember. So it's this value here. So the total income is stored right here. And hopefully now it's the 3rd time and now it's going to work. So income 100. And let's add an expense of 10. Sorry, A is 10. And yes, so 10 is 10%. Actually, let's try it with an income of 200. And then have A equal 10. and now it's going to be 5%, right? And yes, here it is. And now B, let's say 50, and this should be 25%, right? And yeah, so now we have 5 and 25. So these are the percentages that we're later going to display here. So it will be 5 here and then 25. And if we now add another one like C, which is going to be 40, then this one is of course 20%. So 5, 25, and 20. And these are the percentages that we're going to put here right in the next lecture. In this final step of updating the expense percentages, we're just going to display them to the UI. In this lecture, you're going to learn how to create your own for each function, but for node lists instead of arrays. So by now you already know where we're going to add our new method, right? And that's right here in the UI controller. And let's do it here. And we'll just call it display percentages. And of course, this method is going to receive the percentage array that we have stored in our app controller, right? So that's what we did in the last lecture, if you remember. So an argument called percentages, and this is going to be an array. Okay, so these are the percentages that we will display, but where are we going to actually display them? So let's take a look at the HTML. And they're of course not in the incomes, but in the expenses. And this is called item percentage. So we need to start by selecting all of the elements which have the item percentage class. So let's go back. And once again, I'm going to add it in here, right? So expenses percentage label, let's say. And I'm not sure if I copied it. No, I did not. All right. So let's go back. So it's item percentage. All right. And here we go. So expenses percentage label. All right. And now this time we don't know how many expense item will be on the list. So we cannot use query selector because that only selects the first one. So we need to again use query selector all. So let's create a variable called fields and then say document query selector all. And from our DOM strings, we want to expenses percentage label. All right. And this again returns a list. And actually it's called a node list, not just list, but node list. And that is because in the DOM tree, where all of the HTML elements of our page are stored, each element is called a node. And that's also why the property that we used before for moving up in the DOM was called parent node. So we need to now loop over all of these elements in our selection, so all of these nodes, and then change the text content property for all of them, such as we did before. Now, we already know that the node list does not have the for each method, right? So we could again use the hack that we used before. So where we used the slice method of the array prototype to convert the node list into an array. But as I said, that's more of a hack, so like a workaround, and we can actually do better. So instead, let's create our own for each function, but for node lists instead of arrays. And with this actually, we can use some of the knowledge that we gained before about callback functions and passing functions around like variables. So imagine that we already have this function. How would we want to use it? So we want to call node list for each. Okay, so this is how we're going to call the function that we're going to code in a second. And then we want to pass into it our fields, of course, and a callback function, right? So this is similar to the for each for arrays, but this is going to be for node lists. And then in here, we want our callback function with the current and the index. So exactly as we are used from the for each method. And then here we do some stuff. So let's now write actually this function, and I'm going to copy it. So var node list for each is a function. And as we saw here, this function is going to accept a list, a node list, but instead I'm just going to write list so that our parameter name is not too big. And then the callback function, right? So this here is what we pass into the node list for each function. So a list and then our callback here, right? So what is this function going to do? It will simply be a for loop that in each iteration is going to call our callback function. So something very simple actually, but by putting it into a separate function, we have here a piece of reusable code that we could then use for all of the node lists throughout our app, or even in other apps that you're going to code in the future. So each time that you have a node list, you can then go ahead and simply use this node list for each function here, instead of writing your own for loop each time and then put something inside of that. So for var I is 0, of course, and I should be smaller than the list dot length. And so please note that the node list actually has the length property. So it doesn't have all of these fancy methods that we would like to use on it, but it has the length property. So we can use that here. And now we just increment our counter. And what are we going to do in here? So very simple. We simply call our callback function. And now here's the thing. What are the parameters of our callback function? They are the current and the index. And so we can now simply pass them into our callback function by writing them here, right? So the current is the list at position I, and the index is simply I. So it's as simple as that. So does that make sense to you? This is really the power of first-class functions and of being able to pass functions around like this. So what we just did here is something really powerful. So let me explain it again. So when we call our node list for each function, we pass a callback function into it, right? Which is this one. And it doesn't have any code yet, but we're going to put that there in a second. So this function is assigned to this callback parameter. And so in here, we then loop over our list, let's say 5 times if there are 5 elements in it. And then in each iteration, the callback function gets called with these arguments here, which are exactly the ones that we specified here, right? And so then 5 times our code that we have here is going to be executed. And we have then access to the current element and to the current index because we passed them into the callback in here. So let's now use this to display these percentages on our web page. So we can simply say that we want the current element, and now we can use the text content property, right? Which we have used 100 times by now. And so what we want is the percentages at the position index. So imagine at the first element, we want the first percentage, right? At the second element, we want the second percentage in the array. So it's going to be percentages index 0, 1, 2, 3, and 4. So in the case that we have 5 percentage values. So that's the percentage. And then we simply want to add this percentage sign, such as we did before. And that's actually it. Well, not really, because imagine that the percentage is 0, right? And we did that before, and we can actually see it up here. So what we said here is that if the percentage is 0, we display the percentage like this, so with the percentage sign. But if it's 0, we simply want to display this string here, okay? So instead of -1, because that would look weird. So we can say if percentages at the position index, so the current percentage, if it's greater than 0, then make this. and else simply display these 3 dashes. Alright, and with this we concluded our display percentage method. So again, we used a really powerful methodology here by writing this node list function here, this node list for each function. And if you didn't fully understand how this works, then just pause the video and take a look at exactly what happens here. Alright, so now it's time to actually use or display percentages method. So where is it? So this file is really getting big, and sometimes it's a bit hard to find a place, but it's here. So UI controller that display percentages. And again, what we want to pass here is this variable called percentages, right? Which is this one here, which comes from calling the get percentages method on the budget controller. And that's it. Let's test this out now. And let's put our income of 200 here again. And then A of 10. Oh, sorry. This should have been an expense, of course. So again, A of 10. And yes, it's 10%. Let me actually delete this one. So this is working, right? So you have 5%, and it's correct because 10 is in fact 5% of 200. So let's add another one, and let's say 50, and now it should be 25. And here it is. So 25 is displayed correctly. And since this is so fun, let me just add another one of 120, let's say, and this one is 60%. And notice that in here is, of course, it also updated, but we did that before a couple of lectures ago, right? So all of these together are 90%. And actually, if you sum these together, so 5 plus 25 plus 60 is 90. So these percentages are correct. So with this, we concluded the percentage part of this application. And actually, our app is already fully functioning, so all of the important features that we wanted are implemented by now. There are just some minor things that are left to do here, and we're going to look at them right in the next lecture. So come with me there right now. In this lecture, we're going to display the current month and year in our user interface as soon as we start the application. And so in this lecture, you're going to learn how to get the current date by using the date object constructor. So let's create a new method here in our UI controller called displayMonth. Okay, so we're going to use the date object constructor in order to save the current date into a new variable. So let's call it now. So variable now is a new date. So remember, with object constructors, we have to use the new keyword, such as we do with our own object constructors. And then if we simply don't pass anything into the date constructor, then it will return the date of today. We could also do it in a different way. So we could say var, for example, Christmas, and then a new date. And then we could pass into the year. So this year, for example, 2016, then the month. So for December, it's 11 because it's 0 based, and then the day. So this would return a date object with the Christmas date of this year. But that's not something so common to do. So usually we simply use it like this to store the date of today. And then we can use methods to retrieve the current year or the current month or the current day or even the minute or second in which this date object was created. So let's start with the year and create a variable called year. And let me declare them up here. So var now and year. And later also month. So remove this here. So year is now, And this object now inherits a bunch of methods from the date prototype. And the one that we're going to use here is get full year. And this is going to return, in case that it's 2016, it's going to return the year 2016. So really easy. Now all we need to do is to display this on our web page. So let's look at that to find out the class. And it's up here. So it's called budget title month. So I initially only wanted to put the month here, but now I'm going to put the month and the year. So this will be a new element in the DOM string object. So up here, and I'm calling it date label. So then going back here, so now we can use document.querySelector and DOM strings and date label. And if we now set the text content property of this to our year, it should work. So all we need to do now is to actually call this method here. And where's the best place to do that? It's of course in the init function, right? Because that's something that we want to happen right in the beginning after we start our app. So I'm going to say UI controller dot display month. Maybe I should have called it display date, but it doesn't really matter. So let's see if this works. And actually no, nothing happened here. So let's go back. And yeah, here I see the problem. So I didn't actually call this function, this method, right? So that was the problem. Okay, now we have this weird, I don't know what this is, so let me create some space here. Function get full year. So I guess I see what happened there. So the problem is that in here I also didn't call this method. So of course this is a method, so I have to call it. So now I'm sure that's gonna work. Let's see. And yeah, so 2016, the current year. If you're taking this course later, then maybe you'll see 2017. But 2016 is right now as I'm recording this. And now let's get a month here. So I'm saying month is now dot get month. So it's also really easy. So month up here, and now I simply say month plus a space and plus the year. So let's see how that looks. And yeah, so it gives me a number. So month number 8. And we already know that this is 0 based. So now we can do something very simple, which is simply an array containing all of the month names. So this is going to be called month. Okay. So let me first declare it here, month. And now let's write all of them here. So we're already halfway through. Now only 6 more left. So July, August, September, October, and now November and December. So something missing here. All right. And now what we want here, down here, is no longer the month, but the month and with the index number of month, right? And remember, this is 0 based, so number 0 will be January, and the 8 that we saw is not August, but September, because September is the month number 9, and so in a 0 based array, it's number 8. So let's check this out. So alright, available budget in September 2016. So now you also know how to use dates in JavaScript. So let's now move on together right to the next lecture. Welcome to the last lecture of this project. All that's left to do is to make some finishing touches on our app. And so we're going to polish our user interface even more in this lecture. And in this lecture, you're still going to learn something new, and that's how and when to use change events. So what we want to do in this lecture is to improve the user experience here of our input form. So right now, when we hit this select field here, then the outline of this element here is blue, right? And this one as well, and this one, and also the button is blue. So this is the blue of our income, right? Now, if we change this to minus, so to the expenses, this is still blue, right? So there's not really a difference. Now, what we want to do here is to change this to red, so to the expenses color, when we are adding an expense. So this way the user can immediately recognize if he's inputting an income or if he's inputting an expense here. So how are we going to do that? We're going to use an event that is triggered when we change this from plus to minus and from minus to plus. And that's not the click event, because we could click here and then still click on the plus and then nothing really would change, right? But there's another event that we can use, and that's the change event. And the change event occurs each time that we click here and then change it to something else. So now the change event happened. And so we can now add an event listener to this element here and then wait for the change event to happen and then handle that event. So let's now do that. So we already know that all of our event listeners are set up here in this function. So this is no exception, and so we're gonna add it also in here. So document.querySelector, and then DOM, where all the strings are contained, and this one is called input type, right? So we add an event listener here, and now it's not the click event, but as I was saying, it's the change event, all right? And so now we need a callback function here. And we're going to write that callback function into our UI controller, because this has something to do with manipulating the UI, right? So UI controller, and I'm going to call this method the changed type. Changed type. So now we need to go to our UI controller and add that method there. So let's do it right here. So changed type. Alright, so what is going to happen? So let's look at the interface again. So what we want to happen is these three elements here to change this outline, and then this button here to change the color. So we basically want to do some style manipulations. And do you remember the best way to do that? It is to add or to remove some CSS classes, right? And so I already wrote some CSS classes into our style sheet where they are. So this is the red and the red focus class. And we're going to use the red class for the button and the red focus class on the other three elements. So on the select element and the two input elements. So two things that we have to do. We have to select all the three elements which are going to receive this red focus class, right? And remember, it's these three, this and this. And then we need to select the button here and give it the red class. Okay, so let's do that. So for the first three, let's use the query selector all. So var fields and document.querySelector all. And now we need to input the three class names separated by commas, okay? So let's actually do this in separate lines here, because we have three of them. So it's DOM strings dot the input type, then plus the comma, and then DOM strings dot input description. And here we don't need any comma, of course, because the comma is here between the quotes, because we're constructing a string here, right? And DOM strings, the input value. So these three are the ones that are going to receive the red focus class. Alright, so remember, this returns a node list. So in order to loop over it, we cannot use the for each method. But remember, in one of the previous lectures, we wrote a very useful function for that. And it was called, here, node list for each function. So we can now make use of that again, right? All we need to do is to remove this function here from this scope, right? Because if it would be like this, we cannot use it in our other methods or functions. So I have to remove it from here because the other methods don't have access to it. And so I'm going to put it out here, out of the object. So right here after the format number function. So it's still a private function. So only the methods that are in here in this controller module can use this function. Okay. So let's go back to where we were and now use this function to loop over our selection. So node list for each, then input our fields and our callback function. So we want the current element, and the index number we don't really need, because all we want to do is to add the red focus class on the current element. So cur class list, remember, and now I can put add and then the class name, so red focus. Now the problem with this is that once this change event occurs and this function here gets called, this red focus class will get added and will never again be removed because we don't have the remove method anywhere. And actually using remove would not be ideal because we have something better, which is toggle. And remember what toggle does? Basically it adds the red focus class when it's not there, and when it's there on some element, then it removes it. And that's exactly what we want. So each time that the type changes, we want this class to change. And change in this case means that it's there or that it's not there. Okay, so this should already work. So let's check that. So now it's blue and it's still blue. So let me click here as well, so nothing really happens. So let's open up the console. Let's see. So we have some syntax error. So let's go to line 323. 323. So it's this one here. Okay, so I have two parentheses here. So we don't need this, of course. So let's not try it again. So now we don't have a bug. And yeah, it's red now. And so now when we click here, all of this is red, and so we instantly know that we're working with an expense here. And now if we change it back, then the change event is triggered again, and so we toggle our class. So the class is now removed, so it's now gone again. And the same thing here and here, and if I click again, then the class is toggled again, and now it's back on this element. The only small thing left to do is to now add the red class here on our button. And that's the easiest thing in the world, right? So we just need to add another line here saying document.querySelector, and we do this because it's only one element, so DOM strings, and this one is the input button. And again we want to toggle it because of the same reasons that I explained before, and this one is called red. Okay, and that's it. So let's try it again. So everything is blue, the button is blue, and I changed to red, and now look at the button, and it turned red. So amazing, right? So let's add an expense here to see if nothing else is broken in the app now. So 500, and yeah, it works. Or dining out for 58.25, and let's add a salary. And now everything should turn blue again. And yes, so it's blue or green, whatever. And now the salary is 2,500. And yep, everything works as expected. And that's actually it, everyone. We have now finally and officially finished this beautiful application. And it has now all the features that we plan to include, and it has a really polished user interface, right? So it really looks great and it also works great. So really, congratulations for making it this far and for really learning and understanding all of these exciting new things about JavaScript. And now just jump right into the next lecture, which is also the last one of this project, just to take a look at the final structure of our app. First of all, a huge congratulations! You have made it all the way through this app without giving up. And that's really, really amazing. I'm really happy for you right now. And I really hope that you enjoyed this project as much as I enjoyed coding it with you. So let's now look at the final structure of our app. So this is what we built throughout all these lectures. All these methods and functions sitting in different modules and calling one another. So please take some time now to look at the entire code that we wrote and then compare it with this diagram to see that this is really exactly what we did. Because, just looking at the code can be really confusing, right? But after having something like this, it all starts to make sense. So yeah, you should do that. And then, after that is done, I want you to think of ways in which you could extend this app and add even more features to it. And then, of course, I want you to implement these features as well. So not just thinking about them, but really coding them. And that will be a great way to build up your knowledge even more and to start getting some practice in a project that you're already familiar with. So that makes it a lot easier. So good luck with that, and make sure to share your progress with the community. I can't wait to see the features that you come up with. Welcome back. So in this lecture, we're going to get a quick overview of what's new in ES6 or ES 2017, which is actually the official name. But everyone just calls it ES6 simply because it came right after ES5. And so that's what I'm going to do for the rest of the course. So before we start, just a quick recap of what we already talked about right in the first section. So right now, we have all these modern JavaScript versions that we can use in production as long as we transpile and polyfill the code back to ES5, right? And I'm going to show you how to do exactly that in one of the next sections, okay? So we're actually going to use ES7 and ES8 also in the next sections, but for now, I want to start by really focusing on ES6 in this section. Because remember, that's the version that brought us a ton of updates and new features to the language. And so here is what we're going to cover in this section. So we'll start with the two new ways of declaring variables in JavaScript, and that's let and const, and then move on to blocks and ifs, new string methods, and then arrow functions, which is a huge and amazing topic. After that, we're going to talk about destructuring, new array methods, the spread operator, and rest and default parameters, before we finally move on to the big and important topics of maps, classes, and subclasses. Now, there are two other extremely important ES6 features that we're going to talk about a bit later, because they need some more background knowledge, and that is promises for dealing with asynchronous JavaScript and native JavaScript modules to separate our code into different files. Okay? Alright, and that's it for the intro. Let's now move on to the real coding. Let's start with one of the most simple and straightforward changes in ES6, which is the two new ways of declaring variables, which are going to replace the var declarations that we've been using so far. And these are let and const. So this is the starter project for this section that you can download from the course from this section as always. So we will continue with our persons examples throughout this section, since we're already familiar with these. And don't worry about these colored boxes here on the right side. We're just going to need them for some examples later on, okay? So how do we use let and const? First of all, in all of the lectures during this section, I will usually start by writing some code in ES5 and then show you how to do it in ES6 and where the big differences are. So let's do that. Let me just start by writing that this lecture is about let and const. Okay, so I'm going to start with the ES5 code, okay? And let's just say we want to declare a name. And we've done that a lot of times, so we already know we use var in ES5 and the name. And I will call it name5 because this one is for ES5, and then later I'm going to use name6, okay? Because we cannot duplicate these names, so we need two different variable names. So Jane Smith, and let's say her age is 23, and we then change that name to Jane Miller. So imagine that Jane married someone with the last name of Miller. So we can simply mutate this name variable here, right? So let's console log this. And you will understand why I'm doing this in a second, okay? So let's console log this and see what happens. And of course, we see Jane Miller here. Alright, so let's now write the same thing in ES6. So instead of var, we can now choose between const and let. And const is for constants, which means for values that we don't want to change, and let is like the old var. So this is for values that we actually want to change or mutate later on. So let's declare the name as a constant. And so we use const name, and I'm calling it name6 for ES6. And I'm going to call her again Jane Smith. And now the age. And since we know that the age can change, we're going to use let, right? So now Jane is 23, but next year she's going to be 24, 25, and so on. So this is something that can mutate, and so we use let. So age 6, 23. All right. Let's now suppose again that Jane wants to marry and change her name. So if we now say name6 should be Jane Miller, and then console.log the result of that, such as we did before, let's see what's gonna happen. So we get an error here, assignment to constant variable. And that makes sense, right? Because as I said, this const keyword here is used to declare constants, so variables that are immutable, which we cannot change. And if we then attempt to change the value of a constant, it gives us this error here. Okay, so again, in ES6 we no longer use var, but instead we use const if we have a variable that's not going to change its value over time, and we use let if we want to change the value of the variable. So we now have a way to declare constants. But that's not the only thing that's new with let and const. And that's because variables declared with var in ES5 are function scoped, but variables declared with let and const in ES6 are block scoped. Alright, so function scoped and block scoped. And that's a huge difference. So let's see what that actually means with a new example. So I'm now going to write a simple driver's license function, okay? So just that we have something different here. And I'm going to start again with ES5. So function driver's license. And we are going to do something if the person passed a test, okay? So we say if passed test, then the first name is John, and that's actually not right. And the year of birth is 1990. And then we want to console log this. Okay, so this may not be the most realistic example really, but this is just to show you something, and you will see in a second when we write the ES6 code. Okay, so don't worry. So now let me just console log this. First name, let's say born in, and of course year of birth, is now officially allowed to drive a car. So let's call this function actually. And we say that the person passed the test, so we passed true into the function. And let's see what happens. Okay, first we of course have to comment out this part of the code here, so that it doesn't get in our way. Okay, and now of course this printed out to the console just right. So let's now do the same function for ES6. Let me just change this here to 5. And then I'm going to copy it. And here's also 5. ES6. And 6. And 6. Okay. Here we can use a let instead of a var. Okay, because let's assume that the first name can also change. So let can be a good change here. And then for the birth year, of course, that cannot change, right? It's impossible that you change your birth year. So this will be a constant. And now, of course, if we print it to the console, it will work, right? But now it's time to see why let and const are different from var. So let's change this line here, where we actually use these variables first name and year of birth out of the if statement. Okay, and put them here. And then do the same thing in here. All right. And let's see what happens right now. Okay, so we get an error here in line 41, which is this one. So the first one worked just fine. This console log of course worked because we can use the first name and year of birth variables here in the same driver's license function, right? But in here, it's different. We get an error saying that first name is not defined, which is strange, right? But that's because with let and const, the variables are not function scoped, but block scoped. So what is a block? A block is simply all the code that is wrapped between these curly braces here. So each time that we have an if statement or a for block or a while block, we're actually creating a new block. And the variables declared with let and const are only valid, are only accessible by the code that are inside of the same block. So if we move outside of the block, which is what we did here, then we no longer have access to these variables that are here. So this is similar to what we had before with functions, right? So with the var keyword, it works differently. We have access if it's in the same function, right? If we now moved out this console log to outside of the function, then it would also no longer work, because the variables declared with var, as we learned throughout this course, are only accessible inside of a function, but not from the outside. So this is not going to work, right? So we have this error here. So let's move this back and come back here. So this really is a bit different from what we were used to do up until this point, right? So again, we now no longer have access to the variables created inside of a block, which is this one here in this case, because these variables are now block scoped and no longer function scoped. So suppose we wanted to use these variables here outside of the block, then we would just do it the way that before we did it with functions. So we can declare these variables outside of the block, which before we did outside of the function, and then define the variables in here. So let's say first name and const year of birth. And so now in here we can simply define them, and then it should work. Or does it? Because actually this also does not work. It only works for the let declarations. So we simply cannot define a constant here in a block and then use it outside of that block. If we really want to use this constant outside of the block, then we have to declare the constant out here. And then of course it's gonna work. So now it works again. So we declared the first name variable here outside of the block, but didn't define its value, and then defined it in here. And that's why we can then use the first name variable outside of the block, which is the exact same thing that we used to do with functions before, right? So this really is a huge difference between what we had before. But that's not even all. Suppose we would use a variable here before we actually declare it. So let's say we say console.log of the first name. So do you remember what this is going to print out to the console? And I really hope that you do. And alright, it's undefined. And that's because in an execution context, all variables are hoisted and set to undefined, right? And so if we then use them like this before we actually declare and define them, we get undefined. Now in here, it doesn't work quite like that. So let's say we wanted to use the first name variable in here. So let's see what that gives us. And now we get a first name is not defined error. So now we can effectively not use a variable before it was really declared. And I actually think this is a good thing because it may prevent some errors. Now this happens because of something called the temporal dead zone, which basically just means that the variables are actually hoisted, but we still cannot access them before they are declared. So this is just a technical term, but what you need to know is that we can only use a variable after we actually declared and defined it. Okay, and just to finish this, let's just take a look at maybe a bit more practical example, all right? So let's say that in our code, we were using an I variable, okay? So let I be, let's say 23. So this was just a normal variable that we were using in our code, okay? And now suppose we have a for loop, okay? And we usually declare a variable in here, which is a counter called I, right? So I was the variable that we used all the time, so let's also use it here. So we say I start at 0, and this should go on before I equals 5. So as long as I is less than 5, and then I should be incremented. So this is all nothing new for you, right? And then we just console log all of the i's. Okay, and then after that, we also console.log I out here. Remember, which is the variable that we had up here, all right? And before we can run this, let me just get rid of this line so that we don't have that error. And so let's see. Okay, so we have 0, 1, 2, 3, 4, which are these console logs, and then I is 23. So assigning other values to I in here, in this for loop, doesn't change the I variable that we had defined here with the let. And again, that's because these variables are block scoped. And so this I variable here is a completely different variable from this one. So they happen to have the same name, but it really doesn't matter because they are separate variables. It's like having var I inside of a function and var I outside of a function. So these would be also two completely different variables, right? And now here with the block in ES6, it's exactly what happens as well. So I here is a completely different variable in this block than this I here in this other, let's say, block. So if we had var instead, Let's just very quickly test this out. What do you think would I be? And that's right, it would be 5. Because these variables are of course not block scoped. So this is now not a different variable. And so this 23 here will be overwritten, and then in the end we have the final I from this counter variable here. So I really hope this makes sense and that you understood the main differences between var, const, and let. Okay? So as a conclusion of this lecture, if you want to start using ES6, then the best practice is actually to use let for variables that will change their value over time, and const for variables that cannot be reassigned, so that are constant throughout our code. In this lecture, I'm going to show you a new way of creating ifs, using the concepts that we just learned in the last lecture. So in the last lecture, we saw that variables declared using let and const are block scoped. And this means that these variables are defined inside of a block, and from the outside of that block, they are not accessible. Now, what does that sound like to you? Yeah, that's data privacy that we've been talking about a lot during our big project, right? So up until this point, we always used immediately invoked function expressions for that. But it looks like in ES6 we have a new, much simpler way of achieving data privacy, because all we have to do is to use a block. So let's see how. Now a block is not restricted only to if statements or for loops or while loops, so we can also just write a block like this. All we have to do is to use curly braces and then create some code inside of these, and we just created a block. So let's now create a constant in here. So const a is 1, and then let's also create b 2 using a let statement here. So it doesn't make any difference just to use both of them here. And if we now were to console log these two here, console.log, let's say a plus b, then what would we get? Alright, we have an error here, and that's because these values are not accessible from outside of the block. So again, they are block scoped and not function scoped. So what we have here now is exactly like an IFI, right? Like an immediately invoked function expression. So we created some data here that is not accessible from the outside. And it's much easier to write it like this, right? Remember, an IFI in ES5 would be written like this. So ES5, we had to do all this work and write it like this, just to create a simple variable that's not accessible from the outside. And then we also have to call this function, right? So if we do console log now, okay, and let's get rid of that. Then of course we have our error here, right? So that was the old way. So this is ES6. Now let's just try to add var here, okay? So var c equals 3. And what's gonna happen then? And of course you know the answer, right? So again, let's get rid of this. And now of course we see 3. And that's because for variable declarations with the var keyword, it doesn't matter if they're inside of a block or if they're not inside of a block, because they're not block scoped, they're function scoped. Alright, so this is a very simple change that you can do if you want to start writing ES6 code. So if you have a simple IFI like this that you need to write, you can very simply switch to doing it like this. So this is very simple and very straightforward once again. Alright, so let's now move on to the next feature of ES6. Hey there, welcome back. There are big improvements on how we handle strings in ES6. So let's now take a look at the major changes that happened in strings. So let's start by creating some data here that we can work with. So let's define a name. And we do so using the let definition, okay? So we're already using the new ES6 version here to declare our variables. Smith, okay? And then this one is going to be a constant. So the year of birth is a constant because, as we saw before, it's something that really cannot change, right? Okay, and we also can create a function here. And we already know this one. It's a calculate age function. So calc age, and it gets a year. And it simply returns the current year, let's say 2016, minus the year that it receives as an input. All right, so the first thing that I want to talk about is template literals. And that's probably the coolest new thing about strings. And I really love this new feature because it really makes our life easier when working with strings. So imagine that in ES5, we wanted to put all of these data together in a big string. So let's say console.log. So this is the first name. Then we have to use all of these plus signs like this. And for me personally, I find this really annoying. So first name and then the last name. So John Smith. And it goes on and on. So he was born in, now this plus sign again, year of birth. So today he is, and now we can also calculate the age here. So of course we use calc age and then his year of birth. Years old. So this was quite some work, right? So let's check it out in the console. So yeah, this is John Smith. He was born in 1990. Today he's 26 years old. Let's just clear this here. This part was from before. So again, this is our string now. So again, this is a bit hard to write, right? With all of these plus signs, and it gets really confusing. So in ES6, we have a very cool new thing, which is called template literals. And it works like this. In order to use them, we now use backticks instead of the quotation marks that we used before. So backticks are these symbols here, all right? So we use these ones instead of the quotes that we used before or the single quotes, right? So we now use backticks. And this tells JavaScript that we want to use a template literal. And now we can write all of our text and put the variables right inside of the text. And this is how it works. So let's write the same sentence again. So this is, and now we simply can do it like this. So this, let's say $sign here, and then the curly brackets. And now we just have to say first name. And that's it. Now last name. Okay. So let's tag this before we continue. And alright, this is John Smith. So now we don't have to use all of these annoying plus signs and starting and stopping the strings like we did here. So all we have to do now is one big string which starts and begins here with a backtick. Okay? So let's continue our sentence here. So he was born in, and once again we do it like this, in year of birth, and today he is. And we can actually not just put variable names here, but entire expressions. So we can calculate this age right here inside of this template string. So once again, we can use the calc age function here, and it's gonna work just fine. Years old. So now we have the same sentence as before, hopefully. And yeah, it's exactly the same. So this was much quicker, right? And much easier to write. So this is probably one of the easiest and most straightforward things to implement right away when you start using ES6. And it's a huge advantage, in fact, over ES5. So this is template literals, but there's more. So in strings, we also have now a couple of new methods. So we talked about some string methods back in our budget project, but now we have some more new string methods. So let's take a look at them. So let's first start by creating a new string, and I'm just going to call it name, or N actually, which is just going to be John Smith. And now we already know how we do that, right? So we just say first name space last name. All right, so let's now use some of the new methods on this string. So the first one that I want to show you is called starts with. So we can just say n dot starts with, and then, for example, we can say j, and this is then going to return if the string starts with j or not. And actually, to see this, we have to console.log this, right? So let's see, true. Of course, because remember, this one here is John Smith, and of course it starts with a J. If we would put an N in here, it would actually be false. And also a small j is also false, because it's not the same letter. I mean, it's also a J, but it's not a capital J. So JavaScript identifies this as something else. Okay, and such as we have start with, we also have ends with. So let's just duplicate this line with Command D, and then ends with. So let's test if our string ends with th. And remember, it's called John Smith, so we should get true, right? So it makes sense. If we once again say something else, let's say something like this, then of course we have false. So we can test if a string starts with something or if it ends with something. So what about the middle of the string? For that we have includes. So we can ask if the string includes something. So let's, for example, ask if the string includes a space. And what do you think? Of course it's true, because remember, and we can check it out here by writing n, it's John Smith. So of course there's an s in here. Or if we test O, let's say if there's an O in the string, and yeah, we also get true here, right? So these are three very useful methods that are now included in ES6. Okay, and just one more, which is the repeat method. So let me also console.log something here. And what I'm going to do is simply say first name dot repeats. And then we can say how many times we want it to repeat. So let's see. Okay, it's not a function, and actually it's repeat and not repeats. Okay, so my mistake. But now here it is. So John, 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 John. 5 times in a row. Now imagine we want a space in there. Then we would have to write a template literal. Just like this. Okay, so John, 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 and John, John. So it doesn't look much useful in this case, but there are some cases that we need it, and that's why it was also added to the new version of JavaScript. Alright, and that's it with strings in ES6. For me personally, the best thing here is the template literals, so I really like them. All right, so let's now move on to another very important feature that's also very useful, and that's arrow functions. So come with me right to the next lecture. Let's now talk about arrow functions, which are yet another very cool addition to JavaScript. So suppose that we have an array with a couple of birth years and that we want to calculate the age for each of these years. So basically we would have const years. Okay, remember that whenever we have a value or a variable that's not going to change over time, we use the const to declare that variable. And in this case, this is totally the case. So just some random years here, 1982, and let's say 1937. Okay, so remember we can use the map method to loop over the array and then do some stuff with it. And that's how we do it in ES5. So again, we start with ES5 here and then move on to ES6. So in ES6, we would use var to declare a variable, right? So ages, and I'm going to call it ages5 because it's for ES5. And now we can say years.map, and you remember all of this, right? So we have our callback function here, and then our code inside of this callback function. And remember that here in the map method, we have access to the current element, the current index, and also the entire years array. So I'm just going to call it L, which stands for element here, okay? And if we then return something here, which will be 2016 minus the element in this case, it then gets stored into this array that we specified here. So this is how the map method works. So nothing new in here. Let's just simply console.log this array so that we can see that everything works. All right, so these are the 4 ages. Now in ES6, we have a more beautiful and quicker way of writing this part here of the code. So this callback function. So let me show you how. ES6. So now I use the const keyword and I call it ages6 years.map, and now comes the difference. So now we can use an arrow function. And how does the arrow function work in this case? Well, it's just like this. Element, then the arrow function 2016 minus the element. And that's it. So let me explain it to you. So here we have the argument, here we have the arrow operator, and then here we have what we have here in the return statement. So this one here is going to produce the exact same thing as all of this piece of code up here. So for a simple callback function like this here with only one argument, it really is as simple as this. So there's no function keyword, no return keyword, no parentheses, nor curly braces. All we need is the argument, the arrow, and then what we have in our return statement. So it really is as simple as this. And you see how much easier it is for us to write code like this, right? So we have to write a lot less code. Just to make sure, let's also log this one, just to show you that it really worked. And here it is. So it produces the exact same result, and we write a lot less code. Now, if we have more than one argument here, we actually have to provide the parentheses. So let me show you an example of that. So ages6. And now remember, we cannot change a constant, right? So let's change it here to let. All right, and so now it's a normal variable that we can mutate as we want. And let's now write it in a different way. So years.map. And once again, remember that we have access to the current element, the current index, and the array itself. So now I want to access the element and also the index. And so I have 2 arguments. And so, as I said before, I now have to use these parentheses here. So element and index. And then let's use the knowledge that we gained before in the last lecture, which are these template literals. So we're going to put a string in here saying age element index, or actually index plus 1, why not, is simply, and remember that in here we can even have expressions like this. So like 2016 minus the element. And so that's it. So now we used 2 arguments here, and therefore we had to use these parentheses here. Okay. Let's just console.log ages again. So age element 1, age element 2, 3, and 4. So that's the small change that we have to do when we have 2 arguments. Now if we have more than 1 line here, in this return part here, let's say, actually it's just this one here. So if we have more than this line, we also have to use the curly braces that we have to use in normal functions. And also the return keyword is then not implicit, and we have to write it again. So let's see an example of that as well. And I'm gonna call it AJAX again, because why create new variables here, right? So again, the same arguments, and I skipped the parentheses here. All right, and again, I want more than 1 line of code, and therefore I need to use these curly braces. So let's create a variable here, which is the current year, all right, so that it makes sense that we have more than 1 line. And I'm sure that you know by now how to get the current year, because we did this in our project. All right, and we can also calculate the age here outside. So let's say now minus the current element, and then let me return the string that we had before. So this one here. And remember that in this case, I actually have to write out the return statement here, the return keyword. Now here I want age, and that's it. Okay. And here we go. So it worked again. So there are 3 ways of writing arrow functions. The first one is with 1 argument and 1 line of code, and that's the simplest form. If we then add another argument, we need to use the parentheses, and if we then add more lines of code, more than 1, then we have to use the curly braces and the return keyword at the end. Alright, so this is how arrow functions work. And I'm absolutely sure that you see how useful they can be, right? But there's even more to arrow functions. That's not all. So let's move on now to the next lecture to learn all about it. Welcome to the next lecture. Let's continue with arrow functions and see another reason why they are so useful. So maybe the biggest advantage of using arrow functions is that they share the surrounding this keyword. So this means that, unlike normal functions, arrow functions don't get their own this keyword. So again, arrow functions do not have a this keyword. They simply use the this keyword of the function they are written in. And so we say that they have a lexical this variable. So let's now see how we can actually use that to our advantage. And now we're going to use one of these boxes here for the first time. So let's write an object with some properties, and then we will have also a function which will attach an event handler to this box here. Okay? So let's do that. And once again, I'm going to start by writing the ES5 version of this. So let's call this object box and box 5. And we're going to say the first property is color, and it's green. Okay, so we're talking about this very first box here, okay? This, of course, is a comma. The position of that box is number 1. All right, so it's the first one. And then we also want a method here called clickMe. And let's just add a function. All right. Now what we want this method to do is to simply attach an event handler to this element here. So let's just quickly jump into our HTML file and see that it's this one. So it's with the class of green, okay? So how do we add an event handler? We say document.querySelector, right, to first selected element, and then add event listener. And we want this to happen on a click, because that's the easiest one. And then we add our callback, right? And we actually want something very simple here. All we want is to have an alert which says the color of the box, so in this case green, so it's stored in here, and the position, which is stored here. So let's start by creating a string. So I'm just going to call it string str. This is box number, and since we're writing ES5 here, I'm actually going to do it entirely in ES5, and so I'm going to use the plus sign here instead of the template literal. Okay, so I say this dot position, so box number 1, and it is, and then the color. All right, and then we can alert this string. Okay, so let's now call this method, so box5 dot clickMe. And as soon as this method is executed, is called, the event listener will be added to this element. So let's reload this. Now, do you think that this is really gonna happen the way that we intended it to work? Let's check it out. So I'm now going to click on this box here. And it says, this is box number undefined, and it's undefined. Okay, so why is this happening? Why is it not reading our values from this object here, so green and 1? And the reason for that is something that I said in the very beginning of the course. And that is that only in a method call, the this keyword actually points to that object. But in a regular function call, the this keyword will always point to the global object, which in the case of the browser is the window object. And that is exactly what happens here. So this clickMe method is a function attached to an object. So it's a method. And so in here, we have access to the color and the position by using the this keyword, right? But then this callback function that we have here in this event handler here is not a method, it's a regular function call. And therefore, the this keyword here does not point to this box5 object, but instead it points to the window object. And of course, position and color are not defined in the window object. Therefore, what we have here is undefined for both of these. So some say that this is a bug in JavaScript, and others say that this is actually how it should behave. Now, a very common pattern to avoid this is to simply create a new variable in here and store the this variable in that new variable. So let's try that out. So let's say var, and we usually use a variable called self or that, and I prefer to call it self. And so we simply say self equals this. And then the self variable points to this. And so in here, instead of using this, we use self. And then we basically stored the this variable here in this new variable so that we can then use it in the rest of the function. So this is kind of a workaround, kind of a hack to avoid this situation that in this function call here, we don't have access to the box5 object. Okay, so let's now run this again. Click here, and now it works. Now it says this is box number 1 and it's green. All right, so remember that in the beginning I said that with arrow functions, they actually share the surrounding this keyword. So let's see how we can use arrow functions in order to avoid this hack here, right? So let me just go ahead and copy all of this. Actually, there's no need to write it all again. So it's ES6 now. I'm going to call it box 6 and call box 6 here. And now it's not a var, it's a constant. So let's say const. And we don't use this, okay? Because now what we're going to do here is to use an arrow function instead of this anonymous function here. So let's get rid of this. And remember that when we don't have any arguments, or if we have more than one argument, we have to specify the parentheses. So we do that, then the arrow, and then our function body, which is this. And it's actually as simple as this. So now in here we have a function that shares the this keyword with its surrounding. So with the click me method here. And we know that in here the this keyword points to the object. So now in here we can actually use the this keyword, right? So let's get rid of this one here. And let's run it. And I'm going to click now. And here it is. So this is box number 1 and it's green. So now by using the arrow function, we really have access to the this keyword of this method here. Because again, the arrow function shares the lexical this keyword of its surroundings. So if you want to start using ES6 and arrow functions today, then the best practice is to actually always use arrow functions when you need to preserve the value of the this keyword, such as we did here. So using arrow functions here was very useful, right? Let me just show you another scenario here. Let me copy this again and get rid of this one. And this is the ES6, let's call this 66 now, okay? So in here we still have a function that we could potentially replace with an arrow function, right? And it's this one. So if I, instead of this function expression, I wanted to write an arrow, I could simply do it like this, right? It would work the exact same thing. But let's see if the result is still the one that we want. So reload, and now I click here, and now it says undefined again. And why is that? And it's actually very simple. It's because this method here does now also share the lexical this keyword from its surroundings. And the surrounding of this is the global context, right? So this means that this method here also no longer has its own this keyword. So it shares the global this keyword, which of course points to the global object window. So this is the same situation as right in the beginning. We don't have position and color in the window, right? And therefore it becomes undefined. So this is not something that we want, but I just wanted to show you that you have to be really careful with these arrow functions so that you don't lose track of what the this keyword actually points to. So I will just comment this one out because it's not really interesting for us. So again, I just wanted to show you to be careful. Alright, and since this is one of the really great new things in JavaScript, let me just show you another example, because I really like these arrow functions. So we'll have another example here. Let's create a function constructor in order to create a person object, okay? So once again, we've done that a lot of times before, so you already know how to do this. And I'm going to keep it very simple just with the name. So this .name is of course the name. And let's now add a method to the prototype property of the person, so the objects created through the person function constructor inherit this method. So once again, nothing new here. So person.prototype property, and then let's say my friends. And once again, it's my friends 5 because we're using ES5 in this case first, so that I can show you the first example with ES5 and the second one with ES6. So this is a function which actually receives an array of friends. And what we want to do here is to simply return an array which says that the name of the person is friends with each of these elements that are in this friends array, right? So imagine that the person is John and that the friends are Bob and Jane. Then we want to say John is friends with Bob and John is friends with Jane, okay? So let's create an array. Simply call it R, and then we're going to use the map method that we used before once again, and this time here on the friends array. All right. So you already know that we could use the arrow function here, but since I'm writing ES5, I'm just going to do it this way. So we have access to the current element, and so I'm going to call it EL, which stands for element. And so in each element of this array, all I want is to say the name of the person is friends with, and then of course the current element, which is called EL. Okay, and then we simply can console.log the array. All right. Let's now create a couple of friends. Bob, Jane, and Mark. Let's say that should be enough for now. So let's create a new person called John. And then we can call right away the myFriends5 method. And we're going to pass the friends into it, of course. All right. So again, do you think that this is going to work? Take a deep look at this method here and see if the this variable will actually point to what we think it points. Okay? So let's now run this. And actually, something weird happens. So the name is not defined. And this is because of the exact same reason as before. So in here, in this method, we of course have access to the this variable, and it points to the name of the person. So it would be John. But the thing is that in here we call another function, right? Which is this anonymous function. And so in here, the this keyword is not going to point to the object, but instead it's going to point to the global object, which is window once again. Now we could again use that trick that we used before by saying var self equal this. So basically storing the this variable in a separate variable. But I just want to show you another cool trick that we could use here instead. So remember that we have the bind, call, and apply methods, which we can use to set the this keyword, right? Remember that part? So call, bind, and apply allow us to define the this variable manually, and bind creates a copy of this function, while call actually calls it immediately, okay? So what we can do here is to create a copy of this function with the this variable set to this. So this here is the function, right? And so in this function, we can create a copy of this function using the bind method right here. So what do we want the this keyword in here to be? Exactly, we want it to be this. So this maybe sounds or looks a little bit weird, but this is actually going to work. Because remember, here outside, we still have access to the this variable, and it points to the new person. So in this case, it would be John. And so we can basically pass it into this function here, simply by creating a new copy of the function with a manually defined this keyword. So let's check if this works now. And yes, it does. So John is friends with Bob, with Jane, and with Mark. So this is the ES5 version. And you still learned a very cool trick with this bind here, right? All right, and now the ES6 version. And once again, I'm going to copy it and just modify some stuff. So this one is called my friend 6. And then in here, we can change the content of our method. Now I want you to go ahead on your own and change everything here so that we no longer need this trick here. And I'm sure that you can do that by now, right? So please pause the video and do that right now. So I'm sure that you managed to do it. So let me show you my solution. So of course we use an arrow function here, right? And we actually don't need any of this, right? Because we simply have one line of code. So what I'm going to do is copy this, delete all of this, and just paste it back here. And another thing that we can do is to use a template string, which is way cooler than doing it this way. So get rid of all of this. So I'm missing the backticks here, okay. And here we go. So now we have transformed this to an arrow function. And so, as you learned before, this function does not have its own this keyword. And therefore we share the lexical this keyword from our surroundings. And the surroundings is, in this case of course, this method, where the this variable points exactly to the point where we want, which is the instance that we create. So let's create a new instance. And then the this keyword will point to it. This time let's call it Mike. Okay. And then friends 6 here, of course. And let's see that it's gonna work. And actually it doesn't. And that's because I didn't copy the new operator, right? So we were simply doing a function call with the person instead of creating a new object. So let's try it again. And now it works. Mike is friends with Bob, Mike, Jane, and Mike, Mark. Okay, so once again, we use the power of the arrow function here. So I hope that these 2 lectures were enough to really convince you to start using the arrow functions. I hope that everything makes a lot of sense to you up until this point. And if it does, then let's go right now to the next lecture, which is going to be about destructuring. So another new concept in ES6. So let's move on. Let's now talk about something called destructuring. So destructuring gives us a very convenient way to extract data from a data structure like an object or an array. So imagine that we had an array filled with some data and that we now wanted to store each of the elements of that array in a single variable. So let's start again with doing it in ES5, right? And let's first write our array. So a very simple array, just with the name and the age of John, okay, and 26. So if we wanted to store each of the elements in a separate variable, we would simply have to write one variable for each element, just like this. So the name, and it's the first element of John, so 0, and then a variable for the age, and John 1. Okay, so now we have both elements in separate variables. Now imagine that we had like 5 or 10 elements in that array, then it would become a bit impractical to do this every time like this, right? And so in ES6 we have something called destructuring once again. And it would work like this. So ES6 now. So with destructuring, we can destructure a data structure just like this. So we create a new variable, and then in here we put name and year, and then we put our array in here. So John and 26. And what this is going to do is it's going to create a constant called name and a constant called year. And then this data will be stored in each of the variables. So let's actually check that. So console.log with the name and with the year. And actually it should be age. Okay. So let's check it out. Okay, the problem here is of course that I already used the variable called name before, right? So let's just get rid of this. And now it's going to work, of course. Okay, so again, we destructured this data structure here using this kind of syntax here. So it's like the opposite of constructing a data structure. So with this here, we build a data structure, and then with this syntax here, we destruct it. And this actually also works with objects. So imagine we had an object, simply going to call it obj. So first name and last name as usual, right? And now destructuring works in the exact same way. All we have to make sure is that the keys actually match with our new variable names. So let's do that. And now it's an object, and so we use the curly braces here, of course, because the object is also constructed like that. So that's also how we destruct it, okay? So we write first name and last name. And remember that these keys here have to be the exact same thing here. So these new variable names have to match the keys. And now we just say object. And that's it. Now we created two brand new constants which store the data out of the object. Let's just very quickly check that. First name and last name. And here we go. Now, if we don't want the variable names to match with the key names, then we can also use different names. And it's going to work simply like this. So again, we use the curly braces. Then we say first name A. For example, if you want the variable to be called A, and then last name B equal object, and that's it. So let's just quickly see if we have the same. And yeah, again, it's John Smith here. Okay, so this is how destructuring works. But let's now see a more practical application of destructuring. And a very good application is to actually return multiple values from a function. So in a more easier way than we used to do before. So at ES5, usually if we had more than one value that we wanted to return from a function, we would simply return an object. But now with destructuring, it got a bit easier. So let's try that out. So let's create a function that returns the age of a person as well as the remaining time for retirement. So we used that before, but now we're going to use both of these concepts in the same function, okay? So function calc age and retirement. And that's based on a year that we input. So const age. So let's now create a new date here, okay? So that our year is always up to date. So get full year instead of simply using 2016 or something like that. So instead of hard coding it here, minus the input year. So let's now return both of the age and the years until retirement. And so we simply return an array with these data. So age and then 65 minus the age. So supposing that 65 is the age at which we can retire. Could be something different, but let's assume it's 65, okay? So we used that before. And so that's how we do it here. All right, so this returns an array. And now all we have to do is to use destructuring in order to store this into different variables. So we want age and retirement. And this is of course the result of calling the function with, let's say, 1990. So we're now going to have two different return values. Let's just take a look at them. Age and of course the retirement. Okay, so we have already used a variable called age. Let's just call it age2 here. It really doesn't matter, right? Okay, and now it works. So these are the two return values that come from our function. So destructuring is a good solution for this particular case, and we're actually going to see more applications of destructuring, at least one more, later in the course. So stay tuned and come with me right to the next lecture. In this lecture, we're going to take a look at arrays in ES6, because a lot of things were added to arrays. We now have a lot of new methods and also a new kind of loop. So let's dive right into this lecture. And we're actually going to use all of these colored boxes now here in this lecture. So let's start by selecting them. And we're going to save it in a constant. And of course we use document.querySelector all. Let's first take a look now at the HTML. And we see that all of them have this box class name here, right? So let's use that one to select them. So box. Now we already know that this querySelectorAll method does not return an array with its elements, but instead it returns a node list. You remember that one, right? So what we have to do is to transform it into an array. And what we always did in this course was using this weird trick where we called the slide method on the array prototype and setting the this variable to the boxes in this case, right? So in ES5, this is how we would do it. So boxes array and 5 for ES5, we would say array.prototype and then use the slice method and then call it with boxes. So you remember this part, right? And so now we have an array, and now we can use all of the array methods. So let's say we wanted to change all of these boxes here to blue, okay? So like this blue color here. So we can now use the for each method. So boxes array 5 dot for each and our callback function. And here I'm going to write it the ES5 way. So the current element, and I want to change the style, the background color, to this blue color, which is called Dodger blue. So this is a CSS color name. Okay, and that's it actually. So let's test this out. And nothing changed. And yeah, it's because I misspelled here this word. So it's called Dodger blue, okay? So just like this. And yeah, so now they're all blue. But we had to use this hack here, right? And so there's actually a better way now in ES6. So let's get rid of this code and write it in ES6. So boxes array 6, and now we have a new method which is called from. So all we have to do is say array.from and then boxes. And what this is going to do is to simply transform this node list here that we have in boxes to an array. And it's as simple as that. And so now we can say boxes array 6 for each, And now I'm going to use the arrow function. Okay, so I want the current element and I want to change its style to Dodger Blue. And I hope it's correct this time. And yeah, it works. And since this is actually so short and simple, we can even take this from here and do it like this. And so we went from all of this code here to doing the same thing in just one line of code. So this new from method here makes our code a bit shorter and it also looks better. Alright, so let's now talk about loops. So usually when we want to loop over an array, we use the for each or the map method. And they usually work just fine, right? Now, the problem with them is that we actually cannot break from them. And we can also not use the continue statement. So if we want to use the break or the continue statements in a loop, we cannot use for each. And we can also not use map. And so we would use a simple for loop in ES5, which forces us to write a lot of code just for a very simple loop. So suppose that we wanted to change the text here in the boxes, okay? Because now this box is no longer green and this is no longer orange. So let's say that we want to change the text from this box and from this box. So if we're in a loop, we can simply say that here in the second box, we want the loop to continue and not to do anything. So let's start by writing that the ES5 way. So as I was saying, we use a simple for loop here. So you already know how this works, right? Boxes array 5, and it's not active because I commented out this code here, right? Okay. Dot length and I++. So this is nothing new at all for you. And now all we have to do is to say that if it's this second box here, then we want to continue the loop. So let's check it out. And the class name of this one here is box blue. So we cannot simply say just blue, but instead we have to say that the class name is box blue. So let me show you how we can do that. So we say that if the boxes array at the current position, so position I, the class name, and I'm not sure if we already used that in the course, but I think we didn't. So this is a great time to learn this new property. So with class name here, we can retrieve the name of the class, of course, and then perform this kind of check that we have here. So in this case, to see if this element has the box blue class on it. And if it does, then we want to continue. Okay, and I'm sure that you remember the continue and break keywords from the beginning of the course. So what the continue will do is to simply skip this iteration of the loop and go right to the next one. And the break keyword will break this loop and then we don't continue to the next iteration. So if we would use break here, then we simply would break the loop and it would stop here and not continue. Okay, but in the other cases, we simply want to change the text. So boxes array 5, and of course we need to select the current box, and then text content, and let's say I change to blue, which wouldn't make much sense on the second one because it is already blue. So let's see what happens here. Okay, so I changed to blue, nothing changed here, and I changed to blue. Let me just show you what happens with the break. Okay, and so in this case, only the first one would change, and then as soon as we hit the second element, it would break from the loop and not continue. Okay. Now, I really don't like to use the for loop like this. We have to write all of this code here, which always seems a bit repetitive, And then to select each element, we always have to write it out like this. And so in ES6, we now have a new loop. And this new loop combines the easy to use for each with the for loop. And this new loop is called the for of. So instead of for, it's called for of. So let's take out this code and write it the ES6 way. And here is how the for of loop works. So for, and then in here we can create a new variable, a constant for example, and then such as we do in the for each method, we can define our current element. And we can call this whatever we want. We can say current or element or whatever we want. And we say that this is an element of the boxes array 6. And that's it. So this is a simple loop where we can define the current element rather than having to do all of this weird code here. So again, this combines the very easy to use for each or map method with the for loop. So and then in here, we can also use the continue or the break statement, which we cannot in map or for each. So let's do the same thing that we did before. So if boxes array, and actually we want 6. Let me see if it's active here. Oh, it's actually not, because I deleted that variable. So let me just add it back here, okay? So boxes are 6. Alright, just because we need this variable here later on. So dot class name equals box blue. Then we want to continue. Okay, and now let's just copy this part here so we don't have to write it all over again. But here it's now the simpler cur. Or it could be even simpler like C or whatever we want. Now this here is actually not correct, because what we want is the class name of the current element, right? Not of the entire boxes array. So this was a mistake. So let's now check it out. And yep, it worked just like before. This one changed and this one changed. The one in the middle just stays the same. So we went from this a bit more confusing and bigger code to this one here. And in here, we can actually do a little bit better, because now we have these new string methods. And so what we can do here is to use the includes method. So I hope you remember that one from one of the previous lectures. So includes, and we can now say blue. And remember that this one is gonna return a true if the class name contains the name blue. And so this way, we don't have to write here the entire class name, because we're just interested in the blue part. So this makes it even a bit better and more readable. And so you also just saw a good application of this new includes method. And of course, it still works. So this was of course a very simple example, but it's really important to show you that sometimes we might need the break or continue statements in a loop. And in this case, the new for of loop here comes in very handy. Alright, and just to finish, there are also two new and very useful array methods that allow us to find elements in an array. So up until this point, we only had the index of method, right? But now there are a couple of new ones, and I'm going to show you two of them, which are the best ones in my opinion. So suppose that we have a group of children and we know that only one of them is of full age. So let's now find out who and how old that person is. So again, we start with ES5. Let's say the ages of these children were 12, 17, 8, 21, 14, and 11. That's not quite 11. Okay. So the ES5 way, we would first have to create a boolean array to determine whether each element of the array is younger or older than 18. And we could then use the index of to determine the element that we want. So let's use the map method to create an array with true or false values like this. So full age, which I'm going to abbreviate as full, and then ages.map. Okay, and I want the current, of course. And all we need to do here is to return if the current element is older or equal to 18 years. Okay, let's just check this. So false, 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 true, and false, false. So only this one is true. But now we have to find out the position of this element here in the array. And in order to do that, we use the indexOf method. IndexOf, and we want the one that is true, right? And in order to see this, let's use console.log again. And here we go. So it's element number 3, 0, 1, 2, 3. And if we want to now see how old the person is, we need to retrieve that exact element from the array. So ages, and then to retrieve, and now we need to again calculate the position of that element that's true. And so the person is, that's right, 21 years old. So that's a lot of work just for this very simple task, right? And so in ES5, once again, our life is made easier with a couple of new methods. And these new methods are the findIndex and the find methods. So in ES6, let's now start by using the findIndex method. And this method, we can pass a callback function into it, and it's then going to return us the index of the array where the callback function returns true. So it's just like this. So ages.findTheIndex, and then this works a bit like the map or the for each methods. So we have a callback function that has access to the current element, to the current index, and the entire array. And so I can write cur, then my arrow function, and then what I want is the same expression that we had before, which is when the current is greater or equal to 18 years old. So what this does is to basically return the index for the element in which this expression here, so this callback function, returns the value true. And that's as simple as it. So let's actually console.log this result to see if it's the same as here. And yes, it is. So it's number 3. And if we actually want to retrieve the element and not just the index, then we could do something very similar. Instead of having to write it like this way here, so the array and then retrieve the value, now we have a simple method that does all of that automatically. So ages, find, and then this part here is of course the same. So if you don't want to know the index, we actually don't even have to calculate it. So we could just use this one if all we are interested in is to find the value that is greater than 18. And that value is 21, of course. So a lot of new and very useful stuff about arrays. These are great additions to the new standard of JavaScript, so to ES6. All right, so see you in the next video. Hey there! In this video, I'm going to show you a new operator in JavaScript, and that's the spread operator. So the new spread operator is a very convenient way to expand elements of an array in places like arguments in function calls. So let me show you what I mean by expand elements. Let's first create a simple function which simply adds for values, let's say for ages. So function add for ages. And I'm going to call them A, B, C, and D. And we simply return the sum of all of these elements, plus C and plus D. Alright, so let's now test if this actually works. Sum1, because I'm going to use this multiple times, so I'm going to start with sum1. So add 4 ages, and let's say 18, 30, 12, and 21. Okay, and then I'm going to console log this sum. Okay, and it's 81. Now imagine that we had these 4 numbers in an array instead of, for example, 4 different variables. So how would we pass that entire array into that function? So let's start with ES5. And the first thing is, of course, to create the ages array. So 18, 30, 12, and 21. Now remember that we have the bind, call, and apply methods. And we used the bind and the call methods already, but we didn't really use the apply method. And remember that the apply method, what it does is to receive an array. And it calls the function that the apply method is used on using the elements of the array as the arguments. And so we're going to make use of that here. Okay, so let me show you how that works. So now it's sum2, and we say add 4 ages, and then we use the apply method. And remember, we have to specify the this variable as well, such as in bind and call. But we're not really interested in that, and so we can just say that it's null. Okay, and then we pass ages into here. And so once again, what the apply method will do is to take this array and then call this function here using these elements of the array as the arguments, which is exactly what we want to do here, right? Because again, this function doesn't receive an array, but instead it receives these 4 arguments here. So let's now see if sum2 is also 81, which it should be. Sum2. And alright, so this worked. But once again, there is a better way of doing this in ES6. And it's as simple as this. So now I'm going to call it mag3. And we now are going to use the spread operator. So add 4 ages and the spread operator and then simply ages. And that's it. And this is what expanding means. What this operator here does is to expand this array into its components. So in this case 18, 30, 12, and 21. So this here is now exactly the same as writing 18, 30, 12, and 21, such as we did here in this case. So this is what the spread operator does. And now we're just gonna test it. And this is of course not max3, I don't know why I did that. So it's sum3. And now it should be 81 again, and it is. So of course, this method here works exactly the same, but here it's more easy to write, more easy to read, and also to memorize. So instead of using this apply and null, you can simply use the new spread operator to call this function like this with these arguments. And there are actually more use cases, for example, for joining arrays. So imagine that we have 2 arrays. One is for the Smith family. So going back to our person examples here. And so we have John, Jane, and then Mark. And we have an array for another family. Let's say Miller. And in here we have Mary, Bob, and Anne. Now to join these 2 arrays, we can once again use the spread operator. So now it's a big family. And so we say that we want to spread the family Smith and the family Miller. So what this does is to expand this array into the three single elements. It basically takes them out of the array and puts them here. And the same, of course, with family Miller. And just to make sure that it works, so here we have the array with all of the elements. And we can also just put another element here in the middle, for example, or somewhere else. Let's say that there's a new element like a new child. Then we can, of course, put it right here like this. And now here it is. And yet another use case is that we can actually use this on other structures, so not just array, but for example also on a node list. So remember, the node list is what the query selector all returns. So let's see an example of that. So I'm going to select this heading here, okay, and then the boxes, and then I want to change the text color of all of these four elements to let's say to purple. So I'm going to start with the heading, so h document query selector, and it's an h1 element. So let me show it to you. So it's an h1 element. So I'm not going to select it by class or by ID, but simply by its element name. And so we don't need the point or the hash symbol here. Okay, and now we also want the boxes. And we did this one before, so it's just like this. And now we could, of course, change the text color of this element and then loop through all of these here and change the text colors as well. But it's easier if we simply put all of them in the same structure, right? And so we can use the spread operator here once again, because remember, they don't only work on arrays, but also on other structures like node lists, which is what we have here. So let's do that. I'm going to call it all, and then we want h, and we want to spread the boxes. Okay, because h is not a node list, it's simply a node, because it's a query selector and not query selector all. But in here we have this node list, and so we use the spread operator to expand it, and then we have the four elements all here stored in this node list in the all variable. And so now all we need to do is to transform this node list into an array, and then we can loop through it with the for each method. And as we learned in the last lecture or one of the previous lectures, it's very easy to convert the node list to an array, right? So we simply write array and then from, which is the new method, and all, and this returns an array. And so now on this we can use, of course, the for each method. And we want the current element, and now I'm sure that you're already getting used to this new syntax that we've been using all the time now, which is the arrow function. So the current is the argument to the function, and now what we want to do is to change the style of each of the elements. So current.style.color, which is the CSS property for styling text colors. And now I simply use the CSS color name purple. And that's it. That's all we have to do to change all of these colors. So let's see, and it works. So they're all purple now. Not very beautiful, but that's not what matters here, right? So these were a couple of use cases for the new spread operator, and I hope that you see how useful it can be. So now let's move on together. In this lecture and the next one, we're going to talk about function parameters. So let's start with REST parameters right in this lecture. So REST parameters allow us to pass an arbitrary number of arguments into a function and use these arguments in that function. So in the last lecture, we've been looking at the spread operator, right? Now, REST parameters look exactly the same, but they are very different. So they use the same notation with the three dots, But actually rest parameters are the exact opposite of the spread operator. And that's because the spread operator takes an array and basically transforms it into single values, while the rest parameters receive a couple of single values and transforms them into an array when we call a function with multiple parameters. Okay, but enough talking, let's now see a practical example of this. So suppose we want to create a function that receives an arbitrary number of years and then prints to the console whether each person corresponding to these years is of full age or not. And once more, I'm going to start by doing it the ES5 way and then show you how the rest parameters work in ES6, making our life a bit easier. So in ES5, let's create a function called isFullAge and then 5. Okay, and in ES5, if we want to receive an undefined number of arguments, then we simply don't define any parameters for our function and then just use the arguments keyword. And remember, the arguments keyword or variable is very similar to the this variable, and it's a variable that each execution context gets access to. So let's first of all log this arguments variable to the console to see what it looks like. And arguments. Okay. So again, just like this is a special variable that we have access to in all functions. So let's say we want to call this function with 3 years, like 1990, 1999, and 1965. So let's see what happens now in the console. And now we have a small error here, but that's simply because I forgot the 5 here. Okay, so again, and so this is the arguments variable. And we see that it actually looks a bit similar to an array, but in fact it is not an array. So it simply says object here and not array, right? So all of the arrays have the array function constructor as their prototype, which is not the case here. And so arguments is not an array. We say that it's an array-like structure, but it's not really an array. So if we want to use it as an array, for example, to loop through it, then we need to first transform it to an array. And we already know how to do that with our little hack, right? And so we say var args array should be array dot prototype dot slice, and then call it with the arguments. Right? So that's what we did a couple lectures earlier. So now we're ready to loop through this array. And remember, what we want to do here is to calculate if each person is of full age. So it's very simple. We of course need to create a callback function here, and we use current, and we want to log to the console. So 2016, or the current year, minus the current value is greater or equal than 18. And that's it. So remember, the current is of course the current element of the array, and the array comes from the arguments. So all of these numbers that we pass into the function, which are, in this case, our years. So with this, it's actually going to work already. So let's check, and yeah, so it does work. So we have true, false, true. So the first person is of full age. This one born in 1999 is not, and this one is of full age too. So let's try it with a different number of arguments. So I'm going to add 2 more years here, let's say 2016 and 1987. And let's check it again. And so these are the first 3 coming from this function call, and these 5 here come of course from these. So we have true, false, true again, and then false, true. So this person, of course, is not a full age, and this one is. And if we wanted to add 100 arguments here, then it would work with 100 arguments, of course. So this is how we do it in ES5. But let's now take a look at rest parameters in ES6. So ES6. And we're going to write a similar function, but make use of rest parameters. So is full age 6. And now, instead of not having any arguments, we use the rest parameter operator. And as I mentioned before, it's the exact same as the spread operator. So again, we have the 3 dots. And then we say the name of the variable. And so what this is going to do is, as soon as we call the function, it will transform the arguments, for example, these 3 arguments or these 5, it will transform them into an array and then pass it into this function. And we can then access that years array automatically in a function and use it as we did before. So let's do that now. So let me first do exactly the same that we did before. So I'm going to call a function and I'll show you what the years looks like. Let's just deactivate this function call here and take a look at this. All right, so this is years. And now we see that this is actually an array. So that is very handy because now we don't have to do all of this. So we don't have to transform anything into an array because we already have the array. So now all we have to do is to do that console log that we did before. So we can say years for each. And here again, we're going to use the arrow function and say that we want 2016 minus the current year and check if it's greater or equal to 18. And here we go. So this is the same function as before, but making use of rest parameters, which makes our code shorter and easier to read. And just to make sure that it works, okay, nothing happened. And that's of course because I forgot to write the console log here. So console.log, of course, and now it's gonna work. So close it here, and all right. So true, false, true. And if we now added these numbers, these years that we had before, say 2016, 1987, then of course it works the exact same way. So the big difference between the spread operator and the rest parameters is actually the place in which we use each of them. So the spread operator is used in the function call, while the rest operator is used in the function declaration to accept an arbitrary number of parameters. So I hope that the difference between the spread operator and rest parameters is now crystal clear to you. So if it is, then let's take this one step further and make the rest parameters even more useful, okay? So what I'm going to do now is to comment out this code and copy it, because we're going to do some changes here. So let me just copy this and put it back here. Because now what we want to change is to accept another parameter which will act as the age limit. So instead of having the 18 here, we will pass a parameter which is going to tell us at which age a person becomes full of age. So imagine it would be 21 in some countries, then we would need the 21 here. So we simply add a limit. And now we need to add a parameter in here because it's only one parameter. And it's one that we really know that we need. So we need one and only one limit here. Now the problem is that this limit here will also be part of the argument, right? So imagine that we now call this function with, let's say 21 here as the limit, then this will obviously also be part of the argument's keyword, which is not what we want, of course, because here in this argument and in this array, we actually only want the years. And how would we do that here in ES5? It's actually pretty simple, because this slice method here can help us with that. Because remember, what the slice method here does is to allow us to cut a piece of an array. So if we now simply add the number 1, what this means is that it's going to start cutting at position number 1, or basically it will start to copy a part of the array. Or in other words, at position 1 it will start to, let's say, to copy our array. And so like this we can exclude the first argument. So to make this more clear, let's again take a look at the arguments, and then let's console log also the arguments array. Okay, so we have 21, 1990, 1999, and 1965, which are all of the arguments that we pass. And then our arguments array is the same thing but without the 21. And that's because we only started copying at position number 1. So in here, so 1, 2, and 3. So that's what the slice function does. And so we can handle, let's say, a usual parameter plus a number of arbitrary parameters, which are in case these 3. Then all we have to do is to here change it to limit, and we're good to go. So now we don't need this console.log anymore. And so here we have true, false, true, such as we had before. But now suppose that the age limit would be 16, then all of them would be of full age. So we had 3 times true. So you see, adding an argument here to our ES5 function makes it even more complicated. But in ES6, it's nothing like that. All we have to do is to add the limit, and then here we have our rest parameters. So this makes it very clear and very easy to use, because there's nothing we have to change. So all we have to do, of course, is to change this to a limit, and now we're good to go. And we could add as many parameters here as we wanted, and then say with this part here that here we have an undetermined number of arguments. So if we now add 16 here and get rid of this, then we have true, 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 false, true. So it's different than before, and of course it works. So as you see by now, many of the features of ES6 simply allow us to do things that we can already do in ES5, but in a much better, quicker, and easier way. And this is, of course, one of these new features that doesn't allow us to do anything really new, but simply allows us to do something in a better way. Alright, so let's now quickly move on to the second lecture about parameters, which is default parameters. So, I showed you rest parameters in the last lecture, so now it's time to talk about default parameters. And default parameters are actually a very straightforward concept. We use them whenever we want one or more parameters of a function to be preset, so we want them to have a default value. So ES6 brings us default parameters, but there is also a way of coding this in ES5. So let's start by doing that. So we haven't used function constructors in a long time, so let's do that now and create a person. Okay, but we create specifically a Smith person, so a person which is a part of the Smith family. So let's call it Smith person, and we want it to have a first name, a year of birth, also a last name, and a nationality. Alright. And so we say, as usual, should be the first name that we receive. The last name is, of course, the last name, and the same for the year of birth. And the nationality. Alright, so let's now use that function constructor and create a new person called John once more. So it's a new Smith person. Let's say John and 1990. So JavaScript actually allows us to call any function without specifying all of the arguments. So in this case, we only specify first name and year of birth, but leave the last name and nationality empty. And what JavaScript does in this case is that it simply assigns undefined to these two parameters. So they will be undefined. And we're going to make use of that in a second. I just want to show it to you here in the console. Okay, so let's take a look at John. And so here we see, so last name is undefined and the nationality is undefined as well. So what if we wanted to add a default for the last name and for the nationality? So imagine that we always would call this function constructor like this, only with the first name and the year of birth, and that the last name and the nationality would be default. And we can actually do that and make use of the fact that the arguments that we don't specify will be undefined. And so we can then use an if statement or something simpler like the ternary operator and simply say, if the last name is undefined, then let the last name be Smith, and else it's simply last name, so nothing changes. So let's think about it again. So the variable will be undefined if we do not specify the last name, okay? And so in this case, last name will become Smith. And that makes sense because we say that it's a Smith person here, right? And in case that it's not undefined, then nothing happens. And we can actually delete this part from here. And we'll now do the same thing with the nationality. So if the nationality is undefined, then we want the nationality to be, let's say, American. All right. And then after that, this part of the code here will execute and do its work. So let's see what happens now. Okay, so we have a small bug here. And the problem is actually that in the ternary operator, we also have to always specify the else part. So let's just say that in this case, it's last name equal last name. So it doesn't make much sense, but we have to put the else part here as well. And so here, let's say nationality is the nationality. Okay. So let's now take a look at John again. And yeah, so his last name is not Smith and his nationality is American. So we only called the Smith person operator function constructor with 2 arguments, but we still have all of these 4 properties of the object well defined because we implemented something similar to default parameters. Now, these can of course be overwritten. So imagine that we have another person, which is Emily, and Emily is John's sister, and she married with someone else and moved to Spain. And so we can now, of course, specify a new last name and a new nationality. So let's say that we have also a Smith person. She's called Emily. Let's say born in 1983. But her last name is now no longer Smith, but Diaz. So she moved to Spain and is now Spanish and no longer American. And so this is going to override the default parameters of our function constructor. So if we now take a look at Emily, of course, the defaults were overwritten and we now have the last name as Diaz and the nationality as Spanish. So this is how we use something like default parameters in ES5. And now we're ready to see how this actually works in ES6, which is a lot easier and straightforward. So now in ES6, all we have to do is, of course, this part is the same. So it's a Smith person. And we have a first name a year of birth. And now this is where we define the default parameter. So we say that the last name should be Smith and that the nationality should be American if we do not specifically say something else. Then of course this part here is the same, so I will just copy it and that's it. So we don't need any of this part here. All we need to do is to specify the default parameters right here where we actually declare the parameters, okay? So if we now run this and take a look at John, then this is exactly what we had before, but in a better and easier way. So Smith again here, of course, and he is American. And the same with Emily. So we overrode the defaults, and so her last name is Diaz, and she is Spanish. Okay? So REST and default parameters definitely makes it easier to work with functions in JavaScript. So they are a very welcome addition to the language. Okay, so let's now move on. Welcome back. I will now show you something that is entirely new in ES6. And that's a new data structure called map. And in case that you're wondering, this doesn't have anything to do with actual maps, like you see on Google Maps or something. So let me explain what maps are in ES6. So a very common use of JavaScript objects is to use them as hash maps, which simply means that we map string keys to arbitrary values. And we did that a lot earlier in the course, especially in the basics section, for example in our more simple John objects. Back then we had simple keys like name, age or job, and then mapped values to them, like John, 27 and teacher. Now this is called a hash map, and up until ES6 we had to use objects for that. But now in ES6 we have something better, and that's maps. So a map is a new key value data structure in ES6. And one of the big differences is that in maps we can use anything for the keys. So in objects we are limited to strings, but in maps we can use any kind of primitive value like numbers, strings or booleans, and we can even use functions or objects as keys, which is really cool and really a big deal. Alright, but enough theory, let's actually use this in practice and construct our first map. And we're gonna implement a very simple quiz with only one question just to show you how maps work. So this is how we create a map. Let's create a variable and it will be a constant, and I'm just gonna call it question. And we say we want a new map. And that's it. So we just created a new empty map. So let's now add some data to it. And in order to do that, we use the set method. So question.set, and then we set the key. And in this case, I'm first going to use a string so that we can specify the question text in here. So I say question, which is the key, and then the value. And the question is going to be, what is the official name of the latest major JavaScript version? Alright, and that's it. So this is the first key of our new map. So this works a bit like a property in an object, right? So we could have a question property and then assign this string to that property. So that would be similar. But in maps, this is how we define a new key value pair, okay? And so let's now add some answers to this question. So question.set, and now I can use, as I said before, anything in here. It doesn't have to be a string like an object, it can be anything. And so I'm simply going to say 1. So 1 for the first answer. Let's say ES5. Okay. Okay, and another choice is ES6. And let's add another one. so that we have multiple choices here. ES 2015, and the fourth one, ES7. Here we go. Okay, and now we also need the correct answer. So let's add that as well. So that's set, and now I say correct. So we're back to using a string as a key here. And the correct answer is, of course, and I hope that you know it, number 3. So this is the official name of the latest JavaScript version. Actually, the major JavaScript version, because ES7 is the most current version, but that's not the one that everybody uses right now. Everyone is rather focusing on ES 2015 at this point. All right, and what we can also add here is what happens if the answer is true or if it's false. So let's put another key value pair here, and we already used strings as a key. We used numbers, and now let's use a boolean, okay? So if the answer is true, then we want to print to the console correct answer. And if it's the wrong answer, then of course it's false. And then we say wrong, please try again. And so I think that with this, we have everything set up for our question. Let's now load this and take a look at our map here in the console. So question, and here it is. So this is how a map looks like here in the console. Let's open this. And so here we go. Here we have our entries. We can also see the length, and we see that the prototype of this map is, of course, a map. So this is like, remember, like an array, for example, where the prototype is an array. And so this is a new built-in type in ES6, so a map. And this, of course, if we see the prototype chain is an object, and so on and so forth, right? So just to see how this looks in a console. Now, what if we actually wanted to retrieve data from this map? What we do is the opposite of set, which is get. And so what we do is question.get, and then we simply have to pass in the key. So let's say that we want the question. And let's console.log this. And so we should see the value, and that's it. So what's the official name of the latest major JavaScript version? Okay, and another cool thing that we can do with maps that we can't do with objects is to get the size or the length. So we can say question.size, and it's not length like it's with arrays, but in this case it's size. So let's see, and it gives us 8. So this works. So 1, 2, 3, 4, 5, 6, 7, and 8. So we can set data in our map, and we can also get data. But we can also delete data and check if data is there or if a certain key is there. So imagine that we wanted to make this question a bit easier, and in order to do that, we would remove one of these choice elements, right? So instead of having 4, we would have only 3. So let's see how that works. So it's actually very simple. So all we say is question.delete and then the key. And in this case, we want to remove the number 4. All right. Let's take a look at it now here in the console. Question. And so yeah, it's not here. So 1, 2, 3, and 4 is gone. Now, what would happen if we would accidentally run this line of code here twice, so delete it twice? Let's duplicate and find out. Actually, nothing happens. Let's check it out again. Question. So since it's not there, nothing happens. But just to be sure, we can use the hath method. So we can say, if question has the key number 4, then in this case, let's delete it. And actually, This should be here. Okay. So we can get, set, delete, and also check if a certain key is in the map. So if there's a key number 4 in the question, then we can delete that element. And if you decide that you want to delete all of the elements at the same time, then there's also a method for you, and that one is called clear. So let's finally clear everything from our map. So all we have to do is to use clear. So if we now load this and then check out our question, then you see that it's empty. So it's no longer there because we cleared everything. Of course, we don't want to do that, right? And we also don't want to delete the question number 4. So let's just take this out and log something to the console here instead, just to see that the has method works. All right. So set, get, has, delete, and clear are the most basic methods that we can use to manipulate maps. Now, something else that's very cool is that maps are actually iterable. So this means that we can loop through them, which is another thing that we cannot do with objects, right? So the first way of looping through a map is to use the for each method. And so this means that each map gets the for each method, such as arrays do. And all this means is, as you already know, is that the for each method is in the prototype property of the map function constructor. And so all of the maps inherit that method and can then use it. So let's try that. And so we say question.forEach. And such as with arrays, we have access to the current element, to the current key, and also to the entire map. So let's access the value and the key. And I'm actually going to call it like that. So value and key. And let's just log them to the console, okay? So console.log. This is key, and it's set to, and of course it's the value. So let's check this out. And yeah, so here we go. So all our 8 elements here are now printed to the console. And so this means that we can really loop through a map, which is really handy. So we use the for each method, but we can also loop using the for of loop that I showed you before with the arrays. So this kind of loop doesn't only work for arrays, but also for maps. So let's try that out as well. So for, and let's say key, and then the of. So for of question. Now, what if we wanted to access not only the key, but also the value? In this case, we would once again have to use destructuring. And so this is yet another case of destructuring. So instead of simply using the questions variable, like here, like I did here, we use question.entries. So just like this. And what this does here is to return all entries of our questions map. And we can then use destructuring to store the key and values in 2 separate values, such as we did before. So remember, destructuring is using these brackets. And so we simply say key and value. So once more, using the entries method here on the question is going to return all the key value pairs. And we can then use destructuring, such as we did before with arrays, and store the keys and the values in 2 separate variables that we can then use here inside of this for of loop. And actually this also works for arrays. So if you're curious about that, you can simply go try that out, and I'm sure that you're going to make it work. So let's now do the exact same thing here just to see if it works as well. So I'm just going to comment this one out so that it doesn't get in our way. So if I reload this now, we actually get an error, and that's because there's one parenthesis here too much. Okay, but now here we go. So everything works as expected as it did before. So let's now, instead of printing all of the elements in our map, let's use this to only print or for answers here, okay? And the way that we do this is to say that we only want to print the value if the key is a number. So that's the beauty of having this custom data type here for the key. So remember, in maps, the key cannot only be strings, but also like numbers or booleans like down here. And so we can use that to our advantage right now. So we can say that if the type of the key is number, and that's actually that we didn't do before. So you're still learning a couple of new stuff here in this section, which is great, right? So we can use this built-in JavaScript function to check the type of a variable. And so in this case, we only want to execute this part of the code here if the key is a number. And what we want to do in this case is to simply console.log the answer, okay? So answer, then number key, and then of course the value. And that's it. Okay, and to make our question here look a bit better, we just want to get rid of this and of this output here, right? So let's take this out and this one as well. This was just for testing purposes before. So now we have our question and our 4 answer possibilities. What we need to do next is to actually get our answer. And we did that before in one of the coding challenges, and I'm going to do it again right now using the prompt function, which simply opens a pop-up window and asks for an answer. And I'm going to declare it as a constant and call it ans for answer, and then say prompt write the correct answer. So here the user can write 1, 2, 3, or 4. Now the problem with this is that JavaScript is then interpret this as a string, so as text. And so we need to also convert this to a number. And so we use another built-in JavaScript function, which is called parseInt. So this is going to be converted to an integer. Okay, and so now the answer will be a number. So as long as the user enters one of the numbers, of course. If the user inputs text, then JavaScript will not be able to convert it to a number, but we're just going to suppose that the user inputs a number here. Okay, and what do we want to do next? We want to display this string here, so correct answer, if the answer is true, or this string here, so wrong, please try again, if the answer is false. So how can we do that? We could of course go ahead and write an if-else statement like we would have to do if we were storing this data in an object, but we're not. And so we can use, once again, to our advantage, the fact that we stored these 2 strings here with the keys of true and false, so as booleans. So all we need to do is to retrieve this string if the answer is correct, and retrieve this string if the answer is incorrect. So the first thing is to compare the answer with the true answer, right? So we say question.get answer. And so if the input is the same as the correct answer, then this expression here will be true, right? And if it's incorrect, then of course it's false. And now you can see once again the beauty of using true false as the keys. Because now all we have to do is to say question.get and then use this here as the key. Because this will either read true or false. And so if it's true, it's going to retrieve the string for true, and if it's false, it's going to retrieve the string for false. So this is very useful and very handy, so we don't have to write an if-else statement here. We can simply do it like this. Okay, so let's now console.log this so that we can actually see it as our output. Okay, so let's load this and input the correct answer. Let's say 4. And so wrong, please try again. So yeah, it's working. Now if I say tree, which is the correct answer, then we still get wrong here. Okay, so something is not working. Let's see. Oh yeah, and that's because we called it correct here, but then answer down here. So of course, it needs to be correct so that we read the correct value. So let's try it again with number 4. So it says wrong, please try again. And now with number 3, which is the correct answer, and now it says correct answer. So yeah, this is really working. So maybe this part here was a bit tricky and a little bit hard to get used to, but I hope that you really understood it. And if not, then just pause the video and take a look at it again. So now you probably wonder why maps are actually better than objects to create hash maps, right? And there are a couple of reasons. So let's summarize what we learned in this lecture. So the first reason why they're better is because we can use anything as keys, which opens a lot of possibilities, as we just saw with this example. And second, because maps are iterable and making it very easy to loop through them and to manipulate data with them. And reason number 3 is because it's really easy to get the size of a map using the size property, and that can also be very handy. And finally, because we can easily add and remove data from a map. So all of these are strong arguments in choosing maps over objects if we want to build hash maps. Alright, so I hope that all of this makes perfect sense to you and that you start using maps if you choose to get started with ES6. Okay, so see you soon. Let's now talk about one of the biggest additions to ES6, and that is classes. Now, classes actually don't add anything new to the language. They're just synthetic sugar over the way we do prototypal inheritance in JavaScript. And that means that classes simply make it easier to implement inheritance and to create objects based on blueprints. So in ES5, these blueprints are called function constructors, right? And we added methods to their prototype properties in order to make all the instances created through a function constructor inherit these methods. So let's start by doing that now, and then write the same code with ES6 classes after that. So ES5, and I'm going to create a person function constructor. So the one that we already know very well. So person5, because of ES5, is a function which accepts the name, a year of birth, and also a job. Okay, and I'm writing it as a function expression here, okay, but I could also equally have written it as a function declaration, so it works the exact same way. So all of this is nothing new. Okay, so this dot year of birth is year of birth, of course, and finally the job is a job that we input. All right. And now to make all the instances inherit a calculate age method, it's as easy as adding it to the prototype property of the function constructor, right? So all of this is nothing new, but so here we can practice it a little bit more, okay? So the age is, and let's actually create a new date here so that we are always up to date with the year. So get full year minus the year of birth. And let's then simply log this to the console. So very simple stuff. And just to test it, John 5 is a new person called John, born in 1990, and let's say that he's a teacher. Okay, so this is the way that we used to do it in ES5. Let's now do the exact same thing, but using ES6 classes, so that you can see the big difference. And so we use the class keyword, and then we simply say the name of the class, which is similar to the name of the function constructor that we used before. So this should be called person, and I'm going to call it person6 here. And that's it. So it looks a bit like a function declaration, right? But this is actually a class declaration. And the way that a class declaration works is that all classes have to have the constructor method. Okay, so we have to write constructor. And this is where we define the initial properties that we want in our object. So again, it's going to be, of course, name, year of birth, and the job. And then this looks like just a regular function. And what we then do here is the exact same thing as we did before. So we have to say this name is equal to the name that we pass in, this.year of birth should be year of birth, which is the one that we pass in here, and of course the same with the job. Okay, so again, this part here, the constructor part, which every class declaration has to have, is very similar to this part here of the function constructor. Now, if you want to add a method to this, we simply do it also here in the class. So all we have to do now is to say calculate age, and that's it. Now we can add our code in here. So there's no function keyword here, no prototype like we had to do here. No, all we do here is to simply add this new method right to our class. And note that we don't have any separating punctuation here. Okay, so no commas or no semicolons like in objects, for example. In here, in the class definition, we don't need anything like that. Okay, so I'm just going to copy the code from the calculate age method there to here, because everything is going to work the same. And that's it. So this class here is now effectively the exact same thing as this, but it's nicely structured here into this entire class, and it looks a bit better and is also easier to write. And so that's why we say that it's synthetic sugar. And let's now create an instance of this class, and I'm going to make it a constant. So John6 is a new person 6 called John, also born in 1990, and he is also a teacher. And what I want to do now is to actually show you in the console that these two things are the exact same thing. So let's take a look at them here in the console. So John 5 and John 6. And let me open them. And here we see that they actually look the exact same, right? So all of these are the same. The prototype is still the object. And in here, we inherit the calculate age method that we defined up here. Okay. And then in here in the prototype, we also have the calculate age method, which is of course this one here. So writing it like this is under the hood of JavaScript, behind the scenes, converted to the exact same thing as we wrote in the old way. So again, this is just synthetic sugar, which makes it easier to write classes than it was before. And actually, there are some people criticizing classes because they basically hide the object-oriented nature of inheritance in JavaScript. And so some beginners who don't learn about that, they may never really understand how inheritance works behind the scenes in JavaScript. But you do understand it, right? And so you're 100% ready to start using ES6 classes. Now, another thing that we can do with classes is to add static methods. And static methods are methods that are simply attached to the class, but not inherited by the class instances. So by objects that we create through that class. So I actually think that this isn't really helpful, but I still wanted to show it to you. So let's say that we want to add a static class here, simply called greeting. And all we do is to log something to a console. Let's say, hey there. So we can use this like as helper functions. So in order to use this, we cannot use it on John because it's a static method, and as I said, these instances are not going to inherit it. And so all we can do is to call it like this. So person5 dot greeting. So it's basically a method that is attached to this class definition. And this class definition is under the hood, behind the scenes, a function definition. And so it's also an object, as you already know. And so we know that we can attach methods to an object. And so that's simply what we're doing here. So if we now reload this, we get this error here, and that's simply because I misspelled it. But now, of course, it works with our hey there string logged to the console. So again, that part I think is not really useful, but we can still use it if we want. Alright, so that's it for the fundamentals of ES6 classes. Just two more things that I need to say here. And first, class definitions are not hoisted. So unlike function constructors, we need to first implement a class, and only later in our code we can start using it. So this is a very important thing to keep in mind. And second, we can only add methods to classes, but not properties. But that's not a problem at all, because inheriting properties to the object instances is not a best practice anyway. And so that's why this rule is now really enforced here in classes. Okay, so in the next lecture, we will see how to implement inheritance from one class to another. And that's a very cool topic, so don't wait and move right to the next lecture. Now that we are ready to use ES6 classes, let's take it one step further and implement inheritance between classes using subclasses. So, do you remember this slide from when we first talked about inheritance? We had this example where we had two function constructors, or ES6 classes, which is like the same thing, that can inherit from one another. So we have here the more generic class person for all persons, and then we have the more specific subclass for an athlete, because an athlete is also a person, but with some more specific attributes and also methods. And so it makes a lot of sense that we make the athlete class inherit from the person class, right? Now, we have actually never implemented this in our code up until this point. All we did was to make objects inherit methods from their prototype. But this inheritance between classes is really taking it even one step further. And so that's something really cool and sometimes really useful too. So, such as before, let me first show you how to do it in ES5, and then we move on to classes and subclasses with ES6. First of all, let's get back the code that we wrote before for ES5, so that we don't have to write it all over again. So this person5 function constructor, or let's call it class, will be our superclass. So let's now create the subclass, which will be the athlete class. And this is how we do it. So athlete and 5 again as a function, and in this function we actually have to pass in these exact same parameters here as well. So let's just copy them. Okay, so if you want an athlete, we need to say their name, their year of birth, their job, and we also want to define to how many Olympic Games they went. So let's call it Olympic Games. And also how many medals they have won. So medals. Okay, and now in this subclass, the first thing that we have to do is to call our superclass, which is person5, right? So let's do that. Person5, and we actually now have to use the call method. And I'm going to explain you why in a second, okay? So let's first write the code, and then I'm going to explain it to you. So this will be set to this, and then we pass in the 3 arguments that we have. So name, year of birth, and the job. And we can only pass the 3 arguments into here because we received them in this function call here as well, right? And that's why we have to have them here and also in here. Okay? And now it works like just it worked before. So we say Olympic Games is equal to Olympic Games, of course, and this dot medals is medals. So why do we have to call the superclass function constructor with this as the this keyword? And I'll give you a second to pause the video and think about that. To explain this, we need to remember how the new operator works, which is the operator that we use to create a new instance. So when creating a new athlete object, new creates a new empty object, calls the athlete function constructor, and sets the this keyword to the newly created empty objects. So you remember that part, right? So in the execution context that we're in here, the this keyword will point to the new empty object. Now, if we want a person property's name, year, and job to be set on a new athlete object, then we need to call the person function constructor with the this keyword also set to our newly created athlete object, right? And that's exactly what we do here. So after this, all the properties will be set in a new athlete object that's created by the new operator. And that's why we need to call it here and to set the this variable to this. Alright, and now to create the correct prototype chain, we're going to use object.create. Because remember, object.create allows us to manually set the prototype of an object. And we want the prototype of the athlete to be the prototype of the person, so that they become connected. So let's quickly do that and say athlete5.prototype object.create person5.prototype. And that's it. So now the two function constructors are connected and the prototype chain should work just fine. So let's actually take a look at that in the console. And so I'm going to create a new athlete here. And I'll say John athlete 5. So it's a new athlete called John. So remember, we have to set all of these properties that we would set on a person also on the athlete. So John, born in 1990. And now let's say that he's a swimmer, that he went to 3 Olympic Games where he won 10 medals. So quite a great athlete. And let's now reload this and take a look at John the athlete. Okay, so here we go. So we see all of our properties are defined here in the athlete, and we also see that our prototype is the person 5. And that means that the athlete 5 function constructor's prototype property is the same that person 5's prototype property. And so in here we have the prototype of person 5, and then of course we have to calculate age function here. And what this means is that the prototype chain works exactly in the way that I showed you in the section where we talked about all of this. So let's now test this. So I'm going to write John athlete dot calculate age. And if I now reload this, then we actually get this error here. All right. So something must be wrong here in this method. Okay. So let's take a look. New date. Okay, and here it is. So this of course is a method. So get full year is a method. And that's why it wasn't working probably. So let's try it again. And alright. So 26 is the age. And that once again worked because not only all the instances of person can now inherit this method, but also all of the instances of the athlete class can inherit this method. Because as we did here in this line, the athlete 5 class inherits from the person 5 class. So again, person 5 is the superclass and athlete 5 is the subclass. And of course we can also set methods on the prototype property of the athlete5 function constructor. So let's do that. Dot prototype dot won a medal. So this is a method that's very specific only to the athletes, and so all the instances are going to inherit this method if they are athlete instances, of course. And the person instances, they will not inherit this method because it's only in the athlete5 prototype property. So this method will very simply increase the medals of the athlete plus plus, so increase by 1, and then log it to the console. And so now we can also use this one here. Won a medal. So let's try that out. And we got an error saying that one medal is not a function, and that's because it actually has to be after we connect these two function constructors with this line of code here. So we first set the athlete5 prototype property, and then we can add methods to that very prototype property. Okay, and so now it's going to work, and we see that he has 11 medals now. So we started with 10 and now we have 11. So let's now just take a final look at the object in the console. And so now we'll also find the one medal here in its prototype property, which is exactly what we did here. And then of course also the calculate age function here further down in the prototype chain. Great, so now you learned how to connect to function constructors in ES5. So let's now do the same thing in ES6. And so once again, first I'm going to get back this class. Okay, so this is for ES6, and this here is our person. Let's just get rid of this method that we don't want, and let's focus on what we need. So we have our super class here, and now comes the fun part where we create a subclass of the person. And this is actually way easier to do in ES6 with the ES6 classes than with the function constructors like I showed you before. So all we have to do is to say once again class, and this one is called athlete6, and then we just use the extends keyword. So we say that this class extends the person class. Okay, and so always in the subclass we need to say that it extends the superclass. And then we of course once again need our constructor. And remember, all classes need to have this very method. And then in the same fashion as we had to do before with function constructors, we have to repeat the person properties here if we also want them on our athlete. So name, year of birth, job, and now remember what we want to add here is Olympic Games and medals. Now what we did before was to then use in the subclass this call method to call the superclass with the this variable set to this. Now here in classes we have to do something similar, but it's also easier because all we have to do is say super, and this will then call the superclass. And we don't have to manually set any this variable or anything. Everything happens automatically behind the scenes and we don't have to take care of any of that. So of course we call the superclass using name, year of birth, and job. And that makes sense, right? Because these are the exact same parameters that we have in the constructor of that class. And now we just say this dot Olympic Games is equal to Olympic Games, and the medals are medals. And that's it. So let's also add our method here. And so it's the same code as we had before. So this .metals will be incremented by 1 unit. And then let's just log it to the console. So let's use this class and create yet another John athlete. So John, born in 1990, he's a swimmer, went to 3 Olympic Games where he won 10 medals. And just to check that everything works the same, we're going to call the same methods that we called before. So John athlete 6 dot won a medal and John athlete 6 dot calculate age. So let's check it out. And we have a bug. Super keyword is not expected here. So here it's not expected. So it's actually because this is misspelled. So constructor. Okay, so now it should work. And yeah, here we go. It now says that the age is not a number, but that happened because we also had this bug here that we had before. So if we fix this, then it's going to work here as well. So it gives us the same age and the same medals, so everything works the same. But if you take a close look at it, then you have to agree that it's way easier to write it this way here. So these 2 class definitions, than to write all of this here up. Just everything like this. And we have to add this line of code here. And it all looks a bit strange. So I clearly prefer to do it the ES6 way with the class definitions. All we need to make sure is that we really understand what happens behind the scenes and what prototypal inheritance is and how it works and why doing these classes like this works the way that it does. And just to show you once again that these classes are just synthetic sugar, let me show you these athletes here as well in the console. So to prove you again that they look the exact same way. So this is the functioning prototype chain in the way we did it before with athlete 5 and person 5, and then what we did right now. And so we see, if we make this bigger, that it's the exact same thing. So this prototype chain here is the exact same as this prototype chain. Alright, and so with these 2 final lectures about classes, you now truly understand everything that there is to know about prototypal inheritance in classes in both ES5 and also ES6, which is really great. Hey there! It's now time for the final coding challenge in this course, so that you can apply some of the new ES6 features that you just learned in this section. So in this challenge, what I want you to do is to imagine that you're working in a small town administration and that you're in charge of 2 town elements, parks and streets. And this is a very small town, so we currently only have 3 parks and 4 streets, but more parks or streets may be added in the future. Also, all of the parks and streets have to have a name and a build here. Now, at an end of the year meeting, your boss wants a final report with the following data. First, he wants to know the tree density of each park in the town, and that's calculated by dividing the total number of trees by the park area. Second, the average age of each town's park, and that one is calculated by adding up all of the ages and dividing it by the number of parks. The third data that your boss wants to know is the name of the park that has more than 1,000 trees. So your boss knows that there's one park like this, but he wants to know the name of that park. Okay, and as of the streets, we want to know the total and average length of the town streets and also a size classification of each of the streets. And they should be classified into tiny, small, normal, big, and huge. And if the size is unknown, then the default is simply normal. And all this report data should be printed to the console, so that it looks a little bit like this output that I have here. So we have the average age of our parks, and then in here we also have the tree density of our 3 parks, and finally the park that has more than 1,000 trees. And for the streets, we have the total and the average length, and then the size classification for all of the 4 streets. And that's it. Now in this challenge, I'm not going to give you detailed steps on how to solve it like I did before, because I think that you're really ready to do it on your own at this point. And that being said, the goal of this challenge is of course that you use some of the ES6 concepts that we talked about just in this section. Things like classes, subclasses, template strings, default parameters, maps, arrow functions, and destructuring, for example. And of course, you don't need to build anything super fancy here, because all I want with this challenge is for you to practice some of the new ES6 features here in this challenge. So good luck with this one, and if you struggle with anything, then you can just watch the next video to see my personal solution to this challenge. But first, please try to do it on your own. Alright, I hope that you actually completed the coding challenge on your own and really started to use all these new features. So let's see how I did it. So we are in charge of 2 town elements, and these are parks and streets. And they both have in common that they have a name and also a build year. And so what I'm going to do here is to create a class, which is going to be a superclass that contains the name and the build year. And then for each of the park and street, I'm going to have a subclass. And each of these subclasses will hold their specific attributes or properties and also their specific methods. So let's implement that. So class element, and the constructor is the name and the build year. So the name and the build year. And that's actually it. So this is our element superclass. We could also, of course, add some methods in here that all of the park and street elements could then inherit, but I guess that we're not gonna need that for this small exercise. Okay, so let's now create the park class. And remember, since it's a subclass of the element, we need to use the extends keyword. So extends, and the superclass that we extend is called element. Alright, so we need the constructor. And as I explained in the last lecture, we need to repeat the property names that we have in our super constructor, which is called element in this case. So again, name and build year. And then what we also have is the area and the number of trees. So we saw in the exercise that we want to calculate the tree density and that it's calculated by dividing the total number of trees by the area. And so of course, we need to have both of these properties in our object. So the first thing that we do in a constructor of a subclass is to call the superclass. Okay? So name here and build here. So all of this is nothing new for you at this point. So area is of course the area that we pass in, and the same for number of trees. Okay, and so let's now add a method for calculating the tree density of an object. So tree density So as I mentioned in the previous video, this is calculated by dividing the number of trees by the area of the park. And so of course it should be the number of trees divided by the area. And that's it. And since we're building something very simple here, we're just going to console.log the result of this calculation, since that is the final output that we want. So instead of returning it, such as we would do in a real app, we're just going to log it to the console. So let's now use a template string here. And I hope that you did this one as well, because this is one of the easier measures to implement. So what I'm going to do is to say the name of the park has a tree density of, and then our density value, trees per square, and I'm going to use the square kilometer unit. And so in here, the unit that we'll have to put in here will always be a square kilometer. So I'm just putting it at a comment here so that we later know that that's the unit that we're going to use here. So this is not specific to JavaScript. It's just, we could also use square miles or something else, but I'm going to go with square kilometers. And that's why I'm putting it here in the text. So this should be it for the park. Now let's add another subclass for the streets. So class street. And of course, this one is also going to extend the previous element class. And I'm sure that you know what comes now, which is the constructor, right? So of course, once again, the name, the build year, and now we need two other properties here, which is the length, so the length of the street, and the size. Because remember, in our final report, we need to say the average and total length of all the streets together, and also a classification of the size of each street. And the classification is tiny, small, normal, big, or huge. And so here, as the size parameter, I'm going to pass in a number for each of these, and then write a method later on that will then classify the street based on this number. And remember that in our text, it said that the default should be normal. And so we're going to have a default here, but I will leave that one for later. And I'll put it here when we write our method to classify the street. So it will be just in a second. So let's just finish this one and then we write that method. So again, we first need to call our superclass with the name and the build year. And then we need to set our own properties. So the length will be the length and the size. All right, so let's now write that method that I was talking about called classify street. And I'm going to use one number for each of these classifications. So tiny is going to be 1, small is going to be 2, normal is going to be 3, big is going to be 4, and huge, it's going to be 5. So what does this sound like to you? To me, it sounds a lot like we're doing a hash map here, right? And so we're going to make use of the new ES6 feature, which is the map. So let's create a new variable, and I will call it classification. And I'll create a new empty map here. So classification.set, and I'm going to say the number 1 is for tiny. Two is for small. And let me just duplicate these a couple of times. So 1, 2, 3, 4, and 5. And this one is going to be normal, big, and huge. And so when we put in a size here then as an argument, we can use that argument to simply read our classification out of this map here. Because we can make use here of the fact that we can use something different than a string for our keys. So it's different from the objects that we used to use before for this kind of thing. Now just remember that part where I said that we want to be normal to be the default. And so we can make use of default parameters here in ES6 and simply set this one to 3. So now if we create a new street and don't specify this argument, so we can just specify name, build year, and length, then the size will automatically be 3. And then the street will be classified as normal. All right, and so now we can just log it to the console. once again using a template string here, and say that the name, so the name of the street in this case, and we can also use the year now in this case, so we can say the street which was built in. So just to give some more information to the console and also to use the variables that we have available, is a... Okay, and now how do we get the data out of our map? Remember that? Right, we use the get method. So we simply say classification.get, and then we need our number, which is the size. And so of course we can get that by saying this.size. And that's it. So the name of the street built in a year is a normal, for example, street. And that's it. Now with this method, we can classify our street. So we now have all our classes, or our data model, let's say so, defined. So now it's time to create some data. So to create some objects. And we're going to start with the parks. So I will create an array which will contain all of our 3 parks, because remember, we have 3 parks and 4 streets. So I will say all parks so new park, the first one, let's call it the green park. It was built in 1987, has 0.2 square kilometers of area, and has 215 trees. Okay, so that's the first one. Now let's make a new park. This one is going to be called the National Park. So this one is going to be a bit better or bigger. So this one is old, 1894. It has 2.9 square kilometers and let's say 3,541 trees. So really a huge one. And now the third one. Let's call this one the Oak Park. Built in 1953. 0.4 and 949 trees. Okay, so now we have our parks. Let's now create the streets. So the first one, and I call it the Ocean Avenue. Built in 1999, 1.1 kilometers length and a size of 4. So this will then be classified using our classify method, right? So next one, and this one is the Evergreen Street. Built in 2008, 2.7 kilometers, and a smaller street. So I'm just putting kind of putting random data here for a very small town. You could of course put data for your own town or whatever. And maybe you noticed that in here, in this line before, I didn't specify this last parameter here, right? So this is the size one. So just to see what happens when I don't put anything in. So just to show that this default parameter here is going to work. Okay, and just the last one. Let's call this one the Sunset Boulevard, which is a beautiful name, I think. 1982, 2.5. And this, with this beautiful name, it has to be a huge street. So number 5 here. All right, so let's now start generating a report. And what I'm going to do is to write one function for each report and then pass in our array, which contains our data. So for the parks, I'm going to pass in this one, and for the streets, of course, this one. So function report park, and I'm simply going to call it P here. And I will also already define the other function here so that we then just have to fill it. So report parks and report streets. And this one is called S. And I will also just call them. So report parks with all parks and report streets with all streets. So again, in this exercise, I don't want to write any fancy code like we did in our big app project, but instead I'm really focusing here on using some of the ES6 features, okay? So just very simple functions and very simple data structures. So let's start with the parks report. First one I'm going to print is simply say parks report to make it well visible here in the console. So what do we want here? Let's take a look at our exercise. We want the tree density of each park, right? Then we want the average age of the town's park. This actually doesn't make much sense. So it's average age of the entire parks. And then we also want the name of the park that has more than 1,000 trees. So these three things are about parks. So let's put it here. We want the density. We want the average age. And which park have more than 1,000 trees. So the first one is really simple. So for each of our park objects, we want to call the, the tree density method, right? So we have 3 parks in our array, and for each of them, we want to call that method. So it makes sense that we loop through them, right? And for that, we're simply going to use the for each method. And in our callback function, we only want the current element. So this one is for the current element. And then on that element, we can call the tree density method. And that's it. So again, we loop through all of our parks, and for each one, we simply call the tree density method, which is then going to print to the console the density. So let's try that out. And we have some kind of bug here in line 658. So we already wrote a lot of code here. So 658, and here it is. And yeah, so I forgot these parentheses here. So such like regular functions, of course, all of the code has to have these parentheses. So let's try it again. And another small mistake, line 641. And yeah, so here I see the problem. I have num trees here, and here I misspelled it. Okay, and let's hope. Yeah, so now it works. Great. So the green park has a tree density of 1,075 trees per square kilometer. This one has about 1,200, and this one has about 2,300 trees per square kilometer. All right, so that part is already working. So let's now talk about the average age thing. And what I'm going to do here is to create an external function which is going to calculate the average and the total for any array that we input into that function. And so this way we can then reuse it down here in our report streets function to calculate the total and average length of all the streets. Okay, so let me do that out here. And I'm simply going to calculate it calc, because that's what we do. We calculate stuff based on an array that we receive. So we want the total and the average. Now there's an extremely handy method that I didn't show you before, and it's called the reduce method. And the reduce method is used to basically reduce an array to a single value. And it's actually an ES5 method, so it's nothing new with ES6. It's just one of the ES5 methods, similar to for each or map, because all of these loop through arrays. Now the difference is that this one loops through an array to accumulate all the values into a single value. So this is perfect for adding up all of the elements in an array. So let me show you how this one works. So let's say we want a variable called sum. And so we use the reduce method on our input array, of course. And now in here, as with all our other methods like for each and map, we can use a callback function. Now what's different about this one is that we not only have access to the current value and the current index, but also to the previous value. So let me write that out actually. So previous, the current, and the index. Okay, and we're not going to use all of these, but I just want to write it out here so that you have this kind of as a reference. And then what we need to return is, in the case that we want to sum everything, the previous plus the current. And that's actually it for the callback function. Now another argument for the reduce method is the initial value of the accumulator. So the number at which we want to start. So in this case it's going to be 0 because we want to start with our sum at exactly 0. If we wanted to add everything to 100, let's say, then we could put 100 in here. But that's of course not what we want. So imagine that we had an array with 3, 5, and 6 like this, okay? Just as an example. So the previous value would then be 0 in the beginning because that's the initial value that we defined here. And then here in our callback function, our previous plus the current would be 0 plus 3, okay? Then in the next iteration, the previous value would be 0 plus 3, which is 3. And so what we had here would be 3 plus 5, so 8. Then in the next iteration, it would be the previous, which is 8, plus 6, which is 14. And so the final result would be 14. And we had then reduced all of the elements in the array to a single value, which is 14. Now, of course, we can use different things in here. For example, we could multiply them, or we could divide or subtract, or even other things. But now, all we want to do is to simply add all of these elements together. And this reduce method is perfect for that. And so let's now return that sum and also the average. Now we can use the concept of this structuring that I showed you in one of these lectures, in which we simply return an array of 2 elements, and we can then use the structuring to save these elements into 2 different variables when we call this function. So return, of course, the sum, and then the average, and we can calculate it right here because it's very simple. The average is simply the sum of all the elements of an array divided by the length of this array, right? So sum divided by array dot length. So that's it. This is actually all that we have to do in this function. So let's now use it down here. And as I was saying, we can now use the structuring. So const total age and average age. Now, what do we pass into this calc function? We want an array of all the ages of all the parks, right? So let's maybe first calculate this. So we want to calculate the ages. So const ages. So what we're going to do is to loop through all of the elements of our park array and calculate the age for each of them. And we could actually write a different function for that, but I'm not going to do that right now. But of course you could totally do that, okay? So if you want, feel free to do that. So I'm going to use the map method to loop through all the arrays. Then I want the current element, and then the age is very simply 2016, so the current year, minus, of course, the build year. Okay. And let's actually replace this with a new date, get full year, so that this is always up to date. And so like this, we will have here an array with all of the ages for all of the parks. So we saved both of the variables here, so one with the age and one with the average, using once again the concept of destructuring. But all we need here is actually the average. But that's no problem, we can just ignore the total. And so I'm going to print to the console that, or let's put here the number of our parks. So it's p.length, obviously. Have an average of avg age years. Okay, and that should be it. Let me check it out. Okay, so date get full year is not a constructor. So this is what I was missing here, these parentheses. And now current is not defined. So 681, of course it's cur here. And I'm sure that you saw it coming, but I didn't. But now it works. Okay, so our 3 parks have an average of 71 years. All right, and now finally, let's take care of this last part here, which is to determine which park has more than 1,000 trees. So to me, it makes a lot of sense to use the very new ES6 method called findIndex, which, remember, we use on an array to get the index of the element of the array which satisfies or a callback function. So let's first get all of the numbers of trees into an array and then use the findIndex method on that. So what we're going to determine here is an index. So I. And so let's first get all of the number of trees, and these are of course stored in our P array. So we loop through P and then store all of the tree numbers into a new array. So from the current element, we want to read the number of trees property. All right, so this one returns us an array. And since this one is an array, we could now immediately put the next method here, so we could chain these methods. So in order to write less lines of code, let's do that. Now what we want here is to find the index of the element that is larger than 1,000, right? So it's simply this. Element greater or equal to 1,000 trees. And that's it. And we didn't use the find method here. Remember that we have the find and the findIndex method here, which are both new. But we didn't want to use the find because we're not interested in the number of trees, but in the index, so that we can now select the correct park and retrieve its name. So that's what we're going to do now. Console.log. And we can simply say that we want P number I, and then its name has more than 1,000 trees. So, does that make sense to you? Let's check it out. And that's right, the national park has more than 1,000 trees. And let's see it, and it's actually true. So this one only has 215, this one has 3,541, and this has 949. So this is the correct answer, and so it works. So all that's left to do now is to do the report for our trees. So let's copy this one here, and not trees, of course, it's streets. All right, so what do we want here? Let's go check our text here, and we want the total and average length of the town streets. Let's actually copy this one, and then classify the sizes. And classify the sizes, which should be very easy. Now we already have our function which does this, right? So now all we have to do is to reuse it. And again, using the structuring, we can write total length and average length. So we use a calc function, and now let's actually directly get all of our length, and we're doing it the same way that we did before. So s.map, then the element, and then simply retrieve the length of each of them. So this builds us our array with all the length that we can then pass into the calc function. Okay, let's now log it to the console. Once again, we're using a template string and say, or the number of streets here, such as I did before, streets have a total length of obviously kilometers with an average of average length kilometers. So let's check it out. And here we go. Our 4 streets have a total length of 7.1 with an average of 7.775. And ignore these values here. This is a weird bug that JavaScript sometimes has. So of course it should be simply 7.1, but the JavaScript engine sometimes gets a bit confused and it adds all of these 0, 0, 0 and then some random value here. So not to worry about this, the correct result is 7.1. So you can simply ignore these strange number here, and the same thing of course in here. And now all there's left to do is to classify our streets. And so that's very easy as well. We just need to loop through all of them and call our classify street method. Okay. And so here we go. Ocean Avenue 1999 is a big street, a small, a normal, and a huge. So remember here in the third one, which is called the 4th street, I did not pass in any argument, but it still was classified as a normal street. And that's because, as I showed you, the default parameter here is set to 3, which then maps to normal. All right, and that's actually it. So our report now has all of the things that our bosses asked us to include in the report, right? So with this, we conclude our coding challenge, in which we used not all, but at least some of the new ES6 features. What you can do now to practice ES6 even more is to, for example, convert code that we wrote before to ES6 code. So for example, you can redo the older challenges, but this time write it in ES6. Or you could even, if you really feel like it, convert our budget app project to ES6. So that should be a lot of work, but if you feel like it, then it's of course one of the tasks that you can do. Alright, so have fun with that and see you in the next lecture. In this lecture, we will take a look at a very simple example of asynchronous JavaScript. So this is a completely new concept that we've never touched in the course up until this point. And so I'm very excited to show you what asynchronous JavaScript is all about. Now before we actually start, you're maybe noticing that I'm using a different code editor here. And that's because this part of the course was recorded shortly after the rest of the course. And so now I switched to a new editor called VS Code. And if you're interested in that one, you can simply go download it here from this website. But of course, you can also simply follow along using the code editor that you already have. So let's close this one here. And I already opened the file for this section here and also the browser here on the right side. Now what's also different here is that before I used to have an external JavaScript file called script.js, but right now I choose to simply write the code here in a script tag right into the HTML. I find it easier to just do everything in one file instead of having multiple files here. Okay, so let's just write some code here right into this script tag. And we're gonna start with just some old school synchronous JavaScript code, just the way we've been doing up until this point. Okay, so let's write a function called first. And you're noticing here probably already that I'm using the new ES6 syntax, right? So I'm using the const keyword here to declare a function expression using then here the arrow syntax, right? So that's the new stuff that we learned in the last section where we talked about ES 2015 or ES6. And so from now on, I'm going to start using this new syntax here in this section and also in the next one. Okay, so let's just log something to the console here. Hey there. And then we're gonna call this function here as well. Give it a save, reload it here, and then open up our console. And so now we know that everything's working here, right? So our hey there text is actually being printed. Let's now add a new function. This one, just call it second. And in this one, for now, I'm going to log some other text, and I'm going to log second. Then in the first function, we call the second one. So just second. And then a new console.log down here, simply saying the end. Okay, and this will make more sense to you in a second when we start adding something different here into the second function. For now, we simply have hey there here as a result, which comes from here. Then the second function is called, which logs second, as you see here, and then finally the end. Okay, so all of this is synchronous JavaScript, just the way we've been doing up until this point. And with synchronous, I mean that all the instructions are executed one after the other, line by line, just in the order that they appear in the code. And so that's exactly what we have here. But now let's actually add some asynchronous code here. And in order to do that, we are going to use the setTimeout function, which is basically to set a timer in JavaScript. And that will then allow us to write code that should be executed later. Okay, and so that is asynchronous JavaScript. So let's get rid of this one here. And now I can call the setTimeout function. So setTimeout function is a function that we can pass a callback and also the time. So first is the callback. And again, I'm going to use the arrow syntax. So no arguments here. And then the content of the function in here. And then the second argument we pass into the setTimeout function is for how long we want the timer to run in milliseconds. Okay, so I'm going to put here 2000 milliseconds, which means 2 seconds. And after these 2 seconds have passed, then this callback function that we passed in here will run. Okay? And this callback function here will be very simple. All I want to do is to actually log something to the console. Let's say async. Hey there. And let's get rid here of this side panel. Okay, so let's review what we have here. First off, we call the console log. Then we call the second function, and then in the second function, we call this timer here, which after 2 seconds will then run this function here. Okay, and then after that, we run this console.log, which will log the end to the console. So what do you think the result of this code will be? Can you guess that? So let's take a look. And no, you saw that appearing here after 2 seconds. So first we had hey there, then the end, and only after 2 seconds then appeared the async hey there. Let's try that again. Let's wait for it. And here we go. Now maybe you expected that first only the hey there appeared, then we call the second function, then this timer is run, and then after 2 seconds it would then print the async hey there, and only after that it would print the end. Maybe that was what you expected, but that's simply not how JavaScript works with asynchronous code. Okay, and I'm not going to go into a deep explanation here at this point, because that's what I'm going to do in the next lecture. So in the next lecture, you will learn exactly how asynchronous JavaScript works behind the scenes with the event loop and the web APIs and some other parts of the JavaScript engine. For now, I just want you to notice that all of this code here run, and that basically the timer run in the background, and then after it finishes, only then it printed here the text to the console, but that didn't stop this code here from running even before the timer had finished. Okay, so this was just a very simple example to show you what asynchronous JavaScript is, and in the next lecture you will then, as I mentioned before, learn all you need to know in order to deeply understand how asynchronous JavaScript works behind the scenes. In order to escape the so-called callback hell that I showed you in the last lecture, let's now learn about promises, which is an ES6 feature designed specifically to deal with asynchronous JavaScript. Now, before we start, what is a promise actually? Well, it's a complex topic and it's easier to understand in practice, but in simple terms, a promise is an object that keeps track about whether a certain event has happened already or not. And if it did happen, then the promise determines what happens next. And with events here, I mean an asynchronous event, like a timer finishing or data coming back from an AJAX call, okay? So a promise kind of implements the concept of a future value that we're expecting. It's like us saying, hey, get me some data from the server in the background. And the promise then promises us to get that data so we can handle it in the future. Okay? Does that make sense? Now, since we're dealing with time-sensitive code now, a promise can have different states. So before the event has happened, the promise is pending. Then, after the event has happened, the promise is called settled or resolved, which is the same thing, okay? Now, when the promise was actually successful, which means that the result is available, then the promise is fulfilled. But if there was an error, then the promise is rejected. Simple as that. And this is actually important to know because we will then be able to handle these two different situations in our code. Now, in more practical terms, we can produce and consume promises. So when we produce a promise, we create a new promise and send a result using that promise. Then when we consume it, we can use callback functions for fulfillment and for rejection of our promise. So let's now produce promises in order to recreate the example that we built in the last lecture and then consume those promises. And again, let's start by cleaning up here our code from the last lecture by simply commenting it out. So with promises, just like every other object type, we use the new keyword. So we say new promise, and then into that promise, we pass in a function called the executor, which is a function that will be immediately called once the promise is created. Okay, so let's just add that here as well, without actually for now adding any code. So again, an arrow function here. And so that's our promise. And of course, let's also assign this promise here to a variable. So const get IDs, okay? And that's because we're recreating the example that we had up here, okay? And so basically this first promise here will be responsible for doing that first part here with the first timer. So basically where we get these four IDs here from the server with this fake AJAX call here, okay? But now getting back to our promise here and this callback function that we pass into the promise, remember that this one here is called the executor function. And this function here itself actually takes in two arguments, which are the callback functions resolve and reject. So resolve and reject. And that's because this executor function here is used to inform the promise whether the event it is handling was successful or not. And if it was successful, we're going to call the resolve function, and if not, we call the reject function. So remember that we had these two states here, resolve if the promise was successful and reject if the promise was not successful. So if you don't have any result. And in that case, we can call the reject function. And I'm going to show you how we use these functions here inside our promise in a second. But for now, let's put some asynchronous task here in the executor function, because that is usually what happens in a promise. So something like an AJAX call, or in this case, a setTimeout function. So again, to fake the AJAX call, so basically the call to a server to get some data, okay? So again, we're going to use setTimeout. With a callback function after 1 second, okay? Or after 1.5 seconds, that gives us a bit more time to see the result. Now, when this timer finishes here after 1.5 seconds, we want to return the data with some of the fake IDs, just like we did before. And so now it's actually time to call that resolve function. And remember that we call resolve in case that the event was successful. So calling the resolve function here will basically mark the promise as fulfilled. So as successful, right? And that is exactly what we want here. Okay, so let's call the resolve function here. Resolve. Now that function actually takes an argument here, which is for the result of the promise. And so this is basically how we return our result from the promise if it was successful. And what do we want to return here? That's right, that's just this array of these IDs. So let me just copy it from up here and put it down here. All right. So again, what we do here is that after this timer finishes after 1.5 seconds, we say that the promise is successful and that we want to return this data here. And that's why we used the resolve function. And since set timeout is impossible to fail, so this timer will always finish, there's no way it is not going to finish, and so we don't need to call the reject function in this case. But we would need it in some other cases, like when we are dealing with data coming back from a server, where there can happen all kinds of errors. But in this case, we don't need to call the reject function ever. All we do here is to call the resolve function, which marks the promise as fulfilled and returns this data here. All right, and so we produced our very first, very simple promise here, which is stored now in this getIDs variable. Okay, and so now it is actually time that we consume these promises. And in order to do that, we can use two methods on all of the promise objects. And these methods are the then and the catch methods. Okay, so all of the promise objects here inherit these two methods. And so we can now go ahead and use them. So getIDs dot then. And this then method allows us to add an event handler for the case that the promise is fulfilled. So which means that there is a result. So now all we have to do here is to pass in a callback function, which will handle what we do in case the promise was successful, which will actually always be the case here in this promise, right? So as I mentioned before, this cannot fail, and so it will always be successful, and so we can always call the then method on our promise. So let's add a callback function here, and this callback here actually can take an argument. And I'm going to explain to you in a second how this works. Okay, so I'm simply calling this one here IDs, and then an arrow function again, and then just like this. So here's the function body. Now this argument here that we pass into our callback function, which is this entire thing here, right? So this argument here will be the result of the successful promise. So in this case, it will be this entire array. Okay, and so let's now log this one to the console. So console.log IDs. And that's actually it already. So let's check it out and wait for it here. And here we go. So after 1.5 seconds again, it then printed these 4 IDs in this array here to our console. So let's recap what happened here. So we created this promise here with this executor function in it. Then inside that function, we usually have some asynchronous code, which is in this case here our set timeout, which after 1.5 seconds returns this data here in case it is successful. And that's why we use the resolve function. And the set timeout function will always be successful. And so all we need to do is to simply always use the resolve function here and then pass in the data that we want to return from the successful promise. So from the fulfilled promise. And we can then handle that successful, so that fulfilled state down here with the then methods that is available on all our promise objects. All right. So we have our promise object, and then on it, we use the then methods, which is used to handle the fulfilled promise. And into this then method, we pass in a callback function, which will always have as an argument the result of the successful promise. And that's why if we use console log of the IDs, we will basically console log this array here. Okay, does that make sense? Now, as I mentioned, we also have access to another method, which is the catch method, which allows us to add a handler for the case that the promise gets rejected, so that an error happened. So let's try that one as well. And so I'm going to chain these here in different lines. So just like this. And finally, a catch. And here we usually call the argument of the callback function the error and then we can log this error to the console. Okay, so again, right now it's impossible that this catch here is actually called because this promise here is impossible to fail. So we never called this reject callback function in here. But just to try it, let me actually use reject here instead of resolve, just so you see what happens here. And so you see the result is actually the same because we still return this data here, but this time as an error basically. So let's say we didn't have this catch here, and so now it shouldn't have any result. Okay, and so now we actually get this error here. Okay, but right now, since we're actually catching this error here, and we can also instead say something else here, just say error. And then let's try it out again. And so now it says we have an error. And again, we have an error because by using this reject function here, we basically mark this promise as rejected. And so therefore JavaScript assumes that there was an error. And so this part here is the method that gets called. Okay? But now let's put it back, of course, to resolve, because our promise is always successful. Okay, so now we translated this first part here of our previous example, and now let's write the two promises to handle the part where we get a recipe based on an ID, and then where we get another recipe based on the same publisher like we did here in this part. Okay, so let's now add these two promises, and then we can put it all together down here when we consume our promises. Okay, so let's remember how this worked up here. So we passed in an ID into the callback function of this timer, which came from the recipe IDs that we got from the first step. And so let's do something similar here. Okay, and so what we're going to do is to actually create a function which receives this ID and which will then return a promise. So let's say const get recipe, which will be a function that receives the recipe ID, and with this function body here. So again, an arrow function expression here with the new ES6 syntax. Then in here, we can return our new promise. So we return and we say new promise, just like we did up here, right? And now we need to do our executor function. And this part here is always the same. We always say resolve reject, and then pass in the function body. Okay, and now what happens inside of this promise is actually pretty similar to what we have in here. So let's just get it from this part. Okay, but instead here, of course, of the console log, we will resolve this value that we have here. Okay, so just like in our other promise, we actually want to resolve the value. And actually I'm seeing that this is not quite correct because we're still missing our set timeout here, of course. So let's add that very quickly. So set timeout. Then in here we want to pass in an ID. And then this code, of course. Then 1500 seconds. And then we pass in rec ID. So does that make sense? So into this get recipe function, we pass in rec ID, so the recipe ID, which we then pass into this set timeout. And so then it will become ID. And then inside the callback function, we use ID here. So this needs to be ID in uppercase. Okay, now how do we actually consume this promise here? So let me show it to you. So what we could do here, of course, is to simply call the get recipe function here and then add a then to it. So just like this, like get recipe with IDs 2, just like we did before, and then this would return a promise, right? And then we could add the then, and so on and so forth. But this would not really solve the problem of the callback kill, right? Because then again, we would have this callback here, this then inside of another then. And that's not ideal at all. And so there's another way of doing this. And that's actually the beauty of promises, which is something called chaining. So we can return a promise from this then method here, and then simply add the next then method after it. So let me show that to you so that it makes more sense. So I do it like this. Return get recipe IDs 2, and then I can add the next then after this. This get recipe here will return a promise. Okay, so after this here runs, we will have a promise here, and what we do then is to return that promise, and therefore we can then add the next then to handle the result of that resolved promise. Okay, so we now have this promise here and now want to handle the fulfillment of this new promise. Okay, and what will happen when this promise is fulfilled is that it will basically return this data here. okay? And that is our recipe. So let's call this parameter of this callback function here the recipe. And then simply log it to the console. And let's try it out here. So the IDs, and then finally the recipe. So it's working just fine without any of the callback hell that we had up here, right? So now our code is all nicely separated here into these different functions. And then down here we consume these promises. We could of course put this one here into a function as well, but that's not really necessary because we don't need to pass any data into this. So here is get recipe, we did it as a function because we needed to pass in this recipe ID into this promise here. Okay, and so that's the second one. And now finally let's work on the last one. So let's add another function here called getRelated. And remember that this one here is basically to fetch a recipe which is related to the author of the first recipe. And so of course this needs to happen in a sequence because we can only load a related recipe if we already know the publisher that we're looking for. And so we need to do this in these 3 steps just like we did before. So again, return a new promise. Then resolve and reject. And again, this is always like the same here. And oh, I forgot to put the parentheses here for the arrow function. And then again here, the set timeout. Let's just say pub here. After 1.5 seconds, so 1500 milliseconds, and then the publisher. So just the same logic as before. So this publisher is the one that we get here as an input to this function, which will then be passed into the callback function of the set timeout and will then be called pub. Okay, and now I'm just going to copy the code that we have up here again and simply paste it here. And again, we don't want to log it to the console, but we want to resolve this promise and return this recipe here. So recipe, and let's call it recipe here as well. And let's actually also use this pub argument. I think up there we didn't actually use it, but let's do that down here. So let's use a template literal here again. And say pub. And then show the recipe here. So the Italian pizza. Okay, and so that should get the job done. And so now, in order to consume this promise, I'm going to do it in the exact same way as before. So we receive our recipe here. And now I will return the result of calling getRelated. So getRelated. And what we passed in here then is the recipe.publisher, right? So recipe.publisher, because that's in this case here, Jonas, right? So we get Jonas from our recipe and then pass it into the getRelated function. And so all of this here will return a new promise. And so just like before, we can then use the then method on it. And again, we receive a recipe, and so I can call it recipe again, because it's a different function than this one here, and so I can simply reuse this name. And so now let's again log this recipe to the console. Give it a save, and let's try it out. So after 1.5 seconds this one, then the first recipe, and then the related recipe. And now we get an error here saying undefined and then this weird object. And I think I know why this is happening. And that's because our recipe here actually returns a string. Okay, so you see here that we actually resolve this entire string here and not just the recipe object. And so therefore we can then not read a recipe.publisher. Okay, and so instead I'm simply going to add Jonas here Okay, so in this case, it doesn't really matter. And so that solves this first part here. Then after that, I have object, and that's because here I put this entire object here into a string, but instead I just want recipe.title, just like we have here in this line of code as well. Okay, and if I do this now, then it should work. And now, finally, yeah. So Jonas, Italian pizza. I could of course pass something else here, just like my entire name. And so 1.5 and 1.5, and finally another 1.5 later, we get this entire result. Okay, so that's how we do the same thing that we did before with the callback hell with promises. So instead of having this really messy and unmanageable code, which is actually a lot less code here, but it still is really unmanageable, especially if we had more code and deeper nested callbacks, then it would become really like a nightmare to maintain. And instead, we have very nicely separated code here like this, where we produced all of our promises, and then in the end, we simply consumed them here with this chain of thens, and finally then a catch to catch if there's any error. And that's it about promises. Pooh, this was a lot to take in. And I find promises to be one of the hardest, if not the hardest concept to grasp in JavaScript. And so please don't worry if you didn't really understand it 100% on this point, okay? Because what really matters is actually how we consume promises and not so much how we produce. Because that is oftentimes already included in some kind of libraries that we're going to use later in the course. So we learned how to construct and how to consume promises. But the syntax to consume promises can still be quite confusing and difficult to manage. And so in ES8 or ES 2017, something called async await was introduced to the JavaScript language in order to make it a lot easier for us developers to consume promises. So let's now take a look at async await. So again, async await was designed for us to consume promises and not to produce them. So if we want to produce promises, we just do it the way that we learned in the last lecture. But most of the time, we're going to consume promises anyway, and async await makes that a lot easier to do. So without further ado, let's see how to use it in practice. And what we're going to do is basically to change the way we consume them in the last lecture, so this piece of code, and instead use async await. So these promises that we have here, these three, we will continue using them. We will simply get rid of this code here for now and do the same thing with async await. Okay? And so we start by creating an async function. So use the async keyword, then function, and let's say get recipes, and then I'm going to call it AW for async await. Okay? And then we can also just call it down here. All right. So this is a new special kind of function, which simply means that this function is an asynchronous function. So one that basically keeps running in the background just the way that we've learned before. This async function then returns a promise, but more on that a bit later. For now, what's important is that inside an async function, we can have one or more await expressions. So in order to consume our first promise, we can do it like this. We simply say const IDs await get IDs. So this get IDs here is our first promise, right? So get IDs is this promise here. And then to consume it, we simply say await IDs and assign the result to this IDs variable. And what happens here is that this await expression here will really stop the code from executing at this point until the promise is fulfilled. So in this case, this get IDs promise. And if the promise is resolved, which remember means that it was successful, then the value of the await expression is the resolved value of the promise, which is then assigned to this IDs variable. Okay, so again, in this case, our promise will resolve to this value here, so this array, and so this IDs here will then become the value of that resolved value, so that array that I just showed you. Okay, and to demonstrate this to you, Let me then just simply log this to the console. So IDs. Run it, and let's see it. And here we go. So after 1.5 seconds, we log the resolved value of the getIDs promise. Okay, and so again, what happens here is that we fire off the function. So we start the function, and it then keeps running asynchronously in the background. And then here we wait for this promise here to resolve, assign the value to this IDs variable, and then simply log it to the console. Now, if the promise is rejected, then an error will be thrown. And if you want to handle that error, we have to include some more code here, but that's not really important for now at this point. And so I'm leaving that for the next lecture. Okay, so let's now consume our other two promises. So this one I'm going to call a recipe, and we will await the result of our next promise. And that one we get simply by calling get recipe, just like this here, right? So we have our get recipe function, right? Which is this one here, which will then return a promise. And so we await that that promise finishes. And after it finishes, we can then log the recipe to the console. And now the next one, let's simply call it a related and await the next one. So we can actually use, again, this code here. And that's it. So let's check it out here. And this should work the exact same way as before. And yeah, here we go. So here we have our result, just like we had when we consumed the promise in this way here. Okay, and I think that this way here is really a lot easier. So all we do is to simply await until each of these promises here gets resolved. And in each of these lines where we use the await keyword, the execution stops and we wait until a promise returns. So that's how async await works. It allows us to consume promises, but without all the callbacks that we have with the callback hell, and to some degree also in promises with the then and the catch methods. Now I just want to make it very clear again that the await expression can only be used inside an async function, okay? And this async function, remember, it runs in the background. And that's very important because we can never have the main code stopping. And so all we do here is to block the code in the async function, which runs in the background anyway, okay? And so again, stopping the function here is not a problem because it just runs in the background anyway, okay? So in here, in this line of code, we synchronously call this getRecipes function, which then does all this stuff here just in the background, okay? Now, this is all really great already. Now, just imagine that we actually wanted to return a value here from this async function. So let's try something which is not going to work, but I'm going to show you anyway. So let's say that we want to return the recipe. So we can assign then this return value here to this result, right? And then we can log it to the console. Now this is not really going to work, right? So let me show it to you. So all this logs here is this promise, and it says pending here. And so that's not really the result that we were looking for. We were hoping that it would log to the console the result of the recipe. So basically this here, right? And so why didn't this work? Well, it doesn't work because this function here runs asynchronously in the background. And so by the time that we try to run this console.log here, this getRecipe function is still running in the background. And so all that is logged is this promise here, which simply says, well, this rec here, it is a promise, but we don't have any result yet, and so we cannot log anything to the console, right? Because remember that this code here is, of course, run synchronously, right? And so it runs this here, then it puts it off to the background, and then immediately it will run this next line. But by the time we run it, this getRecipes function here will still be doing its job and will then log this data here long after this line here has already run. Okay? So how could we actually solve this problem? Well, remember how I told you a bit earlier that an async function always automatically returns a promise. And so if we return a value from the async function using the return keyword, so just like I did here, then the promise will automatically be resolved with this returned value. Okay? Now this may sound a bit confusing, but it's very straightforward. So let me just show it to you. So this one here doesn't really work, but what we can do here is to then simply use the then method, just like we did before. Because again, this function here automatically returns a promise with the resolved value of recipe. And so we can now use this then, into which we pass a callback function where the argument is the resolved value of the promise. So let's just say a recipe here, or result, it doesn't really matter, let's just call it result. Okay, why not? And then we can simply console.log this result to the console. And we can maybe add some more text so that it's different from this one here. So let's use the backticks here. Then we of course need these curly braces. Is the best ever. So something like this. And so now let's test it again. And wait for it. And here we go. So fresh tomato pasta is the best ever. And so now it works just the way we wanted it to work, right? And so what we did here is to use then, which is basically to consume this promise, just like I showed you before up here, right? Which is possible simply because of the fact that this async function here always returns a promise that we can then consume. Okay, and we will actually need to use this trick here later in the big project that we're going to code. And so it's important that you familiarize yourself with this piece of code and that you really understand and that it makes sense to you at this point. Okay, so I hope you saw that async await makes it so much easier to work with promises. And that's just because of the fact that it looks like the normal synchronous code that we're already used to. It just works in an asynchronous way behind the scenes. Okay, so again, this really looks like synchronous JavaScript code that we've been written all the time. We just need to understand that behind the scenes, because of this async and await, this is asynchronous code. But as long as we understand how and why all of this works, we can now use this fantastic new tool to our advantage. So we've been throwing around words like AJAX and API throughout this section, but before we move on, let's just take a second to understand what these terms actually mean. So AJAX stands for Asynchronous JavaScript and XML, and basically it allows us to asynchronously communicate with remote servers. So let's say we have our JavaScript app running in the browser, which is called the client, and we want the app to get some data from our server, but of course without having to reload the entire page. Well, with AJAX, we can do a simple get HTTP request to our server, which will then send back a response containing the data that we requested. And this all happens asynchronously in the background, just the way we learned before. Also, of course, this not only works for getting data from the server, but also to send data to the server by doing a post request rather than a get request. Now, in practice, there are many ways in which we can do AJAX in JavaScript. And we're going to look at the Fetch Web API in the next lecture, which will allow us to make some AJAX calls in a very easy way. Alright, and since we were talking about servers, we also have to talk about APIs. So, API stands for Application Programming Interface, and on a very high level, it's basically a piece of software that can be used by another piece of software in order to basically allow applications to talk to each other. And that's not just valid for web development in JavaScript, but for programming in general, okay? But now in reference to web development and AJAX and servers, well, the API is not the server itself, but it's like a part of the server, like an application that receives requests and sends back responses. So let's distinguish between two types of APIs that you can use in JavaScript, which are your own APIs or external third-party APIs. So let's imagine for a second that you're building a traveling app, and you have a database with different destinations and tours that you're offering. So on your server, you could build your own API that can receive requests from your front-end app in JavaScript and send back the results. So that would be your own API hosted on your own server. But now you also need some current weather information for each destination, which you don't have in your database, and so you can use a third-party API to get that weather data. Okay, that makes sense, right? And there are actually all kinds of third-party APIs out there, like to include Google Maps into your app, or to embed YouTube videos, to get data about movies, or even to send emails or text messages from within your app. There are really endless possibilities, and that's why APIs are getting so popular in web development. Okay? So these are the very fundamentals about AJAX and APIs, but it's all you need to know in order to get started. So let's move on now and use some AJAX in practice. Alright, now before we do anything else in this section, let's take a look at the project that we're gonna build to get you really excited, okay? And so here it is. This is the project that we're gonna build throughout this section. And it's a small app called Forkify, and it is a very simple recipe searching app. So in here it says search over 1 million recipes, and these recipes, they actually come from a real API that I selected for this project. And so of course we're gonna do all that cool stuff like the asynchronous JavaScript and AJAX and APIs, all of that we talked in the last section. So to try it, let's search for something like pizza, because you know, everyone loves pizza, right? And so now it's fetching this data here from a real world API, again, as I mentioned. And so we have then 30 search results, and we have this pagination here. So we hit page 2, 1, 3, and then we can scroll through these different results. And of course we can select one of these recipes, and again it then loads it from the external API, and as soon as it loads the recipe it stops that spinner and then displays the recipe. Okay, so we have an image, then we have here the ingredients, and we can also adjust the number of servings. So we can hit these buttons and you see that the amount of ingredients then automatically adjusts. So we can move up and down, and let's say we want this one to be for 6 people. We can then also add these ingredients to a shopping list like this, which then appears here on the right side. So cool, right? We can then also adjust these numbers here like this, or we can of course delete some ingredients if we already have them at home, right? What's more? Well, down here is a button where we can then click, which takes us to the website where the instructions for the recipe actually are. Okay. And then finally, another cool feature is that we can save these recipes in our favorites. So we hit this like button here, and then you see up here we now have this list of our liked recipes. So let's now try another one. Let's open this one here, let's say. And we can now also add these to the list, for example. And you see that then we have the 3 down here now as well. And we can of course also like it. And so now you see that we have 2 here. And let's try it with another one. Let's add this one as well. And so now we have these 3 here in the list. And the coolest part is that this actually works even after reloading the page. Or let's say that we open this again. So let's copy the URL, open it to a new tab, close the old one, and you see that the likes, they are still here. And so this is by using something called local storage, which is a cool JavaScript API that we're going to learn a bit later. And so, yeah, I think that's the main parts, the main features of this app. And I really hope that you love it. Because once again, I tried to make it a real beautiful and real world app so that you're really proud after coding this app after all these lectures. So that is the app, and I already opened the starter code that I hope that you downloaded already. So I opened it here in VS Code by hitting here this open command. Okay, and so we simply have 2 folders in the starter file. It's the source folder and the distribution folder. And in the source folder is where, of course, the source code will go. So our JavaScript code and the index.html file. So our markup here. And then in the distribution folder here is where the final files go, ready to be deployed and ready to be served to the client. So of course we're going to go a bit deeper into all of this a bit later, but for now just know that the final CSS file is here as well as the image, and our compiled JavaScript file will also be here. But again, a bit more on that later. You can also see the CSS file here, And if you're interested in the styling of the app, then of course you can dive deep into this file and see all the CSS code that I wrote just for this app. And you see that I actually used some pretty advanced and modern CSS techniques like CSS grid here and a lot of flexbox as well. So this is really a cutting edge CSS as well. So if you're interested in that, then please take a look. It's for free, also included in this project. Okay, and so that's it for this video. Next up, we're going to talk a bit about modern JavaScript and the development setup that we're going to use to build this beautiful and real-world app. Now that we know what this project is all about, let's take a look at modern JavaScript. So the way we write JavaScript has changed tremendously during the last couple of years. Today, we compile ES6 and even newer JavaScript versions down to ES5. We use module bundlers, task runners, external packages, and other dev tools. So up until this point of the course, we have always coded JavaScript in the kind of old school way, okay? But that's about to change with this project, where we're finally going to use JavaScript the modern, more real-world way. Now, modern JavaScript is not so much about the language itself, but it's more about the whole JavaScript ecosystem and environment that we use to write it in, okay? And this one is important to understand. So we still write the exact same JavaScript, but we use it together with a set of tools that make it easier and better to work with. And the foundation of all these tools is the Node.js and NPM ecosystem, where we can find all kinds of third-party open source tools and libraries and frameworks needed for modern web development. And with libraries and frameworks, I mean stuff like React or Angular, or libraries like Lodash or even jQuery. Then we also have development tools, like for task automations, automatic browser reloading, or to compile JavaScript down to ES5. Now, in order to use and share these packages, we need some kind of tool to install and to manage them. And that's where the Node Package Manager, or NPM, comes in. So NPM is just a simple command line interface that allows us to do exactly that. Plus, NPM also allows us to write scripts to use our development tools, but more on that a bit later. Alright, so the first tool that we use in modern JavaScript is Babel, in order to convert cutting-edge JavaScript like ES6, ES7, or even ES8, which together are simply called ES Next, back to ES5. So that all browsers are capable of understanding our code. In a couple of years, this might no longer be necessary, but for now, this is an important step in our development process. Next up, we want to use ES6 modules in order to make our code more modular and therefore easier to maintain by separating different parts of our app into different files. And ES6 brought us exactly that possibility by implementing modules. Now, the problem with these modules is that right now, browsers do not really support this functionality yet, and so we have to bundle these modules together into a single file using something called a module bundler. And the most popular one out there is called Webpack, and so that's the one that we're going to use in this project. Now, Webpack can actually do so much more than just bundling modules, like code splitting, loading many types of assets like Sass or images, decreasing our JavaScript bundle size using an algorithm called tree shaking, and much, much more. But in this project, we're not going to do any of that. We just want to use Webpack to bundle all our modules together. And there are other, way more simple ways to do only this, but I wanted to show you Webpack because, once again, it's really the most popular choice out there. So Babel and Webpack are the main tools that we're going to use, and as I mentioned, these are NPM packages. And the easiest way to run these packages is by using something called NPM scripts, which allows us to run all these tools automatically and very easily in our command line interface. Alright, and that's actually all we need in order to build our modern JavaScript setup. So now that we know all about it, let's set up our development workflow over the next couple of lectures with NPM packages, Webpack, and Babel. Now, before we can use the exciting tools that I showed you in the last lecture, we need to learn a bit about the command line. Yeah, you heard that right. These tools only work in the command line. And so now comes that time where you finally have to learn about it, at least the basics, like moving around in the file system, creating files and folders, copying files, and stuff like that. And I know that many people are afraid of the command line for some reason. And I was afraid myself some years ago, I admit it. But now I love the command line, and I really can't live without it, really. And so can't any serious web developer, It's just part of the job, okay? Now, if you already know this stuff, then please feel free to move on to the next lecture, as you're probably not going to learn anything new here. But for the rest of us, let's get to it. Now, the command line works a bit differently whether you're on Windows, Mac, or Linux. So on a Mac, it is called the terminal, and so let's open it up by opening up the terminal app. Make it a bit bigger so you can actually see me typing, and that should be okay. Now on Windows, the command line is called command prompt, and you can open it up by right-clicking on the start button, and from there choose the command prompt, okay? Now the commands are also a bit different on Windows and on Unix, which is Linux and Mac, okay? So here I'm going to type the ones for Linux and Mac, okay? But I'm going to tell you the ones for Windows as we go, so that if you're on Windows, you can follow this video as well. So that being said, the main concept of the command line is that we're always in a folder. And right now I'm here in the home folder, and I can see the contents of this folder by writing ls. And on Windows, it's called dir, which stands for directory, so like this. But on the Mac and Linux, for that matter, it is called ls, which is for list. So in my home directory, I have these 8 folders here. And now I can actually move into these folders. So in the command line, I can use commands to move up and down in my folder structure, okay? So I'm on a desktop now, and so let's say we want to get into the desktop because that's where the project folder is. So you see, here on my desktop is where I have this folder for the project that we're going to work on in this section. And so now, here in the command line, I can also move into that folder. And in order to do that, I have to use cd. So change directory. And this one is actually the same on Windows. So I write cd, and then I write desktop. Hit return, and now I'm in the desktop folder. And you actually can see it here. So it's changed here from this home folder, which is what this here means, to the desktop folder, which is now the current folder, or the current working directory. Okay? So I can do ls again, or dir on Windows, remember? And now I see the contents of the folder. Now to move into this one here, again I use cd, and then I can write the name of the folder. Now if I start writing it like this, then I can also hit the tab, and it will then automatically complete the rest of the path for me, because if I started writing 9f, then there's really no other path here that it could be. And so automatically the command line knows that this is what I'm trying to write. Now if you have some folder names that are similar in the beginning, then you have to write the name of the folder until it is different from all the others. And only then you can hit the tab button in order to autocomplete. So now I'm in the Forkify folder here. Let's use ls again. And so you see the dist and source folder that I showed you before. Now if we actually wanted to move up, we can also do that. And again we use cd, and then we use ... Okay, so ... always means the folder above. We are in the Forkify folder now, and if I execute this command, then we're back in the desktop. Okay, but let's actually move back into it. And if we don't want to repeat the same commands that we wrote before, we can use the up and down arrow keys on our keyboard in order to run through the commands that we wrote before. So just like this. So here you see all of the commands that I wrote before. So this is the one that we want to move back into the Forkify folder, right? ls, just to make sure that we have the right folder names here. Now this is now getting a bit cluttered here, and so we can actually clear this up by writing simply clear. At least here in the Mac command line. On Windows you have to write cls. So cls like this. Okay, so I write clear, and then I am back to having this clear command line. Okay, let's now actually make a new folder here in this Forkify folder. So I'm writing mkdir, which stands for make directory. And again, this one is the same on Windows. So let me call this one here test. And so now we should see that we have 3 folders. So dist, source, and test. And we can confirm this by opening up the folder here in the Explorer. And here it is. So here is the folder that we just created in the command line. Now moving into that folder, so cd test, we can now create a new file in here also using the command line. So on Mac and Linux, the command is called touch, and then the name of the file that we want to create. So let's say I want to create test.js. Now on Windows, it is a bit different. Okay, so let me tell you how it's on Windows. On Windows, you have to write copy null and then the file name. Let's say also test.js. And this is actually only with one L. So this is not a mistake. It's not two L's, not like this. It's actually just like this. Okay, so it sounds a bit weird maybe, but this is how it works. Okay, so that's on Windows. Of course, I'm not going to execute it here, so I'm just going to get rid of it. But right now, here, if I'm in this test folder and do ls, I'm going to see this newly created file in here. Let's create another one, touch jonas.js. And indeed, now both of them are here. And again, I can confirm this here, of course, in the Explorer. So Jonas and test.js. Nice. So what can we do now next? Well, let's copy jonas.js into the main folder. Okay, so how can we do that? Well, it's actually very easy. We just need to use the cp command, and on Windows, it's simply called copy. So just like this. Okay, so cp, the name of the file, jonas.js, and then the directory. And I want to copy it into the parent folder. And remember how we write the parent folder? Well, just these two dots, right? So let's execute it, move up into the Forkify folder, and then let's check it out. And indeed, we have dist, source, and test folders, and then the jonas.js file that I just copied here. So again, I'm going to confirm it, and here it is. And of course, it's still here. Because we didn't move it, we did copy it. Okay, and since we're talking about moving, let's then go back into this folder and move the other file out of the test folder into the home folder. Okay, so cd into test. And now to move, we use the mv command on the Mac, and on Windows, just move. Okay, so mv, the test file, and actually this also works with files. So I can simply hit the tab key and then it auto-completes the file name here as well. So mv test.js to the parent folder, so dot dot again, and here we go. Now if I do ls here now, we should only have the jonas.js file left, right? And indeed, here we go. And if we go up, well, you already know that it worked, I'm sure. And indeed, now test and jonas.js are both here. So that's how we create folders and files and copy and move them. Now, as a final step, let's also learn how to delete these files. Okay, so from here, I'm going to delete jonas.js and test.js. So in order to do that, I'm going to use the rm command. So rm jonas.js, and again, autocomplete, and then I can hit return. But be careful here, because this remove command will actually remove it permanently. So it will not move it to the trash, but instead it will delete it immediately from your hard drive and it's gone forever. So be really careful with this command, okay? And on Windows, this one is actually called del, so delete. So rm, and I hit return, and now it should be gone. Let's confirm it. And indeed it is gone. And actually I could have done both of them at the same time. So jonas.js and test.js here in the same command, but let's now simply do it separately with the test.js right now. And so finally they are both gone. Okay, now let's clear this command line again, move into the folder, and then remove this file here as well. So this file here. Or actually we can do better. We can simply delete this entire folder containing the file. And this way I can also show you how to delete folders. So let's actually go back. Let's take a look here. And so we want to get rid of this test folder. So on a Mac, you simply do rm again for remove, but then you have to use like an option or a flag, which is the R, which stands for recursively. And this means that it will one by one delete all the files in the folder and then the folder as well. So rm minus R, which stands for the flag R, and then test. Okay, let's check it out. And now it's gone. Now in Windows, this works a bit differently, and it worked like this. So it's rm dir, then /s, and then the name of the directory. So it would be something like this. Okay, not going to do that, of course. So now we're back to the original state of our folder. Just one more thing that I want to show you is how to open files directly here from the command line. So let's move into the source folder, cd source, and in here should be the index.html file. Yeah, and so let's now actually open it And it's as simple as using the open command. And on Windows, you use start instead of open. Okay, so simply start just like this. So index, then tab to autocomplete, and now it should open in the default program, which in this case is Google Chrome. So let's try it. And here we go. So that's the index.html file here. It's unstyled because it's not connected with the CSS. But yeah, so it actually opened up the file that we asked for. And yeah, so I think that's the really basics that I had to show you here with the terminal. So again, this is really important stuff to learn because all the tools that we're going to use next run directly from the command line. And so you really need to have some basics, of course. And so I hope this lecture gave you these basics. And so let's now move on together right to the next one. Hey there! Let's now set up our development workflow, which will include npm scripts, Webpack, and Babel by installing Node.js and npm on our computer. So in order to install Node.js, just head over to nodejs.org, and then down here you should have the buttons for downloading Node.js. And make sure to install the first one, which says recommend for most users. And maybe you're on another version, maybe it's not 8.10, which is the most current version by the time of recording this video, but anything above 8.10 should be fine. So I'm not going to download and install it right now, because of course I already have it installed, but please go ahead and do that now. Then after everything installed correctly and you're ready, open up your terminal so that we can confirm if Node.js actually installed correctly. And in order to do that, simply write node and then -v. And this will check the version that you have installed of Node. And so in this case, I'm on 8.9.4. And if you see the version number of Node that you just installed, then it means that you were successful. So everything's working fine. Now, if you get an error here, then it means that Node is not correctly installed and you should probably go back and try it again or something. Also, we can check out if npm was also installed, because npm, the Node package manager, automatically comes with Node. And so by typing npm also -v, so flag for version, then you should also get your version number, which in this case is 5.6.0, but if you get anything above that, it should work just fine. Okay, and with Node now installed, let's go ahead and create a package.json file for our project. And I'm going to explain a bit later what exactly that is. For now, let's just move into our project folder and create that package.json file in there. So here in the terminal, remember we use cd to move to the folders. And I'm on desktop, and then I'm on 9 Forkify. Let's check it out. And here we are with the dist and source folders, just as we saw in the last lecture. Now to create our package.json file, which is basically a file which contains informations about a project for npm, we just type npm init, and then it will start asking us some questions down here. So we can say the package name, and I will just call it Forkify. You see that here in parentheses, that's the default name that is automatically taken if we don't write anything here. Then the version in 1.0.0 is okay. Description, I can say something like Forkify project. The entry point, doesn't really matter at this point, test command, git, keywords, author. You can put your own name here, license. And now we have the final result here. And we just hit return again. And so this will be our package.json file. And if we hit ls again now, we see that we already have this file in here now. So let's now head over to our text editor. And indeed, you see that it is already here. So package.json. So you see the name that we gave it, the description, and the author. Then we also have something called scripts, and we're going to talk about that a bit later. And again, I'm going to explain a bit better what this package.json file is all about. But for now, let's go ahead and install Webpack using npm. So I'm going back here to my npm. And so in order to install packages, rewrite npm install Webpack, and then we also have to say save dev. Save dev. And what this save dev option here means is that it will save Webpack as a development dependency of our project. So you will see this in our package.json file in a second after Webpack has installed. And so that's it. let's now go back to our package.json file, and indeed, here it is. So we saved Webpack as a dev dependency by using the save dev option, right? And now in our package.json file, it created this dev dependencies field, to which it added the Webpack package on the current version 4.2.0, okay? So remember in the intro lecture about modern JavaScript that I mentioned that we basically have two types of Node.js packages. Ones are libraries and frameworks and stuff like that, and others are development tools. So libraries like React or jQuery, for example, they are really dependencies because we use this code in our project, in our app. But something like Webpack, this is really just a development tool. And so it's here in the dev dependencies field. Now imagine that we wanted to use something like jQuery here. Then we can also go ahead and install it. So let's say npm install jQuery, but this time we only say save, okay? And so this will not save it as a dev dependency, but as a dependency. So let's go ahead and check that one out. And indeed, here it is. So dev dependencies is Webpack right now, and dependencies is jQuery, okay? And so this file here now has all of these informations listing all of the packages, so all of the dependencies that we use in our project. And that's very important because if you want to move this project to another computer or work with another person on the same project, then everyone's on the same page, so everyone knows which dependency we're using in our app. It's also important because it allows us to install all of these dependencies here automatically if we don't have this node modules folder. Okay, so this folder here is where all the packages go. So let's take a look at it. And you see that these are all the packages right now in our node modules folder. And they are here because these are actually the dependencies of these dependencies. So for example, Webpack or jQuery, they themselves have lots of dependencies. And so we need to install all of these here automatically in order for Webpack and jQuery to work. Okay. Now, if we went to share our entire project here with someone else, we wouldn't have to share this huge folder here, which has these thousands and thousands of files. We really wouldn't need to share. All we need to share is this package.json file, which has this information about our dependencies. And the other person could then go ahead and automatically install these dependencies. And so let me actually show how we could do that. So let's actually go ahead and remove this folder. Okay, and so now all our dependencies are actually gone. So we have no more dependencies, but we have our package.json file, which lists the dependencies that we have, so Webpack and jQuery. So if we now go ahead and simply type npm install, then it will go ahead, grab our dependencies from the package.json file and install all of them. So let's go back, and here it is again. So here is the folder again with all the packages back in there. Now, one last thing is that we also can uninstall packages. So right now we don't really need jQuery here. So let's go ahead and delete it, so to uninstall it. And all we have to do is to say npm uninstall jQuery and again save. And so let's wait for it. And if we go back, now you see that this object here is empty. So no more dependencies. We have only this Webpack dependency right now. Okay, so that's installing and uninstalling. Now, before we leave, actually there's still one more thing that I want to mention, which is that these packages that we installed here with the save dev and save options, they are locally installed. So they are installed only for this project, but we can also install packages globally. Okay, so basically in order to make them accessible from everywhere on our computer. Right now, this Webpack dependency only works inside of this project. But if we wanted to install it globally and make it accessible from everywhere, we could also do that. So let me show you how. And actually, we're going to do that with another package, so not Webpack, but instead let's use something called Live Server, which is another package that I really like, which allows us to create a very simple and local web server to serve some static websites. So again, npm install, name of the package, and then instead of save or save dev, we can simply say global. And now let me show it to you. And yeah, so we got this error here, which is basically because we don't have permissions to do this. So on Mac and Linux, you have to prefix this command here with sudo in order to give permission to do this. On Windows, maybe this is not necessary, but usually here on the Mac, this is what happens when you install global packages. So let's try it again. I will put in my password and now it should install globally. Okay, and so remember that this was installed globally, and so I should be able to run this command now from everywhere. So let's move out of this folder actually. And so now I'm back on the desktop, so on a completely different folder, and I can now run this command just like any other command in here in the command line. So live server, and now this is not going to work actually, but let me show what happens. And actually it did work. So it opened here a local web server here on this port, showing me the folders that are in the current directory. Okay, so let's go back to the terminal, and here you see, so serving users, and then here the URL. Now to exit this program here, let's hit Ctrl+C, and so in order to move out of this program. Okay, so this was just to show you that there are locally installed packages with safe and safe dev, and then we can also use globally installed packages, like we did here with this live server example. Okay, now let's move back into our project folder, clear this console, and yeah, so I think that's all that I had to show you in this video. So we installed Node.js, then we used the npm package manager in order to install dependencies, and remember there are dev dependencies, which are only tools that we use for development, and then they are like real dependency, so code that is actually used in our app. So imagine we're building a React app, then of course we need to use the React API, and so that's going to be a real dependency, okay? Then besides these two locally installed packages, we have the global packages, which we install using the global flag here in the command line, which can, instead of global, you can also write, so instead of writing this, you can also simply use the .g flag, okay, which is a lot easier. So that's it. In the next lecture, we're then going to go ahead and configure Webpack. In this lecture, you will learn how to create a basic Webpack configuration. So Webpack is the most commonly used asset bundler. So it doesn't actually not only bundle JavaScript files or modules, but it bundles all kinds of assets like JavaScript, CSS, and images, okay? So we see here, like on this left side, all of these dependencies, all of these files, like depending on one each other. And Webpack then bundles these together into just one JavaScript file, one CSS file, and then these images here, okay? Now in our case, we're not interested in CSS or the images, we just want to bundle all of our JavaScript files into one big bundle, okay? So I'm gonna use Webpack 4 here, which by the time of recording is the most current version available, okay? And this version actually now supports something called zero configuration, where you don't even need to write a configuration file, okay? So if you want to do that, you just need to have one source folder in the root, and then in there one index.js file. And Webpack then will automatically create a distribution folder and put the bundled file in there. But that's just for really small apps, and so that's not really what we're interested in, okay? And so we will write some configuration. And in order to do that, let's go back to our text editor and add a file here called webpack.config.js. So this is just a regular JavaScript file. You can see it here, but actually Visual Studio Code identifies this file here as a Webpack configuration file with this icon here, okay? Now in here we have one object in which we can specify our settings or configuration, okay? So just one object, and then we want to basically export this object from this file using the Node.js syntax, okay? And that works like this. So module.exports, and then we export here this object, okay? So don't worry about understanding this part here. This doesn't really matter. This is just, again, to export this configuration object that we're about to write here, so that Webpack then can take this object and work with it, okay? Now, to create this configuration, we need to know that in Webpack there are 4 core concepts. It's the entry point, the output, loaders, and plugins. And we will just do a very simple config here because, again, our app is fairly simple. So starting with the entry point, all we need to do is to specify the entry property here in this object. And the entry point is where Webpack will start the bundling. So basically this is the file where it will start looking for all the dependencies which it should then bundle together. Okay, so we're going to start seeing how this really works once we start experimenting with this, right? Now in here, we can specify one or more entry files, but for now, we just want one entry file, and that is this index.js file. Okay, so let's now simply specify the path to that, and it is dot, and what dot means here is the current folder. Okay, so just like in a command line, when we have dot dot, so something like this, this means go up to the parent folder, but just one dot is the current folder. So current folder, which is the project folder, then go into the source folder, then JS, and here it's index.js. And that's it. That is our entry point. So that's the first property in this object here. Next up, we need to define the output property, which will tell Webpack exactly where to save our bundle file. So we specify the output property, and now in here we actually pass an object. And then in this object, we put the path, so the path to the folder, and then the file name. So path, and I'm going to leave it empty for now, and then the file name. And as the file name, we simply want bundle.js. So that's kind of a standard name for a Webpack output. Now about this path here, this actually needs to be an absolute path here. And in order to have access to that absolute path, we need to use a built-in node package. Okay, so let's include that node package here. And it works like this. Require path. Okay, so again, don't worry about the syntax here. This is just to include a built-in a node module, again, called path, and then put it in the path variable. Now in here, what we want to do then is to use a method which is in the path package, so path.resolve, and then we use the dir name variable that node gives us access to. So this variable here, this is the current absolute path. And so we use path resolve to now join this current path, so the working directory, the Forkify directory, with the one that we want our bundle to be in, which is dist, right? And then in there, JS. Okay, does that make sense? So again, this path resolve, which is a method which is available to us through this path package that we included up here in this line, we will then join the current absolute path with the one that we want our bundle to be in. So dist/js. So basically this folder here, right? And so now Webpack will output our file to this directory with this bundle.js file name. And that is now actually all that we need in order to get started. Now we can just make this a little bit better, because in Webpack 4, we now have something called the production and the development mode. So the development mode simply builds our bundle without minifying our code in order to be as fast as possible. But the production mode will automatically enable all kinds of optimization, like minification and tree shaking, in order to reduce the final bundle size. Okay, so that is another property that we can set, for example, by saying mode development. Okay, and so now it will be as fast as possible and not compress our code, because that's not necessary during development. Okay, so for now that's our very simple configuration. Later on we are going to look at loaders and plugins as well, but for now we just want to specify the entry and the output, and also the mode here. Now in order to actually test this out, we need to create a new JavaScript file. Okay, so right now we have the index.js, which is our entry point, remember? And so now let's say that we want to include a new module in here, so that we can actually test if the other module is included, so if they are bundled together. So just for testing purposes, let's add a new file here called test.js. And in here, let's say console.log imported module. Okay, and then we can also export something from here. So we say export default, and now let's just export some number here. So let's say just 23. Okay, and so this is the official ES6 module syntax that we're using here. So if you want to export something, we use the export keyword, and then we can have a default export or a named export. And I'm going to explain all of this in one of the later lectures, when we're going to start implementing our app's architecture using ES6 modules. But for now, just keep in mind that this is the easiest and standard way of exporting something from a module. Okay, so we have a console log and then we export something from this module. And now here in the index.js file, which is our entry point, we can then go ahead and import something. So we have to give it a name, a variable name. So import x from, and then the name of the module, which in this case is test. So the current folder / and then test. And now when we import from a module, we don't even have to specify the .js. So all we need to do is write test, which is the name of the module, and what we exported. So remember, we exported this 23 here. This will then be saved into the x variable, okay? Because we called it x. We could call it also a number or num, for example. So that doesn't really matter. But right now we have access to what we exported from this module here into this num variable. Okay, so let's now log that to the console. So console.log, and let's say I imported num from another module. Okay, and now right now this wouldn't actually work in the browser if we weren't to use Webpack. So we really need Webpack now in order to bundle these together. Okay. So again, this is only going to work with Webpack or some other bundler. And that is exactly why we're actually using it. So we have our example set up. Now there's just one last thing that we have to do, which is to go to our package.json and add an npm script. So let me now do that, and then I'm going to explain you what an npm script actually is. So let's call this one dev, which stands for development, and then we don't want any of this. So what we want here is to call Webpack. And actually, that's it. So all we need to do here is to actually call Webpack. So as soon as we start the npm script called dev, it will then open up Webpack, look up our configuration here, and then do the work that we specified here. So it will read our entry file, do its work, and output it exactly here as we specified. And why do we have to use an npm script for this? Well, because that's just the only way, or at least the best way, to launch our locally installed dev dependency, just like Webpack is. Okay, now actually in order for this to work, we need to do one more thing, which is to install the Webpack command line interface. So right now we only have Webpack, but we need something to be able to access it through the command line interface. And so there's another package for that one. Okay, so Webpack, they could have done it all in one package, but they decided to put that functionality of accessing it via the command line in a separate package. So let's install that very quickly as well. So we already know how to do that. So npm install, and this one is called Webpack CLI. So it's also an official Webpack package from the same authors. It's just to get access to Webpack through the command line interface. And again, we want to save it in our dev dependencies, hit return, and wait for it to install. So here we go. Let's check it out. And here you go. It's now actually in our dev dependencies here as well. So right now we're ready to launch this npm script. And it's actually very easy. All we have to do is to go back to our terminal, say npm, and then run. So run is the keyword if we want to start one of our npm scripts. And this one is called dev. And so let's hit return and see Webpack doing its work. And that's it. So it's already finished. You see bundle.js with a size of 3.59 kilobytes. And so let's check it out. And here you see it's actually right here. Let's open it up and you see it looks really weird. So it has all of this code. And down here, like really inside of this, you see some of the code that we wrote. So something like this here, I imported, and then all of this weird code. So it's really hard to understand what Webpack does behind the scene, and it doesn't really matter to us. All we want is for this to actually work, right? And now one final thing that we need to do in order to test this is just to create a quick HTML file here inside of this dist folder, just to include the bundle file and to see in the console if everything's working fine. I could just use this one that we already have here, but I can just create a new one as well. So index.html. Then I use Emmet here, and I'm not sure if you're aware of this tool, but in VS Code at least Emmet already comes pre-installed, and so all you have to do is to write this exclamation point, hit the tab, and then it will write this pre-formatted HTML skeleton for you. Okay, so let's just include a script here. JS bundle.js. Okay, so I'm going to call this one here test, and so let's open it up, and let's actually do that from the console. Okay, so open dist index.html, hit return, and here we go. So that opened that HTML document, hit inspect to open the console, and here we see the result. So you see, imported module, and then I imported 23 from another module. So that's perfect, right? So this imported module here comes from the test.js, so this one here. Then we export 23 back into index.js, where it's saved as num, put into the string, and logged to the console. And you see that 23 is exactly the number that we exported from test.js, right? And you see now that it's perfectly working. So that's amazing, right? Webpack is already configured, everything is working just fine. And so yeah, that's fantastic. Now one last thing here regarding this mode that we have here. So we set it to development, but once we're ready, we then want to set it back to production. But that's not really perfect, having to come back to this configuration file here in order to change this. And so we can actually move it here out of the config and into our npm script. So let me show that to you. So we delete it from here, come to the npm script here, the dev one, and then we can actually set that mode right here. So mode and then development. Okay, and then what we can do next is to add a new script called build, which is also for Webpack, but with a new mode, which is then finally production. Okay, and so let's use this one now. So the dev one is now for development, and build is once we're ready, we build it then with the production mode so that it will then compress our code. So let's test that here back in the terminal. Let's clear this here, and I can actually use Command K, at least on the Mac. I'm not sure how it works on Windows. And then let's say npm run build. Then it will do its work. And you see that right now it's much smaller. Remember that it was like 3 point something before, and now it's only 647 bytes. So it's much smaller, and we can see that here as well when we open it. And so, whoa, now it's just this small piece of code. All right. So all of this was compressed to just this piece of code, right? Now, running these commands here, these npm scripts, over and over again, whenever we want to see the result of the code we just wrote, is of course not perfect. And so in the next lecture, we will make our lives a bit easier by installing something called the Webpack dev server. But that one I'm going to leave for the next lecture, because right now I think this is already more than enough for just one video. So see you then in a second. Now, in order to make our lives a bit easier when writing JavaScript, we're going to add the Webpack dev server to our setup in order to automatically reload the page when we save our code. So besides all the amazing functionality, including in Webpack, it also provides us with a development server, which will automatically bundle all our JavaScript files and then reload the app in the browser whenever we change a file. And this is of course a huge time saver and makes coding a lot more fun. Now let's start by actually installing it, because again, Webpack dev server is an npm package, and so let's install it. So npm install Webpack dev server, and then again, of course, we're gonna save it as a dependency, so a dev dependency. All right, let's go back just to check out the package.json file, and confirming that, of course, it is now added here to our dev dependencies. Now, in order to configure this dev server, let's go back to our config file here and add yet another field here. And this one is simply called dev server. And in here, we pass an object in which we can then specify a couple of things. Now, the first one is the content base. So content base. And in here, we will specify the folder from which Webpack should serve our files. And in this case, that is the distribution folder. So dist, so this folder here. And that is because basically this is here the code that we're going to ship to the client. So our app, all of the final code of that app is here inside of this distribution folder. So we will always have an index file with the HTML, then the JavaScript, image, and CSS. And so as I explained at the beginning, this source folder here is only for our development purposes. So all our source code basically goes here, which then gets compiled or bundled into this distribution folder as bundle.js. And so what we really want to serve is only what's in this folder here, right? And this is actually the only thing that we have to specify in this case. We can also specify the port, but a bit more on that later. So for now, let's just leave it at this. And now to make it work, again, let's just add a new npm script here, okay? And one of the standard names for this kind of stuff is called start. So a script start will always be a script that keeps running in the background and updates the browser as soon as we change our code. Okay, so this is again kind of a standard name, just like dev and build. So these are all standard names that you will find in other projects as well. So start, and what we want here to happen is to run Webpack dev server with the mode of development. So just like here, we pass the development option, and then we can also specify another option, which is open. And all what that means is that it will actually open up the page in the browser automatically. Okay, so let's actually try this out. So this should already be enough here. So let's open up our console or our terminal and write npm run start. Hit return, and here we go. So this is again the same page that we had before. And let's open up the console again, and we see that it's actually working. Well, there's one thing missing here, but that's just the favicon. So that doesn't really matter. So you can just ignore this error if you get it as well. And so you see that it's actually the exact same thing as here. But the difference is that this code here is now running on a real web server. It's a local web server, so it's localhost on the port 8080, but it's simulating a real HTTP server. While this one here is just a regular file opening. So you see it here, it's like it's the file protocol, and then the entire path that we have here. Okay, so this here is much better because this simulates a real environment with a real HTTP server. So let's close this one up here and leave this one open. And so we can now change some stuff here. So instead of returning or exporting 23 here, let's export 99 or something like that. And then we can also change this text here in the index.js called test.js. So let's save these two, go back, and you will see that this should now automatically reload. And actually it did not, so let's take a look at the terminal here. And it actually says that it did recompile these two files here, but still, for some reason, this is not really working here. And if we reload it ourselves, then it still says here this what we had before. So let me try to restart this server here. So in order to stop this process here, because as you see, this process here is now running, it's not giving us a new line where we can continue writing commands. So it's still running. And if you wanted to open a new one, we can simply open like a new tab by hitting Command T. And on Windows, you will have to open a new window. Okay, so we can do this, or we can also stop this process here that's running by hitting Control C on the Mac. So not Command C, but Control C. Okay, and so now it's stopped. And so let's actually run it again. npm run start. Open a new one. Let's inspect it. And well, something is not working. So let's go back here, see what's going on. And I think I actually know what is going on here. So when we're running the development server, Webpack will bundle our modules together, but it will actually not write it to a file on disk, but instead it will automatically inject it into the HTML. Okay, and so we could actually go ahead and delete this bundle file here, because right now it still looks the same here in this console, because it's still simply reading the result from this bundle.js file and not from the one that we're generating on the fly, so through the dev server, because there's something that's wrong here. And the problem is that the output path here is this dist and then /js. And so it will basically try to inject this bundle into an HTML that is here in the same folder, so also in the JavaScript folder, which is not the case. So the index.html is outside. And so we want to get rid of this part here. So the real path of the output is now only dist, and then we can put the JS here in this file name. Okay, so this is no problem. This works just the exact same way. All we're saying is that really now the output folder is this entire dist folder here. Okay, and no longer just the JavaScript folder. And this will be important for something else, as I will show you in a minute after we have this working. Okay, and so this dist folder here is now the exact same as here, and so now it should actually be working. All right, so let's actually quit this here, clear the console, and run npm start again. Open up the console again, and whoa, here you see, now it's finally working. I imported 99 from another module called test.js, and so that's exactly the change that we did a second ago. Now let's change it again here. Let's say to 1, 2, 3, 4, 5, save it, go back, and here we go. So now it says 1, 2, 3, 4, 5. Awesome, right? So without us having to reload anything, it does it automatically, injects it into this file here, and it just works. And let me show you that we can actually even delete this bundle here, and it will still keep working. So let's now put even more here, 8, 9, 10, or just 8, 9, okay? And here you go. So the bundle.js file is actually gone, but this here still keeps working. So great, right? Now one final thing that I want to do in this video here, besides making this development server work for us, is to also copy this index.html file into our distribution folder. So this here is basically the HTML that holds the HTML for our app, at least the bare bones structure, so to say. And we see that down here, we also have this, well, this outcome in the script here. We could even just delete it all together. Okay, so no script tag in here. And this is our source code. Now what we want to do with this is to automatically copy it inside of the distribution folder and then inject the script tag into it automatically. And Webpack allows us to do just that very easily. So let's do that. And in order to do that, we use something called plugins. So remember, in Webpack we have entry points, output, loaders, and plugins. And so let's now talk about plugins. So basically, plugins allow us to do complex processing of our input files, and in this case of our index.html file. So we want to use a plugin called HTML Webpack plugin, and in order to use it, once again, you can probably guess it already, we have to install it. So we go back to our terminal here, and now we're using this new tab here that I created earlier. So npm install HTML Webpack plugin. Give it a save dev, and then here we go. Okay, now just like before, we have to require this package and save it to a variable. So const, and the standard here is to simply call it HTML Webpack plugin. And then use require, and then the name of the package, of course. All right, so now we installed and required, so included basically, the HTML Webpack plugin. And so now in here, we can specify our next property, and this one is called plugins. And plugins basically receives an array of all the plugins that we're using. And so the first and actually only one is of course our HTML Webpack plugin. And here we're missing a comma here, of course. And all right, so in order to use it, we use new and an HTML Webpack plugin. So this is the variable from up here. Because basically this is here like a function constructor. So it's like a new class. And so that's why we're using new here, as we're already used to do, right? So new HTML Webpack plugin. And then in here, we pass a couple of options. Again, using an object. Okay, so this is a very common pattern in modern JavaScript actually, is to always pass options using an object like this. So this entire configuration here is an object, and so is the options here for this plugin. Okay, so remember what we want to do. So we want to copy each time that we're bundling our JavaScript files. We also want to copy our source HTML into the distribution folder and include the script to our JavaScript bundle. So basically, again, this is our source, and this index here will then be our final and ready to go to production HTML file. Okay, so we specified the file name, and let's simply call it index.html, and then we use the template property. So template is basically our starting HTML file. And this one is located here at source and then index, right? So again, current directory, then source, and then index.html. Now we can also use this plugin to actually create a new HTML file from scratch automatically without providing any template. But that's kind of outside of the scope of this tutorial, okay? But you will see that there are some apps that don't even have an index.html file in their source code, but instead it's automatically generated on the fly by Webpack. All right, so let's get rid of this one here. So delete, and let's actually check out if this is going to work. So I'm stopping this process here. And now you actually see here in the background that it says disconnected. So it immediately noticed that we disconnected our server here. So let's now run it again, and it will then open a new tab. And whoa, here we go. So you see that right now we already have the Forkify app, and that's because Webpack already copied, you see it copied this index.html file into the dist folder. And as I mentioned, it's not really visible right now because it's not saving this data on the disk. Okay, so when we're using the dev server, it will not save the files on disk. It will simply like stream them to the server. Okay, so if you go now and open up inspect, then here's of course the exact same code as we had before. And that's because if we inspect the elements here, you will see that it injected this script. Okay, so just like magic, this worked just fine. Now, if you wanted to actually see these files here on disk, we would have to run one of these commands. So for example here dev or build, and this one then will actually do the bundling and save it on disk. So let's do dev here in this other tab that we have. So npm run dev, then it does its work, and now you see index.html is here and bundle as well. And now you see down here when we come here, here is the final JS bundle.js. And it is the file name that we specified here in this config, right? So exactly this one here. So this seems like magic, but that's just the work that Webpack does here behind the scenes. And it is a fantastic tool and very helpful in our development workflow. I agree that it's a bit difficult to set up. There are easier options out there, but this is also the most powerful. And so once you have the setup, you can then use it in the future for your own project, and of course do some changes to make it even better. But for our project, this is more than fine, just like this. The only thing that is missing now is to include Babel. So in order to convert ES6 down to ES5. And so that's what we're going to do next in the next lecture. All right, and now as the final step, let's integrate Babel into our workflow in order to make it really complete and ready for us to start working on the project. So as you see from the website, Babel is a JavaScript compiler in order to use next generation JavaScript today. And it can be rather complex and confusing to set it up, but we're going to use a very straightforward configuration in order to do it. And it's all here in the documentations, and you can read through it if you want. But of course, I'm going to show you now, again, the most straightforward way that there is to set up Babel. So first off, in order to make Babel work, we need again to download a couple of packages. So let's fire up our terminal, come to this one, and let's clear it up. And so the packages that we need to install are, so again, npm install, and the first one is Babel core, which contains the core functionality of the compiler. The next one is Babel preset env. And now we're doing something that we didn't do before, which is to install many packages with the same line. And that's totally possible. So we can install multiple packages in the same command. So we have Babel core, and now the next one that we want is Babel preset env. And this is a Babel preset that will take care that all the modern JavaScript features are converted back to ES5. And a bit more on this one a bit later again. And finally, we need Babel loader. And this one is needed for Webpack in order to actually load Babel files. Okay, but again, more on loaders a bit later. Now finally give it a save dev here, and now we're going to install all of these 3 packages at the same time. So let's check it out here in the package.json file, and indeed here we have Babel core, loader, and preset env. Okay, and now we need to learn about the concept of loaders in Webpack. So loaders in Webpack allow us to import or to load all kinds of different files, and more importantly, to also process them, like converting Sass to CSS code or convert ES6 code to ES5 JavaScript, which is exactly what we're going to do now, right? And so for that, we need the Babel loader, because Babel is the one that will convert this ES6 back to ES5. And again, the syntax for this is a bit weird. So how it works is we use module, pass in an object, and then in there, we need to specify the rules property. And rules then receives an array of all of the loaders that we want to use. And for each loader, again, we need an object, right? So again, this is all a bit weird and confusing, but you just need to set this up once. So once set up, it will keep working forever basically, right? So for each of the loaders, we need the test property. And for this one, we use something called a regular expression, and we're going to talk a bit more about this later. Okay, so in this regular expression, what we want to say is that we want to test for all the JavaScript files. And the JavaScript files are the ones that end with .js. So we want .js at the end. And that's what this here means. So this test here will basically look for all of the files and test if they end in .js. So that's what this regular expression here means. Okay, so all of the JavaScript files will use the Babel loader. And so we use the use, and then again we pass it an object here, and then finally we use the loader property, and then we can say Babel loader. Woo! So that is really a lot here to write, and again it looks really complex here with all of these modules, rules, tests, and then use, and finally the loader. And a lot of newbies are confused by all of this, but really I don't think it's such a big problem. Okay, so Babel loader, this is the package that we installed before. So remember, it's here in our package.json. So this Babel loader package is what allows us to use this here then in Webpack. Okay, and we can actually add something more here to this rule, which is an exclude. And with exclude, we say that we want to exclude everything that's in the node modules folder. Okay, because if we wouldn't do this, then Babel would apply to all of the thousands of JavaScript files that are inside of this folder here. And we of course don't want that to happen. We just want it to do in our own project, and so we can exclude this entire folder here. And again, we use it as a regular expression here with these 2 slashes at the beginning and at the end. Okay, so again, what this rule does here is it tests for this .js at the end, which this one here means, and if it is a JavaScript file, then it will apply the Babel loader. Okay, and so that's how we use Babel, step 1. And step 2 is that we now actually also need a Babel config file. So not only for Webpack we need this config file, but also for Babel. So let's create a new file here, and the one for Babel is usually called Babel RC. So just .Babel RC. And once again, VS Code here actually already recognizes it here as a Babel 6 file, and so it puts this 6 here as the file icon. So in here, all we pass is just this object, and so this one is different from Webpack, which is a real JavaScript file. This one here is just a dot file. Okay, so we have this object, and then we pass preset, and into preset we pass an array and say that the preset that we want is called env. Now a preset here is a collection of code transform plugins, which are like the pieces of code that actually apply the actual transformations to our code. Okay, and the one that we select here is the env, which stands for environment. And we actually installed this here before as a plugin, right? As a package, sorry. So the Babel preset environment, Okay, and so now in the config file, that is exactly the one that we use. So preset environment. So we select the preset and say that the one that we want is the environment. So the one based on environment. And now we can actually specify the environment that we want to target. Okay, and by environment, I mean like the browsers. So we can do it like this. Write target. And actually this needs to be in quotes like this. And then we pass in another object. And so once more, this is really confusing, you know. Okay, so browsers. And now, finally, we just pass in an array saying which browsers we want to target. Okay, so in here we can now say stuff like the last 5 versions. And what this will do is that Babel automatically figures out which ES6 features it actually needs to convert in order to work on the last 5 versions of all the browsers. Okay, and so that is what it means with environment. So we say which environment we want it to work, and then Babel automatically figures it out. There are of course other presets that we could use, but then we would like manually have to say what we want to convert and what not. And with this preset, well, it all just happens automatically. So we can say something like last 5 versions, we can say 2 or 10 or whatever. And we can also say something like we want at least the Internet Explorer more than 8. Okay, and we can add more stuff to this, and you can find more examples on the documentations of Babel, but I guess for now this is enough. So again, we say that the preset should be based on environment and that we want to target the browsers, the last 5 versions, and Internet Explorer greater or equal to version 8. Okay, give it a save, close it up, and we're good to go. So right now ES6 or even ES7, ES8 or ES Next, so all the future versions of ES, so of JavaScript, will be converted back to ES5. Now there are some things that we cannot really convert because they simply were not present in the ES5 version of the language. And so there's no way that we can simply convert them back from ES6 to ES5. And so these need to be polyfilled. And I'm talking about things like promises or methods like array.from, so stuff that just were not present in ES5, and so we cannot really convert them back. Okay, and so we need to polyfill them, which basically adds this to our code. So the promise object, for example, is not present in ES5, right? But we can write some ES5 code that basically implements the promise in ES5 so that we can then use it in our code. Okay, and so that is exactly what a polyfill does. So how do we use a polyfill? We need to install another package. Okay, so npm install Babel polyfill. Now this code is actually code that will be in our final code. So as I've explained, this will basically implement like a promise in ES5. And so this is not really a development tool, but it is really code that is going to go into our final bundle, right? And so this is not a dev dependency, but it's a real dependency, as I like to call it. And so we just use save and not save dev. All right, and it's installed, as you can see down here. Now all we have to do is to add it in our Webpack config, and where we do it is in our entry point. So I said before that in the beginning we just had one entry point, but there can be multiple, and now we actually will have multiple. And so now we pass in an array. So let's open it and close it here. And so our entry points are now this polyfill that we just installed, and then our original entry point. Okay, so we can simply say Babel polyfill here, and Webpack will then automatically figure out where this code is located and will then bundle it together with this code that we have here. And so in the end, we have one huge bundle which has both all the polyfills for the ES6 code as well as our own code, of course, in the index.js file. Okay, so basically installing Babel was a 3-step process. First, we installed all of these packages and then added this rule here with the Babel loader. Second, we created then a config file here in order to tell Babel which stuff we want to convert back to ES5. And then finally, we also included a polyfill in order to not convert, but polyfill the features that we cannot convert with the Babel loaders. So with all of this work done, let's now finally test this. So in the index.js file, we actually have this, well, this is already ES6, so this template string. And also in here we have, well, here we don't really have any ES6. So let's also add a constant here. So const x equals 23. And let's add it now into this template string here somewhere. So num from another module called test.js. Let's just add variable x is x. Okay, so let's give it a save and then run our Webpack command. Okay, so npm run dev, right? And so this will now create our bundle. And whoa, we have some errors here. So let's check it out. So there's some errors here. And we can see it's in Babel. And so we have something invalid here in our config file. Okay, so presets. And so it looks like we're missing like some parentheses there, right? So let's go back to our Babel RC file. And what we're missing is that here we actually need another brackets. Okay, so we have one brackets here, and we then need to close it in here. And what's also missing here is a missing s here. So it's presets and not just preset, and the same for target. So it's targets and not just target, okay? So give it a save now, and let's try it again. And so now it should really work. And you see, yeah, now it's done. Now it worked just fine. So let's try and open up this bundle.js file, which was just converted. And so, whoa, so you see here, let's go to the beginning, that we have this huge amount of code. And most of this actually now comes from the Babel polyfill. So you see down here when we scroll that it actually included here the Babel polyfill. And so all of this weird code here, all of this is probably coming from the Babel polyfill, okay? But we will also be able to find our own code in here. So let's grab this piece of code here and then search for it in the bundle. Then we will be able to find our own code. And so here it is. And you can already see that it actually did the compiling from ES6 to ES5. So before we had const x equals 23, and now we have var here, right? And also before we had a template string here in the console.log, and now you see these normal quotes and then the plus signs in order to join the strings, just like we did it in the ES5 way. And so this proves that Babel is now really working. It is doing the real conversion from ES6 to ES5, and it's also doing the polyfilling. So it included all of these polyfilled that we specified. Okay, and so now we're actually really done with our setup. So we used entry points, we used outputs, we used the dev server, plugins, and also loaders here in our Webpack configuration. And so I hope that you're fairly confident with using Webpack at this point. Of course, there's a ton more to learn, and you can always check out the Webpack documentation, or you can search for some tutorials online, and there's a lot more to learn actually. For example, you can use loaders for Sass in order to convert it to CSS, and that's something very popular and it's very useful as well. So you don't need to include an additional Sass converter outside of Webpack, so you can do it all inside of Webpack very nicely. But in this project, that's not really necessary. And so again, we keep it here very simple, just in order to make it work according to our needs here. So that being said, I hope you learned quite a lot in this small series of Webpack lectures so that you're now ready to really move on to the project from now on. Let's now talk in detail about how ES6 modules really work. And so in this video, you're going to learn how to import and export stuff from and to ES6 modules by using both default and named export and imports. So let's open up our index.js file. And we can actually close the package.json file. And also we can get rid of the test.js file. So this was just to test if Webpack was working all right. And we don't need that anymore. And we also don't need any of this stuff here anymore. So let's get rid of all of it so that I can now explain you how ES6 modules work. Okay, so let's create a new model here for the search functionality. So a new file, and I'm going to call this one search. And usually we always write JavaScript files all in lowercase. But in the case of models, it's like a convention to always use uppercase here for the model name. And so this one here is for search, and so I'm just using search with the upper S, okay? And just search. And now the same one for the view. And remember from the last lecture, this one is called search view. .js, of course. Okay, so we just created the search model and the search file, and we also have our index.js file, which is going to be the controller. Okay, now we're not going to add the real code in here just yet. For now, I just want to show you again how named and default exports and imports work in ES6 modules. So we already talked a bit about this when we talked about the Webpack tests, so the test.js that I just deleted. But now let's really dive into it. So starting with default exports, that's the ones that we use when we only want to export one thing from a module. And that's actually pretty common. And that's why we have default exports. So with default exports, all we have to do is to say export default and then the thing that we want to export. So let's say we simply want to export a string saying I am an exported string. Okay, and so this is our default export. We don't specify any constant here or any variable at all. We simply put our expression, so this string here, right after the export and default statement. Okay, so this will now export it from this file. And if we want to now import it into the index.js file, we do it like this. So we say import, and then we have to give it a name. So let's call it string, for example, and then from, and then the path to this module. And in this case, it's in the models folder. And so we have to say first the current folder, remember, then slash models, and then slash search. And remember, I already told you before that when we import a module, we don't have to specify the .js. So just the name of the module, which is search, not search.js. Okay, and so like this, we have now this value stored in string. So in string, we right now will have I am an exported string. And in here, we really can give it any name that we want. We can also call it just str or x, or it doesn't really matter, okay? So let's just call it str. So default exports, they are really simple. They work just like that. Now, if we want to export multiple things from the same module, then we have to use something called named export. So let me show it to you in here in the search view file. Okay, because later we will actually export many functions from here. And so let me show you how we can do that. So it's actually pretty simple as well. Again, we use the export keyword, but now instead of default, we declare the constant or the variable that we want to export from here. So imagine we want to export a function. So let's say const, and for example, let's say we want to export a simple sum function or add. And we pass two numbers into it, and then we return a plus b. Okay, so just a very simple function which takes two arguments and then returns the sum of a plus b. So this is here again the arrow function syntax, and I'm sure you're already familiar with that by now. Let's say we now want a similar function to this one here, which multiplies two numbers. So multiply, and then again the same as before, which will a times b. Okay, so now we have two exports here. And let's say we want to export something else. For example, an ID set to the value of 23. So now we exported three things from this module. And if we want to now import it from here, it works in a slightly different way. So again, we have to say import, but then we have to specify what exactly we want to import from the module. So we use the curly braces, and then imagine we just want the add and the multiply. So we say add and multiply from, and then views, and then search view. And again, we omit the .js, right? And so with this, we only imported the add and the multiply, and we have to use the exact same names that we exported here in these named exports, okay? And that's why they're called names, because we give them a name, and then in order to import them, we have to use the exact same names if we want to use them, okay? Now let's also add the ID, and so we can now use these. let's get rid of this line, and now let's log all of this to the console. So console.log in a template string here, using imported functions. And so let's here add these functions actually, or use them. So let's say add, and then we can actually use ID, which is 23, and also pass 2. So now we pass in the ID and 2. So the two variables that are available to us right now. So add and ID. And let's use the other function here as well. So multiply. And now I can pass 3 and 5. And also, since we're at it, let's also include the str, so the string, so that we have everything in one nice console.log here. And I see we're missing here this curly brace here. And so now we should be good to go. Okay, so let's test it out. And actually it should already work, and it does. And that is because here in the terminal, this process is still running, as you can see. So our dev server is still bundling up all our JavaScript files as soon as we save the files. And so in here we have now using imported functions 25 and 15. And so these are the results of the functions, so the imported functions. So up there here in this pop-up it says 23, plus 2 is of course 25, and 3 times 5 is 15. Right? Then here I am an exported string. So all of this is working just fine. Now imagine that we want to use different names here. We can actually do that as well. All we have to do is to say add as a, for example, and multiply as m, okay, and then just ID. And so now we can use a and m in here. Okay, so let's give it a save, go back, and it still works, right? So we basically changed the names of the imported variables, so the imported functions here in this case, but they are still variables, so it's the same. Okay, so we can export them using one name and then import them and assign them another name by simply using this as syntax here. So this is the second way of doing named imports coming from named exports. Now the third way is a bit different, but there is actually still a third way. And so let me actually comment this one here out and start it again. So I can say import everything from this here. So let's copy this part. And so I can do it like this. And then I also have to give it a name here. So import everything as, and let's just say search view. Okay. And so everything is now called search view from views/search view. All right. And if we now want to go ahead and use the stuff that we exported here, we have to do it like this. So we have to use search view dot add. And here we have to use search view dot multiply. And here, of course, we also have to use search view dot ID. Okay, let's check it out again. And here it is. So still working just the exact same way. So that is the third way of doing named imports. So again, here we import basically everything and put it into this variable here, or this object. And then on this object is where all of the variables then live. And so we can then use them. So here, search view dot add, dot multiply, and dot ID. Okay, and there are different use cases where we can use these different methods, and I'm going to use all of them throughout this project. But I just wanted to make this separate video in order for you to really learn how modules work all in one video. Okay, so we can get rid of all of this here now after learning this. Okay, so this was again just to test it. And so now we're good to go and really ready to start with the project right in the next video. Okay, so I hope to see you there very soon. So we're now ready to start working on the Forkify project. And the first step will be to start using the underlying recipe API. And so we will use a real-world API here, probably used by thousands of services out there, based on what we learned in the last section, of course. Also, you'll learn about the concept of API keys and why we need them. So the API that we're going to be using is called food2fork.com. So head over to this website here And then from here, we can use this recipe API. Okay, and that brings us to the documentation page of this API. So this API allows us to do two types of requests. First off, we can search for recipes, and second, we can then get data about one specific recipe. So in this first, the search request, it's going to return a list of 30 recipes. And from there, we can then select one of the IDs and then make a request for that specific recipe during the second endpoint. So we have the search and the get endpoints of this API, okay? Then down here, we see the parameters that we have to include in the API request, but more on that a bit later. What I also wanted to show you is that we have different plans here. So the first one is the free plan, and that's the one that we're going to be using. So we can do 500 API calls per day, and then you can also pay if you want. And we always have to have an attribution whenever using the free plan, saying powered by foot to fork. And that's why we have it down here actually in our app. Okay. So now please go ahead and create your own account here, because that's how you're going to get the API key that you need in order to make this API work. So I already created this account, and so I just need to log in here. And then I can see my API key right here. So please go ahead and create your own account, because you should use your own API key instead of using mine. Now you might be wondering what an API key actually is, and so let me explain it to you. So an API key is like a password that's given to each user. It's like a unique ID that each user can use in order to make requests, and so that the API can track how many requests you make per day. So remember that here in the free plan, we can only do 500 requests per day. And so they use this API key here in order to track that. Okay, so I'm going to copy it and then paste it here actually in this file here, just so we have it here in the index.js file where we're going to make our requests in a second. Okay, now let's go back here to the API itself, the documentation, in order to learn how we can actually do the search request. So this is the URL that we have to use to make the request to. And then down here, we have to pass in the key, so the API key that we just got, and then also the search query. Then we can also pass in the sort parameter and the page parameter. And we're going to talk about these later, but for now, we just need the key, and then of course also a search query. Okay, so the URL is this one. So let me also copy it over here to our code editor. Okay, and now that we have all of this, let's actually try to experiment with this API. So not really building the app just yet, but just writing a simple function here to experiment and try out the API. Okay, so let me write an async function. So get results for get search results, and the parameter is let's pass in a query. Okay, so here we have the space, and then down here we can then call this async function. Okay, now about the HTTP request that we're going to make for the AJAX call. In the last section we used the fetch function like this, right? Now there are some problems with the fetch function that I actually mentioned before, which is that it doesn't really work in all browsers just yet. So in the modern browsers, of course, it's going to work just fine, but if you get on a very old browser, then it might not recognize fetch, and that's actually a problem. And so instead, what we're going to do is to use a very popular HTTP request library called Axios. Okay, so in order to use Axios, we need to install it and get it from npm. Okay, so let's use our terminal again here. Let's clear this here and do npm install Axios. Okay, and then save. And again, it's not safe dev because this is not a development tool. It is really code that we want to use in our app. Okay, so let's wait for it. And there you go. Let's just confirm it in our package.json file. And indeed, here we go. So we installed the package, and now let's import it. And importing packages actually works almost the exact same way as importing our own modules. And so again, we use the import keyword. So import Axios from, and now comes the name of our package. So in the last lecture, I showed you that we have to specify the path to the module that we want to include, right? Now with this npm modules that we install from an external source, we don't have to do that. All we have to do is to specify the name of the package. So all we have to do is to say Axios, as it appears here in the dependencies. So it's Axios here, and so we call it Axios here in this import, okay? And then as I hover over it, you actually see the entire path, which the code editor actually figures out on its own, okay? And so that's where the package lives, and Webpack, when bundling our modules together, will then automatically also figure out where it is. Then here we could give it actually any name that we wanted. We could do just A, okay? But it's like a convention, like a standard, to give it here the same name as the package name, okay? So let's now use Axios to do our AJAX call. And it actually works the exact same way as fetch, okay? So the package just gives us access to this Axios function, which will then do our HTTP request, okay? And this one here actually works on all browsers, unlike the fetch API that I showed you before. And there are also other things that this one here does better than fetch. For example, it automatically returns JSON. And with fetch, remember, we had to do it like in 2 steps. First, we had to wait for the data to come back, and then we had to wait for it to convert to JSON. So we had this 2-step process. And with Axios, it happens all in 1 step, and that's much better. And also, Axios is a bit better at error handling than fetch, and I'm going to show you that in a second as well. So Axios, and then in here we have to pass the API URL. Okay, so let's copy this one, do a template string here, so that we can now include the query. Okay, so let's see how that works here in the documentation. So for the key, we have the key parameter, as you see here, and for the query, we have the queue parameter. Okay, and so how it works is like this. So we have search, and then in order to add these parameters to the URL, we have the question sign, and then the name of the parameters. So key is our key, and let's actually save the key here to a constant. So const key, and I'm going to cut it from here and paste it up here. And of course it needs to be a string. So putting the key here, and then the next one is queue. Remember, so for the query, we use queue. Right? So again, this queue here is coming from the API documentation. So this queue here, right? Okay, so this here will do the AJAX call, and just like fetch, it's going to return a promise. And since we're using async await here, let's then await this result and save it to a constant. So constant result, and then await the result of this promise. Okay, so remember, that's how we handle promises with async await, right? So the resolved value of the promise that we start here will then be saved into this res variable. Okay, and now just to take a look at what we get back from this AJAX call, let's simply log it to the console. And that's it for now. So let's actually try it out. And if you take a look at the terminal, you will see that it has probably already built our bundle. And yeah, it did. So this is actually the time of recording this video here. And so right now it just bundled this module here together. Okay, so let's take a look at our console. And here we have this error again that we had before. So this is again the error where some domains don't allow requests coming from other domains, okay? So that means that the authors of this API, they have not really implemented the cores into their API. And so we need to get around that again using the cross-origin me proxy. Okay, so yeah, it's this one here. Let me show it to you again. So all we have to do is to really prefix our URL with this URL here, okay? So the cross-origin.me. So let's do that here. And again, I'm going to create a constant for that. So this proxy URL, and now I'm just going to plug it in here. So proxy, and so let's see what happens now. And we're still getting an error here. You see it's a 403 error, which means that we're not allowed to access the resource. And so maybe we need to try another proxy here. So let's just search for course proxy here. And the one that I'm going to use, which I've used before also, is this course anywhere. Okay, so let's just copy this one, and it works just in the exact same way. We just need to replace this proxy name that we had and put this one. Okay, and so now our request is going through this server here. So let's try that out again. And we also forgot to add our search query. So let's add pizza here again and try it out again. And all right, so we now finally got our response. So let's try to open up this object, take a look at it. And you see there's a lot of stuff here. These are the headers of the HTTP request. Then here we have the request itself. But what really matters is the data really here. So we have the data here, then we have the count property, and then the recipes array. And this is what we're really looking for, right? So you see that we already got our 30 recipes here, all in this recipes array. Okay, so let's actually go back and say that we only want to display these recipes. So let's create a variable here. Const recipes is result.data.recipes. And so let's log just the recipes. Okay. And so let's wait for it. So this time that we're waiting here is the time that it takes for the AJAX call to come back with the result. So here we have all of our recipes. So you see that we have a publisher. Let's open it up here. So we have the URL on food to fork. We have an image, we have a publisher, and this is the ID that we're going to need to use the second endpoint of the API, which will be to search for recipe. And then we can get even more details about the recipe, like ingredients and all that good stuff that we need to display our recipes then here in the middle of the app, right? So this already works. Let's now talk a bit about the error handling. So let's say we put an invalid key here. So let's just add something weird here to the beginning of the key. Let's try it again, and we will then probably get back with an error. So again, we see the forbidden status code here, right? And so let's now handle these errors. And remember, we have to do it using the try catch statement. So we want the code to try if this piece here works. So try. And this one here actually as well. And then catch any error that may occur, and let's alert it in this example. Okay, so here we need to call it error, for example, and then log it to the console, or actually alert it into its own window. So let's try that out now and see what happens. And here we go. So the request failed with a status code of 403. And if we had done the same AJAX request with fetch instead of Axios, it would probably not have catched the error, because again, error handling works a bit different in fetch than it does in Axios. And in Axios, it's way more intuitive and better in my opinion, okay? And so that's why I'm always using Axios instead of the native fetch method, okay? But anyway, of course, we want to go back to what we had before. Let's get rid of this. We can also get rid of this piece of code. It's not really necessary. And so one last time, let's try it out if it works. And indeed, we get back all recipes. And you also see that they're all about pizza here, right? So it always says pizza. Let's try something like tomato pasta. Come back here. Now it takes some time to get the data from the server. And now they will be all about pasta. So pasta and tomato. So you see that both are now here in the title. So pasta salad with tomatoes. And so, yeah, this API is actually working now. And so right now we are ready to start building this beautiful app here using this underlying food to fork API that we just explored. Let's now start to implement the MVC architecture by building the model for our search functionality. And so in this lecture, you're going to learn how to build a simple data model using ES6 classes that we talked about before. So we actually already have our model file for the search. So let's open it up and so that we can build our model in here. So we're going to use ES6 classes in order to describe the data model for the search. And the data for the search is really just the query and then the search results. And so the only thing that we're going to export from this module here will be this class. So let's say export default and then class called search, of course. And remember how we define a class? Well, the first thing that we need to do is to always add the constructor method, which is the method that's always called as soon as we create a new object based on the class. Okay, so we need a constructor, and in there we pass the properties that we want the new object to have. Okay, for example, in this case, we want to have a query, and we then say this.query equals the query that we passed in, right? So remember this pattern, how we define a class? If not, then don't worry, it's going to become a lot more clear once we start using this class here in a second. Okay, now the second thing that's important about the search here is the search results, of course. So we're going to have a method here that we can use to get the results for the search query. Okay, and we actually already wrote that, kind of. Okay, so let's get this code from here that we wrote in the last lecture and put it here into search. And so this function that we have here is kind of the method that we're looking for. Okay, so let's copy it or cut it, paste it here, and then all we need to do is to get rid of this function keyword, right? Because this is how you define methods. So usually you define them like this, so just the method name and the parameters, but in case that it's an async function, then it works just the same as it works with regular functions. So we just use the async keyword, and so we say that this is an asynchronous method of this class. Okay, of course we don't need this here. These definitions, they should always be at the beginning. So these kinds of imports, we usually always include them right at the beginning of each of the modules, okay? Now, a couple of things that we need to change here. First off, this method here does not have any parameter because we will always read the query right from the object itself, right? So in here, instead of query, we use this.query because the query will already be in the object once we call the getResults method, right? Then next up, we also need to change this line here because we actually want these recipes here to be saved in the object as well. So let's say that we want this.result to be the recipes that we got from the AJAX call, okay? And again, this will become more clear in a second once we start using this method and this class, okay? And then we can also log them to the console just to see if everything's working. And that's actually it, okay? So very simple, this is all we need for our search data model. And so let's now go ahead and import it here into the index. So import search from search. Okay, and now let's create a new variable called search also, but this one with a lowercase, and so it is a different variable. And now we use the new keyword as always and pass pizza into it, which remember is the query, right? So this query parameter is the one that we need to specify whenever we create a new object based on this search class. Okay, and then this query will be attached to the object as being this.query equals the query that we inputted. Okay, so let's get a look at that actually. Okay, in the console, so that we can kind of review how everything works here with the classes. Okay, so let's wait for it. And yeah, of course, there is this error because I put the wrong path here, so I forgot to add the models here. But now it should be okay. And here you go. So this is now the search object that we created. And you see that it has the query property set to pizza, and then in its prototype, it will have the get results, right? So this is the kind of prototypal inheritance that we talked about all the time throughout this course here. And so I'm not going to go into that again, because at this point, I'm sure that you're really familiar with how it works, okay? And now as a final test, let's actually go ahead and use the get results method, okay? So search dot get result. And that's actually it. So let's try it again and let's wait for the result. And for some reason it says recipes is not defined. So let's take a look at what's happening here. And well, let's just console.log it here. Just to see if, well, if something's not working right. Okay. So actually we have data here. So I'm not really sure why it's not working. So let's try it again here. Just waiting a second here. So recipes is not defined again. So let's go back. And yeah, so the problem is actually here. So here we should have this dot result. Okay, and so now of course it's going to work just fine. Wait for it, and here we go. So here's the data that we were looking for, and so our data model works just fine. Okay, so let's get rid of this console.log, and actually of this one here as well. Well, let's just comment it out. Maybe we're gonna need it later. And this is how our data model works. So you see that instead of returning the result right away, it simply stores it here in this dot result, so that all the data about the search are encapsulated inside of the object. So we have both the search and then the corresponding result both stored inside of the search object. And this has some advantages that we're going to talk about right in the next lecture. Welcome back. In this lecture, we are going to build the search controller. And in order to do that, you will learn about the concept of application state, and then you will learn a simple way of implementing state in our app. So let's open up index.js, which is where we're going to put our controller. So again, each model and each view will get its own file for each of the functionality. But for controllers, I'm going to put all of them into the same file because that makes it a lot easier. As you will see, when the file gets bigger and bigger as we're adding more controllers. And it will be easier to have them all in one file, okay? So let's now talk a little bit about something called state. So imagine our final app running with all the search queries, the recipes, the likes, the shopping list. So what is the state of our app in any given moment? So think about what is like the current search query, or what's the current recipe, or how many servings are currently being calculated, and what's currently in the shopping list. So all of these things in one given moment are the state. So all this data in the current state, in the current moment of our app, all of this data is the state, and we want that to be in one central place, like one central variable, like an object in which we have then basically all the data that defines our app in a given moment in one place, in one object. Okay, so that's what we're going to implement now, and it's actually very easy, at least in our very simple app like this. Okay, now there are entire libraries for state. Maybe you've heard of Redux, which is used together with React. So that's a very popular state management library. But in this case, we will just do something very simple, just one object, which is the state of our app. In Redux, this is like the store, it's called the store, but let's just call it state here, okay? So const state, and for now it's empty. And let's actually add a comment here. So saying the global state of the app. And in here we will have the search object. So all the data about the search, which we actually already coded up in the last lecture. So remember, in the search object is where we have the search query and the search results. And so that will be part of our state. Then we want the current recipe object. So that will be later when we're talking about the recipes. Then we also want the shopping list object. And we want the liked recipes. Okay, and so again, all of this data will be stored at all time in one central variable, which we can then access throughout our controller. Okay, so instead of having many variables, like having the object stored in some place in some variable, or having the recipes like hidden from other functions, from other scopes, we have everything in one place, accessible to everything inside of this module. Okay, so that's a pattern that I really like to use, and it's really helpful in this case. So again, we start with an empty object here. So each time that we reload the app, the state will be empty. And we will actually make some of the state persistent a bit later, which means that when we reload the page, then the state or some part of the state can actually persist. So it can be saved. But let's leave that for later. For now, let's start implementing here part of the controller for the search. And the first thing that we're going to do is to actually add an event listener for the search form. Okay, so basically for this button and for this entire form. So let's take a look at our HTML. And it is up here. So the form that we're looking for is this one here called search. So let's now add an event listener for whenever we submit this form, okay? And event listeners are something that go into the controller because that's where we're then gonna delegate what we want to happen when the user submits the form, right? So document.querySelector add event listener, and the event we're looking for is the submit event. And then, of course, our callback function, in which we pass the event object into. Okay, and let's see what actually happens right now. So when we click this here, you see that the page reloads, right? So let's take a look again. And we don't want that to happen. And so we say e.prevent default, right? So we did that before, of course. And then we can now also create a new function that we want to be called whenever the form is submitted. Okay, so instead of putting all the logic here inside of this callback function, let's make a clean new separate function from this. Okay, so control search. Okay, so no arguments here. All we want to do is to put this code basically outside of this callback function here, make a nice separate function just for this. Okay, so whenever we submit a form, we prevent the default from happening, and then the control search function is called. And now let's think what we want to happen. Okay, so I will actually make now a bunch of comments listing each of the steps that must happen here in this search controller. Okay, so the first one is that we should get the query from the view. So let's call this simply query. And I will simply add a placeholder here now and say that we should then do this later, okay? Because in our view module, we will have a function that will get the search query from the user interface, okay? Of course, we could put this right here. We could now do a document query selector and then read that data right from the user interface, but that's something that has to do more with the view. And so we're going to put a method for that, or a function, into the search view module, okay? But we're going to do that in the next lecture, so that we have one lecture for each of these different parts of the architecture, okay? So right now we're talking about the controller, so let's leave it like this for now and then come back in the next lecture and code all of these functions for the view, okay? Now if there is a query, we then want to create a new search object, right? So let's say if query, so if there is a query, then what we want to do next is new search object and add it to state. So let's do that. So state.search will be a new search object with the query, right? So similar to what we did here, but now this time around, we are actually going to store it here into our global state object. So this one that we just talked about in the beginning of the video, right? So let's get rid of this here. And next, what should we do next? Well, we can now prepare the user interface for what's going to happen. Okay, so like clearing previous results or show a loading spinner. And so that's what we're going to do here as a next step. And again, I'm leaving that for the next lecture, but that's one of the steps, so I'm putting it here right now. Next up, let's actually do the search. So search for recipes. And so that's where this method here comes in. So on our state.search object, we now can perform the getResults method, right? So again, state.search is where this object now lives. So this new instance based on the search class. And on that, we of course have the getResults method available so that we can then later display these results in the user interface. And actually that's exactly the next step. So render results on UI. Okay, now of course we only want this here to happen, so we want the rendering of the results only to happen after we actually receive the results from the API, right? And so what we do have to do here is to actually await this promise, right? So since we use await here, now we need to say that it is an async function. And we do that right here, right? Because this here is where we define the function. And so we say async function so that we can then use await in here. Okay, makes sense? So again, this here returns a promise, right? And why is that? Well, let's open up the method here. So this is an async method. And remember that every asynchronous function, it automatically returns a promise. Okay, and so here we then have to await. So until the promise resolves and comes back with our data. Okay, now we're not really going to render the results on the UI, but what we can do here is then to log these results to the console. So console.log, and where are these results actually stored? So they are in state.search.recipes, right? Or is it result? I'm not really sure. Ah, yeah, it is result. You see, so it stores it into this.result. And so here it's then state.search.result. And let's actually get rid of the console log. Ah, we already did that. So the only console log that we have is going to be this one here. Okay, and so what this means is that the getResults method runs and we wait for it to finish basically. And only after that is done, we can then log to the console the result here. Okay, and so with this, we can test if this async await here is actually working as intended. So let's test it out. And we don't actually have to input anything here because again, it's not really being read right now. Right now, we're just using the input pizza here as a temporary query, right? So let's just hit search here and let's wait for it. And indeed, it did came back with our data here. And it's all on pizza, right? And you can see that this console.log came from index.js line 27, which is exactly, well, it's not exactly this one here, but I guess the line number is not correct because of all the Webpack bundling that's done behind the scenes, but it's pretty much the same, 25, okay? So that's really all there is to control right now. So all we have to do now is to actually implement our view so that we can get first the query from the view, that we can then prepare the user interface for the results, like having that spinner, clearing the input maybe. And then finally, we want to also render these results on the user interface, of course, instead of just logging it to the console, right? So if you're ready to do that, then just come with me right to the next video. This will be a longer video where we're going to write a couple of functions for the search view. And so in this video, you're going to learn a couple of advanced DOM manipulation techniques. We're going to use ES6 template strings to render entire HTML components. You will learn how to create a loading spinner, which is really cool, I think, and a lot of other smaller things and techniques. So let's get straight to it. So we already have the file here, searchview.js. Let's close up this one here as well. And so, yeah. So this module will have a bunch of functions regarding the search view. And so we will export all of them using named exports. Okay, and so let's start by the one to read the input from our input form. Okay, so remember the syntax, we write export, and then when we're using named exports, we just write the name of the variable, the function in this case, that we want to export. So get input in this case. So what do we want to do in this function? Well, all we want to do is really to return the input value of the field. So we will select the DOM element, get the value, and then simply return it. Now we could do document.querySelector and all that stuff here again, but I think it's better to have one central variable where we have all of these DOM elements that we need in our app. And that's a bit similar again to the budgety app, where we also did something similar, because it's a lot easier to have everything in one central place instead of having these document query selectors all over the place, which can turn into a maintenance nightmare if we ever were to change like this entire underlying markup here. And with this, our views will get a little bit more decoupled from our markup. Okay, so let's now create a new module for that right here in the views folder as well. And I'm going to call this one base.js. Okay, and we can then also go ahead, before we forget, we can go ahead and import it here, or maybe not yet. Okay, let's first export some stuff here. So what we want to do here is to create an object which will contain all of the elements that we select from our DOM. So all the elements that we need from our app. And we will then export that. So export a variable called element. And so this will be an object again. And I'm doing it as a named export because later on we will have some more stuff here in this module. And so let's go with the named exports here. Okay. So let's call this one search input. And so what we want to do here is document.querySelector, and let's take a look in the markup again. And so the input field that we're looking for is called search field. So let's copy it. And here we go. So now we have an element with a property called search input, which contains this DOM element here, right? Now we also did some document.querySelector in here. And so let's actually get rid of that here as well. Let me copy it and insert it here. And of course, we're needing the name here. So search form for this one. And now let's give it a save. So you see that there's an error here. And so VS Code, this editor here, marks then this file here as red in the entire file tree. Okay. Now we need to, of course, import this element. And so we use the curly braces, remember, elements from, and this one is in views, and it's called base. Okay, and actually we can also already start by importing this search view file. Okay, so let's do, and in this case we are simply going to import all of the functions because we already know that we're going to need all of the functions that are in the view in the controller. Okay, so we want everything as search view. Okay, and remember that this will then be an object in which all of the exported variables from the search view module will be stored, right? So I explained you that in one of the previous lectures. I hope you remember that. So views and search view. All right, and so now we can say elements, and let's take a look at what we called it. So we called it search form. Let's get that. And so now we should be good to go. And from now on, we're simply going to put all of our DOM elements right here into this object. Okay, so let's do the same here again, actually. So let's get this one and import it here also into the search view. So element dot search input, right? Let's double check. And yeah, so it's called search input. That is our search field. And all we need to do now really is to say that we want the value. So remember that this is an arrow function here, of course. And if you only have one line, then this is an implicit return. So we don't even need to write like return. So this will automatically return this value that we specified here. So elements.searchInput.value, which will be whatever we input into the search field. Okay, now let's give it a try here and replace this pizza that we had here with what we really want. So how do we specify this function? Well, we simply use search view, which is, remember, what we imported from the search view module, and then .get input. And my text editor, VS Code, actually already knows that get input is one of the functions in there. So it's very smart, it's very handy. And so again, it's really a great text editor. Okay, just to make sure that everything works here, let's log it to the console. It should reload now, and we have an error here. So let's go back to search_view.js. And yeah, of course. So I tried to import the base element from the views, but we are already inside of the views folder. And so I don't need any of this. So we're in the current folder and then just base. Okay, and so that should work now. And yeah, it did. So instead of writing pizza now, let's write pasta. And indeed, it writes pasta to the console, gives me the recipes, which are now hopefully about pasta. Yeah, so pasta with pesto, then the best lasagna. And you see that they're all about pasta now. So great, that part is already working. And so let's now do the most exciting part actually, which is printing these results here to the user interface here into this left column of the app, right? So let's think about how we are going to do that. Well, here in the state.search.result, so this one here, this is our array with our 30 results, right? So let's now write a function in the view which can receive all of this result and then print each of the elements, so each of the recipes in that array to the user interface. So let's come back to our search views here and write another function. And I'm going to call this one render results. And what it's going to receive is, of course, all of the recipes. Okay, so we receive an array of 30 recipes here, remember. And so now we need to loop through these in order to then print each of these to the user interface. So let's say recipes.forEach, because remember that is the best way to loop through an array. So instead of having all the logic of printing here in this function, let's do a separate function that has only one purpose, which is to print one single recipe. Okay, and I'm doing that because later we will add some more stuff here when we implement the pagination. And so it's better to have one function for each separate task. Okay, so nicely separating different functionalities into different functions. So I'm going to have another function here, which is going to be called render recipe. And this one will receive just one recipe. Okay. And note that I didn't prefix it with the export command because we don't need to export this function to the outside. We just don't need it outside of this module here. And so it's just like a private function here. Okay, and so we can now call this function here. And we could do it in a more complicated way, like something like this. So with a callback function where we specify the input and then we say render recipe with the current recipe, but that's actually not necessary, because all we need to do is really to write render recipe like this, and it will then automatically pass the current element into this function, into this render recipe. And so for now, all that the render results function is going to do is to loop through all of the 30 results and then call the render recipe function for each of them. And so this is where the rendering will actually happen in this function here. So let's now get the HTML for each of the results, which is stored right here. So I have it here in comments into my HTML file. So what I have here is, let's do a quick overview of the HTML. So we have the header in the top. So you see the header, which is this entire element here. So all of this here is the header. Then on the left side here, we have the results element. And then in there, we already have the unordered list, which is called results list. Okay, so I decided to already put it in the HTML and not have it dynamically generated by JavaScript. So it's easier to already have this and then just fill it up with each of these li elements in JavaScript, which is exactly what we're going to do next. So we have all of these results here. And then down here, well, we have the buttons for the pagination, but we're going to take care of that later. Then in the middle, we have the recipe element. So this big part here. Then we have the shopping list on the right side, as you see. And then I guess, no, that's more in the top. So here we have then this likes panel here. So this here. We're going to hide that here later when there's no like pages. But for now, again, let's leave it as it is. Okay, anyway, what we really want to grab now is this code for one li element. Okay, so let's create a variable called markup. And now remember back in the budgety project, which we still did with ES5, and when we wanted to insert some HTML, we really had to put it all in one line, and it was this really bad looking and confusing syntax. But right now in ES6 with template strings, we can do it in a very easy way. So just make a new template string and then give it some space here, and now we can simply write it like this, as if we would be writing real HTML. So this is really cool, I think, and looks much better. So this looks really like as if we're writing in an HTML file. It actually looks a bit like React here also. Okay, and let's now look at the data and actually also at the final result in order to see how this is supposed to look once it's done. So I have this here also open in another port. So this here is the final working project, okay? So let's write pizza. It has this nice spinner that we're going to implement next, and then we have all the results. So what we have here is this image, then this title, and then down here the publisher. Okay, so let's see if we can find that data in our results. So let's put pizza here as well, and it should now log it to the console at some point. And indeed, here we go. So let's take a look at the data for each of the recipes. And so we have an image URL, we have the publisher, and we have the title, and also the ID. And so this is all that we need in order to print the results to the user interface. Okay, so let's go through the markup one by one and replace the static data here with our dynamic data coming from the API. So we'd start here with this part here, and this is actually the ID of the recipe. And you're gonna find out a bit later why this is important when we start loading recipes. But for now, let's simply insert the ID in here. So since we're into a template string, we can now use this template string syntax. So what we want here is, let's go back to grab the name of the property, and it is called recipe ID. Let's actually copy it. And so it's recipe.recipe ID, right? So recipe is the variable that we put into the function, coming of course from this function call down here. And so then from the recipe, we read the recipe ID. Okay, so going back here, and now we changed it, and so yeah, let's get it back here and wait for it, and here we go. So this object here is now our recipe, and then we need to read recipe ID, image URL, publisher, and title. Okay, so next one is the image URL, I guess. And so yeah, it is here. So let's replace this as well. Okay, now here we have the title. And finally, the publisher. Let's just copy this part. And here it's not, it's title. Okay, and let's actually put it here in the alternative text for the image. Let's put the title here as well. Okay, and I think that's it. We just have to remove this class from here, which is for the active class. So that one doesn't really matter. We just need the results link class. Okay, and so this here generates a variable containing the markup that we want to print. But now we need to actually, of course, render it to the DOM. Okay, so where do we want to render it? Well, we want to put it here into the results list. So let's add it here to this elements object. So search result list, let's call it like that, document dot query selector, and let's copy this one here now. And so elements dot search res list. Now remember the insert adjacent HTML method that we used before. Remember that one? Let's take a look at it just to remember how it works. Maybe it's been a long time since you've taken the rest of the course. So I always like to use the MDN library in order to get help about the different methods. So let's take a look at how it works. And so basically we have to specify the position and then the text, so the markup that we just defined. And in here we can do different keywords. So we can put before begin, before end, or after end. And here is basically the position of each of these 4 keywords. So imagine that this here is our list element that we just selected. And so we want our elements to be put before end. So here, okay? So we always want a new element to be put on the end of the list. So first the first one, then the second, then the third, all the way until 30. If we did after begin, then we would put the second one before the first, then the third before the second, and we would end up with the inverse order. Okay? And so we're going to use before end and then the markup. Okay? I hope that made sense. So before end and then of course the markup. And that's it. So all of this will be executed 30 times, each time for each of the recipes. So let's hope that this actually works. And in order to see it, of course, we need to import it here. So search view dot render results, and we need to pass in the recipes. So that is state dot search dot results. I guess. Let's take a look again at the model just to make sure. And it is called, okay, it's just called result. Okay, does it make sense? Just to make sure that it actually does make sense, we have this result stored inside of our state element, right? We also have our imported functions from the search view, which we did up here. And so now we're bringing everything together here inside of this function. So we read the input from the input field. This one we don't need anymore. Then we create a new search object which contains that query. Then we actually get our results from our API call, wait until that is done, and finally we render it to the user interface, so to the DOM, by using this method that we did in the search view just before. So let's now hope that this actually works. Writing pizza, and we don't have the spinner yet, of course, but let's wait if it actually happens. And now we have an error here. But that's not a problem at all, so let's try to debug it. So what it says is that recipes.forEach is not a function. So let's find out why by logging to the console what recipes actually is. So console.log recipes. Okay, because it's an array, and so it actually should have the forEach method attached to it. Let's wait for it. Pizza. And we still get the same error. And oh cool, yeah. This is of course just a stupid mistake. Okay, I'm sorry for that. So this is a capital E for each. This is how it works. Okay, so let's reload it. Write pizza again. And let's wait for the result here. And whoa, here we go. So it actually printed our results here to the user interface, just like we wanted it to work. So that is actually perfect. Okay, it's not quite perfect actually, but there are some things that we have to change here, but at least it's now really putting our results here to this page. So that's already a huge step forward. So that's really cool. Next up, there's just some small corrections that we need to do, like clearing this text here from the field. So let's take care of that now. And write a function export clear input. And we're missing the const here, of course. And so this is actually pretty similar to the one before. Elements.search input.value and set it to nothing. Okay, and now we're actually not returning anything here, so it's cleaner to wrap this here into these curly braces, because otherwise there's an implicit return of the result of doing this, and we don't want that. Okay, we're also missing the semicolons down here. It's not a big deal, but let's keep our code clean here. Okay, so clear input is the name of this function, and let's now use it here. So we're going to put it here in prepare UI for results. So search view dot clear input, and that's it. Now another thing that we want is, well, let me actually show it to you why we need to do this. So let's again search for pizza here and wait for our results. So we have our results here, of course, and you see that actually it cleared our input. And let's now search for pasta. And what you will see happening now is that it will add these new results here on the end of these. Okay, and so what we need to do is to actually clear the results before we can display them. And so that's another thing that we can put here in prepare UI for results. So we can clear the input and then also clear the results from the previous search. So let's quickly do that as well. Clear results. And we already have this list selected. So it's just a search res list here. And how do we remove the entire HTML inside of this element? Well, it's actually very easy. We can simply set the inner HTML of the element to nothing. And so the HTML inside it will be empty, which means that it will simply delete all of the HTML, so all of these li elements that are currently in it, right? So let's test that one out as well. So again, our first search is for pizza, which should display in a second here. Here we go. So again, our 30 results. And now pasta. And before showing the new results, it will actually immediately delete these results, right? Well, not really. And so probably our method is not really working. So yeah, it did add these here to the end. And of course it did, because we didn't even call this method here in the controller. So clear results here. And now it has to work. There's just no way around it. So this time pasta first. Here we go with all our 30 recipes, and now pizza. And you see now it cleared the search list and displayed the new recipes. Now the next thing that we're going to do is to shorten these titles. So we want all of these titles to be just in one line. And if they are too long, well, we just want the first words and then 3 dots here, indicating that the text can continue. So we have some of these here longer than just one line. And so we're going to fix that in the next video, because this one I think is already getting long enough. Let's continue coding up our search view. And so as I mentioned in the last video, the goal for this video is to now reduce this title size here whenever it occupies more than one line. Okay, so basically what we want is for these main titles always to occupy just one line. Now we also don't want to cut words in half. So in this case here, imagine we don't want the CRU, for example, to be up here and then having the rest of the word cut out. So we only want entire words here and then followed by like 3 dots, okay? So that's kind of a tricky small algorithm that we have to write here. And so let's see if we can pull it off, okay? So I'm going to add a new function in here. And once more, it will be like a private function. So it's a function that we don't need in the outside world. So const limit recipe title. And what we receive here is a recipe, and we can also receive a limit. So limit of characters that is acceptable as the maximum length of the title, okay? And let's now actually use something that we talked about in the ES 2015 or ES6 section, which is default parameters. So let's set this one here to 17. And I found out through experimentation that 17 is really the sweet spot here. So it's the best limit for this kind of layout here. But of course we could pass other limits into here. But if we don't pass any limit into the function, then 17 is the one that will be used. Okay. Now the first thing that we're going to do is to test if the length of the title is actually longer than the limit, because only then we need to do something, right? And here it should actually be title and not recipe. So we're only going to pass the title into this one. So if the title dot length is greater than the limit, then we have to do something. and else we will simply return the title again. And I'm not going to write the else statement here actually, so I'm not going to do this one here and then put return title in here, because we're going to have a return statement in here as well. And then it's a good practice to just leave it like this, okay? So we're either going to return something from here and then the function finishes anyway, and if this test here turns out to be false, then we move on to this one here and return the title as it was before. Okay, so this of course only applies if the title is longer than the limit that we defined. So how are we going to pull this off? Well, the best strategy that I came up with is to split the title into its words and then use the reduce method on the resulting array, which then allows us to have an accumulator. And that accumulator is just like a variable that we can add to in each iteration of the loop. And what we're then going to do in each iteration of the loop is to test if the current title length plus the next word is still under the maximum length. Okay, so that sounds probably a bit complicated, so let me write it out in code here, and then it will make total sense. Okay, so we take the title and then split it. So split is a method that is available on all strings, and we split it by space. Okay, so let's simply write an example string here as a comment. So pasta with tomato and spinach, for example. Okay, and so by splitting it by the space, this will turn into an array with 5 elements: pasta with tomato and spinach. Okay, and so since we now have an array, we can use the reduce method on it. So reduce, and then we pass a callback function which has the accumulator and the current value as the input. So X stands for accumulator and then the current. Okay. Or let's just write current like this. All right. So this callback function is the first parameter to the reduce method, and then the second one is the initial value of the accumulator, which should be 0. So we start with an accumulator of 0, and then throughout these loops we will add to it. Okay, and I will explain you how and why here in the next steps. So let's actually experiment with this example string here and go through each of these iterations here just to show you how this actually works. All right. So in the first iteration, the accumulator is of course 0, right? As we defined down here. Now we are going to test now in each iteration if the accumulator plus the current dot length, so that's the length of the current word, if it's still under or equal the limit. Okay, and if it is so, then we will push this word into a new array. So let's actually create that array like up here. So a constant new title and just a new array. Okay, and this is a constant which we cannot really mutate, right? So why are we starting it as a new array and then keep adding stuff to it? Well, that's possible because adding stuff to an array is not really mutating the underlying variable itself. And so the title can perfectly be a constant, and we can still keep adding stuff into the array. And the same goes, of course, for objects. Okay, so new title dot push the current word. So let's see why this makes sense. So again, the accumulator in the first one is 0. Then the accumulator plus the current length will be 0 plus 5, right? And 5, which is the result of this here, is still under the limit of 17. And so we can push this word into the new title array. So let's write it out here, that the new title now has the word pasta in it. Okay, and finally we have to update the accumulator. And this works in the reduce function by returning a value. So the value that we return in each iteration of this loop in the callback function of the reduce method will be the new accumulator. So we return accumulator plus the current length. So that's exactly what we did up there in the test. Okay, and so now in the next iteration, the accumulator will be 5, right? And let's actually copy this part here so that we don't have to do it over and over again. And so again, this is here just to simulate what happens in each iteration as we go through this. Okay, so in the second iteration, we're now looking at the word with, right? And so 5 plus 4 is 9, okay? And so 9 is still less than the limit of 17, and so we can add the word with to the array. So let's do that. And then next we return the accumulator plus current length, which will be 9. So in the next iteration, we will have 9 as the accumulator. The next word is tomato, so 6 plus 9 is 15. And 15 is still less than 17. So we can add the word tomato. Right? Then next iteration, now the accumulator is 15. And the next word is and, which is 3. So the current length is now 18, which is of course more than the limit. And so this word is not pushed into the array for the new title. Okay? Up here I'm actually missing the word tomato here. It's not a problem really, it's just so that it doesn't confuse you. Okay? Then in the next iteration, we will look at the word spinach here. And so just to make it really complete, we now have 18 here in the accumulator, plus the length of spinach makes it 24. And so of course it still doesn't pass this test here, and so spinach is also not pushed into the new array, and that's actually it. So we looked at all the 5 words, and our final array is pasta with tomato. Okay? So let's now actually return the result. So let's return, and I'm going to put this in a template string again, or new title, and then we can use the join method. And this is basically the opposite of split. So what this will do is that it will join the elements of an array into a string separated by spaces. And so that puts it back into a sentence with spaces between the words. Okay, and then the 3 dots. Oh, and I forgot to close this one here. And okay, so we have our new title, which is this array of the words, which will be joined by putting spaces into the words and then add the 3 dots to show that the title is longer than just the words that are displayed. So I hope this made sense to you. And we could have done this here with the for each method and having an external variable here for the accumulator. And we could have then in each of these iterations have updated that external variable. But the reduce method already has the accumulator built in, and so I thought it's a good idea and a good use case to use this method here. So we had to go through all of this a bit complex algorithm here just because we don't want to cut the words into halves and want full words always in our title sentence. And if you found a simpler way of doing this, then please let me know in the Q&A, but I think this is here actually a good solution and a good use case for some of the JavaScript features like reduce. And it's also always a good thought experiment to come up with this kind of code, right? So let's now actually use this method here. So I'm going to copy it, and where we need it is here in the render recipe function. So here is where we print the title. And so all we need to do is to insert it here and pass in the title, and that's it. So we could now pass here the limit, but as you know, we have it preset to 17, and so there's no need to pass the additional argument into it. So you notice that here in this curly braces in the template string, we can not only use the variables directly, but we can also include functions like I did here. And so that's pretty handy here as well. Okay, so let's now actually test this out. So I'm using pizza again, and let's see. And indeed, here we go. Well, there's something wrong here, so a small bug somewhere where I'm inserting the parentheses. And yeah, here it is. So that shouldn't be there. And so let's now check it out again. Writing pizza. So if you count the characters here now, you will see that they're never more than 17. So 4 and 9 and 14. So that's less than 17. Here we have 4, 8, 13. Here we didn't even need to apply the algorithm. And so we immediately just returned the title because it's only 8 characters long. This one is also less than 17, and so you see that all of them are just on one line now. If we were to increase this here, let's say to 20, then there will probably already be some words that are different. And let's actually do it here. So we can pass 20 now to overwrite that 17. Let's give it a try now. Yeah, we really need that spinner here for the feedback. And so you see that here, these 3 dots, they now moved to the second line already. So that one was too long. Here is the same situation. Here is the same thing. And so, yeah, 17 is really the sweet spot that's best here. Okay, so that's done. And now all there really is to do is to implement this small spinner here that rotates while we are fetching our data from the API. So in order to give the user the feedback that we're actually doing something here and that the app is working. So let's do that right in the next video. Let's continue where we left off in the last video and build our loading spinner. And in order to implement the spinner as fast as possible, let's remember that it should appear here in the search results list, but also here in the recipe whenever we click on one of these results here. Okay, so we should have that in mind and build this spinner, this loader, for reusability. Okay, and so let's actually not include it in the search view, but in base.js. Okay, because again, this is not really just for the search, but we're gonna use it later also in the recipes. Okay, and so base here is basically where I put the styles that are reusable and other stuff like these elements. They're also being used and reused across different modules. So let's say export const render the loader. Okay, and now we actually want to pass one argument into this loader, and that is the parent element. Okay, so remember what I mentioned in the beginning, that we will do this loader here for reusability. And so the best way of doing this is to pass in the parent and then say that we want to attach this loader here as a child element of the parent. And so in the case of this list here, we can pass in this parent element here so that the loader will be attached to this. And if it's the recipe, we can then pass in this parent element. All right, so let's create a variable called loader. And then using the template string method that I showed you before. So we're just going to write some HTML here. This one I cannot copy from anywhere, so let's just write it out here. And actually, even inside of JavaScript here, this HTML still gets auto-completed, which is pretty amazing, I think. So we have this div with the loader class, and then in there we have an SVG. And so this is an icon. And then use href, and then in our images, it's the icons.svg, from which we select the icon CW. And that's it. So how does this actually work? So let's take a look at our CSS file here. So that's the CSS file. Let's search for loader. And here we have it. So we style the loader here with this height, this width, and this fill. But the magic really happens here, which is this animation, which is an infinite rotating animation. So that's the animation that I defined here with the keyframes at rule. I'm not sure if you're familiar with that. But anyway, we have this animation here, which basically makes this icon rotate 360 degrees. Then we say that we want it to be infinite. And so basically, as long as the element is on the page, it will keep rotating. Okay, and that's as simple as it gets. So really simple stuff here. That's all we need to do here in this situation. Now, where do we actually attach it to? Well, that's the parent that we pass in. So parent, and then again, we use our insert adjacent HTML. Let's take a look again at the documentation here. And so this time around, we're going to put it right after begin here. Okay, so right at the beginning of the parent element. So let's copy this function here. I'm not going to write it out myself. So after begin, and what we want to attach actually is the loader. All right, And that is it, I guess. So moving over to our index.js file here, we now need to edit here, prepare UI for results. So the first thing that we want to do, or actually not so, after clearing the results from the search view, we now want to render our loader. So let's say, and actually we have to import it still. So it is here inside of this base file, right? And so let's actually add the render loader. So these are all named exports. And we could actually have done it with the asterisk import here. So basically importing everything at the same time, but I'm keeping it like this because later we are actually going to add some stuff here that we're maybe not going to use here. And so we don't have to expose it to this global index.js file. Anyway, we can now use render loader here. And all we have to do now is to pass in the parent element. And the parent element where we want this to be is actually this results. Because the results list is an unordered list and we don't want the div inside of that. So this is only for li elements. And so let's actually attach it here in this div. So it is called results and we need to then add it here into, of course, into this elements. So search document.query selector Okay, let's copy out this one. So elements dot search res. So this renders the loader. Okay, close this one up and let's check it out. And here we go. So here it is. And it keeps rotating and rotating and rotating, waiting for the data to come back. And here we go. So here is our data, but the spinner is of course still rotating here. So that's not ideal. And so let's get actually rid of it. Okay, but let me just inspect it here for you to see it. So that's the icon that we included and with the infinite rotating animation here. So that's our spinner. Now we also need a method to get rid of it, right? So let's get back to our base.js and create the clear loader. And this time around, we don't need to specify the parent. All we need to do is to select the loader. Now, right now, we cannot really select it like we did here in the elements. And that's because by the time that this code runs, the loader is actually not yet on the page. And so we cannot select anything that is not yet there. So what we need to do here is to do the document.query selector right here. So const loader document.query selector and then the class. Now it really bothers me to hard code this class into this query selector here now. I really want all of these classes like to be in a central place. So just like we did here. So this is a lot cleaner. And in order to achieve the same thing, we will actually create a new object like this. Element strings this time around. So I'm going to call this one loader, and it has the class name of loader, as we already know. Okay, so down here we now can say element strings dot loader, and the same thing actually up here. So if we were ever to change now the loader name in the CSS for some reason, then all we had to do would be to come here to this element, change it here, and then it would work automatically here in both of these methods, instead of being hard-coded down here and also here in the render method. So maybe you think that's a bit overkill, that's not really necessary, but I like to keep things like that because I'm always looking for usability and maintainability. Because that's something really important in all coding, not just JavaScript, but also CSS and whatever really you're writing. Okay, so in here, we now selected the loader element. Now let's test if it exists so that we can then delete it. Okay, and actually this here is not ready yet because we still need to add the dot. So let's do that using a template string. So dot and then this part. All right, and we cannot add the dot in here because then the dot would also be here in the class name, and we don't want that. So this really has to be just a class name, and then we add the dot here for the class selector here right in the query selector. Anyway, if there is a loader, then we want to delete it. And maybe remember from the Budgety app that deleting an element from the DOM is a bit strange. So we have to go up to the parent element. So parent element, and then basically we move down again and remove a child. Okay, so in order to remove an element, we always have to remove a child. And in order to do that, we need to move up to the parent. Okay, and so we pass in the loader again, which is our element, and that should be it. Okay, so what we want to do here is when we render the results, we first want to start by removing the loader. Okay, and again, we need to actually pass it in here or import it. So we want to render and we want to clear the loader. So all of these methods, we want them to be available here. And so let's say clear the loader, and that should do the job. So it already reloaded. Let's search for pizza again. Whoa, what's that? Well, something's wrong here. I mean, it did the functionality, so it added the loader and then it removed it. But I guess something is wrong with the class names. So yeah, of course it's not elements, it's element strings. So here and down here, it should be element strings. Give it a save. Let's try it again. And yeah, here we go. So now it rotates and it disappears as soon as the results come back. So that's exactly the look that we were for. Okay. Now, next up, we have to implement the pagination. So right now we have all of the 30 results all on the same page. And that's not really helpful because it makes the page way too long. And so what we want to do is to have 3 pages with 10 results on each. And so in the next lecture, that's what we're going to take care of. So see you then. As a last step in the search functionality, let's now implement the search results pagination. And in this lecture, you will actually learn some cool new stuff, including the super useful closest method for doing event handling in a much easier way, and also how and why to use data attributes in order to read data from HTML5 elements. And so let me first show you what we're actually trying to achieve. So I'm going to my working example here. And so what we have down here is this button which has page 2. When we click it, then we have the next 10 results. We can go back to page 1 and to the next page, page 3, and then we have the next 10 results. And then of course we can go back all the way to page 1. And so let's now go ahead and implement that in our code. And we will implement this functionality in 3 steps. So the first step is to change the render results function, because that's the function that will be called whenever we click on one of the buttons. Okay, so we not only need to pass in the recipes now, but we also need to pass in the page that we want to display. And we can also say that we want to pass in the results per page. Okay, and we can set these here as a default to 10, let's say, and we can also start with page number 1 as a default, but of course we can then override it. Okay, makes sense? So imagine we click on the button to go to page number 2, then this render results will be called and page will be set to 2. Okay, then the second step that we need to implement later is to render these buttons actually on the interface, and then the third step will be to attach some event handlers to these buttons in order to actually make the functionality work. Okay, but let's start with changing some stuff here in the render result. And it's actually not really difficult. So what we want to do here is to not display all 30, but only the number of results per page. So in this case here, 10. Okay, and so let's define a start variable. Let's set it here to an arbitrary number for now, and we're going to implement this logic here later. Okay, but for now let's just put some random numbers here. So we have a start and an end variable. Let's set this one here to 10. This one here to 0. Okay, so that I can now show you what we actually need these variables for. So what we're going to do then, after determining which should be the first recipe to show and which one is the last, well, then we can simply take a part of the total array. So remember that this recipes here is the array of all the 30 recipes. So we can now take just a part of this, which is done using the slice method. And I think we've used this before in one of the other projects. And so the first parameter that we need to pass in is the first point where we want to start basically copying the array. And that's at start. And well, you can guess it. The second parameter is for end. And let me actually show that to you, just so you can become more familiar with the documentation. So I usually always like to use whatever I'm searching for and then MDN, which is in my opinion the best web documentation out there. Okay, so you see slice returns a shallow copy of the portion of an array into a new array. Okay, and so we can pass in the begin and the end, which is exactly what we did. And both of them are 0-based indexes. Okay, so how do we actually calculate the start and the end? And the best way to figure it out is with an example. So let's say you're on page 1, and so you want to start at 0, right? Because the index in the array is 0-based, and so the first position is 0. So on page 1, you want to start on 0, and you want to end on number 9, right? And with that, we will select 10 elements. Now, if we were on page number 2, well, then we would like to start with number 10 here, like this, okay? So how do we implement this? Well, we can simply say page minus 1 times the results per page, right? And that's it. So again, on page number 1, it will be 1 minus 1, 0, and so we will start on 0. On page number 2, it will be 2 minus 1 is 1 times 10, so we will start on page number 10. And of course, on page number 3, it will be 2 times 10, and so we start at 20. And this will actually work for whatever page you passed in here. So we could hard code it specifically just for page 2 and 3, because we know that right now from the API we only get 30 results, but imagine that the API would change in the future and we would get 100 results. And then this code would no longer work, and if you do it like this dynamically, then everything is going to work. Okay, and then the end is actually just the page times the results per page. And that's it. So on page 1 it will be 1 times 10, so 10, and then 20 and 30. And what this means is that actually the end number here is not actually included in the new array. So let's take a look at that here in the doc again. So here's what I was saying. So slice extracts up to, but not including the end. And so when we put 10 here, it will really only copy until 9, which is exactly what we want. So 10 results. Okay, makes sense? So let's actually now go ahead and test this. And if we do it right now, it will actually already work, I'm sure. So if we now type in pizza, we will only get 10 results. So let's wait for it. And let's count them actually. Put some more space here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Perfect. Let's change it here now as a default to 3. And actually, let's also change this one here to 5. Just to see if everything works. And indeed, we get 5 results. Put it back to 10. Let's check it out again. And indeed, here we go. All right, so that's now implemented. Let's now take care of rendering the actual buttons. So let's write a function, render buttons. And you see that this is again a private function. And that's because we will call this function from the render results. Okay. So what do we actually need here? Well, let's put in just a page for now, and we're going to add more arguments later down the road if we need them. Okay, so of course we could have done this functionality here, so the rendering of the buttons right inside the render results. But again, I like to keep different stuff in different functions here, so to make it more reusable and more maintainable. So the goal of this function here is to render the buttons according to the number of the page that we're on. So let me show it to you again, how it should work in the end. So when we're on page 1, then it should only display the button for next. If we're on the second page, so not the first one and also not the last one, then we have both buttons to go back and also to go forward. And when we're on the last page, well, then we only want the button to go back. Okay, so how do we actually now implement this? Well, we need to know on which page we are and also how many pages there actually are. And how do we actually know how many pages there are? Well, all we have to do is to divide the number of results by the results that are displayed per page, right? So we need to pass in that data to our function. So we need the num of results, and we need how many results we have per page, right? Does that make sense? So let's call this one here pages, which will mean, again, how many pages there actually are. And we calculate this by doing the number of results divided by the results per page. So in our example, we have 30 results, and on each page we have 10 results. And so 30 divided by 10 will be 3. And so now we know that we have 3 pages. Now imagine that for some reason this changes here again. So if the API changes in the future, and instead of 30, we get back 45, for example. Then 45 divided by 10 would be 4.5 pages. And we don't want that, of course, right? So we want not 4.5, but in this case, we want 5 pages in order to have room to display all of the results. And so we have to use a function which is part of the math object, and it's called math ceil. And so this will basically round it to the ceiling, so to the next integer. So if we had 4.1, then it would round it up to 5. If we had 4.4, it would also round it up to 5. Because if we used normal rounding, then, well, 4.4 would be just 4 pages, because it would be rounding down, right? But we always want it to the ceiling. Okay, so we have 3 pages. And so let's now do some if-else statements. So saying what we just said when we looked at what buttons we want available on each page. So if we are on page 1, so page is 1, well, then we want the button to go to next page. So for now, I'm just writing it down here so that we can then know what to do. Else if, so if we're on the last page, we only want the button to go to the previous page, right? So how do we say the last page? Well, it's just that the page is equal to pages, right? So if we have 5 pages and we are on page 5, well, it means that we're on the last page, right? Here, let's say only button to go to next page. And here we only want the button to go to the previous page. So these are the 2 edge cases, but then we also have the case that we are in one of the middle pages. And so that means that the page is less than pages, right? So in this case, we want both buttons. Okay, now imagine that we only have one page. Then in that case, we actually don't really want to display any buttons at all, right? So let's say here that the page should be 1 and pages should be greater than 1, okay? Which means that there are actually more than 1 page. And the same thing applies to the last case. So in case that we're on the last page, well, we really only want a previous button if there are more than 1 pages. And so let's now actually write the code for the buttons. And you see that we will have a lot of duplicate code here, right? Because we will have a button here, and here we will actually have both buttons, and here we will again have a button. And so all of this HTML code will actually be pretty similar. And so what we can do is to once more export it to an outside function. Okay, so let's do that. Const create button. So what do we need to pass into this function which is going to render the button? Well, we need to pass in the number of the page that we're in so that it can then print that number to the interface, and we will have to say if it's a button to go back or to go forward. And so let's call that one the type. Let's now go to the HTML and actually grab the button here, because it should already be somewhere here. And let's actually get this here as a comment. And now before we paste it here, I can see that we can actually get rid of these parentheses, because all we really want to do from this function here is to return the markup for this button. Okay, so we're going to render it down here inside of the render button functions. Okay, and so from here we are actually only going to create the markup. And so we just want to return a template string from this one here. And so this is now just some regular HTML here as a comment, as you know already. Okay, so this is just so that we see what's the difference between the previous and the next button. So you see here that we have the results button previous and the results button next. So that's one of the differences. And also here in the icon. So here we have left and here we have right. Okay, but that's actually all there is. So let's go ahead and copy this one here. That's not correct. All right, so let's start with the number here. So imagine that we're on page number 2 and that we want a previous button. So in that case, we want to say page number 1 here, right? And in case we are on a next button, well, then we actually want page number 3. And so depending here on this type, we can now specify what we want to display here in this page number. So let's say that here as the type, it can either be previous or it can be next. Okay, and both as strings, of course. So in here, whenever we call this create button, we are going to pass in the number of the page that we're currently in, and either if it's a previous or a next button. Okay, and so let's now use the ternary operator here in order to make an if-else statement, but in just a single line. Okay, so we can say if the type is previous, so previous, well, then what we want is page -1. And if it's not, then we want page +1. Okay, makes sense? So imagine we have a previous button and we're on page number 2. Well, then we want to display that we want to go to page number 1. So 2 - 1. But if we have a next button, well, then on that button, it should say page number 3. And so that's page +1. Okay, next up, we can do the same here for the icon. So we have left and right. So again, if it's a previous button, then the arrow should point to the left side, and in the other case, it should point to the right side. Okay, and so that icon here coming from the icons.svg will then display exactly that, what we want to do. Next up, we have this class name up here. So results button previous for the previous button and next for the next button. So here we can simply plug in this type. So let's get rid of this and just say type. Simple as that. And so that's almost it. There's just one more thing that we need to do here, which is to actually plug in the data into this button containing the number of the page where we want to move whenever we click this button. Okay, so basically we need to encode this number here, and I can actually copy it right now so that it's stored inside of this element, inside this component. And so in HTML5, there's something called the data attributes. And so we can say data, and then we can specify a random name. So like go to, so go to page, so the page that we want to go to. And then let's simply paste in here the number that we want to be here. Okay, and we're then going to use this property here later when we attach the event handler to these buttons. Okay, so just keep in mind that we're going to use this one here later, and by then I'm going to explain to you why. Now all we need to do is to call actually this function here in all of these different cases. Okay, so create button with the current page, and then in this case here we want the prev, so the previous, right? And actually no, we want the next, of course. From page number 1 we want to go to the next page. Now this here should then be assigned to a variable, right? Now we cannot use a const here, right? So we cannot say const button, and that's because const and let, so the new ways of declaring variables in ES6, they are block scoped, and so they're only available inside of this block. Okay, and so if I declare it inside of this block, well, then button is not going to be available outside of this block. So what I have to do instead is to declare the variable outside with a let, because we will want to change it. Okay, so we cannot use const here because we then want to reassign it. Okay, so now we can say button, in here. We can say button here, but with prev. And then we can also say button in here. But here, remember, we actually want both buttons. And I'm not sure why I deleted the comments. Let's go back here. So prev, and here we want both buttons. So now we need a string which contains one button for next and one for prev. So let's do that. So a template string again here. I'm not sure why this one closed. So one for next and one for previous. Okay, so I created a string which contains the result of calling this function here 2 times. So these 2 strings. And so we will then have these 2 buttons. Okay, so all we need to do now is to actually then insert this new element right into our DOM. And so where do we actually want this? Well, let's go back to our HTML, and well, it should be inside of this div here called results pages. So let's add it to our element. So we have search res and search res lists. Let's now add search res and pages. So elements dot search res pages dot insert adjacent, and not element but HTML. We want it at after begin, so right at the beginning of the element, and then of course the element we want to insert, which is of course the button. Whew, so that was a lot of code. Let's actually take a look if this is working. Okay, so this is our result. Oh, and I see an error here already, and it is in base.js. Let's take a look. And actually it is red here in the code editor. It was already telling me something's wrong. And for some reason I added this semicolon, which I shouldn't. And so let's see if it works now. Give us some more space. And I do not see any buttons down here. And yeah, of course I don't, because we did never call the, where is it? So we did never call the render buttons. Okay, so let's go ahead and do that. So some comments here. Render results of current page. And render the pagination buttons. So render buttons with the page, which is page. The number of results is the length of the recipe, right? So recipes is the array which contains all of the recipes, and length then gives us the amount of recipes that are in there. And then finally, the third one is results per page, which is just results per page, which is this one that we get as an input to this function. And so let's take a look at that again. And so, well, something is not right here. And I guess, yeah, the problem is that we're still on page 3. So of course we always want to start on page number 1. And so here we go, page 2. Well, the icon is not really at the right place, but we're gonna take care of that in a second. And then of course, if I click, then it doesn't do anything yet because we didn't yet attach the handler. Let's just inspect this element here so that I can show you this data attribute that we added. And so this one here. So we have the data.goTo, which is set to 2. And so next, when we're adding the event listeners, this is how we'll know which page we should move to. Okay, so instead of reading it from the text, so from this DOM element here, we will simply read this property here, which is a lot better. Okay, so it works on page number 1, and so let's hope it also works on page number 2. And we're gonna test that once we have our event handlers properly working. And so that's what we're going to do next, actually. So that's going to be in the controller again. So in the controller is where we have all our event listeners, and we then control what should happen based on what was clicked, of course. Now in this case, we actually have a small problem, because where do we actually attach these event listeners to if the pagination buttons are not yet there when the page is loaded? And so we have to use something called event delegation again. So we used that before in the course. And so the concept is that we attach the event listener to an element that is already there, and then we try to figure out where the click happened so that we can then take action based on that. Okay, and so the element that is actually already available at load is this one. So results page, which is where we put the buttons into. And so that's where we have to put our event handler. So elements dot search res, and it is here pages. Add event listener on click. We want to have access to the event so that we can then use the target property. Remember that one. And so let's actually log it to the console. So e.target. So e is our event here, our click event in this case, and then the target. So exactly where this click happened. Now in order to be able to view two buttons and not just one, let's go to page 2, because then we should have the previous and next button. So let's test it out. And indeed, we have page 1 and page 3. And so let's now click on the buttons. And you see that here now we have the element where the click happened. Now I clicked here on this text. Now watch what happens when I click on the icon. You see that we then get the icon. And if I click here outside really on the button, well, then we get something else. And so how do we actually now define where we want the click to happen? Or in other words, how do I say that I want something to happen when I click on this button, when in reality I'm clicking at this text or maybe even at this icon and not really the button element itself that I'm looking for? So how can we do that? Well, we actually have something that helps us in JavaScript for dealing with just that. And that is the closest method. So again, let me try to show that to you. So it works on all DOM elements, and you see that closest returns the closest ancestor of the current element, which matches the selector given in the parameter. Okay, so let's see that in action. I'm going to create a new variable here actually. So let's say button. So e.target. And now the closest. And so now in here we put a selector. And the selector that we want is the class of the button that we're actually looking for. So let's go back here. And so what we're looking for, and well, now it's gone, so I cannot show it to you anymore. But the button that we're looking for is the one with the button inline class, right? So I showed you that we sometimes click on this SVG here or on this span, but really we're only interested in clicks to the button itself. And so we can now use the closest method and say that we are only interested in the ones with the class of button inline. Okay, and now I should actually go ahead and save this in the element strings here. So put it in here, but I'm not going to do that because then I would have to do the same here for this one and for this one here as well. And so right now I'm not going to go down that route. Okay, so let's keep it simple here. And right now I'm going to simply log the button. So what's going to happen here is that now, well, let me show it to you. So what happens now is that I still click here on the span or on the icon like this, but it will then find the closest element with the button inline class. So this is exactly the button that we're looking for. So no matter where I click now, we only get the button, which is exactly where this data here is located. Okay, so what we're interested for is the button where we have stored the page number. So this one here is page 3, and this one will of course show page 1. Okay, and so that's the number that we're interested for, and therefore we really need to just select this exact element and not any of their child elements. Okay, so let's now say if there is a button Then let's read the go-to page. Okay, and so now we're actually going to read out the data that is stored in that data attribute that I showed you. And it is so useful because all we have to do now is to say button.dataset.goto. And that's it. Let's log it to the console. And test it out, of course. And you see it shows me 1 and here 3. And that is again, of course, because it's saved inside of this attribute. So we can read out this data attribute whenever we prefix an attribute with data, then this variable here gets stored in the dataset.goto here in this case. Okay, and if it was something else, then of course, for example, if I had page here, then it would be dataset.page here. Okay, and so this is a very handy way of having access to data. Now you saw here maybe that this is not really a number, it's really a string, because a number looks like this. So it's in the console, it's shown blue, and so we have a string here really, and so we still have to convert it to a number. So we can use parse int, so it will basically convert it to an integer, and we still have to specify the base of the number, which is 10 here, right? So 10 just means that we're on base 10, so from 0 to 9. For example, if I were to put 2, then we were on binary, and so we will only use the 0 and the 1. But that's not the case, we are on base 10, so let's just keep it like that. Okay, now all we need to do is to use our render results method or function. Now all we have to do is to call it just like we did before, but specifying the page, which by default should be 1, of course. And so let's do that. So we used it before here to render, and here we didn't pass it any number because we could simply pass in number 1, but that's the default anyway, so let's not do that. So all I'm going to do is to just copy it here. I'm still leaving the go-to page down there so we can check it out, and then all we need to pass in is the go-to page. And that's it. That's all we need to do really. So I hope this is making a ton of sense to you, and I'm sure it is. So let's now click on 2, and it will add these new down here below. Okay, we also have all of this here, so that's not ideal, of course. So whenever we add some more results here, we first should actually clean out the list before we keep adding to it, of course. So we have render results, but before we do that, let's actually use clear results. And we did that before here again, so clear the results. And so now it's becoming really handy that we have it all nicely separated into our different functions and modules, because we are of course reusing all of this code from before, and so we just have to do clear results and render results again here. Just get rid of this one here. And the other problem was with these buttons, so we should actually also clear out the buttons. Okay, so let's do that in the clear results, and it should be here. So clear results, and so we also have to say search rest pages.innerHTML should be empty as well. Let's try it out one more time. So that is page 1, and here we go. Page number 2 with the next results, and finally page number 3. And great, that's awesome. So it's really working. Also, the numbers here are correct. What's just not correct is these, this should actually be on this left side, and this here should be on the right side. So I'm not really sure why that is happening, but let's take care of that for a second. For now, let's just appreciate that it's really working. So it tells us to go back to page number 2, because we are on page number 3. Now we're on page number 2. And so now it says go back to 1 or next to 3. And then here we just have the forward button, just as we said here in our render buttons code. So just as we did here, right? And the problem with the text being on the wrong side is just because this one here should actually come before the icon. Okay, and so now everything will be perfect. Just one last time before we can finish with this video, and so now it works. So perfect. So I hope that wasn't all too complicated for you. And of course, when you're doing your own app, you're not going to implement it in the exact same way. And so all I want you to really understand is the entire logic or behind this pagination. So basically creating the start and the end numbers and then rendering the buttons here according to the page that we're currently on. Okay. Also, it's important to remember event delegation, which is something really important again in JavaScript. And we did that here again. We did it on other projects, but so now here we did it once more for you to remember it. Okay. Anyway, this was a huge lecture. Great to see that you're still with me here, and take a break now and then see you in a second in the next one. Welcome back. Now that the search functionality is fully implemented, let's start working on the model for a single recipe selected from the search results. And so let's start by creating a new file in our models folder, of course. So recipe.js. And this one will actually be a bit similar to the search model. Okay, so let's open up this one here side by side. I can close these files. For now, I don't longer need them. So again, we're going to use access here for our AJAX call, and we will also create a class for this recipe to hold all the data for one recipe object. Okay, so import Axios from Axios, and we will export a default class called recipe. We give ourselves a constructor, and this time what we're going to pass in will be the ID. Okay, and then we say this.id equals the ID that we pass in. Okay, so each recipe is identified by an ID, and when we create a new recipe object, what we will pass in is that exact ID. And based on that ID, we can then later do the AJAX call in order to get the rest of the data for the recipe. Okay, and so that's actually the next method that we're going to code, which will be called getRecipe. Okay, and we already know that we're going to use an async here. And so for now, you're super familiar with this stuff already. Okay, let's then use a try catch, such as before. And here just console.log the error in case there is any. But what really matters is, of course, what happens here in the try block. So let's set the result to what we await from the AJAX call using Axios again. Okay, so that's again very similar to what we had here. Now we need again our key and our proxy. And so we could now go ahead and copy these here to the recipe model, but that's not ideal, because then imagine that we had a new key or a new proxy, then we would have to change it in two places, and that's not ideal. So instead of doing that, let's create a configuration file where we can store these two variables, then import this file into these two files, so into these two models, so that we can then use these variables in there. Okay, so we're going to do that right in the home, in the home JavaScript folder, so in here. And I'm simply going to call it config.js. And so I'm going to take these out of here and put them right here. Okay, now it's not actually the best practice to have this kind of data here stored on the client side. Okay, because everyone using your app can easily access, for example, your key. Now in this case, it's not really a big deal, but please remember to never store any real sensitive data like this, so on the JavaScript client side, okay? And ideally, you would do maybe these AJAX calls on your own server and then have your own API from that server, from where you would then do the AJAX call in the front-end client, okay? But for now, in this example, this is perfectly acceptable, okay? So let's then go ahead and import it here, first into the search, and we're going to do a name export, so key and proxy, from another path to the module, which is one folder above, so ... and then config. Okay, and so with that, our proxy and key variables are back here in this file. Just copy them to this other file, to the recipe. And so now we're good to go. Okay, now let's actually go ahead and copy what we have here and then do some changes, because the URL is really the same. Okay, at least up until this point. So let's take out this part. And in order to figure out how we get the recipe, let's then go back to the documentation. Okay, so we have the search and we have the get recipe, remember. And the search request should be to API/search, the one that we used before. And in order to get the recipe, we use API/get. Okay, and then the parameter is again the key, and then also the recipe ID, which is here called OR ID. So we use the get route, and then we pass the key into, and also the recipe ID. And that recipe ID will be the one stored in our object. So this .id, right? And that's it. So again, this axis call here will then return a promise, which we await because we're in an async function. And so again, we're using async await, which I believe is the best way of using asynchronous JavaScript. Okay, and now just to test this out actually, so in order to see what kind of data we get back from the server, let's just log the result to the console so that we can then figure out what exactly from the response we need to save. Okay, so this should work for now. Let's now go ahead into our main controller, import this recipe model, and then create a new recipe from it. So import recipe from same folder, models, and that's it. Let's add some small comments here. So this was the search controller. And then let's also have the recipe controller. Okay, so we're not going to do the recipe controller just yet, but we already then have our code ready for that. So let's simply create a new variable here for now, just to have a new recipe. And let's pass in an ID. Now, what ID do we actually want to pass in here? Well, let's try out one of the ones that we already have. So let's try to get one from our search result. So we use pizza again, and something did not work here. So we get this error here, and here we see that we have the proxy and the key both set to undefined. So there was probably something wrong with the config file. And yeah, indeed. So here we have to add to export. So in order to actually export these variables from the file. And now that should be working. So let's reload it. And now we should get back the results very soon. And here we are. Now, if we click on one of these, then we will actually have the ID here displayed in the URL bar, right? Because remember that back in the view, let's take a look at that. So in the search view, where we displayed the search result, so where is that? Yeah, so we put the recipe ID here in the href, so this hash symbol and then the recipe ID. Okay, and so that ID is exactly what we need to search for recipes. Okay, and so let's go ahead and copy this number here and then plug it in here into this new recipe. Okay, and so all we need to do now is to call the getRecipe method on this newly created object, right? Because of course this object here inherits this getRecipe method from its prototype. Okay, so that's basically how the ES6 class works behind the scenes with prototypal inheritance. So r.getRecipe, and that should then trigger this console.log here right after we receive back the data from the recipe with the ID that we passed in here as this number. So let's give it a try. It should now reload. It actually already did it here down here. So you already have the data here, and if you open up the data property, then we have our recipe in here. Okay, so we have data.recipe, and then in there we have all kinds of stuff. So we have the image URL, then we have an array of ingredients here. Okay, then we have the publisher, the URL of the publisher, the recipe ID again, and the source and the title. So the source is where the recipe actually comes from and where the directions are. And so we're actually going to need most of these properties that we have in here. Okay, so we need the title, we need the publisher, so the author basically, we need the image, we need the URL itself, and we also need the ingredients. Okay, and all of this data here live at data.recipe. Okay, so let's now go ahead and save all of these to our object. So we want to have the title, so this .title will be, remember, res.data.recipe.title. Okay, so res is the actual result, and then remember that we saw in the console that we have data.recipe where all of this data lives that we need now. Okay, so this.author, and I'm going to call it author and not publisher, is at res.data.recipe.publisher. Next up, we want the image. And let's actually just duplicate this here a couple of times. So the URL, which is called the source URL here in the data. And then finally, we want the ingredients. And so that should be working now. So let's get rid of this console.log here. And what I'm going to do instead here is to log our object. So again, this is just for testing, of course, but now I want to actually see the entire recipe. And so here it goes. And indeed, we have our author, the ID, the image, which for some reason is not really working. Then we have the ingredients, we have the title and the URL. So that's all that we need in order to display the recipe on the UI here in one of the next steps. Okay, now something wrong here with the IMG. So probably there was some typo there. And in here, I guess it's just image. Okay, so let's wait for it again. And here you go. So now it's actually there. All right, so that's the data that comes back. Now let's just add a couple more things to our data model. So let me show you how our app works in the end. So what we have here is not only the stuff that we got from the server, but we also have the cooking time and we have the amount of servings. Okay, so let's now add some methods to calculate these. Okay, so let's do calc time. Now, of course, we don't have an accurate way to estimate the time it takes to cook one of these recipes. So let's just do a very, very rough estimate and assume that for every 3 ingredients, we need 15 minutes. Okay, so let's start by saying that the number of ingredients is this dot ingredients dot length, because remember these ingredients here, it will be an array of all the ingredients. Okay, and so with length we get how many ingredients are in there. Then let's calculate how many 15 minutes periods we have. So periods, so we have the number of ingredients divided by 3, and we want to round it up to the highest integer. So math.ceil, and we already reused this one before, right? And so finally we can calculate the time, which is just a period times 15. Okay, let's add that comment here in order to make sense of this code. Okay, so something very simple here. And now for the servings, we're actually not going to do any calculations at all. We're just going to say that this.servings is 4. Okay, so again, we could have like a very complex algorithm here trying to figure out how many servings we are based on the amount of ingredients, but that's not necessary at all. We just say that we have 4 servings on each of the recipes. And okay, that's it for our data model. We're going to add some more stuff to it later, but for now this is enough to get us started with the recipes. Now to finish, let's just test out our error handling here as well. And let's add like an alert here so that the user can actually see the error. And let's actually just say something went wrong. And a sad face. Okay, and so let's assume that we put in the wrong key. So let's just add a couple of random numbers here. And so this, of course, will be a wrong key, and we should then have an error message. Okay, so let's try it out. And indeed, we get this error here, which says we have no access to this resource, which of course is because we have a wrong key. And then the user also gets this message here, something went wrong. Okay, so this also works. So the try catch here again is working. And so let's now start working on the controller of this recipe part right in the next video. In this video, we will implement a controller for the recipe section. And this is actually a pretty cool lecture where you will get some new knowledge. And so you will learn how to read data from the page URL by responding to the hash change event. And also how to add the same event listener to multiple events. So probably quite a long video, so let's get started. So in order to figure out how to implement the controller, let's think again about how we implemented the search functionality. So what we have here is that whenever we click on one of these recipes, we get the ID of that recipe right here in the URL bar, right? So take a look at this here whenever I click on these different recipes. So you see that the ID there changes. Now inside this URL, this entire part here is called the hash, okay? So it's the hash symbol and then whatever comes after that. So this here is the hash. And we can then actually make use of the fact that we change these hashes here whenever we click on one of these different recipes by using the hash change event in JavaScript. Okay, so there's an event that's called hash change that is fired off each time that the hash that we have in the URL changes to something else. Okay, and so let's go ahead and use that event. Okay, so this was just for testing here. And so let's now add an event listener. And this one we will actually add to the global object in JavaScript, so in the browser, which is window. So window.add event listener and then the hash change. Okay, and what we want to call here is the control recipe function, which we didn't write yet, but that's what we're going to do next. Okay, so we had the control search function here. And so let's now create control search. So first thing that we should do in here is to actually get that hash, okay? So I'm calling this one the ID. And we can get it from window.location. Okay, so window.location is the entire URL. And if we then use the .hash property on it, well, that's then just the hash. So let's try that one out. Console.log the ID. So remember that we have this event listener here whenever we change the hash, which will then call the control recipe, which will log the current hash to the console. Okay, and of course we need some examples here again. So here we go. So take a look at this, where the ID of the search item that I click here, which is this one, will be translated here into the console, right? So you see that? Now if I click twice on the same, then nothing appears because we didn't change the hash, okay? And so the event is not fired. But each time I click on a new one, then the ID is here, of course, in the URL in this hash, and then also down here. So great, that part's already working. Now what we're really interested in is only this part, so only the ID, but without the hash. So let's take care of that. And we can simply do a simple replace, because this is a string, and so we can of course call all the string methods on it, and we will then replace the hash with nothing. Okay, and with that, the hash symbol will be gone. Okay, so let's now go ahead and do something with this ID. And first off, we need to change if we actually have an ID. Okay, because imagine that we would simply do this, so get rid of everything, then we don't have any ID, and so we don't want to create a recipe object. So we only do all this logic that we're writing next in case that we actually have an ID. So let's add some comments here, just like we've done before. So get the ID from the URL. Then prepare the UI for changes. So this is similar to what we had before again. Create a new recipe object, of course. Then get the recipe data. Then we need to call our functions that they created for the servings at the time. So calc time and calc servings. So we need to call them here as well. And finally, when we have all of this in place, we can then render the recipe. Okay, so let's fill this here up with whatever we already have. So prepare UI for changes. We don't have any UI methods just yet, but what we can do here is to create the new recipe object. Okay, and of course, again, we will put this in our state. So we already have the search inside our state, and next we will put then the recipe. So state.recipe will be a new object based on the recipe. And of course, what we pass in here is then our ID. Okay, next up, let's get the data from the server. And so we need to call getRecipe, right? So that's one is at state.recipe.getRecipe. Now, of course, we want this to happen asynchronously. So in the background and in a way that the rest of the code is only executed after we get back with the data. So we are going to use, of course, await here, and don't forget to then change the function to an async function. So yet another async await function here so that we can load our recipe data in the background. Next up, state.recipe.calc servings. All that starts with calc time. Okay, and finally, we can then render the recipe to the UI. We cannot do that just yet, but let's simply log the object, okay? So state.recipe, because for now we don't have any UI methods just yet. Okay, so let's quickly go over that again. So we start by getting the ID from the URL by using window.location.hash and then replace the hash symbol with nothing, so that instead of the hash, we just end up with the actual ID that we need for the search. Then we create a new recipe object based on a model that we coded up in the last lecture, save it in our state, just like we did with the search. So again, all of our data is stored in one central place, which is the state that we can then get access to. Then after that, we call getRecipe here, which due to the fact that it's an async function will return a promise. And so therefore in here we use await to wait for the promise to get back with the resolved value. Okay, so here the code will stop executing, and then after that we will simply calculate the time, the servings, and log everything to the console. So let's test that one out. Searching for pizza again, and let's try this one, pizza dip. So we get the ID, of course, and then our recipe. And all the data is actually here. So that's amazing, right? So we can right now select recipes from our search list, and it will already display the data here in the console. So here's the next one. And if we click on another one, then of course it will work as well. And so great, that part is already working. Now imagine that we would reload this page here. Okay, then nothing happens, because again, this only happens whenever the hash actually changes. Okay, and so we need to fix that, because imagine that the user saves this URL here as a bookmark, for example, and then when he comes back, then nothing happens really. Okay, and so what we need to do also is to add an event listener to the load event, which basically fires whenever the page is loaded. So window.add event listener, load, and then control recipe. Now I promised you in the beginning of the video that I would show you how to basically add the same event listener to different events. And that's useful here because we're calling the same function here simply for these two events. Okay, so let me show that to you. And it's actually very simple. We just need to think a little bit about it. Okay, so let's comment out these two. And what I'm going to do is to do an array with these two events. So hash change and load. And then I will simply add a loop to it. So a for each, where each of the elements is an event. And I will then do window.addEventListener. And then in here we pass the event. So event, and then of course control recipe. And that's it. So we just went from 2 lines here to just 1 line of code. Now if we had like 10 lines with these events, then of course it would become even more useful. Okay, so let's get rid of this here, and I hope this made sense to you. So again, we saved the strings for these 2 event types into an array, and then looped over them and called window.eventListener for each of them, passing in the corresponding event. Okay, and so let's check it out now. Let's reload it, and you see that now it's happening. Okay, so the load event is now doing its work here, and it doesn't only work in case that the hash actually changes, but also if the page loads. Okay, and so now it's even more important that we have that if statement which checks if there's actually an ID. Okay, because right now there's not an ID, and so we of course don't want anything of this here to happen. Now finally, and this is something that we didn't do in the other controller, is that this await here can of course go wrong. So right now we're assuming that this promise here will always resolve, but of course it can get rejected. So we actually talked about that before in the last lecture, where I intentionally put a wrong key here. So in that case the promise rejects, and this will of course then also have an effect here on this async await, right? So in order to handle that event here as well, let's add another try catch here. And so we actually, all of this we only want to happen in case that everything goes well, right? And so let's just alert like error processing recipe. Okay, because of course we only want to render, for example, this recipe in case that everything goes well with getting the data from the server. Okay, so let's introduce an error here again. So a wrong key, which will then trigger an error. So let's just click on one of these, and of course it says something went wrong, which comes from the first catch, and then again error processing recipe, which comes from the second catch. Okay, so basically the first one comes from this catch block here, and so then this entire promise here will reject, and so we will then also enter this catch block here, which will then trigger this second alert. Of course, let's go back to the way it was before. And the error handling could of course be a bit better. So instead of having these alerts, we should add some messages to the user interface, but that's a bit too much for this simple example. And so I'm not going to go that way. Of course, you can implement that yourself if you feel like it. Okay, so that's it for this recipe controller. Now, since we're at it, let's implement the same thing here in this search controller, because we didn't do it up here. So again, we only want to render the results here in case everything goes right with getting the search results from the server. So try, and let's move up all of these and catch the error. Okay, and something else that we want to do here then is to still clear the loader. Okay, so we don't want to render the results, but we still want the loader to go away in case that there's an error. Okay, so that should be it. Okay, everything's working. And so next up, let's actually continue building our model here, because now we need to process these ingredients. Right now it comes back as an array with just 11 strings, but we want this to be a bit better. And so in the next lecture, we're going to take care of that. Let's keep working on our recipe model now, this time writing a complex function to process the ingredient list. And so we will use a lot of stuff here, like using array methods like map, slice, find index, and includes, and you will also learn how and why to use the eval function in JavaScript. So in this lecture, what we're trying to do is to basically read through the list of ingredients and in each ingredient separate the quantity, the unit, and the description of each ingredient. So for example, here we have 4 ounces of cream cheese. And here we have 1/4 of a cup of sour cream. And we need to have them separately for 2 reasons. First, because we later want to implement this function where we can decrease and increase the number here. And so of course we need to have them in a separate variable. And the same thing happens when we add these to the shopping list. We also have them separated here in the number, in the unit, and then the ingredient itself. So we can, for example, update this number here, and everything else of course stays the same. Okay, so we need a way to read through the list of ingredients and then parse each ingredient into the count, the unit, and the description of the ingredient. So let's take a look at a couple of our results here. So let's say pizza again. So let's wait for the data here to come back from this first recipe. And here we go. And so we have our ingredients here. And you see that we have these numbers here like 4.5 cups. Then we have some stuff here in parentheses. Then we have teaspoon, we have cup, now we have cups. Okay, and so all of these units, they are all different in each of the recipes. So here we have like teaspoon, but if we go into this last one here, let's wait for it. If we take a look here now, for example, here we have TBSP, which stands for tablespoons, but then we have teaspoons again spelled out like this. And so here we have cups, and probably somewhere else we have cup. And so we need to first, before we actually start parsing the ingredients, we first need these units to be all the same across all of the recipes, so that we don't have sometimes teaspoon and another times teaspoons and then TBSP and so on and so forth. So when we have cup or teaspoon or ounce, we always want it to be the same. Okay, and we also want to get rid here of these parentheses, okay, because they don't really add anything here in most of the cases. Okay, so we're going to rid of the parentheses. And then we need to kind of standardize the units. So let's start by doing that. So the recipe, and we add a new method, parse ingredient. And so what we're going to do is to create a new array with some new ingredients based on the old ones. Okay, so const the new ingredient is this dot ingredients, and now we will use the map method. So basically a loop over ingredient where in each iteration we can save a new item to this new array here. So in each of the iteration we have to simply return a value which will then be stored into the new ingredients array. Okay, remember that from one of the previous projects? So we pass in the element and then we have our callback function in here basically. And then finally we will then say that this dot ingredients will be the new ingredients. Okay, so that's basically how this is going to work. And so let's define what we are going to do. So first we want uniform units. So all the units should be all the same. Then remove parentheses. And finally into count, unit, and the ingredient itself. Okay, so how are we going to do this first task? Well, what I'm going to do is to create 2 arrays. In one array we will have the units as they appear in our ingredients, and in the second array we will have them written exactly like we want them to be. Okay, so let's do that out here. So units long. And so let's say that we have tablespoons. But we want it to be TBSP. And what we're going to do here is then to loop through this array here and see if one of these long units is there. And if it is, then replace it by the short version. Okay. Now, sometimes we saw that we also have tablespoon, like this, okay? And that is, of course, still TBSP. And so that's one of these cases where tablespoons or tablespoon can appear, but we still want it always to be the same, okay? And so that's a great use case for why we have to uniform these units like this. And the same happens with ounce. So it may appear ounce or it may appear ounces. And of course, they should both be OZ, okay? And so we have these data structures here which store the way that it may appear in the recipe and then the way that we actually want it to look. Now another example is teaspoon and teaspoons. So again, a plural, but we really want the abbreviation of TSP like this. And then finally, we may also encounter cups or pounds. And cups, we want it to be cup, and pounds, we want it to be just pound. All right. Now let's create a variable here called ingredient, which will be based on the current element. Right, so right now this element here is each of the elements of the array. And so we set ingredient to that L, but to lower string or to lowercase. Okay, and that's because it even may sometimes appear like with a capital T, something like this, for example. But we don't want to include all of these cases here in our long units. Instead, we can simply convert everything to a lowercase and then can start from there. Okay, and I'm using a let here because we are going to mutate this variable here in a second. And so therefore we cannot use const because then we could not change it. So as I was saying, we are now going to loop over the long units, so the one that are appearing in the ingredient. So we use for each, and then this is how it's going to work. So let me first write it out and then I'm going to explain it to you. So in our callback function, we need both the current element, which I call unit here, and then also the current index. Okay, and what we're then going to do is to manipulate the ingredient variable, as I mentioned before, so the one that we created up here, and we will replace. And what we're going to replace is the current unit, so that's the unit here in this callback function, with the unit short that we want. So unit short at position I. Okay, does that make sense? So the tablespoons here, for example, is at position 0, and this TBSP here is also at 0. And so if we find this tablespoons in the ingredient, then it will be replaced with the unit at the same position, but in this other array. So unit short, as we have here. Okay, so again, we loop over each of these long unit possibilities and replace that text with the shorter version, which appears in the same position. And that's why we have to repeat these here. For example, tablespoons, tablespoons, they're both the same here, but we have to repeat them so that they are still on the same position, right? So for example, this one here is at position number 5, 6, 7. So cup is at position 7 in here and in here as well, so that they can still match when we do this replacement here. Okay, and so right now the current ingredient no longer has the long unit, but the short unit. And so we can now move on to the second step with our ingredient already with the short unit in there. Okay, so next up, let's remove the parentheses, and that should be a bit easier. Now, sometimes when you're developing, you might not know how to accomplish a certain task. And so what you do is to basically Google it. So let's do that together now, just so I can show you how I usually do it. Okay, so what I would do in this case is to simply write JavaScript remove parentheses. Okay, so let's take a look at the results here. Remove parentheses from string, remove text between parentheses. So this is here actually what we're trying to accomplish. Then we can take a look at the example and see if it applies to our case. And so yeah, so imagine we have this and we want this. So the parentheses, including the text, should be gone. And so the solution is to use something like this. So we can just go ahead and copy it, and I will explain it to you in a second how this works. But for now, let's simply grab it and use it here. Okay, so we want ingredient to be ingredient and then replace. And we have to store it here in the new variable because this doesn't change the underlying variable, but instead it returns a new one. And so we have to change that result somewhere. Okay. Now, what is this weird replace here? That's what is called a regular expression. And let me show that to you also here. So let's write mdn regular expression. And regular expressions are kind of a complex topic in programming because they're really quite confusing. But in essence, regular expressions are patterns used to match character combinations in strings. Okay, so that's exactly what we're trying to do. In our example, we're trying to match a character combination which starts with the opening parenthesis, then has some text in it, and then closes the parenthesis at the end. So I'm not going to really teach you all about regular expressions, but as a basics, what you need to know is that they always start with these slashes, so they start and end. And so that's what we have here. So we start and we end here with this slash. And so we already know that this is a regular expression. Okay, well, let's replace this here by our normal quotes, which is the ones that we've been using all the time. And so we want to replace everything that is inside the parentheses and the parentheses themselves with nothing. So let's take a look again at the regular expressions. And all these symbols that are in the regular expression, they have different meanings. So for example, if you write this hat here, then it matches the beginning of an input. Or this $sign here matches the end of an input. This symbol here means that the preceding expression can happen 0 or more times, and so on and so forth. So this is really a lot of stuff that you can do here with regular expressions, again, in order to match different situations in a string, okay? So let's take a look again at ours. So an arbitrary amount of spaces, after that the parenthesis symbol, after that an arbitrary number of other characters, then the closing parenthesis, and then again an arbitrary number of spaces. So whenever we match that, we are going to replace it with a space. Okay, and whenever you need something like this, you can usually just Google for regular expressions for achieving something like this. So you can find regular expression for matching certain types of phone numbers, or of an email address, or of a zip code, or whatever you need really to match in a string. There's always a regular expression for that. And if you want to try to come up with your own, well, then you can just try to read this tutorial or read some other tutorial online. There are tons of them. Okay, so this one here removes our parentheses. Okay, and so let's now actually try to test it out to see how it works at this moment. Now, before we can do that, we actually have to return something from here. So return the ingredient. Okay, so as I explained at the beginning, that's how the map method here works. So in each iteration, we have to return something which will then be saved into the current position of the new array. Okay, now in order to not always have to write in pizza or whatever else that we might be searching for when we're testing, let's actually do the same here for the load event. Okay, so basically this is just for testing. Let's write that here. So whenever we test, we will start the control search, and we will, instead of getting from the input, we will simply write pizza. So let's check that out. And it doesn't work. And yeah, of course. I need to add this one here to the window. All right, so let's wait for it. And yeah, so automatically pizza here turns, instead of us having to write it here out all the time. Now, something else that we can do here for testing purposes, again, is to, let's take a look at it, is to expose this recipe here to our global window. Because right now in the console, we don't have access neither to the state nor the recipe or the search or any of that really, because it's not exposed to the global object, okay? But we can do that. So we can do, let's say window.r, which is going to stand for recipe, equals state.recipe. So testing again. And so right now we will have access to the recipe object right in the console because it's now on our global window object. Okay, so let's test that out again. And as soon as I select something, when it comes back. Now let's type R. And indeed, here it is. So here's our recipe. Okay, and so now we can then go ahead and call that parse ingredients method on it. So for example, this one here, we have ounces, cup, and ounces in tablespoons, all written out as a long form. So let's now say r.parse ingredient. Let's take a look at R again. So it should by now have changed our ingredients, right? And so it did actually replace it. So now it says OZS. So ounces, well, something is not right here, but it's probably just an S that I put too much. But here it converted the tablespoon as a long unit, as it was here, to TBSP, right? So that's perfect. And I see why it did that OZS thing, even if it's not written out here like this. It's because it found ounces probably, but then only replaced ounce. And so the S stayed there and it was then OZS. And so we have to turn it the other way around. So the S first and then the singular. And the same here for teaspoons and only then teaspoon. Okay, so that's a small detail. It's not a big deal, but I just wanted to show it to you. Okay, so this is the first one here. Let's say R parse ingredients. Take a look at R. And here we go. So we have cup, we have TSP, and we have TSP here, but we're missing the space now. Okay, and that's because of the parentheses. Okay, so we removed the parentheses and then didn't insert a new space, but instead we removed it completely, and so the spaces are gone as well. Because remember, here we also select the space in front and after parentheses. And so we have to add a new space here. Okay, so let's wait for it. Choose this one, or actually another one. Remember, it can't be the same thing because then it doesn't change the hash. Oh, we have an error here. I'm not sure why. So let's try another one again. So this one. And again, we get an error here. That's very weird, but it still works here. So, and so now parse the ingredients. Let's take a look at R, and now it should be gone. So yeah, so we have cup and TSP and cup. And yeah, so the first two steps of our processing are already working at this point. And so now really comes the hardest part, which is to separate the numbers from the units from the rest of the text. And as you can see, probably this is going to be quite difficult because, for example, in here we have all of this should be the number, then we have the unit, and then we have the text. But here we only have this normal number. Here we don't have any number at all. And let's take a look, for example, at this example. So let's wait for it to come back. Then we need to parse the ingredients actually. And so here you see the example where we have a number but no unit, but then again some text. And so each situation is really different, and so we have to be prepared for all of these cases. So basically we have the case where we have the number, the unit, and the text. Then we have the case where we have only the number and just the ingredient text and no unit. And sometimes we don't have any units and any number. So just like in this example of most of these ingredients down here. Okay, so how are we going to do this part, which is the most complex by far? Well, first of all, we are going to test if there is actually a unit in the string, and if so, where it is located. Okay, so the first thing is to convert the ingredient into an array. And I'm going to do that by splitting it through an empty space. Okay, so whenever there is a space, it will now be split, and each word will become a new element in the array. So we've used that here before, and so I'm sure you're familiar with it already. Okay, now comes the trickier part where we have to find the index at which the unit is located. Okay, so unit index. And so how are we going to do that? Well, the first thing that comes to mind would be to use index of, like this, right? But this one is not going to work because what we want to do is to find the position of the unit, but we don't know what the unit is. If we knew which unit we were looking for, well, then we could use index of. Okay, so for example, if we were looking for TBSP, if we already knew that, then we could simply ask which element of the array is equal to TBSP. Okay, but it doesn't work like this in this case because we don't know what unit we are looking for. Each ingredient has its own unit, or maybe not even a unit at all. And so what we're going to use instead is find index. And once more, this is an ES6 method that I actually already showed you in the ES6 section, but right now we have a real-world use case for it. Okay, so remember, into the find index function, we actually pass in a callback function. So for each element, which we're going to call element 2 here in this case, because element is already taken up here, well, basically for each of these elements, it will make a test. And what we want to test here is units.includes element 2. So how does this work? Well, includes is a brand new array method. I think it's like an ES7 or even ES8, and it returns true if the element that we're passing in is in the array, and it returns false, of course, if the element is not in there. Okay, so what we're going to do is for each current element, it will test if that element is inside of the units array. And what I mean here is units short. So this array here with our final short units. And so for each of the elements in the array, it will basically perform this test. Okay, so again, this is like a loop, but in the case of find index, it will return the index of the position where this test here turns out to be true. Okay, so let's again use the example of ounces, for example. So it will loop over the array and it will only return true when there's an element in the array that is ounces, and it will then return the index in which this here turned out to be true. Okay, and so that's the only way to find the position of the unit when we don't really know which unit we are looking for. Okay, so this is a great trick and a really great use case of find index, which is a great addition to the JavaScript language here. So it's really a cool new method on our arrays. Now, as we mentioned before, there are now several different possibilities here for the find index. So let's use an if-else statement. So if unit index is greater than -1, this means that there is a unit. Okay, so if it is -1, then it means that it couldn't find the element. So in this case, it means that all of this here turned out to be false. So basically, if none of these words here appear in the array, so in our original string here, then that means that this unit index will turn out to be -1. Okay, so we can actually already add that one here. Unit index is -1, then that means there is no unit. Okay, but actually there is another case. Okay, so there's the case where there is no unit, but still there is a number. Remember, so for example, one bread, that doesn't really need a unit, but there is a number and there is text. Okay, and so we assume that the number always appears in the same position. And so what we're going to do is to say array ingredient 0, which is the first position, and then we're going to parse it to a number, an integer, with the base of 10, remember. And so if this is successful here, so if it can be converted to a number, well, then this here will return the number itself and will therefore coerce into true here. Okay, there is no unit, but the first element is a number. Okay, so again, we're taking the first element of the array and we convert it to a number. And if the conversion is successful, well, then it will return that number, which will then coerce to true. And if it's not a number, then it will return not a number, which will coerce to false. Let me actually try to show that to you. So let's use parse int with this string here. And so it returns 234, which is a number. But if we had something else, so text, well, then it returns not a number, and that will then in turn coerce to false, leaving us with the third option, which is this here. there's no unit and no number in first position. So this one is the most straightforward case, and so let's go ahead and start with this one. Okay, so the first thing we're going to do is to create a new variable here, and it will have to be a let and not a const. And also it has to be outside of each of these blocks here, because again, let and const are block scoped. Okay, and so we need to define them outside of the blocks and then mutate them inside of one of these blocks. So this is the final object that we're actually going to return, which is the object ingredient. Okay, and for now it's empty here. We're just like initializing it. So our ingredient object will always have the count. It will have the unit, and it will have the ingredient itself. Now, in the case that we have no unit, well, the unit is empty. I will simply say that it is 1, because we have to put something here. And so rather than putting like 0 or something, we simply put 1. So for example, if it says tomato sauce without any ingredient, well, we just say that we need 1 tomato sauce. Okay, and now as for the ingredient itself, well, if there's no number in a unit, all we really want is the entire ingredient. Okay, so that variable here, that we split it up right in the beginning. So we can say ingredient, or even better in ES6, when we have an object which is like this, so when we say ingredient is ingredient, well, we don't need any of this. We can simply do it like this. So instead of having to repeat it, we just put ingredient, and well, it will automatically then create this property ingredient and assign the value to it. In this case, this one. Okay, so next up, we do the one where there is no unit, but the first element is a number. So this one is also not really hard. So the number we already know is this one here. So let's just copy it. So the count, the unit, we don't have it again. And then the ingredient, well, it's just the entire array except the first element. So the first element here is for the number, and the rest of the array is the ingredient. So array ingredient, then we slice it and say that we only want to start at position number 1, and if we don't specify the second argument, it goes all the way to the end, which is what we want. And so we have now the entire array except the first element, and now we have to put all of these array elements back into a string using, of course, the join method. Okay, so we had all of these array elements like Italian, tomato, and sauce, and now we just put them back together into a string here with this join. Okay, so these are the two easier cases. Let's now test it out before we start with the more difficult one, which is this one. All right, let's wait for it. I guess it's getting, yeah. So let's take a look. Let's say our parse ingredients. And let's take a look. And nothing really happened here. And I know why this is happening. It's because we didn't return the object, but instead we just returned the ingredient string, so the one that we were working with up until point number 3. Okay, so let's do all of this again. And you see that it already got back here with the recipe. So let's parse the ingredients. And so here you see some of these say undefined, and that's because we didn't yet take care of the first case. But the other ones, well, they now say 1, then the unit is empty, and then we have the ingredient. And so if we compare that with the initial state, well, we see that it's exactly correct, right? So here we had just these strings, and then now we have all of these objects where it says always 1, then the unit, and then the ingredient. Let's say if we can do the same with another one. So let's say parse ingredients. And now we actually have all of them undefined except the last one. Okay, so let's take this one here as an example to see what we have to do next. So you see that, for example, here the unit is the third element of the array, right? So the first element will be the 4, then the second element will be this 1/2, and then the third element will be the cups. But then in this case, in number 2, well, the first one is the number, and then already the second one is the unit. Okay, and so what we will do is to assume that everything that comes before the unit will always be the number. Okay, so in this case, we will say that 4 1/2 will be the number, and then after that comes the unit. Okay, so let's implement what I just said. So const, I'm going to call this one here array count, is in array ingredients slice from the beginning until the unit index excluding. Okay, so if the index is number 2, well, that means that position 0 and 1 will be for the count. Okay, so just like in the last example where 1 1/2 were the first 2 positions, so these 2 are part of the count. So let me write that down here actually. Example 4 1/2 cups. Our count will be 4 and 1/2. Okay, and now we need to figure out a number out of these values here. Okay, now let's actually get this here, and I will put another example because there can be, of course, different example. So if it was just 4 cups, well, then our count is just 4, right? And so we have different situations here. So you see that this is getting quite complex, and of course this is just a great exercise to think. Okay, so it's not really important that you memorize how you can parse recipe ingredients, but it's important that you understand the thought process that we go through in order to figure out how to accomplish the goal that we have. In this case, well, it's parsing our ingredients in the way that we defined initially. Okay, and so we use the tools that we have in order to achieve a goal that we established. And that's what coding is all about. Okay, so that's what I want you to understand. It's not really memorizing that I want you to do. It's just understanding how we can use these different tools to achieve exactly what we need. So again, we have these 2 cases here where there's more than 2 elements before the unit, and also the case where we have just 1 number. And in this case, it's really simple. So let's say if our count.length, which is what defines how many elements there are before the unit. So if it's just 1, then the count is array inc 0. And actually I have to define the count before, so just the situation that we had before. So defining it outside of the block. Okay, so if there's only 1 element before the unit, well, then that element is of course the number itself. So the count is then array inc 0. And that's not yet the final story, but for now let's assume that this is how it works. Now if we have more than 1 number, which is usually like something like this, so 4 1/2 or 1 2/3, something like this, well, then we have to do it differently. And so now I'm going to show you the eval function that I mentioned before. So what we're going to do is to basically join these 2 strings, because they are strings in this array here, okay? We're never talking about numbers, it's really just strings. So we're going to join these 2 strings using a plus sign and then do something called evaluate the string. Okay, so I'm going to explain you how and why. So the array of ingredients dot slice from the beginning until the unit index, right? So on these first elements, we are going to join them using the plus sign, and we will then evaluate whatever is the result of that. Okay, and we wouldn't have to do it like this, but this is just a great opportunity to show you this function here that you might encounter someday when you're looking at some JavaScript code. Okay, so this one here, for example, will turns out to be a string 4 plus 1 1/2. Okay, and what eval will then do is that it will evaluate this string here as being a JavaScript code. And so it will do the math here and calculate 4.5. Okay, so if we do eval of this, well, this will then turn out to be 4.5. Okay, so does this way of calculating here make sense to you? Now this is almost done now. There's just one edge case that we also need to talk about, which is what happens in this recipe here. So let's wait for it. So you see here in the ingredients that some of them, they have this dash. So instead of being 1 and then 1/3, it's like 1 minus 1/3, but it really means 1 plus 1/3. So it's 1.5 here, for example, not 1 minus 1/2. Okay, and so that is actually not good because none of our cases currently covers this. But what we could do here is to simply replace this minus with this plus and then evaluate that string as well, just like we did before. Okay, and so that's actually pretty easy. All we have to do here is to replace the minus with the plus. And then finally, of course, say eval like this. Okay, so if there is a minus, then it will simply be replaced with a plus, and then the string will be evaluated in order to return the correct number. Okay, so now all we have to do is to recreate this object here. So our final ingredient object. So this is really a long lecture here. There's a lot to do, and it could be even more complete. So there are still some edge cases which are not going to really work, but I think this is more than enough for what we're trying to do here. Okay, so our count will be our count, and so this is the same case as before here with the ingredient. We don't need to specify count equal to count because yeah, we already have this variable here with that name. So next up we have the unit, which is located at array of ingredient at unit index. Okay, and then finally we have the ingredient, which is also in array ingredient dot slice. And so we want to select a part of the array, and it starts right after the unit. So at unit index +1 all the way until the end. Okay, and we then want to join this, of course, back into a string. And all right, that should actually be it. So that was a lot of work. Let's test if it's gonna work. So let's get rid of this here. We don't need this testing. And also, where's the other one? And of course also this pizza here. So let's get rid of all of this. And then what we want to do here, before we display the recipe, we also want to parse the ingredients. So let's say and parse ingredients. And so we want state.recipe.parse ingredients. So let's take a look now. And it should be fetching our recipe here now. And indeed. And so now we have all of our units here, and it's actually working, you see? So we had 1 and 1/3, I remember here, and now it's this number 1333, which is the exact result of that. Now this part here doesn't really look right, so shortening, and then the rest seems kind of cut off. So let's actually try to log to the console here the ingredients without being processed. So console.log state.recipe.ingredients. And so here are the results. And actually it's correct. So it's shortening it and may substitute butter. Okay, so I'm not really sure what this is here. Maybe some of you will know what that actually means, okay? But anyway, it looks like this is kind of correct. So let's test it with a couple more results here. So let's take a look at this one. And I'm not sure if it did come back. Oh yeah, I guess I just clicked on the same one that was already active. And so take a look, and yeah, great. So we had 4.5 cups, and it was converted to 4.5. So perfect, this is perfect, it really works. So that's just amazing. Let's take a look at this one. I remember that this one here was a bit different from the other ones, but it should still be working. And indeed, yeah, it looks fantastic. So I think we're really done here now after a long lecture of writing all this code. And maybe this was not even the perfect code. So everyone will have different ways of achieving the same result, but I hope that this kind of made sense to you, and if not, then just go a bit through the code by yourself and try to really understand what happens here. For example, this part here, I find it a bit tricky here maybe to understand, and so try to go ahead and figure everything out on your own. That doesn't really make sense. Okay, anyway, take a break now and see you in the next video when you're ready for it. Let's now finally render the recipe in the user interface. And so that starts by creating a new views file here. So recipe view.js, and then also right away import it here. Okay, and now simply duplicating this line here and replacing search with recipe. Okay, so again, we're going to import everything into recipe and then use these different functions as like methods on this recipe view object. Okay, so the most important function that we want in recipe view here is to, of course, render the recipe. So export and render recipe, where we put in, and I forgot, of course, the equal sign. So we put in the recipe and then we render the markup that we're going to create here. So just like before, we create a variable called markup and give ourselves a nice template string. This here should be mark up. And now let's actually get our HTML code here. So we have an element called recipe already in our DOM, and what we're going to insert in here is basically all of this HTML code here. So all of this. So let's grab it. And that was too much. So that is our HTML. So let's get ahead and paste it here. Whoa, what's going on here? That doesn't look correct at all. Okay, so that is a lot of code and it looks quite confusing. So let's figure out what exactly we have to replace here. So first off, we have the image here. And so that's the first thing that we're going to replace. And so remember, we passed in recipe, and the recipe is obviously the recipe object. And so in there we have the property called img. And so that's where the URL to our image is stored. So image. Then as an alt text, let's just use the title. So recipe.title. Okay, and I'm actually going to go ahead and copy this one here because it's really always the same. Then in here, we also have the title. Okay, then down here, let's create some space here. We have the recipe details. So we start with the time. And so in here, we want the recipe time. So instead of 45, it's the custom time. Then here it is the servings, so 4 servings, and now it is recipe.servings. Let's take a look if that's correct. So yeah, so we have time and servings, right? Down here we don't really have anything important for now. And then next up we have the ingredients, and it's this huge list of stuff. And for now, let's get rid of this. Not all of it, but at least all of them but one. Okay, and so I'm going to come back to the ingredients a bit later here. For now, I just want to finish with the directions, where we have the publisher here. So the pioneer woman turns into recipe.author, and then finally down here we have the URL. So that's where the directions of this recipe actually are. So our API doesn't return us the directions on how to cook the recipe. It just gives us the link where the user can then go ahead and find it. Okay, so that is the markup here now, except the ingredients. And before we move on, let's actually render it here with insert adjacent HTML. And so let's go ahead to our, where is it? Yeah, our base file, and create a field here for recipe. And then go ahead and select that element. So document.querySelector. And remember that is actually called recipe also in the DOM. So give it a save, close it. And so we actually didn't import it yet. Okay, so let's simply copy it from this one here, so that we can now use it in here. So elements.recipe.insert adjacent HTML. And this one we want right at the beginning. So after begin, and of course, markup. All right, and now about our ingredients here. So of course we don't know beforehand how many ingredients there are going to be. And so we have to do it here obviously with a loop. Okay, so what we're going to do here is to basically take our ingredient and then loop over them. And so remember that inside a template string, we cannot only just put in the variables, but we can do all kinds of stuff. So recipe.ingredients.map, and so this will loop over them and create a new array that we can then use. And so in there we then have access to each of the elements, obviously. And so what we're going to do for each of the elements is to actually call a new function that I'm going to create in a second, which is render ingredient. Or actually, let's call it create ingredient, because it will not really render anything to the screen. So we will not create real DOM elements here. Okay, so create ingredient. Let's put it up here. It does need to be exported. And so this is just what I put into the function ingredient. Yeah, now it's correct. And actually we don't even need this, because such as before, we're actually just going to return a string from this one. Okay, so where's the code for this? And here we go. Whoa, what's happened here? Let's go ahead and put this right. And all right, now all we have to do is to replace this stuff here. So first off, we have the count, which is ingredient.count, remember. Then we have the unit, which here is gram. And then finally here is the ingredient itself. And right now I'm actually remembering something, which is that in a recipe, there's still something that we have to do. Okay, but let's leave that one for later. I hope I don't forget that I have to change something there. So this here will return this string to us that will then be put into this new array, but we don't want an array here, right? We just want a string. Okay, so the result of this here, we will simply join it. So join it, and that's it. Okay, so again, this here returns an array in which each of the elements is the markup for one of the ingredients. Okay, but we don't want an array, of course, inside our HTML. We just want regular text. And so we can simply join all of the elements together as a huge string containing the markup for all of these ingredients. And of course, once again, we could have done this all inside of this callback function here instead of separating it into a new function, but I think it's much cleaner having it like this. And with that done, let's actually test it out. So we have a search controller, we have the recipe controller, and now instead of logging it to the console, we want to render it, obviously. So first off, we clear the loader. So just like before, and actually we don't have any loader yet, so we first have to put it there in a second. But let's just start by putting the recipe view.render the recipe. And now we of course have to pass in the recipe. And so where's the recipe? Well, it is at state.recipe, obviously. Okay, so this clears the loader, but we still have to render the loader. And we do that right at the beginning here at prepare UI for the changes. Right? So we need to render the loader. And now we need to pass in the parent, remember. So we always need to pass in the parent so that the loader knows where to actually display itself, basically, okay? And so this one here is now at elements.recipe, remember? So the element that we just created before. So we render the loader, then we create the recipe, get the data, calculate all this stuff, then finally clear the loader once the data is back, and then render it. And so let's test it out now. And you see that it's already doing some stuff here. And that's because this one here is still active. And whoa, indeed, here it is. So we have our homemade pizza here. So at the time, the servings, all of the ingredients, it's all there. And also here the author. But let's test it out here. Right, pizza. So let's try it with this one here, for example. And now I see something. So we have to clear this old recipe before we can load a new one, okay? So let's wait for this one and then take care of that clearing. So next up, we need to clear this up, okay? So recipe view, and then simply export. So elements.recipe.innerHTML set to nothing. Okay, and so now each time that we want to load a new recipe, we first need to clear it. So recipe view dot clear the recipe. Okay, so we clear the recipe, then we render the loader, and then all the rest happens. So let's search for pizza again. And now we have these two spinning here, but that's no problem at all. And so we have our best pizza dough ever. Let's take a look at this one here, for example. But I can already see that everything's working just fine. Right? Oh, this looks delicious. Okay, so yeah, this is already working just fine. Now remember that I said that I needed to change something here in the recipe model. And that's because here we have some of the units, but there can be other units like grams or kilograms. Okay, and so in that case, we cannot really recognize it as units because, well, in here, for example, where we find the index for the unit, we test if it's included in the unit short, and unit short does not include like grams or kilograms. And so let's add these to this array. And what I'm going to do is to actually create a new array simply called units. And now I'm using ES6 destructuring. So remember, I can use these three dots to destructure units short. And what this will do is that basically it will separate it into its own components. So basically what this means is that instead of having an array inside an array, we will have all of these elements. So it will take these elements out and put them here. Okay, and then we can add like kilogram or just gram. Okay, so now all we have to do is to change it from units short just to units. Okay, and so now we can recognize kilograms and grams here as well. All right, now I'd already loaded because of the save that we did. So whenever we save something, then it reloads and it already has the hash here, and then it just loads the last recipe, which is actually perfect. So that's exactly what we want. Now let's just look at this example here, for example, and you will see in the ingredients, let's wait for it. Yeah, so you will see like this 4.5, 1.75, 0.25, and that's, well, that's not really ideal. So we want it back to like 1/4 or 4.5, like we had it initially, okay? And so we have to implement a function for doing that. So take a small break and see you in a second in the next video where we're gonna do exactly that. Hey there! So let's now continue building our recipe view. So in case you don't remember, where we left off is that we now want to create a small function which basically converts these decimal numbers here into fractions. So here, for example, we would have 4.5, here we would have 1/4, here we would have 1 3/4, and so on and so forth. Okay, now in order to do that, we will actually use a small external third-party package. okay? Because coming up with all this code would be a bit too much for this lecture, okay? And so it's a great opportunity to show you how to include once more external packages through the npm package manager, okay? So the one that we're going to use is called fraction.js, and it's just a very small, very simple library which will allow us to basically put in a number and then get the numerator and the denominator out of that number, okay? So for example, if you were to input 0.75, it would give us a numerator of 3 and a denominator of 4, so 3/4. Okay, so all we need to do is to go ahead and use npm install fractional in our terminal, and not the process that is running, but of course this one here. And we also want to save it in our package.json file. And here we go. So let's take a look at that. And indeed, here you go. So fractional is now available to us. And so we can go ahead and import that. So we will import, and it is a named export. And I'm going to show it to you in a second from, and now we just need the fractional. Okay, so again, for an external package installed through npm, we don't need to include the path. And actually this one is called fraction and not fractional. Okay, so this package doesn't have a really good documentation, but I know that it's exporting a named export called fraction because that's what we see here. So this here is another way of like importing modules with an older syntax. Okay, so this is like the Node.js syntax and not the ES6 syntax that we've been using. But it requires here this package and then the dot fraction. Okay, and so this here is the one that we're looking for and the one that we imported over here. So that's a named export. We can also see that in the index.json file. This is not really important, but just in case that you need to know this kind of stuff. So you see here module.export.fraction. Okay, and so you see that it has a named export called fraction. Okay, and so that's the one that we're importing here now at the top of our file. Okay, so let's create a function here called format_account, where we put in a count, so basically a number, and then we're going to return a formatted string. Okay, and we're then going to go ahead and use that here in the render recipe, or actually it's in the create ingredient. Okay, so it's right here. So we pass that into format the count. Okay, and this will then return a better formatted number here instead of the raw number that we have in our data, in our object. So let's start off by asking if we actually have a count. Okay, because it is possible that from our data processing, the count is actually undefined. Okay, so I mentioned before that there might be some unsolved cases here in the parse ingredients. Okay, and so it might sometimes return undefined here for the count. Okay, so usually that's not the case, but it might happen. And so in that case, all of this code that we're going to put here is not going to run, and instead we can simply return like something like this, so a question mark. Okay, so instead of it saying undefined in the user interface, it will have this question mark, which is going to look much nicer. Okay, so let's pretend that our example here is 2.5 as the count. Okay, so just that we have an example here in order to know how to build up this code. Okay, now this is then later going to translate into 2 and 1/2, right? So just as a reference. Now the first thing that I want to do is to separate the integer part from the decimal part, okay? Because imagine if it were 0.5, then it would look different. And let's actually take that as an example as well. So if it was 0.5, then we would just have a half, and that's of course a different situation here. So let's start by doing that. And now we are going to use something called destructuring, and I hope you remember that from the ES 2015 or ES6 section. So basically we can define two variables here at the same time, okay? And you're gonna see why in a second. So we have our count, we will convert it to a string. So we use toString so that now we can split it. And of course we split it by the dot, okay? And so this will now be an array of a 2 and a 5, both as strings. So in this example here, so in 2.5, we will now have the integer as 2 and the decimal as 5. Now the only problem with that is that they are now both as strings, and we want them to be as numbers. So we need a new array with them as numbers, and so we can use map, right? And what we're going to do in here is to simply parse int the element with a base of 10. Okay, and so now we're going to have 2 and 5 both really as numbers in these two variables, right? Now, in case there is no decimal, which is perfectly acceptable, then we will simply return the count. Okay, imagine that we have just 2. So if we have 2, then we will have no decimal at all. And so we can simply return the original count, which was 2, and call it a day, because then our work is really done here at this point. Okay, so that's the first case actually. But now let's say if the integer is 0. And so that would be this case here, okay? So the integer is 0 and 5 is the decimal, so 0.5. And so now comes the case where we actually want to convert 0.5 to a string looking like this, so to 1/2. So how do we do that? Well, we're going to use the fractional library now. So we create a new variable, and I'm simply going to call it fr, which stands for fractional, and then we say new fraction based on count. Okay, so based on count, it will now create a fraction, and from there we can read the numerator and the denominator. Okay, and so what we're going to return here is a string, so a template string with fr numerator, then a slash, and actually without a space, and then fr.denominator. Okay, and so in case we have 0.5, well, this will then automatically calculate that the numerator is 1 and the denominator is 2. Okay, and so then we're going to return 1/2, just like this. And with that, we're done with the formatting in case that the integer is 0. Now, if it's not, so for example 2.5, well, then it's a bit different. So we still need to create a new fraction. But really, we don't want to create a new fraction of all of this. We just want to create a new fraction of the 0.5 still, okay? Because otherwise, we would simply end up with 5/2. So we could have this intermediate step here like 5/2. So that's the same, okay? But we don't want to display it like this, which is still 2.5, but it looks better like this, so 2.5. That's a bit more logical, right? It makes more sense. And so what we really want is to create a fraction just of the 0.5 part. And what that means is that we simply have to do count minus the integer, right? And then from there, it's actually pretty similar to this part here. Now, all that's missing is, of course, and I hope you can guess it, the integer part, okay? So we do this fraction here only with 2.5 minus 2, right? So count is 2.5 and integer is 2. So 2.5 minus 2 will be 0.5, which will be then 1/2. And then here in this return statement, in this template string, we put it back together basically. So we put our 2 and then our 1/2, which is this. Okay, so once more, this is really not for you to memorize how this specific case works. I just want you to be able to think logically, basically, about how we can achieve the goals that we need to achieve. Okay, and in this case, there are some particularities, like having to do it this way here, for example. Okay, but that should now work. So let's test it out. And we're still loading the same recipe. And indeed, here we go. So we have 4.5, 1 3/4, 1/4, and 1 3/4. So that's perfect. It works just fine. And now one last thing that I want to implement here is the functionality that basically the recipe that we select here from our search list will then get selected with this gray background here, okay? So right now it's this pizza here, and so this one is gray. And if I select this one here, well, then this one here stays gray, okay? So that shouldn't be all too hard. So let's go back to our code and quickly implement that. And we actually want this to happen when a recipe loads, but the DOM manipulation itself happens in the search view. Okay, so let's actually add a method or a function here in the search view, and I'm going to call it, let's say, the highlighted selected. And so for that, I need an ID, of course. And so let's see how we can do that. So what I'm going to do is a documented query selector, of course, because it's an element that's not yet there when we load the page. And so I can't do it in my base.js, so in my elements object that we've been using so far. So query selector, and so now we can use the power of the CSS selectors, because actually that's what we can input here. So this is like a CSS selector, as you know already. And so we can select all links based on attributes. And the attribute that we're looking for is the href. And we want to say that it has the ID. Simple as this. So we have a link always with the hash symbol and then the ID, right? So let's take a look at the search list just to make sure that we're on the same page here. So the links, they are, as you can see down there and also up here, it's always the hash and then the ID, right? And so we want to select the element that as an href attribute has exactly this ID here, so this hash. Okay, so you want to select it and then on the class list add the class of result link active. And again, I could put this here into the, where is it? It's not this one. So I could put it here into the element strings, but I'm not going to keep using this one here, because then if something changes, I will have to actually change it here in the element strings and also in the code that I put in here. So like in here, I would have to go ahead and add these element strings also here inside of all this markup that I input here. And that's way too much work. And so I'm not going to go that way. I'm just going to leave it as it is. Okay, so I'm just going to hard code these class names here, just as I do it also down here. Okay, so here we also have all of these hard coded basically. So results links, and that's actually the one where this new class will be attached. So result links, and if it's active, then we have result link dash dash active. And actually, yeah, it is results and not just result. And so now you see it's the same result link active and then result link if it is not active. Okay, so highlight selected. And now let's go ahead into our controller and say highlight the selected search item. And of course, we have to do it again in the recipe controller, because this only happens as soon as we load a recipe. All right, so search view dot highlight selected and then the ID. Okay, let's take a look at it. And it will not be perfect yet. And you will see why in a second. So if I hit it now here, well, then it's actually not really working at all. So let's check out the console here. So what do we have here? It says here that it's not a valid selector. And so let's see why that is. And yeah, we can close this one, I guess, for now, and the recipe as well. And so the problem here is that we are lacking some quotes here. Okay, so in CSS in the selector here, you have to put it into quotes. Okay, so let's check it out again. And now it says it cannot read class list of null. And so that's actually another error, which is that in this case, there was not really a search. And so how can we highlight a search result that's not really there? Okay, so let's add an if clause before that. So if state dot search. So if this exists, then it means that there was a search, and only then one of the search items can be selected. Okay, so let's wait for it. And it still says it can read class list of null. And I'm not sure why that is, so let's check it out again. And I guess it must be somewhere here. And yeah, so indeed, this quote is not in the right place. It should be here. Okay, so this is here what it goes inside the quotes. So just the ID with the hash. Okay, and of course this code cannot be outside of this bracket. Try it one more time. Well, here it is. Now it's still not working. Oh, what's going on here? Well, it doesn't give me an error anymore. Let's try another one here. And it's still not working, as you can see here. And so let's try it one more time. Yeah, what's wrong is this. So when we add a class to the class list, we cannot put the dot selector because the dot is just, it's just a selector. And so here we really just need to pass in the class name and not a selector. Okay, and so that should now finally fix it. So let's try it out. Again here, writing pizza. And let's just click the first one here. And now it stays active. Okay, great. Now the only problem is that when I click this one here, then, well, the other is still active. And when I click this and this and this, and so all of them now, they stay active. And so a very simple solution to that is to, whoa, what's happening here now? I guess I clicked on too many of them at the same time. So what I have to do here is before adding the class to one of them, I have to remove it from all of them first. So let's just select them all first and put them into a variable. And I'm going to call it results array. And so I'm making array.from, which I already explained in the ES6 section. So document.query selector all. And the ones that I'm looking for is this results link. Okay, and again, I'm not using it from the element strings. Okay, but instead I'm simply hard coding it right here. So I'm not boring you here in these videos and make them longer and longer than they really have to be. Okay, so this is an array now. And now finally results.array. And then for each of them, let's simply remove the class. So element.classlist.remove. And then let's just get it from here. And what was that? Okay. All right, great. Just a final test now. Now it selects this one and let's hope it works. And indeed, it removes it from there. And yeah, so it really works. So I guess we're done with this part. Now there's just one thing that there's left to implement. So take a look at it here again. And that is, of course, the functionality where we can decrease and increase the servings. So you see, whenever I hit this button here or decrease button, then all of these numbers here, so the count numbers of the ingredients, they all get automatically updated. Okay, and so that's what we're still missing. And so we're going to take care of that right in the next lecture. So see you there. All right, let's now finish up this recipe part by updating the servings and the ingredient list whenever we click the increase or decrease buttons. And so you're actually going to learn something new in this video that we haven't talked about yet, which is another way of implementing the event delegation using the matches method on DOM elements. So again, the idea is to decrease or increase both the servings and the ingredients here whenever we hit these two buttons. Okay, so let's start with the model here. And I'm adding a new method here called update servings. And so we actually need to update the servings and also the ingredients. Okay, and we actually need also a parameter to this method here called type. Okay, and so that we in here can pass like a string saying decrease or increase in order to decide if we need to increase the servings or to decrease. Okay, so basically if we hit the minus button, then we will pass in decrease, and if we hit the plus button, then we pass in increase. Okay, so let's create a variable called new servings that will be set according to the type. Okay, so let's use the ternary operator here and say if it's dec, so it stands for decreasing, well, then this dot servings -1, else +1. Okay, now this will not update here this dot servings, it will simply then assign this value to type. Okay, or sorry, it will actually assign that value to new servings. Okay, so if type is decrease, then new servings will be this dot servings -1, and otherwise it will be this dot servings +1. But it will not update right away this dot servings. So we have to take care of that later, and actually we can do it right now. Okay, but we still need that new servings variable here to calculate the new ingredients, and that's why we had to calculate it first. So this dot servings will be the new servings. All right, and now as for the ingredients, well, we need to update all of the count numbers, right? Because the count numbers that we have, they're valid only for the current amount of servings. So we assume that we have 4 servings and that the count that we have in the recipes are perfect for that. So if we then decrease or increase the servings, then we also have to update the counts. And we're gonna have to do that for all of the ingredients. So this dot ingredients, and remember that this is an array, and so let's use for each now. And for each ingredient, we will have to change the count. So inc.count will be, and remember that inc is the current value in the for each loop. And well, the count will be the old count dot count times the new servings divided by the old servings, basically. So this dot servings. Okay, so imagine that we had 4 and now we have 3. So if we had count before of 1, then, well, before we had 4 and now we have 3/4. Okay, so that makes sense. Now we can make this even better, because instead of having to repeat the inc.count here, we can simply put the multiply here, and then this will mean the exact same thing. All right, and only now we can then finally update the this.servings in the object. Okay, if we had done this here immediately, then we couldn't use it here. Okay, and so that's why we have to do it afterwards. So this updates the servings and both the ingredients in our data model. So that's the first part, and with that we're done. Next up, let's go ahead to our controller here and implement the event handlers for the 2 buttons. Okay, and so once more we have to use event delegation, because these buttons, they are not yet there by the time we load the page. So the only thing that is there is the recipe element, so all of this. And so that's where we will have to attach the event listener to, and then use the target property of the event in order to figure out where the click actually happens. So just like we did before, but in a slightly different form, as you will see in a second. So handling recipe button clicks. Okay, so we have a recipe controller, and then let's add it here also to the same thing. Later we will add then some more event handling to this, because remember we also have the like button and the add to list button. But for now we're just going to take care of the increasing and decreasing of the servings. So anyway, let's now attach the event listener to elements.recipe. So that's the element that's already there at load time. And then add event listener, click, and then we need the event, of course, so that we can then use the target on it. So last time that we did event handling, I showed you the element.closest, right? Ah yeah, here it is. So here is the closest. Now this time around we cannot use closest, because there's more than one thing that we might potentially want to select. Okay, so here in this case we knew that we want to select the button inline. The problem was just that there are some elements in there which we could also click on. Okay, but right now the situation is different, because we have different elements that we might want to click on. We have the increase button, we have the decrease button, we later will have the hard button and the add to list button, and so we cannot use closest, because then it would be impossible to target these different elements. And so instead what we're going to do is to basically test what was clicked and then react accordingly. Okay, and so this time around we're going to use the matches method instead of closest. Okay, so let's use an if statement. And so event.target .matches. And now in here, we can simply pass a CSS selector, just like with the document.query selector, for example. So we can simply say button decrease, which is the class name. So let's take a look at that. So search view, and that's not the correct one. So yeah, recipe view. So we have here the, where is it? And actually I see that we're missing here the class names. Okay, so let's add button decrease and button increase. Okay, so the first one is decrease for the minus, and for the plus it is increase. So what we say here is that we want to do something if the target matches button decrease, or we can add a second selector here, just like we do in CSS, button decrease, and then any child. So that's what this asterisk here means. So that's like the universal selector inside of this parent element. And let me, not here, so let me show you why that is. Because again, we might click on this element or on this element. And so like this, it will match these two elements here as well, okay? So because again, this turns out to be true if the target matches the button decrease or any child element of that button decrease. So that's what this part here of the selector means, all right? And so now we can then respond to this. So is clicked, okay? And now we can go ahead and copy this because it's pretty much the same for the next one. And I see that here is actually a mistake. Let's go ahead and copy this one. And here we want increase. And here also. So what do we want to happen in this case is, of course, state.recipe.update servings. And we pass in decrease. So that's the string that we defined to pass in, okay? And then the same here for increase. All right, and then just log it to the console. So the entire recipe, okay? Just so that we can see the actual serving, because right now it's not yet updated on the user interface, of course. State.recipe, okay? And so yeah, let's test it out. Oh, something is happening. So you see the servings is now decreased to 3. Great. And now this is at 1.5. And this one here, yeah, this here is the original state. And so you see that it was 2 before, right? And so it's actually working, even updating here the ingredients. So you see 1 cup of mozzarella, and now it's just 0.75. And if I decrease it even further, then let's see what happens now. And indeed, it's 1 and 0.5. Now let's see what happens when I keep clicking. And the problem is that we now have negative servings, -5. And here we actually have not a number on all of these, okay? So that's something we have to fix. And of course, that's very easy to do. So we can only do this if state.recipe.servings is greater than 1. Only then we can decrease it more, okay? And here for the plus, well, there's not really a limit. I could put a limit here as well, like that we cannot put it to 100 people, but that's not really necessary. Okay, and so now finally, let's of course update the user interface as well. And so I'm gonna add a new method here, export and update servings again, and let's call it update servings ingredients. Okay, and we pass in a recipe, and based on that, we will then update everything. Okay. So again, we have to update the counts, and we have to update the servings or the ingredients. Okay, so it's not counts, it's the servings themselves. So the first one should be fairly easy. Document.query selector, And once again, I have to do the query selector here because this element is not yet there by the time we load the page. And so we're looking for the ingredient count. So where is that? Servings, it is this weird class name here. And ideally, we could have some class names that are specifically just for JavaScript. Okay, but well, in this case, I just did it like this. So no big deal, it still works, obviously. Okay, and so now just changing the text content to recipe.servings, and that's it. So this one is very simple, and now on to the next one. So basically what I'm going to do here is to select all of the ingredient counts and then update them one by one. So let's take a look at that. So count, so recipe count is their name, all right? So I'm going to go ahead and copy it. And so let's start by saving the selection here actually. So count elements, okay? So array.from, and now we do our document.query selector all from recipe count. Okay, and now what do we do with this? Well, we do a simple for each loop. And now in here we actually need the element and also the index. And you will see why in a second. So we're going to change the text content of each of this element. And what do we change it to? Well, first of all, we use the format count function that we used before. And what we're going to put in here is the recipe.ingredients. Remember, that is the array. And now at position i.count. Okay? Makes sense? And that's why we needed the I here. Because basically we're looping over two arrays here at the same time. So we have the recipe.ingredients array and the count elements array. So we're using for each on this one, and then also using the current index to retrieve the value from the ingredients array. We could have done it the other way around. So the for each could be on the recipe.ingredients, and then we would use the index on the counter elements. So anyway, this should now be actually working already. So let's wait for the reloading of it and let's try it out. Well, that didn't really happen. And yeah, I guess that's because we didn't really call this function here. So that's a stupid mistake. So recipe view dot update servers ingredients, and in there we pass the recipe state dot recipe. And the same, of course, also for the case that we increase the serving. Okay, so now we should be ready to rock. So let's try it. And here we go. It's working. That's fantastic. So we can increase it as we wish. Now let's try to decrease it even further. And it stops at 1, just as we defined. Okay, so perfect. Awesome. It's really working. And so with this, we actually finished this section. Well, we're going to add some more stuff here, namely this like button and this button here. But for now, it is really working. And so I hope you're proud of yourself for making it this far into the project. Next up, we're going to take care of this shopping list. So if you still want to continue this momentum, well, then just join me right in the next video. Welcome back to the next part of the app, which is the shopping list. And in this video, we will build our data model, where you will learn how and why to create unique IDs using an external third-party package. You will learn or remember the difference between the slice and the splice methods on the array. And also we will see some more use cases for the find index and find methods also for the arrays. So let's get to it. So as always, the first step is to create a new file in the models folder. So list.js. Okay, and once more, we want to represent the shopping list through an object. And so once again, we built a class here, which we used as a blueprint, of course, to then generate the list object later in the controller. So let's export default, of course, a class called list. Then the constructor, And this time around, we're not going to pass anything into the constructor. So basically, when we initialize a new list, we don't need to pass anything. All we want to do is to say that we have an items property set to an empty array. Okay, so this.items is an empty array. And so when we start adding new elements to the list, they will all be pushed into this items array. Okay, so basically all of the elements in our list will all be stored in this one property, this.items. All right, so let's now create a method to add a new item to the list. So we need to pass in the count, the unit, and the ingredient, right? Because our list is of course a list of ingredient, and it has the same structure as we have the ingredient data. Okay, so remember, we always have a count, a unit, and an ingredient. And so that's exactly what we're going to add to the list as well. Okay, so basically we will have an array in which each of the elements is an object which will have the count, the unit, and the ingredient. All right, so let's actually create that item here, item, and it will have the count property. And now remember that we don't actually have to specify it like this because it's just the same name. And so in ES6, that's not necessary. And the same goes for unit, and the same goes for ingredient. Now there's just one thing missing here, which is an unique ID. So we need each of the items to have an ID so that we can later identify them when we want to update their count or when we want to delete them from the model and from the user interface. Okay, and so we gotta have a unique identifier for each of these items. And we did something very similar in the Budgety app, remember that? And back there we simply specified a number and said that whenever we added a new item, then the next one should have the next number as an ID. So the first one had 0, then the second one had ID 1, 2, 3, and so on and so forth. But that then created some problems. When we deleted some items, then we had to go figure out the next ID that we should use. Remember that? And so this time around, we're going to do it in a different way. So we're going to include a small library which will create unique IDs for us. Okay, so let me show that package to you. And I already have it opened here, and it's called unique ID here on GitHub. Okay, and so it's very simple. So it will always create unique IDs based on the current time, process, and machine name. Okay, and all we have to do is really use the unique function, and it will then return us a unique ID. Okay, so let's now install this package here and save it to our package.json file. And we can wait for it, and while it does its installation, we can already start including it here. So let's import unique ID from unique ID. But this one here is not correct. Unique. So yeah, it's just really like this weird way of spelling it. So unique ID from unique ID. And so let's add the ID property. On ID, we want to have unique ID. And that's it. So this will create a unique identifier for each of the items based on this small library. Just take a look if it's already installed. And indeed, here it is. So unique ID on version 4.1.1. All right, next up, we want the ability to delete an item. Okay, and so now we need these IDs, okay? So what we're gonna pass into this delete item function is just the ID of the item that we want to delete, which we will probably get from the user interface. And then based on that ID, we are going to delete the item from our items array. So how are we going to do this? Well, we will use the splice method. So on this.items, we will use the splice method. And now what does the splice method do? Well, basically we pass in a start index and then how many positions we want to take. And it will then return these elements and delete them from the original array. Okay, so it mutates actually the original one. And this one is a bit similar to another one, which is slice. So slice is very similar to splice, with the difference that slice accepts a start and an end index of the portion that we want to take, and then returns a new array. And also it doesn't mutate the original array, okay? So for example, imagine that we have like this array 2, 4, and 8, okay? So let's add a comment here. So if we say splice 1 and then 1, it will start at position number 1 and take one element, so only this 4. And it will then return 4 and mutate the original array. So returns 4, and the original array is 2 and 8. Okay, so that's what happens with the splice. And if we say slice with the same, then it will start on 1 and end on 1. Okay, so it will still return 4, and the original array will be the entire array from the beginning, because we do not mutate the original array. Okay, but the difference here is that this one is the end index, while in splice, this number here means how many elements we want to take. So if we said 1 and 2 here, well, then it would take 4 and 8, returns 4 and 8, and the original array will only be with number 2. And if we had 2 here, well, then it will actually return the 4 like we have it here. Okay, because remember, the second here is the end, but it's not included. So actually, if we had 1, 1, then it would return nothing. Okay, because it would start in 1 and end on number 1, and so it wouldn't return anything. And only when we say 1, 2, so start at position number 1 and end on position number 2, well, then it will return the 4, and of course not mutate the original array. Now what we got to do here is to find the index at which we want to splice. So basically what we want is, based on the passed in ID, we want to find the position of the item that matches this ID. Alright, so let's start by doing that. So const index, and we will use this .items .find index. Okay, and so we already used this one here before. It's a very handy method for doing this kind of stuff. So we have a callback function which receives the current element, and all we have to do now is to test if the current element .id equals the passed in ID. And so it will now find the index of the element which satisfies this condition. So where the element ID is equal to the ID that we passed in. And so with this, we got the index where that exact item is located. And so all we have to do now is to say index and 1, because we only want to remove one element, right? So we start at the position where the item is located and then take out one element. All right, and that's it already, because this mutates the original array, and so it will really it will delete this element from our original items array. Now we also could now return the deleted item. All we had to do would really be return, and so this will now return the deleted item, okay? But we don't want to do that, so all we really want to do is to just delete the item, okay? And so once more, we use the very handy find index method. Now next up, and actually this is already the last one, is that we want to update the count. Okay, so we're not really going to update the entire element, but we will simply allow it to update the count. And so we will pass in the ID of the element that we want to manipulate and also the new count. And let me quickly show it to you in the user interface in the final app. So what I'm trying to do here is this one. So we have these buttons here where we can update the amount of the ingredient, but not the unit, of course, and also not the ingredient itself. So all we can really change here is the count. And so that's why we're having this update count, where we pass in the ID and then the new count that we want to save in the object. And this one is actually even easier to implement than the one before. So let's say this dot items. And so what we want to do now is not to find the index, but to really find the element itself. And so we can do that by using find. So yet another ES6 method, which is a bit similar to find index here, but instead of returning the index, it will return the element itself. And now the rest is really the same as up there. So we want to find the element which has as an element ID the one that we pass in. Okay, and so this will return our item, and then we can say that we want the count of that item to be equal to the new count. And that's it. So with one line of code, we achieved this functionality, which without ES6, so without this function here, would have been a bit more complicated to implement. Okay, so I hope this makes sense here. So this part, which is maybe the most tricky part, but I hope it still made sense to you. So again, what we do here is basically to loop through all the elements in the items and then select the one that has the ID equal to the ID that we passed into the function. Okay, then we return that object and change the count property on it. Okay, and so let's now go into our controller and include this. So import this basically. So recipe, and change them both to list. And now, just like before, let's actually create a new element. So a new list element, just to test it out in the console. So const L is a new list, and I will then attach this here to the global window object, such as we did before. Okay, and actually we could simply do it like this. So window.l is simply the new list. And so now we're going to be able to use all of these methods here that we just created. Okay, so let's try that. And now we have these all these console logs here. So let's get rid of that. Actually, we don't need that. So it's actually the state.recipe, I guess. Probably it's not, but we also don't really need that one. And what we really want here is this state.recipe.ingredients. All right, so let's wait for it. And now we should be able to access L, which is, of course, an empty array only at this point. So let's use add item here. And remember, what we need to pass in is the, well, I guess it starts with the count. Yeah, so the count, the unit, and the ingredient. And of course, the ID will be figured out automatically. So let's say we need to pass in 2 tablespoons of salt, for example. Okay, let's add another one. 2 tomatoes. Oh, and you see it didn't add it to the list really. So let's take a look at that. And yeah, of course. So we simply created the item here, but we still have to push it to the array, right? So that's a stupid mistake, but no problem, of course. So all we have to do is this.items.push the item variable that we just created. Okay, and then it's also a good practice to return the newly created object here. Okay, so return the item. All right, so let's try that again. So 2 tablespoons of salt, and you see it already returns the new object. So it's working now. And you see here, this is the unique ID that was created by the unique package. Okay, so let's add the other one, the 2 tomatoes. And you see it has a different ID, of course. So it's really working. So let's now delete the first one here. And so we need to pass in the ID, remember? So l.delete item. And we need to pass in the ID. Let's take a look at L now. And now we're only left with one array, which should be the one with the 2 tomatoes. So let's take a look at that. And indeed, we have the 2 tomatoes. So great, that's working. Now, just as a last step, let's try to use the update count method. So l.update count. We need to pass in the ID once again. And now we want 10 tomatoes. Okay, take a look again at L. And indeed, we have now 10 tomatoes. Okay, so our API is working. And notice how I said API here, okay? So of course I'm not talking about the API that we use to get the recipes. So API is, again, it's just a term that we can use also for this kind of stuff. So we just basically created an API for creating and updating lists, okay? And so we just tested this API and everything's working correctly. And so in the next video, we're gonna implement the view for the list before creating finally the controller. So let's now build the very simple shopping list view. And as always, we start by creating the new file. Then let's get our elements simply by copying it from here. And okay, so we're only gonna have 2 small methods in here. One to render the item and then one to delete the item from the user interface. Okay, so very simple stuff here in this view. So the first one is to render the item. And in order to do that, we will simply receive the item as an input, and the other function will be delete the item. For which we need an ID. So in a similar way to the list model, okay, so based on an ID, we can delete the item. And in order to render it, we need to have the item object itself. So let's start with this one here. Create a markup variable such as before. And so let's get that markup here from our HTML file. So where is that? So here we have the UL, which contains the shopping list items. So all of these items are inside the shopping list element. Okay, so let's copy this one. All right, and since we're at it, we can also create this shopping list here in our DOM elements, and it is in the base. So shopping will be document.query selector and then shopping list. All right. So the first thing that we're going to use is the ID. And so just like before, let's add a data attribute here. So data item ID should be equal to item.id. So the one that we passed in here with the list item. Okay, so this is the same way that we did before. So we specified a data attribute here in this view, such like we did here in the search view. Okay, remember that one? So in here somewhere, we should have, well, where is that? So yeah, it's here in the button. So here we have this data attribute, which is data goto. So we called goto to this one. So we can later select the elements based on that data attribute and based on that ID in our case. Okay, so this will be useful in order to delete the item. So we have the ID attribute. Let's now include the count, and the count is actually here in the value. Okay, so we have an input field, and that input field has a predefined value, and that value is what we want to specify here. And it will be item.count. Okay, and the same thing goes for the step. So the step is like the change that happens when we hit the arrow buttons on the number field. So let me show that to you here in this example. So we have this list here, and you see that, for example, here we have 0.25. And when we hit the up button, then it will increase by 0.25 to 0.5 and then to 0.25. Okay, and so we can define that step. And if we do the same here, then it will increase not to 1.25, but to 2, 3, and so on and so forth. And here, for example, it will increase to 9, then to 13, and so on and so forth. Okay, so we define that we want the count also to be the step. Of course, if you want to manually change it by hand, we can also write in. Okay, so whenever we click these buttons here, our value gets updated. So next up, we have here the unit. Of course, so item.unit, and then here we have the ingredient. Okay, and finally, we also want to add a class here so that we can later select this input so that we can then read this value here to update it in our model, right? So when we want to do this updating here, we need the new count, and that new count is of course gonna come through this input field. Okay, and so we want to read the value, and so in order to do that, let's add a class here so that we can then easily read it out. So this is going to be called shopping count value. So very simple. Okay, and now all we have to do is to insert this markup to our elements.shopping adjacent HTML, and we will do these here at before end. Okay, so that one is added after the other. Okay, so if we already have 2 items there, then we want the third one to be after the first 2, right? Okay, so that one is now done. Let's move on to the next one. And so let's now actually already use this data item ID property that we have here, because into the delete item function, all we pass in is the ID. And so now we have to select the element that we want to delete based on that ID. So documented query selector. And now we can use the CSS attribute selector, which is simply using these brackets. So we want to select based on data item ID, which should be equal to, and now we need to quotes, and then we pass in the ID, and that's it. And so now when we pass in the ID, we will be able to select the exact element, because here we basically attach that ID to our element here, okay? And so the goal was, of course, to be able to do exactly this, okay? And so now, remember how we actually remove stuff from the user interface. We have to move up to the parent so that we can then remove the child. So remove child and then item again, and that's it. So right now we cannot really test this because you don't have our controller yet. I mean, we could, but it's not really necessary. So we're just going to move into the controller right now in the next video, and then we're going to be able to see if all of this works. Okay, so see you there in a second. And to finish this shopping list part of the app, let's now build the controller. So we can close up this file here and go back to our index.js controller file. Okay, so where do we actually want to add the event listener? And we have to do it right here in this event listener that listens to events on the recipe object. Okay, let's take a look at that. So at recipe view, so we already have two event listeners on here, right? So for the plus and the minus buttons, so the button decrease and increase. And so now we need to add an event listener for the button to add all the ingredients to the list. Okay, and that button is down here. So it's this one, the recipe button. And actually we see that we have the recipe button also down here. Okay, and so let's add another class to this one here. So let's say a recipe button add. And so this will be the class for the button that adds all the ingredients to the list. Okay, so going back to this event listener here, so we already set this one up to handle all the events that happen inside of the recipe object, right? And we need to do it because we need this event delegation, because all of these elements that we're trying to select here, they're not yet on the DOM by the time that we load up the page, right? And so we need to do it this way. So else if, and we're going to do it in the exact same way as before. So we're going to test if the element that was targeted matches the string that we're looking for. Okay, so it's this one here or any of the child elements. So just like before. And so that's the CSS selector for all of the child elements of this element, so the recipe button. Okay, and again, that's because the click might actually not happen right on this button element, but inside of the SVG or even this use element, or also this span element. So it can happen on all of these, but we really want to catch it on this button itself, right? So what do we want to happen when the target matches this button here? Well, we will want to call our control list function. So the function that we're going to create next. And so that's it. So we have a recipe controller, we have the search controller, and now we're also going to have a list controller. Recipe, and I'm going to put this one here. So the list controller. So just like before, let's add the steps that we got to take here in this controller. So first off, create a new list if there is none yet, right? Because imagine that we add the ingredients to a list, then open up another recipe, and then we add those ingredients as well. So in that case, we don't want to create a new list, of course, because we already have one, okay? And we can actually already start implementing this, okay? So if there is not state.list, well, then state.list will be a new list. And that's it. Remember, we don't pass anything into the list because it's empty and we don't need to pass anything in there. We just want to basically initialize and with an empty object. Okay, next up, what are we going to do? Well, what we want to do is to add each ingredient to the list, right? So where are our ingredients? Well, they're at state.recipe.ingredients. And remember that this one is an array. And so let's simply loop over this array, and then for each element in the ingredients, we're going to add a new element to our list. Okay, so it's as simple as that. So for each. So what are we going to do here? We will do state.list, which is the element that we just created up here. And now we can call add item on it, right? So that's the data model that we just defined a few lectures ago, right? So we have our add item method here, to which we add the count, the unit, and the ingredient, okay? And so let's pass all of that data into this function. So we have l.count, we have l.unit, and we have l.ingredient, right? And that's because l is currently one element of the ingredients, and all the ingredients have, of course, a count, a unit, and an ingredient. And now let's take a look again at this function here, or add item function, because it will actually immediately return this item to us. Okay, and so that's great because we can now save that. So let's save it to this variable, and so let's add this item right away to the user interface. And I think we hadn't yet imported. Now that's right. So recipe view, and this one is called the list view. So we have, and where is it? So we have list view dot render item, and then we just pass in the item. So remember, it is, we don't need this one anymore. So we have our render item function here, which receives an item. Okay, so we just pass there, and then it reads all of the data that it needs and basically prints it to the user interface. Okay, so add each ingredient to the list and user interface. And that should actually be it for this step. So let's now finally test it out. And we can actually test it with this here. So add to shopping list. Whoa, and here they are. So it's really working already. That's awesome. So it basically looped through all of these ingredients here and then put each of them here in the list. Okay, and so we already have this loop here. So we have this for each loop here, and that's why we didn't need to include a method here in the list view that loops over all the items. So we did that in the search view, right? So we had render results, and then we looped over all of these results and rendered them one by one. But in this case, that's not necessary because we already have this loop here, and so it's easier to just have this one simple function that will then render them one by one. Okay, so this part is working as of now, and now the next thing is to actually add an event listener to this button here, okay? And also to these, basically to these buttons here, so that we can both delete this entire item and also update the value in our model whenever we change the value like this. So let's implement that. And once again, we are going to need event delegation, right? Because all of these items, they're not yet there by the time that we load the page, right? So let's do that right after here. So handle, delete, and update list item events. So where do we want to catch these events? Well, they are on elements.shopping, right? And so add event listener, click, and we of course need the event. And so yeah. So first thing that we're gonna have to do is to try and read the ID of the element that we clicked on. Okay, so basically we are trying to retrieve this ID here. Okay, so based on the data item ID. And so how are we going to do that? And actually we already used, and it's quite simple. So let's say const ID is e.target, and now we're going to use a method that we used before. Can you guess which method we will need to use here? Well, it's the closest method, okay? And that's because we need to specifically find the element which contains our ID that we want to read. And so we need to specifically find an element with the shopping item class on it close to where the click happened, okay? So closest shopping item is what we're looking for. And then just as before, we can use dataset and then the name that we gave it. So we gave it the item ID, right? So we called it item ID, and that's why we said data dash item ID. Okay, so that's how it works with dataset. And just like that, we already have our ID. So wherever we click on the user interface now, and now it's gone really, but wherever we click, no matter if we click here on this text, on this button, on the number, or wherever we want really, it will always go to the closest shopping item and then read the ID from that. Okay, so once again, closest is a really powerful method. It's really, really helpful. Okay, and so next up, we want to handle the delete event, or the delete button really. So we say if e.target.matches, and so this time we're going to use matches because that's going to return a true or false value. So what we're trying to test here is if our target matches the shopping delete class. And once more, let me show that to you. And so it's this here. So shopping delete is the class of this button. And so we will have to test if this is the one that we clicked on, basically. So shopping delete, or again, any of its child elements. Okay, so that's always the same logic. And so if this is the case, we will want to delete it from both the state and the user interface. So very simple, state.list.delete item. And of course, we pass in the ID, so the one that we already read here in this previous step. Okay, and then finally, list view.delete item as well. And again, we pass in the ID, and that's it. Now the test is a bit better. Let's actually make all of this window here, or all of this state here. So let's make all of this state available to us in the global window object for testing purposes. And so now we will be able to see if it actually deleted our items from the state, so from the underlying data as well as from the user interface. Okay, so let's use another recipe which is maybe a bit shorter with not that many ingredients. Now this is better here. So this only has 6. And so here are our 6 ingredients. So let's now click on this and see what happens. Oh, we have an error. And this one is happening in the list view. So let's take a look at that method here. And so it's probably this part here. So probably it didn't correctly select this element that we were looking for. And so this part here doesn't work correctly. So first of all, let's actually test if there's an item. And so basically we only do this here if there is an item so that it doesn't throw that error. Okay, but now we also have to find out what's going on here. And I can already see the problem, which is that here it's date, where it should be data, of course. So let's try that one again now. Add everything, and now let's delete the salt, and it's gone. And now just to confirm that it's also gone from the state, let's take a look at it. So we have the recipe and the list, of course not the search, because we didn't search for anything. And so let's take a look now at the list. And indeed, we only have 5 elements, and the salt is not in there. And so it actually worked. All right, and now only one more thing, which is to update this data here. Okay, so let's now quickly take care of that as well. So back here inside of this event listener, we can simply add a new else if and say e.target.matches. And let's see what we want to match this time. So list view, and it's this class here. So again, this is here the element where our count will be stored and where we can update it using these up and down arrows. So let's take this one. And in this case, we actually don't need to select any of the children because there are none. Okay, so it's just this element. And so what we need to do now is to read the data from the interface and then update it in our state. So let's call it val, standing for value, and our value will be stored in the element that was actually clicked, right? So let's say that we, and now it will be gone, or actually not. So let's say that we clicked this here. And so our target will be this exact element, right? So this input element. And if we click this one here, then the target will be this one. And so what we want to do now is to read the current value of the element that was just clicked, okay? And what that means is e.target. So e.target is the element that was clicked. And so since this is now an input element, we can read the value property of it, which will then contain the number, so the value that is in there. Okay, so very simple. Now all we have to do is to actually parse it as a float number, because otherwise it's going to be a number, which is not what we want. All right, and now state.list.update the count, and now we have to pass in the ID and the new value. And that's it. And it's not called value, really, sorry, it's called val. Okay, but now that should be it. So handle the delete button, and now here let's say handle the count update. Okay, now just notice that we're not really listening here for an event where we update this count here, okay? And now it's gone. But anyway, we are not looking for the event where we update this number. We are just looking for the event when we click here, okay? And so, yeah, that's when the event will be triggered. So whenever you click on one of these buttons, then it will change. So let's put olive oil like here to 3. And let's then take a look at state.list. Okay, so we have 6. And let's take a look at olive oil. And here's olive oil. And yeah, it updated to 3. So awesome, it really worked. Now we can delete some of this stuff here. Let's delete all of this. Let's change this one here to -5, which doesn't make much sense, and we could change that. But well, at this point you already know how to do that, and so I'm not going to keep boring you with all this repetitive code. Okay, let's just take a look at this again. And you already see that we only have two elements now, which is -5 instant yeast and then 3 olive oil. So cool, it is working, and so we're done with this part here as well. So next up is then this likes functionality, where we can finally like some recipes and then basically add them to a list of favorites. So that's going to be the last thing that we're going to do. It's going to be a bit more difficult than this list here, but I think it's a great addition because you will learn some new cool stuff. So congratulations for making it this far, and see you in the next video. Hey there, and welcome back. Let's now build the last part of the app, which is the likes, and we're going to start again with building the model. So let me start by showing you the functionality that we're actually trying to implement here. So I'm opening the final app version here. Then let me search for pizza, open up the first result here. And it's not loading because it's the one that's actually already loaded. So the next one. And so down here we have this heart, and now we want to be able to actually click the heart. It then becomes selected, and it's added here to the list. Okay, and if we move down to the next one, then we can like this one as well, and now we have both on the list. And if we come back to the first one, then the like should still be there, and indeed it is. And then we can add some more, and the list then keeps growing and growing, adding all of our elements. Okay. If we then go back to this one, we can unlike, of course, and then it moves it out here of the list and it's no longer there, of course. So that's what we're trying to implement here. And let's start again with the model. So I'm going to call this one here likes.js. And now this one will actually be a bit similar to the list class. Okay, so we will have a list again, and in this list, instead of saving the ingredients as before, we are going to save the likes. So export default class and likes, or constructor, and again we don't pass anything into it, but we initialize it with a empty array, which is going to be stored in this.likes. Okay, and so again this is a bit similar to the list class, and so we could do the subclassing here. So just like I showed you in the ES6 section, where we can add subclasses to classes. But in this case I think it doesn't really make sense, because first, they're actually not that similar, and also they are semantically quite different. So a shopping list and a list of likes is quite a different thing. So it's not like, for example, a pizza recipe, which is still a subclass of recipe. So they are like related things. But the list of likes and list of ingredients, well, they're kind of a different thing. Okay. Now, nonetheless, let's add the add like method here. And so again, this is a bit similar to the list that we coded up before. Now this time we are going to pass in the ID, the title of the recipe, the author, and the image. Okay, and so that is the data that we need in order to display it like this. So when we want it here in the list, we need the author, the image, the title of the recipe, of course, and then the ID so that we can then open it up like this. So we need always to have this ID so that we can call this URL. Okay, and so that's the data that we need to save here in each individual like. So ID, title, author, and image. So let's create a like object, and an object that will contain simply all of these elements. So ID, title, author, and the image, and we will then push it to the likes array. So this dot likes dot push the new like. Okay, and then just like before, we are also going to return the newly created like. Okay, and now we have to delete like also, which needs as an input the ID. And so this one is actually quite the same as before. So let's actually go ahead and save us some time here. Go to the list, copy all of this here, then get rid of this here. And so all we have to change really here is change it from items to likes. Okay, and then it's going to work in the exact same way. So we pass in an ID, then we find the index of that ID, and then remove the element corresponding to that ID from the likes array using the splice method. Okay, so that's exactly the same as before. Now we also need another method here, which is the isLiked. Okay, and again we're passing in an ID, and this method here is basically to test if we have a like in our array here which has the ID that we pass in. And this one is going to be important for this functionality here. So where we want to display this button here as either liked or not liked. So we have to know when we load a recipe if it's a liked recipe or if it's not, in order to then accordingly style this button. But you're going to see why a bit better when we start coding the controller and the view. So how can we do this? Well, we just need to try to find the index of the ID. So in a very similar way to up here again, and then see if it is different to -1. Because if the index is -1, it means that it is not there. So what we're going to return is this.likes.findIndex and then find the index, of course, where the past ID is equal to the current ID in the current loop. Okay, and we will then test if this is different than -1. Okay, and that's because if we cannot find any item with the ID that we passed in, then this will be -1. Okay, and if this is -1, well, then this entire expression here will turn out to be false, which is what we want, because it means that the recipe with the ID that was passed in is not liked. Now, on the other hand, if this turns out a number that is not -1, well, then this here will, of course, be true, and we will then return true, because the recipe with the ID that we passed in is, of course, liked. So it is basically here in this array. All right. So that's the isLiked method. And now we also need a very simple method called getTheNumberOfLikes. Okay, so this one just returns this.likes.length. And okay, so this should be enough for the model. For now, we will add some more stuff a bit later, but for now it works fine just like this. And I think we don't really have to test this here now in the console, because it's so similar to the list model, which is already working, and so the likes should be working as well. And if not, well, we're going to find the error then in a second in the next video, when we will start coding up the controller for this likes. Let's quickly continue and build now the controller for the likes feature of our app. So this is where we left off with our model. Let's put it this way here and start working on the controller again. Okay, so let's get this code here inside the like controller. Now, where do we actually trigger a new like? Well, it happens, of course, on that like button, right? And that like button is again in the recipe, and so we will control that click again in this event listener here, okay? So all events that happens on the recipe, we will all of them handle here in this event handler. So you're already handling the decrease button, the increase button, and also the add to list button. So we didn't write it down here. Let's actually do that. All right. So let's grab the name for the selector. So it is in recipe view, and the like is this button. So it's the recipe love class that is associated with the button. Okay, and so that's the one that we want to test for now. So else if the target matches this selector or any child element, just like before. Okay, because I think there are some childs, and yeah, of course. So this SVG here might also be where the click happens, and in that case, we want to still match the button itself. Okay, and what is going to happen in this case? Well, we want to call the like controller, which we don't have yet, but we will do it in a second. So it is simply the controller control like. Okay. So again, just like before, let's start by creating a new likes object, okay? And again, we will only create it if it's not yet there. So if we have state.likes, or actually if we don't have state.likes, then we say that state.likes is a new likes object. And now we need to think about two different states that can happen. So let's say that we have a recipe that is already liked. So in this case, if we hit the button, then we want to remove this recipe from the list of liked recipes. And so we want to change the underlying data model. We want to change this button here like this. And we also want it get removed from here. But if it's the other way around, so if we didn't yet like it, well, then we want it to be added. And we want it to be added here also in the user interface. Okay, so we have two different situations. And so now we are going to need that method that we coded up before, which is to test if a certain recipe is already liked or not. So let's start with what happens when it's not liked. So state.likes.isLiked. And now we need to pass in the current ID, which is, and let's actually put it out here. So current ID is state.recipe.id, right? So let's say current ID. And then we're also going to have an else statement. So in the case that the current recipe was already liked. But usually when we encounter a new recipe, it will usually not have been liked yet. And so we're starting with that one here. Okay. So let's actually say that here. User has not yet liked current recipe. This one like this. Okay. And then down here, let's copy this. So I always like to keep my code commented. User has liked the current recipe. All right. So we then want to add the like to the data. So to the state, let's say, we want to basically toggle the like button. So in this case, where it has not been liked, it will then become the full heart. And in the other case down here, it will then become the empty heart, basically. Okay, so toggle the button and then add like to the UI list. And if it's the other way around, well, then we're going to do the other thing. So remove like from the state, toggle the like button still, and also remove it from the UI. Remove like from UI list. So let's start by creating a new like here. And that is done by saying state.likes. So what we created just up here. So state.likes.addLike. And so what do we need to pass in here? And let me actually do it in separate lines. So the likes, we need to pass in the ID, the title, the author, and the image. Okay, so the ID is the current ID. Then we have state.recipe.title, and we have the author, and of course the image. Okay, so we created our new like here. Then we toggle the like button, and we cannot do that yet because we don't have the view functions just yet, and then add it to the UI, which we also still don't have, but let's simply console.log it. So state.likes. Okay, and the same thing here in the other case. So instead of removing it from the UI, for now, let's just log it to the console. And so here we add it into the likes, and here we want to remove it from the likes. So all we have to do is to say state.likes and delete the like. And we pass in the current ID. And that should be it. Okay, so that's what we defined right here in our likes model. So we hooked it up down here also. Yeah, so we have control like, and so we can now actually test it out already. So let's search for pizza here. And hit the like button. And we have an error. Okay, so likes is not defined. And yeah, of course, so this likes here is not defined. And that's because we didn't include the model just yet. All right, so now we should be ready to roll. Oh, we have our likes array already here. And indeed, it is the best pizza dough ever. So it's working, you see? It has this current ID also here. And so great, it's working. Well, it's not really here yet. And so let's now try it out with another one. And yeah, now we have both. And it's also working. And if we now go back to this one here, well, now I will hit this button here again and see if it's then deleted. And indeed, it's gone. So it's working. So now we only have the deep dish fruit pizza, so the next one. And if I now also dislike this one here, well, then it's gone. So all our likes are now gone, which means that our controller is currently working. Okay, so next up, all we have to do now is to create the view. So toggle this button here, and then also display the list of likes up here. And in this video, we're gonna handle the user interface for the likes. So let's create a likes view. Okay, then get this part here. So our elements, close it up. And now the first thing that we're gonna do is to create a function to toggle the like button. So we say export const toggle the like button. Okay, and in here we will pass the isLiked variable. So a boolean saying true or false whether the current recipe is liked or not, and we will then adjust the button accordingly. So basically what we want to do here is, so in the recipe view, where do we have the icon? It's, yeah, it's actually right here. So we want to change basically this icon here. So we can have the icon heart outlined or just icon heart. Okay, so outlined is when it's not liked, and without the outline, so just icon heart is when it is liked, actually. So let's just copy this part here so that we know how this is written actually. And so let's create a variable for this name here, okay, according to the isLiked variable. So const icon string. And so we're using the ternary operator here and say if it's liked, then it should be icon heart. And if not, then it's icon heart outline. Okay, and now we can actually select that button. So let's take a look at the class name. And so it's recipe love. And what we need to change is on the use element. So recipe class, and then the use element is a child of that. So we're selecting this one, and now all we need to do is to change the href attribute here. So this one. So how do we do that in JavaScript? And I'm not sure if we have done this before. And so all we have to do is to say dot set attribute, and then we say the attribute that we want to change, which is the href one, and then what we want to set it to. And we want to set it to, let's take a look. So to this, well, actually to this here, and then we will add the string that we just created. So img/icons.svg, and then our icon string. Okay, makes sense? So we're selecting the element where the icon is located. So it's this use element, parent of recipe love. And then we set the href attribute using this method here to our icons.svg, and then with the icon name according to isLiked. All right, so let's test that actually in index.js. And yeah, here it is. Okay, and actually before we can do that, we need to, of course, import this list view, and it's not list, it is likes. So likes view. So likes view dot total like button, and now in here we pass true. Okay, so this is the case where the user has not yet liked the current recipe, and so after he likes it, then of course it should be liked, and so it's true here. Right? And then the next one is the opposite, and it will be false. Okay, so that part should now be working. And actually we can test it here, and it's working. Well, kind of, at least. It seems like one of the strings is not correct. So where do we have that? So it's icon heart and icon heart outline, and should be outlined like this. All right, so yeah, now it's working. Okay, so cool. Now what's not working is that when we come to this page here, it will not be toggled. So let's say we like this pizza now. Then we choose another one. And when we then come back, well, then it will no longer be with the liked icon here, okay? So if we now click, then it's unliked, now it's liked again. But it should be liked right from the beginning, okay? And so we need to implement that, and that will be in the recipe view, okay? So when the recipe is loaded, then we already need to know if this recipe is liked, and then display this button here accordingly. Okay, so let's open up our recipe view, and then in here we need to not only pass the recipe, but also if it's liked. So is liked. And then we come down here to the icon, and we can then just change this here, put in a variable, and use the ternary operator. So is liked, and if it is liked, well, then don't add anything here. And if it's not liked, well, then add the outlined. So this is a bit similar to what we just did in the other function. So if it is liked, then it will just be icon heart, and if it's not liked, then the dash outlined will be added. All right, and then finally, of course, we also need to pass in the is liked when we render the recipe. So index and is liked, and where? Here it is. So we have state recipe, and let's now separate it into a different line. And we also need to pass in state.likes.isLiked, and then the current ID. And we have that available to us here in this function. So here is the ID actually. Okay, so the current recipe ID. And so here we test if it is liked. Okay, and so here this will then return true or false, which is what we passed into this render function. So not this one. Whoa, what's happening here? Well, anyway, so we pass it into this render recipe saying if it's liked or not. All right, so let's test it out now. And it says error processing recipe for some reason. Okay, so it means that it happens somewhere here. So let's actually also log the error to the console. Okay, so I'm not sure what's happening here because maybe something is wrong with this here, but I'm not really sure what it could be. So let's try to load this again. And so now we can see the actual error. Cannot read property is liked of undefined. So let's take a look at that. It is at control recipe. And so the problem is it's right here. Okay, so it cannot read this state.likes.isLiked because whenever we reload the page, we don't yet have a state.likes. Okay, and so therefore we cannot really read then this method. Okay, now in the next video, we will make this like data persistent. So basically we will save it in the browser, and when we reload the page, it will still be there, and then it will no longer be a problem. But for now, a good way of fixing this is to simply out of everything. So here in the global scope, we can simply add a new like to the state whenever we load the page. Okay, so just for testing here, so that we remove it later on. All right, so let's test it out again now. And yeah, so now it's working. So let's search for pizza. And so we liked it, we can dislike it, and that still works. Let's like it again. And now let's try coming to the next one, like it as well. Come to another one, and then come back to this one. And you see, it is still liked. So great. And this one here should also still be liked. Now we can unlike it, come back to this one, unlike it as well, come back to this, and it's still unliked, just as we put it before. So that functionality is now actually working. Next up, let's add a small function that will ensure that this heart here, so this entire menu here, is only displayed when there's actually a like. And if there's no like, then this entire button here, like this heart icon, should disappear. All right. So back into the likes view, let's say export const toggle like menu. And we can pass in the number of likes here. And based on that, we're going to figure out if we should show or not the like menu. So first off, we can actually add that element to our base.js. So let's take a look at the HTML, and it is right at the top. So what we're looking for is this. So this likes list here, or actually this field here. Okay, so this here is the icon. And so that's the one that we want to show or hide, depending. So base.js, let's add a new one here, and I'm going to call it the likes menu. Remember, likes menu. So all we have to do is to say elements.like menu, and now we can manipulate the style property. Okay, so in order to just manipulate a single style in CSS, and what we're looking for is the visibility. Now, as you already know, if we had many styles that we wanted to apply, well, then we would just define a class in CSS and then toggle that class here using JavaScript. But in this case, it's just the simple visibility property. And so let's just do it like this with the style property here. Okay, so we can now do a ternary operator and say that if numLikes is greater than 0, well, then it should be visible. And if not, so basically if it is 0, well, then we want it to be hidden. And that's it. That's really all it takes here in this case. All right, so it's the toggle like menu. So index.js, coming back, and yeah, actually it's right here. And so this should also happen in the control like, and it doesn't really matter if the user has already liked it or not. And so we can just add it here after all of this. So list view dot toggle the like, and it's not button, it's the menu. All right, and then in here we pass the number of likes, which remember we did a method for that actually. So get number of likes. So state dot likes dot get number of likes. So let's test this one out again, and we have a warning here. So thank you Webpack for actually telling us that toggle like menu is not in the list view. And yeah, of course not. It's likes. It's the likes view, obviously. So let's again search for pizza. Open this one here up. And actually it's already opened. So the next one, and now we have 1 like, and so if it's here, of course, and now we should have 0 likes, and now it's gone. Now when we loaded the page, it was actually also there. So let's add the same outside here. And again, this is just for testing because we are going to change this in the next lecture when we're gonna persist this likes data, okay? But anyway, for now, let's just put it outside here so that when we reload it now, well, then it's really gone. Okay, and as the last step, we will now finally actually render our likes into that menu. Okay, so just like this. So this is again very similar to the way we did it before. So render the like, and we're going to pass in the like, and then create our markup variable just like usually. Now we need to get up that markup from the HTML. So for each like, we will have this list item, and yeah, it's here. And now what do we need to put here? Well, here it's of course the ID, so like.id, and so let's grab this and copy it. Here we have the image. Here we have the title as the alternative text. Here also the title. And finally here the author. Okay, and then finally we need to insert the HTML. And so first off, let's add this here to our elements. So the likes list. So likes list, document.query selector. So likes list, and so elements dot likes list dot insert adjacent HTML, and again before end, and our markup. And since we're added here, well, we don't need to test it yet. Let's first add the delete like function as well. So export delete the like. And for that, we need the ID as usual. So let's select the element. So document.query selector. And then we will do our special CSS selector where we can select based on the href attribute. And we did this one here before in the in the search view, I believe. So yeah, so it's down here. So we select it based on the ID. And so let's actually go ahead and copy it because it's the exact same thing. Okay, so we want to select all of the anchors, so all of the links which have the href with this ID. All right, and actually this is not quite correct because we don't want to select all of the links. We just want to select the links that are actually a like. Okay, so we want to select not the links, but the ones with the likes link class. So likes link, and then the ones that have this ID. Okay, and the same actually applies to the search view here. So we don't want to select all of the links because then that might select the link in the likes list and not the one in the search result. And so that is here a small bug. And so instead, let's simply select the result link. So it's this results link. Okay, so that's the one that we need to actually select. All right. Now this selects the link, but we don't want to just remove the link. We want to remove the entire li element, right? So we're selecting this link element, but what we want to delete really is this entire list element. Okay, and that's very simple. We just select the parent. So parent element. So very simple. And if there is an element, so it's always best to test if the selection here was actually successful. So if there is an element, well, then we can remove it. And just like before, we move up to the parent element and remove the child. Okay, so now it's time to actually test this. And so this is our version, pizza, and so let's try it with the pizza quesadillas. No error, and it's here, but it's not really in the list. So something went wrong here. Well, this functionality here still works, and the button is still gone, but something in the code is not correct, and it didn't even give us an error. So maybe it's just something with the render like. And yeah, I guess the problem is that we didn't really already call these functions. Yeah, so we just logged it to the console. And so of course we need to do likesView.render the like and pass in the new like. Okay, and so that's why we saved it here also to this variable. Okay, so we did the add like, which then, remember, returns the newly added like. So we can save it here into this variable and then pass it to the likes view module. All right, so we have render like here, and then also, well, let's get rid of this console.log here actually, and here as well. We already know that it works, and so all we have to do now is likes view dot delete like, and what we need to pass in now is the ID. So current ID that we have up here. Okay, and so now we should be good to go. So let's like this one. The heart appeared, and here we go. So we have pizza quesadillas. Now we have to also like shorten the title here, right? So just like it appears here. And we already have a function for that, right? So it's right here in the search view, right? It is the, where is it? Yeah, so it's the limit recipe title. Okay, and so now we want to actually use it here in our likes view as well. So first we have to export it. And so let's now actually import this entire module into our likes view module. Or actually not all of it. So all we really want is the, and I have to go back to copy it. So all we want is just this function from the search view. Okay, and so here we have title, and so it's actually not this one, it's here, the one in H4. And so let's now say limit the recipe title, and let's see if that works. So pizza, let me like this one here already, and yeah, so now it's better. Let's now like this one as well, and indeed, here we go. And so I can now click this, and it takes me to that recipe. And at the same time, it also actually highlights it here. So everything's working perfect. Our icon is also still liked. If we take a look at this one, then this is not liked, but we can add it, and you can see that it now is added, of course, also to this one. Now let's open one of these, and let's unlike it and see what happens. And it's gone. So it's working. Our functionality is now fully implemented, and it works just fine. So let's delete all of them and take a look if the button actually disappears. And indeed it does. Okay, let's edit back, and here we go. And if we now reload this, well, then it's gone. So it's no longer liked. And so what we're gonna do in the next video is to actually persist this data. So basically save it in the browser, and when we then reload the page, all our likes will still be there. So that's then a bit like more useful for the user if we were to use it like on our local computer. Okay, so great work, great job making it all the way until this point. There's just a tiny bit missing, which is this functionality that I just talked about that we're going to implement right in the next video. Welcome to the last video in this section. So let's wrap up our project with some final stuff that we need to take care of. And the first thing is that I spotted a bug that sometimes happens when we update the servings. And not in all recipes, but let's look at one specifically. which is this one. And actually it's already open. Okay. So first we have this weird huge number here. Okay, and so that doesn't look so good. And if we now increase this here, then you see that at some point it doesn't actually do anything, but instead it gives us this error here. And this error has to do with these two long numbers and with some rounding issues. And so we will have to go back and fix that. And so what's responsible for displaying these numbers here is a function that we coded up a long time ago, which is the format count. And that is in the recipe view. Okay, so here we have the format count. And so sometimes, again, we have numbers like, well, something like 0.333 and so on and so forth. And the fraction function here apparently cannot really deal with that. And so the solution is to simply round the number that comes in. Okay, so let's simply create a variable here called the new count and then round it to like 4 decimal places. Now, for some weird reason, the math.round only returns integers, okay? But there's a workaround for that. So if we were to pass in just count, then we would entirely lose the decimal part. But instead, we can multiply this by 10,000 in this case, because we want 4 decimal places, and then divide the result by 10,000 again. Okay, and so with that, we can still use math.round in order to have the 4 decimal places that we want. And if we want 5, well, then we can simply add another 0 here and 1 here, but that's not really necessary in this case. Okay, and so now everywhere we used count, we will simply use the new count. Okay, so let's test it out, and it looks a bit better already. So it's still not perfect, but for now I am going to leave it like this. Okay, so it does work actually. But anyway, what matters now is that we no longer have this error here when we reach the number 6, so 6 servings. So the error is gone, and now everything works just as intended. So let's move down. And yeah, so everything works now. Next up, let's clean up a bit our code. And by that I mean just the index.js. So we have some stuff here that we don't want in the production version. So for example, we don't want to leak all of our state data into the global object. And so let's take out that one. Let's see if we have some more. So we have some console.log here of the ID. That one we also don't need. Give it some more space here. And let's see. Yeah, so down here we have another thing. So another variable that we added to the global object, which we don't need at all. Okay, so now I think it's a bit better, a bit cleaner code. Now, next up, let's actually start up our build process. So this one here, where we use Webpack in the production mode. Okay, so let's move to our terminal. And right now we can actually quit this task. Okay, so we no longer want our development version running here because we're finished with developing. Okay, and so if you reload this now, you will see that the site can't be reached because, of course, our connection is lost because the web development server is no longer working. Okay, but anyway, what we want to do now is npm run build. That will then bundle up all our files, create a small reduced bundle, and actually write it to disk as well. So we end up with a bundle size of 125 kilobytes, which is actually not really small, and an index.html of 17.6. Okay, and there are methods for shrinking this down here, and it will probably be possible to do this, but that's a bit too much for this course. For that you can take like a more in-depth Webpack course. Okay, so what matters here for us is that actually the bundle is now written to disk, and we see that our code is this beautiful piece of code. All right, so that's minified, compressed, and yeah, so that's the result of Webpack. We cannot figure out what the hell all of this is, but it also doesn't really matter if you're just interested in making this work. Okay, so I guess we're finished with this project. Of course, we could make it a little bit better, and so let's take a look at a couple of suggestions of stuff that you could improve here. So if you want to have some more fun with this project, then the first thing that you can do is to implement a button to delete all the items in our shopping list at the same time. So right now we can only delete them one by one, but you could put a button to basically clear the entire list all at once. Then second, you could also implement a functionality to manually add items to the shopping list. So having like an input field with a small button so we can add more stuff to our shopping list besides the ingredients of the recipes. And also you could then store all of this data in local storage like we did with the likes. Okay, so that would make it a bit better again. Now, another small thing that you could change is the ingredient parsing algorithm. Okay, so that part that I showed you, like for example in that recipe that we just saw with this huge number that looks a bit difficult to understand. So you could improve that and some other edge cases that do not really work with the current way the algorithm is done. Okay, so I didn't want to make that video even longer than it already was, but you sure can improve on it. Okay, then next up, you can come up with an algorithm for more precisely calculating the amount of servings. So right now we simply added 4 servings to each of the recipes, but maybe with some research and analyzing the data, you can try to understand how many servings we have based on the amount of ingredients. Okay, so that could be a fun algorithm to code up. Okay. And now finally, you could improve the error handling. So instead of having these alert windows popping up when there's an error, you could like display this somewhere on the user interface, okay? So these are just a couple of suggestions that you have, and I'm sure that you can improve the project even more than this. And if you do, then please make sure to share it on the Q&A in the course, okay? So I would be really excited to see that. And all right, so that's really it. I hope you had as much fun with this project as I did, that you learned a ton of new stuff along the way, and that it will ultimately make you a bit better at coding JavaScript. So thanks for making it this far in the course, and see you next time.